Hello everyone, this is Aditya, and today we are going to cover Engineering Mathematics 2 Algebraic Structures. So let's start with the video, but before that, please do like, share, subscribe my channel, and please support this video so that it can reach to maximum number of people. And now let's start with the video. So before understanding algebraic structures, you all should know that what is meant by a binary operation or composition. Well, let me define it first of all, and then we will see what it is actually. So let A be a non-empty set. Okay, then a mapping or function. Suppose this is it from A cross A, the Cartesian product, to A, which is denoted by this is the operation A cross A to A. This is how you represent it, is said to be a binary operation, binary operation or composition. We will see in a couple of minutes that what it actually means, but for now let's just understand its definition, and there's something more to go. So suppose for any element uh, element A comma B which belongs to A cross A, then the image of it under the operation this is denoted by this symbol. Okay, so A and B are your free images, and when you are operating this operator, then the image is this, right? It is similar to, like, if I say you have to add two elements to pre-images. So A, suppose A cross A to A. So suppose A comma B belong to A cross A, then it means that A operation B is equal to A plus B. So this is how the binary operation works, right? So we have assumed a non-empty set, then a mapping or function, like it goes from A cross A to A, right? Okay. Or function from this to this is said to be a binary operation or composition, right? Because this also belongs to A. It means that A belongs to A, B belongs to A, and A operation B also belongs to A, right? So a binary operation is taking from A cross A to A, right? So that is why this is how we represent. Okay, understood? So now let's see what is algebraic structures, right? Okay, let me read this. So now let's see what is algebraic structure. Okay, algebraic structure, right? So a non-empty set A together with one or more operations which satisfy some fundamental properties which are called axioms. No need to worry about them, we will discuss it. In this case, it's like closure axiom and associative axiom and many other things. We will discuss it. No need to worry about that. Okay. For now, just see the definition. axiom is said to form an algebraic structure, right? And notice that the operation may or may not be binary. Operation may or may not be binary operation, right? Or composition. Okay, so this is how the things goes. Okay, now let's moving to groups, and of course don't worry about it, we will discuss it soon. And yeah, one more thing, in this lecture we will be sticking to the binary operations only. Okay, so now let's see. Hold on. Let me erase this. So now let's see what are groups. Groups. Okay, so basically it is suppose a non-empty set G is said to a group a group if with respect to this, and here it is a binary operation, right? If you know the meaning of if means if and only if. Means this is the only condition, right? Only conditions. The first one, closure property. What is it? Let's see. Okay, so suppose for any two elements any two elements hmm, a comma b belong to G, then a plus b, I mean a and then a binary operation b, right? This is the binary operation b should also then belongs to b, right? And this is of course the definition of the binary operation only. Binary operation definition. If you remember, I said that if A belongs to A and B belongs to A, then A operation B also belongs to A. Similar is the case over here. If A and B belongs to G, then it implies that A operation B also belongs to G, right? Understood? Okay. So now let's see the second property. It is called associative property, right? Property, right? So let's see. So if A, B, C belongs to G, then A operation B operation C is equal to A operation B operation C, right? Fine, is it correct? Okay. Let me erase this so that I can get more space to write the third property. Okay. So let me erase this stuff and yeah. Okay. So let's see the third property, existence existence of identity element or identity. Okay, so suppose I mean there's a condition, there exists an element E belonging to G such that E operation A is equal to A operation E is equal to A, right? And of course A belongs to G, right? Of course it has to be, right? And what is the fourth property? Let's see that also. Okay. The fourth property, it states that existence of inverse element or inverse, right? So each element each element A belonging to G, there exists, you know the meaning of this symbol? There exists, it means there exists uh, an element A dash which belongs to G such that A operation A dash is equal to A dash operation A is equal to E, which is the identity element. Okay, so I hope you understood this, and let me recap everything so that you can understand it better. Okay, so let's see, and of course you will see it using examples also, lots of examples, so no need to worry. So first is the closure property, which is simply A belongs to G, B belongs to G, implies A operation B also belongs to G. Yeah. And second, associative property, it states that A belongs to G, B belongs to G, C belongs to G. It implies that A plus B plus C is equal to A operation B operation C, not plus. Okay, correct. And what is the third one? It is the existence of identity element. So for any element, there exists E belonging to, I mean, there is a E belonging to G, which implies that A operation E is equal to E operation A is equal to A, right? For all A. And fourth, existence of inverse. It means that there exists A dash belonging to G such that A dash operation B A is equal to A operation A dash is equal to E, which is, sorry, I am not well, so that is why I'm sorry, actually I'm not well, so that is why. Okay. Uh, where E is the identity element. Okay. So now let's erase all this, and now let's see some problems, and I mean some theorems, and then we will see certain problems, and then we will see what is an abelian group, and then we are going to look subgroups. Okay. So now let's start with that. Let me erase this stuff. So now let's see how we represent a group and what are some of the theorems. So notice that a group is represented by, so this is the binary operation and this is the representation of group, okay, or simply G. And why I'm saying that group has to be represented like this? Well, because when we defined the group, we said that it is a non-empty set G is said to form a group with respect to a binary operation. So we are considering the group with respect to a binary operation. That is why we are showing a binary operator over here. But of course, if it is well defined, then we don't need to show if it is obvious. Okay, that is why. Now let's see some theorems. Suppose theorem number one. Let me erase this because it is now of no use. Okay. So theorem one, what it states, a group G or like this contains only one identity element. Okay. So how do we prove it? Let's see. So let's assume that let's assume there exists sorry, there exist there exists two identity elements Sorry, I'm not well. So E1 and E2 belong to G, right? Okay. So you know from the property, from the existence of the element, of the identity element, E1 and then this must be equal to E2, then this, it must be equal to E2, right? And we can also say E2, then this is equal to E1, then this is equal to E1, right? Isn't it true, right? This is from, suppose from the property, of E1, and this is from the property of E2, right? Since E1 is acting as an identity element, which means that when it is when an operation, a binary operation is applied, is used over here, so it should give E2 as output if E1 is the identity, and same is the case with E2. But notice that E1 binary operation, E2, they both are similar, they both are equal, right? They both are equal, which implies that these two implies that E1 is equal to E2, which implies that there exist only one identity element, right? Okay, so now let's see another property. Okay, so now let's see theorem number 2. It states that if we have a group this, then each element has only one inverse, right? Inverse. So how do we check it? Let's see. So suppose there exist two inverse, suppose A1 and A2. I mean, let there exist, let's assume there exist two inverse elements, two inverse A1 and A2 belonging to G for A belonging to G, right? Then it implies that A plus A1 should be equal to element, the identity element, and of course A1 this, okay, and A operation A2 is equal to E is equal to A2 operation A, since we proved that there exists only one identity element. And now what we are going to do, we know the associative law, associative property, A plus A1 plus A2, it can be written as A plus A1 operation A2, which is equal to, what is A operation A1 is equal to E. So it is E operation A2, which is equal to A2. A2, right? Okay. So now we have A operation A1 operation A2. It can be expressed as A1 A2 A operation A2 operation A1, which is equal to E operation A1, which is equal to A1. And since from the property of associativity, we can say that A1 will be equal to A2, right? Which implies there exists only one inverse element for an element, right? For a given element, okay? Right, rest you can write, okay? Now let's see another property or theorem. So for a given group, this, we have to prove that A operation B is A operation C. It holds. We have to prove that this is equal to B is equal to C. I mean, this implies that B is equal to C. Okay. This is left cancellation rule or property. And second one, this is equal to A plus B is equal to C. This is the right cancellation property. This you will do on your own. Do on your own, and this I will do. Okay. So first one solution or proof. So A and then this B is equal to A, this C. Okay. Now we are going to apply the identity, I mean the inverse element of A. What it will be? Suppose A inverse operation A, this is equal to A inverse operation A operation C. What is this? This is E, this is E. Applying both sides A inverse on left side. Okay. Okay. So E operation B is equal to E operation C, which implies B is equal to C, right? From the property of the identity element. Okay. And this is very simple. And of course, you will do the this part, and similarly you will do this part also. It is very easy, right? And now let's see if anything else is left. We will do it. Okay, let's see what is an abelian group. Okay, let me erase this, then we will see. So now let's see what is an abelian group and what are its properties. Let's see. So abelian group is also called commutative group. Okay, I hope my spelling is fine. I guess it's correct. If it is not, then please do correct it. Okay. Okay, so of course it is a group. Okay, which means it will follow closure property. It will follow associativity. It will follow identity element. It will have identity element. It will have inverse, right? Inverse, right? And these things make it a group. But what else we have to add is that if A comma B belongs to G, then A operation B should be equal to B operation A, and it is the commutative property. Commutative property. So it should hold commutative property also to be eligible to become abelian group, right? Okay. So now let's do some problems, okay, and then we'll go to subgroups. Okay. So this is your question that we are given the set of integers, that is called the set of integers, and the binary operation, this, where binary operation is defined by A operation B is equal to A plus B plus 1 for all. This represent for all A comma B belonging to the integers, right? So you can pause the video and try this question, and now I'm going to solve this problem. Okay. So in this, we have to check that whether it is a group or not, right? Okay. So let's see it. So Z and then the binary operation is that. So let's check for closure property right now. Closure property. Okay. Suppose A comma B belongs to Z, right? Then A operation B is equal to A plus B plus C. I mean A plus B plus 1, right? And notice that A belongs to Z, B belongs to Z, 1 belongs to Z, which means A plus B plus 1 also belongs to Z, right? Which means that property verified. Okay. Okay. Now, what is the second property? Associativity. Associative property. It states, suppose A comma B comma C belong to the integers, then A operation B operation C is equal to, let's see what is it, A operation, what is B operation C? It will be B plus C plus 1, B plus C plus 1, right? Is it correct? A operation B is equal to A plus B plus 1. You can say that X operation Y is equal to X plus Y plus 1. Put X is equal to B and Y is equal to Z, Y is equal to C. You get B operation C is equal to B plus C plus 1. And that is what is happening over here. And now you can consider it as suppose capital B. So A operation capital B must be equal to A plus capital B plus 1. And what is capital B? It is A plus B plus C plus 1 plus 1, which is equal to A plus B plus C plus 2. Are you understanding this? How I did this? It is very simple. I assumed that this stuff is called B, capital B, and then I applied the definition of the binary operation which is given in the question, and we got this, and I substitute back the value of capital B. Okay. So let's remember this. It is A plus B plus C plus 2, right? Okay. Now let's do it like this. A plus, I mean A operation B operation C, it is equal to A plus B plus 1 operation C, right? Okay, now you can apply it over here also. Assume it as capital A, so capital A operation C is equal to A plus C plus 1, which is equal to A plus B plus 1 plus C plus 1, which is equal to A plus B plus C plus 2, which means that associative property is verified over here, since A operation B plus, I mean B operation C is equal to A operation B operation C, which implies that associative property is verified. Okay. And what is the third property? Existence of the identity elements. Let's see that also. Not elements, it is elements. Sorry, I made a mistake while speaking. Okay. So third is the existence of identity element. Okay, forget the spelling right now what I have written. Okay, so suppose we are given A comma B belong to what is this side, Z. So we assume, let's assume there exists E belonging to, let's assume that there is an identity element E belonging to Z. Okay, so it implies that A operation E must be equal to E operation A must be equal to, let's apply this now, we get A plus E plus 1 must be equal to A, right? Since this is the definition, it must be equal to A. Now let's apply A plus E plus 1 is equal to A, which implies E is equal to -1. And we indeed got an identity element, so it means that existence of identity is also proved. Now we have to check for inverse. Let's see that also. Let's erase this for that purpose, and we'll see further that what exactly is it. Okay, so existence of inverse, existence of inverse element, inverse of an element, right? Of an element. Okay, so suppose A inverse belongs to set Z. Suppose for all A belonging to Z, there exists A inverse belonging to Z such that, are you understanding what I have written? For all A belonging to Z, there exists an A inverse belonging to Z such that A operation A inverse is equal to A inverse operation A is equal to E, the identity element. So let's substitute, we get A plus A inverse plus 1 is equal to E. What is E? E is the -1. E is -1. So A inverse is equal to -2 minus A. And which implies A inverse belongs to Z, right? And here E belongs to Z from this, right? Which means that there exists inverse of all the elements in the given set, in the given group. Okay, And of course, if you want, you can check for abelian also, and it is also abelian. Why? Because A operation B is equal to A plus B plus 1, B operation A is B plus A plus 1, and they both are equal. So it is an abelian group actually. But since we were asked to prove that is it a group or not, so it is a group. And of course, it is an abelian group also. Now let's see another question. Okay, let's erase this. So this is our second question, and in this we are given that prove that set of all real matrices, and this is the matrix such that a square plus b square is not equal to 0, form commutative group with respect to multiplication. You can try this one, and now I'm going to solve this. You can pause the video. So let's check for the closure property. Closure property. Suppose we represent this as set A, right? So A belongs to suppose A belongs to group G, right? We have assumed, and B also belongs to G, right? For the timing, we are assuming G, okay? Then A operation B is equal to A multiplication B, right? Correct? Okay. So it means that it will be equal to A B negative B A into C D negative C, I mean negative D C, right? And when you evaluate this, what you will get? You will get A C minus BD, and you get AD plus BC minus BC plus minus AD and minus BD plus what is it? Minus plus AC, right? Okay, so we got this. What is the determinant of this? Let's see. Okay, but wait, it is AC minus BD. This is AD plus BC, A AD plus BC. This is AC minus BD, right? So it is of this form only. Notice that if we assume this as suppose arbitrary A dash and this as B dash, so this is negative B dash and this is A dash, just like this. And when you take the determinant, what you will get? AC minus BD whole square plus, I mean minus AD plus BC whole square, right? And of course there was a negative sign, so it will become plus. And when you solve this, you will get A square plus B square into C square plus D square, right? And notice that since A and B belong to G, which means that A square plus B square is not equal to 0, and C square plus D square is also not equal to 0, which means that their product also does not belong to 0, is not equal to 0, which is also not equal to 0. So it means that in this case also we are getting the same result, right? Since this is just the determinant of this quantity, right? A square plus B square, right? So it means that it is a closure property, which means that which implies A operation, I mean A operation B also belongs to G, right? Okay. So this is how you prove it. And the second property is the associative property. And you know, for every matrix there exists associative property, right? This is the basic law which you know. And you know that under multiplication matrices are associative, okay? That is the basic thing which you know, okay? And the second and of course you have to prove that also using the elements A B C D and E F. You take the elements, you show the product that they both are equal. You have to prove that, okay? I'm not doing that, that is your homework, okay? And the third thing, the existence of identity element, of course, I1001, right? It is the identity element. So when you multiply by it, you get the same matrix. And for the existence of inverse, of course, the matrix should be non-singular, which means that its determinant should not be equal to 0, and which is true in this case. So it means inverse exists, right? And for the fifth case, for proving it to be abelian group, and from those four we have proved that it is actually a group, and from the fifth one we have to prove that AB is equal to BA, and that is your homework. It is just simple multiplication which you can do, okay? So let's move into the next question, okay? And that is also your homework which I'm giving, okay? You can try it. Okay. So this is the question that prove that set of all complex number a plus ib where I is equal to the square root of -1 and a comma b belong to the real numbers and a square plus b square, that is the, suppose if I represent it as z, then mod of z square is equal to a square plus b square is equal to 1. We are given this, form abelian group with respect to multiplication. So it is similar to the case of matrices, but now we have the imaginary numbers and it is easy. You can do it. Okay. For closure, you will do a plus ib into c plus id, and you will check for the mod of that value, what you of that complex number, right? And for associativity also, you have to prove that you take first two group and multiply, then multiply it with the third one, and then you leave the first one and then you multiply second, third, then multiply it by that. Okay. So from that also you can check. And for the third one, existence of identity element, of course you can do like that. Okay. A plus E, I mean A operation B must be equal to A, which means A plus IB multiplied by E must be equal to A plus IB, so E is equal to 1, right? You got this. Okay. And similarly, A plus IB into A inverse, or suppose X inverse, else it will become confusing, is equal to 1. So you can solve X inverse is equal to 1 upon A plus IB, which is equal to A minus IB by A square plus B square, right? Is it correct? Okay. So this is how, and it is actually equal to A minus IB, right? So in this case, inverse is A minus IB, right? Okay. And when you multiply them, of course, you will get A square plus B square, which is equal to 1, right? From the given definition. Okay. So this is how you can check it. I'm not solving the completely. It is your homework to try it. I explained the problem. Okay. So now let's see another problem. This is a very simple question. The set Z forms commutative group with respect to addition. Justify. So you have to just assume elements A belong to Z, B belong to Z, C belong to Z, and then just A plus B belong to Z. It is true. Then for associativity, A plus B plus C is equal to A plus B plus C. This is also true since it is addition. Existence of element A plus E is equal to A, which means E is equal to 0. So E is the identity element, and A plus A inverse is equal to 0, identity element. So A inverse is equal to negative A. So where there exists inverse also. And for abelian, you can try using A plus B is equal to B plus A. So it is commutative also, so it is abelian. Rest, it is your homework to do it correctly, properly, in a proper manner. Okay. I told the method. So now let's see that what is meant by a subgroup. Let's see. Just a minute. Let me erase this. So what is a subgroup? Let's see. Suppose you have a group G like this, okay, and H be a non empty subset of G. Now if H is also a group, then it's called the subgroup of G, right? Okay, so suppose you have a set H, which is a subset of the bigger set G, which is said to be a group. Then if H is also a group, then it is called a subgroup of G, right? So basically, if G is a given group, and of course a group is a set also, then if there exists a H which is a non-empty subset of G, such that H, and here the binary operation is this, is also a group. If that is also a group, then we say that H is the subgroup of G. Okay, this is the basic thing which I need to tell. And there is a theorem which is used to check whether it is a subset or not, I mean subgroup or not. We are going to discuss that. We will see a problem and then we'll end this lecture. And yeah, we will do more problems and we will study about Zn function and all in the practice session, because that will be more helpful, right? Right now I gave the basic idea so that you can do everything, right? Okay, so now let's see the theorem. We won't prove this one. Okay, if you want you can try as a homework. Okay, so let this be your group, be a group, a non-empty subset H of G forms a subgroup forms a subgroup forms a subgroup of if and only if, first, for all a comma b belonging to H, a operation b must belong to H, right? This is the first condition. And second, for all a belonging to H, there exists a inverse belonging to H. Means there exists inverse, and this is the definition of the binary operation or the closure property, right? And this is your existence of inverse, right? So let's see one problem and then we will end this lecture. Okay? So let's see the question. It states that consider the group Z, and here the binary operation is the plus, and the set 2Z. What does 2Z mean? For example, it's a set of integers. It's minus 2, minus 1, 0, 1, 2, till infinity till infinity. Then 2Z is defined as twice the elements of Z, which means minus 4, minus 2, 0, 2, 4, and so on and so forth. Which means that set of all even integers, right? So this is the definition of 2Z, and now which means that it is the subset of the original set Z. Okay, defined by 2Z is equal to this quantity. Examine whether 2Z form a subgroup with respect to plus or not. Okay, so the first one, we have to prove that H itself is a group or not. So we will see it using the closure property. Closure property that suppose A belongs to H and B belongs to H, and of course we are given that Z is a group, so we don't need to prove that. Okay, which implies A operation B is equal to A plus B, right? Now the question is that whether it belongs to H or not. Well, you know that A belongs to H, and what is H? H is 2Z over here, and B belongs to 2Z again, which means A is of the form 2x and B is of the form 2y, which means 2x plus 2y, which is equal to 2 times x plus y, and which itself is an even integer, which means that, which implies A plus B is itself belonging to H, right? Or 2Z. Here H represents 2Z, or you can represent simply 2Z also. That is also fine. Okay. Now let's see the second property, the associativity. Associative property. It states this A, this, and then this. Of course, it is true, since A plus B plus C is indeed equal to this quantity. You add it in any way, it is still the same. Okay. Now let's see existence of identity and all. We will see that, and let's see. Let me raise this also. Yeah. The third one, existence of identity element. So if A belongs to H, then A operation E must be equal to A, right? If E belongs to A, correct? I mean belong to H, sorry, it implies that A plus E must be equal to A, which means E is equal to 0, which means E belongs to H. Why? Since E is equal to 0 and 0 is an even number, right? If you understand this. Okay. Now fourth one, existence of identity element, I mean existence of inverse for any element. Any element. Okay. So A, suppose A inverse belongs to H, and of course A belongs to H and E belongs to H. We have found E is equal to this quantity. So we have A operation A inverse is equal to E, which means A plus A inverse is equal to 0, which means A inverse is equal to A negative, right? And since it is integer, A is an even number, so negative A is itself an integer only, even integer, right? Which means it is a group. And now we have to check whether it is abelian or not, abelian group. To check for abelian group, we have to check whether it is commutative or not. Well, we don't need to check for abelian actually, but still, if you check, it will be A plus B and B plus A, and of course, it is commutative, so it is abelian group also, right? And this is how you check. It is very simple. You prove that it is a group, and of course, you could have used the theorem also. That is also fine, but this is a more better way to solve these kind of problems, right? So I hope that you have enjoyed this video and understood all the concepts of groups and subgroups. And of course, this is not the end, and we will see some better problems in the practice session. In that, we will learn many other types of groups like the Zn group and all. And for now, bye bye, take care, and please do like and subscribe my channel, and please support this video. Bye bye, take care.
Hello everyone, this is Aditya, and today we'll discuss functions in single variable in the form of a deep one shot, and in this way we'll discuss questions also. So please do like, share, subscribe my channel, and now let's get started. So what all we cover in this lecture? Let's see. We will cover Rolle's theorem. We will cover Rolle's theorem. We will cover MVT, mean value theorem, Lagrange mean value theorem. We'll cover generalized or Cauchy mean value theorem. We'll cover Taylor series in single variable, obviously, first of all. And then we will come to Maclaurin, right? So let's start with Rolle's first of all, right? Okay. And most importantly, we will solve the questions also, right? So let's start. Rolle's theorem. So what is it? Let's see. For example, if you have a function f of x is equal to y, right? Or simply say y is equal to f of x, right? And what is a single variable function? Means the y is dependent upon x, right? It is dependent upon single variable. So that is why it is said a function in a single variable, right? Okay. So what are the conditions to satisfy Rolle's theorem? Well, let's see. For example, you have a function and you are evaluated this function in the interval x belongs to closed a to b, right? Okay. So what is its significance? Let's see. So fx must be continuous in closed a to b, right? Okay. And fx must be, what is the meaning of continuous? Means it should not break at any instant, right? At any value of x between a to b, right? And x must be differentiable between open a to b, right? Open a to b, okay? And f at a must be equal to f at b, right? Okay. So why do I am telling all these conditions? Let's see. So let's draw such kind of function. Well, let me draw it. So this is our f at a, and it is given it is equal to f at b. Okay, f at b, right? Suppose this is your a and this is your b, right? Okay, this is point a, this is point b, right? F a comma fb, a comma fa and this b comma fb, right? So what are the conditions that you can draw this graph? Well, let's see. The first way is you can draw it like this, somewhat like this. The second way is you can draw it like this, a constant function. And the third way is you can draw it like this, right? There's no other possibility, right? And why do I am telling all these possibilities? Well, when you are drawing this graph, then you see that at in this case, this and this, where you are where the function is not a constant function, in that case what is happening is you are getting a peak over here, right? And in this case also you are getting a peak. But in the case of a constant function, you're not getting a peak, but you can see that it is a constant function, right? So what does it tell? Let's see. So let's see with a different case. I mean, this one, where you are getting a peak. So observe that in this case, the function is rising, it's increasing till a particular value, suppose this, and then it is gradually decreasing, right? Since fa is equal to fb, so it means that the function will increase till a certain value and then will start decreasing. Or maybe there is a possibility you can draw it like this also, maybe this and like this, right? You can do it like this also, so you can get multiple peaks in this case, right? Okay, but for simplicity we will look into the basic idea, right? Okay, so just observe that this is the peak, so it corresponds to some value of x at x is equal to c, right? Okay, this is the case. So why do I am telling all this? Well, the Rolle's theorem states that if a function satisfies such conditions, this and this, then it means that there exists a c which belongs to a to b such that f dash at c is equal to 0, right? And observe that since it is the maximum value, so at that point the tangent is 0, means that slope of the tangent is 0, which means the derivative at that point will be 0, right? You can interpret from the graph, because the function is increasing then decreasing, so there is a point where the function becomes 0, the derivative of the function becomes 0, right? Over here f dash x, oh just a minute, let me turn off, yeah, f dash at x is greater than 0. Here f dash at x is less than 0. So here f dash at x is equal to 0 at this point. And here point is c, right? I hope you are understanding it. Okay. Let's see the proof also for better understanding. Well, you observe that f at c plus delta x, right, minus f at c will be less than equal to 0, right? Since c is since at c the function is attaining its maximum value, right? So what does it tell? It tells that wait, so this is your equation 1. Okay, now just see, f dash at c plus delta x minus f dash at c divided by delta x will be greater than 0 for delta x less than 0. I hope you are understanding it. Means you are going towards left, right, towards f dash x is greater than 0, right? And when you are seeing f of c plus delta x minus f at c by delta x, it will less than equal to 0 for delta x greater than 0, right? We are understanding it. And notice that this is f dash at c only and this is f dash at c only, right? Okay, it is the LHL and this is the RHL. This is the LHL and this is the RHL, right? Or rather I should say not RHL, it is LHD and this is RHD, right? Okay, which means f dash c is greater than equal to 0 and f dash c is less than equal to 0, which implies f dash c is equal to 0, right? I hope you are understanding it. Okay, so that is the basic proof of the Rolle's theorem, and let's see some questions upon it so that the things become more clear. So let's see some questions. I have brought a question series also over here. So I hope that let's do the first one. First of all, let me change the color. Let's do this one, right? It is a bit easier for you to understand, so that is why, and rest you can solve it on your own. And let's see first of all the roles question. In this you are said you have to verify the Rolle's theorem for this expression in 2 to 3. Okay. F at x is equal to x square minus 5x plus 10 for x belongs to open closed 2 to 3, right? Okay. So since it is a polynomial, so it is a continuous function and it will be differentiable, right? So you don't need to prove it. Since it is a polynomial, which implies it will be continuous plus differentiable. You can write the statements on your own. I'm not discussing about all that. Okay. And you observe that f at a is equal to f at 2 is equal to 2 into 2 square minus 5 into 2 plus 10 is equal to 4, and f at 3 is equal to f at b is equal to f at 3 is equal to 3 square minus 5 into 3 plus 10, and it is equal to 4. You can check it, right? Okay. Which means it is satisfying the condition of Rolle's theorem. So there must be a point that exists, right? In that case, f dash of x is equal to what? It will be 2x minus 5, right? 2x minus 5 is equal to 0, and evaluate it at x is equal to c. So you get c is equal to 5 by 2, right? Okay. And observe that c belongs to 2 comma 3, right? Maybe I did not wrote it over there. No, I have written. Okay. And observe that in this question, yeah, that's it. So that means there exists a point c is equal to 5 by 2 where the Rolle's theorem is satisfying, right? Okay. Hence Rolle's theorem verified. And now let's see next question. Let's see. I will do third one and you have to practice the second one, okay? Because they both are similar. So let's see the third one. Okay. So let me change the color. So let's see. Third one, you're given fx is equal to x to the power 13 plus 7x cube minus 5 and is equal to 0, and we have to prove that it has only one real root. Okay. So for the time being, you can assume that fx is equal to x to the power 13 plus 7x cube minus 5 has two roots, alpha and beta, has two real roots, alpha and beta, right? Just for instance, because if you prove that there can't be two real roots, then you can gradually prove that there can't be 3, 4 and more roots, right? So there will be only two possibilities, that there is no real root or one real root, and we can check it further, right? So let's first of all see what is it. Okay. So just observe that it is a polynomial again, so it is continuous and differentiable, so I'm not writing it to that. And observe that f at alpha will be equal to f at beta will be equal to 0, since it is the root. They both are the roots, right? So just differentiate this expression f dash at x is equal to 13x to the power 12 plus 7x square 3 into, right? So you get 13x to the power 12 plus 21x square. It must be equal to 0 at x is equal to c. And you get c square common. You get 13c to the power 10 plus 21 equal to 0. And observe that there is a possibility that c can be 0, but that will a particular case, right? So we can't just take that case and solve, right? So that is why you have to take a general case. So you get c to the power 10 is equal to negative 21 by 13. And observe that it is c raised to the power 10, means it is c raised to some even power. So it can't be a negative number. So it implies there exists no c belonging to alpha to beta, right? which means there exists no real root. There exist no two real roots, right, or more than it. So there is only one possibility, that there are only two possibility, that there can be no real root or there can be one real root. So how do we check it now? Let's see. Let's substitute f at 1. You get 1 plus 1 plus 7, yeah, 1 plus 7 minus 5, 1 plus 7 minus 5, and you get it equal to 3, right? And you use f at 0 is equal to negative 5, yeah, which means the function is going somewhat like this. At some point between 0 to 1, the function is gradually negative over here and then it is increasing, right? Okay, so it means it is cutting the x-axis at least at one point, at max at one point, right? So it has one real root, right? Exactly one time it is cutting the x-axis, so it has one real root. Okay, I hope you understood it. And let's see what's the next question. Well, prove that between 2 points. You will do it on your own. Sorry, you will do this on your own. Just assume this as the function and then differentiate and put c. You will get this expression, right? Okay. And now let's move on to the next topic, Lagrange mean value theorem, and rest I hope you can do in rules, right? There is nothing much to it. Okay, so now moving on to, but before moving to Lagrange mean value theorem, I will teach you all theta h form. What is it? Let's see. Well, let's see what is theta h form. For example, you draw a graph, okay, A to B, right? And you choose a point over here, for example C, right? Okay, now you have to represent C in terms of A and B, right? So how you will represent it? Well, suppose H is equal to B minus A, means the width, you can say, right? So you can say C is equal to A plus B minus A, but it is wrong because you will end up getting C is equal to B. So to manipulate this, you put theta over here. Wait, why did I use the theta over here? Well, let's see. Theta is equal to A plus theta into B minus A. What is the limits of theta? Theta is belonging from 0 to 1 in the open braces, not the closed. So what is its significance? Well, when you substitute theta as 0, means forcibly you are substituting theta as 0, you get C is equal to A. And when you substitute theta as 1, you get C is equal to B. You can check it, right? And these are the extreme boundary points, right? And in that case, you can't put the C as 0 and 1 since you are using the open braces, but we are forcefully trying to put theta as 0 and 1 and we are getting A to B. We are getting the boundary limits, which means between 0 to 1 we will get the value of C, right? I hope you are understanding. Between theta from 0 to 1 you will get this region, right, excluding A and B, right? Okay, so you can write C is equal to A plus theta h, right? This is just a way to represent things, nothing more. Okay, it makes the calculation easy. Now let's move to LMVT. So let me write over here, this is the first topic, okay, and this is going to be our second topic, right? Okay, LMVT means Lagrange mean value theorem. What does it state? Let's see. Okay, it is very simple. The function must be continuous in closed A to B and must be differentiable in open A to B. That's the condition. Okay, I hope you got this, right? So if these two conditions are satisfying, then there exists a C belonging to A to B such that f dash at C is equal to f at B minus f at A by B minus A, right? This is the condition. Okay, I hope you are getting it, and if you are not getting it, we will see it using a question also. But first of all, let's approach it graphically. Let me use different sketch for it. Okay. So this is the condition, not the condition, but the graph maybe. This is A, this is B, right? This is this point and this is this point, right? Okay. This is your f at A and this is your f at B. There is no condition f A is equal to fb, right? Understand it. So you get somewhat like this, maybe, right? And now just join this and this point, right? Okay. And name it as AB, right? What is the slope of AB? M of AB is equal to f at B minus f at A by B minus A, right? Is it correct? Yeah. So what is the basic idea of Lagrange mean value theorem is that you will try to find a point C such that the slope of that point is equal to the slope of the line AB, right? Right? So what is the slope of the point C? It will be f dash at C, right? So you will try to find a point C, f dash at C, such that the slope of that at that point is equal to slope of that line AB is equal to f at B minus f at A by B minus A. This is the basic idea of Lagrange mean value theorem geometrically and graphically, right? Okay. There is one more method you can use to prove this theorem, but I don't believe in that much because it is very much like rote learning sort of thing. But let's see. You assume a function phi of x is equal to f at x minus f at b minus f at a by b minus a into x. And in this case, you observe that phi at a will be equal to phi at b. You can solve it, right? So in this, you will apply Rolle's theorem and you will differentiate phi of x and you will get this expression only, right? But I don't believe much into this because if you know the graphical approach, it will be very easy, right? But for knowledge purpose, you should know this, right? Okay. Maybe I should write it over here that phi of A is equal to phi of B, right? Okay. Now let's see a question on LMVT so that the things become more easy. Let's see, is there any question? So verify. Let's start with the 8th question, 8th first part. Rest you will do on your own, right? Okay. Verify LMVT for the following case, right? Okay. We are seeing the 8th first question and it states f at x is equal to x minus 1, x minus 2, x minus 3 for right? Okay. So let's see the question. Fx is equal to this. Okay. So you have to solve, you have to verify Lagrange mean value theorem on it. Okay. Let's see. Just see it is a polynomial again, so it is differentiable and continuous. You don't need to check it, right? And you can just multiply this stuff. You get x square minus 3x plus 2 into x square minus 3. You get x cube minus 3x square plus 2x minus 3x square plus 9x minus 6, right? And just observe that you get x cube minus 6 6 x square. I guess I'm doing the calculations right, I hope, right? Okay. Plus 11x minus 6. If my calculations are wrong at some point, just bear with it because maybe there's chance that while recording the things may not be fine. That is why. So just observe it, and if there's a problem, then please let me know. I will clear it. Okay. So now you find f dash at c. Just differentiate it and then put c, right? You get 3c square minus 12c plus 11. And notice that it will be equal to f at b. What is f at b? F at 4 minus f at 0 by 4 minus 0. This is f at b. This is f at a. This is b. This is a, right? I hope you are understanding it. So you get 3c square minus 12c plus 11 is equal to, when you substitute 4, what do you get? You substitute 4, you get 3 into 2 into 1, you get 6. 6 minus, you put 0, you get negative 1 into negative 2, it will become 2 into negative 3, it will become negative 6. So you get negative 6, right? Divided by 4, which is equal to negative 3, right? I hope you are understanding it. So you get 3c square, you get 3c square minus 12c plus 14 is equal to 0, and you solve for c, you get 12 plus minus root 144 minus 4 into 14 into 3, and you get what expression do you get? I hope that maybe I made a calculation error over here. Yeah, it will be plus 3, right? So that was the issue, sorry. So when you bring 3 over here, you get 8 plus 8 is equal to 0, right? Okay. So now let's see, c is equal to 12 plus minus root, just Brahmagupta formula, right? We sometimes say Brahmagupta formula, we sometimes say Sridharacharyaji's formula, and somewhat like that. 144 minus 4 into 3 into 8 by 6, right? So you get c is equal to 2 plus minus root 144 minus 12. What is 12 into 8? It is equal to 96. And 144, 96, when we subtract, you get simply 48, right? I guess I'm doing the calculations right. Please bear with me if it is wrong, right? And you get so why do I'm writing it? It will be 48, right? By 6. Okay. So c is equal to 2 plus minus 48 by 36, and you can solve it very easily. 4 by 3, you get c is equal to 2 plus minus 2 by root 3, right? And observe that these two quantities, these two values of c is indeed belonging to 0 comma 4. So I had said, as in the case of Rolle's theorem, you can get multiple c's. In the case of LMVT also, you can get multiple c's. So that is why these both c are valid, right? Hence proved. Hence Lagrange mean value theorem is verified. Let's see another question which maybe we can solve. Well, let's do 10th one, right? This is somewhat a new type of question. So we won't do first of all 10th one, we'll do first of all we will do 9th one, right? Because 9th first part and rest you will do on your own, right? I will tell you all 9th first and second part, because these two will make some sort of problem for you, right? So I will discuss these two, right? So in LMVT only, I will tell you all one thing, that you know that f of b minus f at a by b minus a is equal to f dash at c, right? Now use theta h form. You get f at b minus f at a is equal to h into f dash of what was c? C was a plus theta h. A plus theta h, right? So you get f at b is equal to f at a plus h into f dash of a plus theta h, right? And this is very much helpful result. Why? We will see it, right? Let's see. Just remember it. Okay. So let's see. The question number 9th, first part, right? Okay. Let's see. It states that we have to prove that using mean value theorem, that is the Lagrange mean value theorem in this case, you have to prove that, show that this expression, okay. So basically you need to prove that x minus 1 upon x is less than log of x is less than x minus 1. You need to prove it for x greater than 0. Okay, I guess it is greater than 0 or greater than 1. I have to see it. Yeah, it should be greater than 1 only, because in that case log will be right. Okay. greater than 1. Okay, so how do we solve it? Well, let's see. X belongs to closed 1 to x, right? Okay, just assume it. So it means a is equal to 1 and b is equal to x, right? So just use f of x equal to log x. Okay, we have used fx is equal to log x. Okay, so you get fx is equal to log x, right? Okay, so simply you know that f at b is equal to f at a plus h into f dash of a plus theta h hota hai. We know this. Okay, so what does it mean? It means that f at b is equal to f at a plus h into what I am writing. Yeah, what is b? B is equal to x is equal to function at 1 plus h is b minus a. What's the derivative of log x? It will be 1 upon x. You put 1 plus theta into x minus 1, right? 1 plus theta into x minus 1. Basically, you derivate, you get 1 upon x and you put a plus theta h. A is equal to 1 and theta is theta and h is x minus 1, right? Okay. So you get log of x is equal to, what is log of 1? It is simply 0 plus x minus 1 upon 1 plus theta x minus 1, right? Okay. So you get log of x is equal to x minus 1 upon 1 plus theta x minus 1. Okay. And you know that theta belongs to 0 to 1, right? So forcefully set theta is equal to 0 because see, when you forcefully put theta as 0, you get the minimum denominator. And when you get the minimum denominator, you get the maximum value of the function, which means log x will be less than equal to this quantity, because you won't get less than equal to since theta was not in the domain. Since 0 was not in the domain of theta, right? That's why. So this is your first expression. And you put theta as 1, you get the maximum denominator. So you get the minimum value of log x. Just substitute, you will get this expression, right? So combining, you get x minus 1 upon x is this expression, hence proved, right? And just notice, for example, if you would have a negative sign, for example, you would have got x minus 1 by 1 plus, instead of 1 plus, you would having 1 minus theta of x minus 1. So in that case, what would the criteria? In that case, theta is equal to 0 would not yield the maximum but the minimum value, and theta equal to 1 would yield the maximum value, since when you substitute 0 you get the maximum value of the denominator, and when you substitute theta as 1 you get the minimum value of the denominator, right? Okay, just note this, just some logics and everything will be clear, right? So now you will do this question cos x1. I hope that no, you can't do this cos x1 because it is related to Taylor series right now, so we won't worry about it. You will do this fifth one on your own, right? On your own, right? Okay. And the 10th one also you can do it. Let's see how to do 10th one, then we will proceed to our next topic of Cauchy mean value theorem or generalized mean value theorem, right? So you have to prove that the cube root of 28, it lies between 3 plus 1 upon 28 to 3 plus 1 upon 27, right? Okay. So in this case, what you have to do is you have to apply some logics and you will be able to figure out the things, right? So how you will do it, let's see. Okay. So in this case, just you are not given any function. So in this, you have to assume a function. Since it is cube root of something, so you will assume cube root of x as a function, right? This is the basic idea, that you will assume this function only, right? You can't approach using any other function, right? So it is a basic idea. Just it is probably the case you assume the middle function as the function by which you have to work out the expressions, right? Okay. So basically, and you will assume that x goes from 27 to x. Why so? because you see you get a 3 plus some expression, and over here also 3 plus some expression. So which means that it will be better if you use such approach, right? Because if you put f at 27, you will get 3, right? So that's why. Okay, so now just apply LMVT. You get f at x will be equal to f at 27. I am not writing the formula again, you know it, plus x minus 27 into f dash of 27 plus theta into x minus 27, right? Okay, and since you are evaluating it at 28, I will directly substitute it over here, is equal to, what is 27? 28 minus 27, it is equal to 1. And what is the derivative of x cube? As x to the power 1 by 3. X to the power 1 by 3, when you derivate it, you get 1 by 3, x to the power 2 by 3, right? You can solve it. It is very simple result, okay? Plus 1 upon 3 into x plus 27 plus theta into 1, because 28 minus 27 is still 1, raised to power 2 by 3, right? So f at 21, it is equal to cube root of 28 is equal to 3. What is the cube root of 27? It is 3, right? Plus 1 upon 3 into 27 plus theta raised to the power 2 by 3, right? You put theta as 0. Since theta belongs to 0 to 1, you forcefully putting theta as 0 so that you get the minimum denominator and you get the maximum value of this function, of this value. It will be less than 3 plus 1 by 3 into 27 to the power 2 by 3, right? So you get cube root of 28 is less than 3 plus 1 upon 3 into, what is this, cube root of it is 9, and it was 27. So you proved the first expression, right? Okay, so you got cube root of 28 is less than 3 plus 1 upon 27, right? You proved this thing. Okay, now what you have to prove? You have to prove that it is less than 3 plus 1 upon 28. Let's see how you will prove it. Cube root of 28 is equal to 3 plus 1 upon 3 into 27 plus theta raised to the power 1 upon 3, 2 upon 3, right? Now put theta is equal to 1. So you get cube root of 28 is equal to 3 plus 1 upon 3 into root 20. Let me write it clearly. 28 2 by 3, right? And this is the minimum possible value, right? Okay. This is the minimum value, right, of this expression. Okay. But this is not similar to what we are asked. So how we will solve it? Well, let's see. You can write this expression as 27 raised to the power 1 by 3 into 28 raised to the power 2 by 3, right? Or just leave this. You all can simply do it like this. What is the expression asked? It is asked 3 plus 1 upon 28, right? So just compare these two. Well, if it will be greater than, if this expression is greater than, then you can clearly say that cube root 28 will be greater than this expression also, right? Since if A is greater than B and B is greater than C, which implies A will be surely greater than C, right? Okay. So you solve it, you get 1 upon 3 into 28 raised to the power 2 by 3 will be greater than 1 by 28. So you get 28 by 28 raised to the power 2 by 3 will be greater than 3. So you get 28 cube root will be greater than 3, which means 28 will be greater than 27. Yeah, this is correct. Which means this expression is greater than this expression. So it means that cube root of 28 is greater than 3 plus 1 by 28, which implies that cube root of 28, it lies between 3 plus 1 by 28 and 3 plus 1 by 27, right? That's the expression. Okay, done. So let's move on to the Cauchy's mean value theorem now. And yeah, you can solve this expression also. Let's see how we solve it. We will do 11th also. Wait. Let's see. So in this you have to prove that now let's solve the question number 10 and I mean 11. So there's some disturbance. Now it's fine. So we had to prove that sine of, let's see what was the question, I don't remember. So let's see, sine of x minus sine of y is less than equal to x minus y. Okay, so you need to prove this and constantly prove this experiment. Okay, we will see it. Sine of x minus sine of y is this quantity, right? Okay, so what we can do is now, what you can do is that you can assume fx as sine of x, right? Simply assume this expression, right? Now apply Lagrange theorem, Lagrange mean value theorem, sorry. F at b minus f at a upon b minus a, here b is equal to y, a is equal to x, right? Or you can say opposite also, x and y, since whatever the case is, right? So f at x minus f at y by x minus y is equal to f dash at c, right? Okay. So you get sine of x minus sine of y is equal to, what's the derivative of sine x? It will be equal to cos x, right? It was equal to x minus y into cos of c. Just take mod both sides as given the question, and this is the thing. And notice that so we get sine of x minus sine of y is equal to x minus y into cos of c. Well, let's see. Cos of c, it lies between negative 1 to 1, and notice that the mod will lie between 0 to 1, right? Okay. So just substitute this expression and you get that sine of x minus sine of y will be less than equal to x minus y, since the maximum value of cos c is 1, right? So you can just say this thing, right? Okay. So I hope you understood that how we will solve it. And the consequent part, it states that consequently prove that this expression is greater than this. You can prove it using LMVT, right? You don't need to worry about it. Okay. Again, you can use like we did in this case, right? Just apply that thing. It is this question. Okay. So now I don't think so that there's any question left. So let's move on to Cauchy's mean value theorem. Okay. So just a minute. I hope there is no disturbance, right? Cauchy mean value theorem. What is it? For example, it is applicable for two functions, right? For example, if you have two function fx and gx, right? So in that case, and you are given that they both are continuous and differentiable in a to b, right? Open a to b is they are continuous, and in closed and in open a to b they are differentiable, right? So in such case, right? So in such case, there exists a c belonging to a comma b such that f dash at c by g dash of c is equal to f at b minus f at a by g at b minus g at a, right? And notice that in this case that g dash of x should not be equal to 0, right? Because if it will be 0, then the result will be undefined, right? It is simple, right? How do you approach it graphically? First we will see graphical approach, and then we will move on to the approach that we generally use, like some sort of rote learning kind of thing, right? And after that I will tell you something really amazing result, and which will blow your mind, really. I'm not joking, it is true. You can just remember one formula, and from that you can derive any formula in this chapter, right? It will be really amazing. Let's see how. But first of all, let's see it graphically. Graphically it will be like this, right? Okay, this is x, this is your y. Okay, so just see, this is your a and this is your b, right? And suppose this is a, this is this function, this is this function, right? And suppose this is like this. Okay, just assume for the time being this is a and b, right? You are joining these two, right? Okay, so what is this? Well, you are using x is equal to g of t and y is equal to f at t, right? Why? You will see it later, okay? And t belongs to closed a to b, right? Okay, okay. So what's next? Well, let's see. Well, what will be a? A will be g of a comma g of comma f of a, right? And simply this will be f of g of b comma f of b, right? Okay, this will be expression. Okay. So when you join these two expressions, what you get? The slope of AB, it will be equal to G, it will be equal to the F at B minus F at A by G at B minus G at A, right? Is this expression correct? Okay. So similarly, as you did in the Lagrange theorem, you will find a slope, a point on the graph such that the tangent to the graph to that point is parallel to AB, right? So suppose this is the point C, right? Okay. So what is it? You get dy by dx at x is equal to C. You get dy by dt by dx by dt. You get f dash of t by g dash of t at t is equal to C. You get f dash at C by g dash at C is equal to f at b minus f at a by g at b minus g at a, right? So that is the expression. So this is a graphical way to prove this thing. And if you are asked mathematically, then in that case you can apply again phi function f at x minus f at b minus f at b minus f at a by g at b minus g at a into g of x minus g of a, right? So why you are doing this? Since in this case you can apply again Rolle's theorem, right? But I am not much into the favor of this, since it is more sort of rote learning kind, because there are very less logics for this, okay? So I prefer the graphical approach more, right? Okay. So I had said that I will tell you one formula, and using that you can approach all the three formulae very easily. So let's see it. Well, you know Cauchy mean value theorem. It states that f at b minus f at a upon g at b minus g at a is equal to f dash at c by g dash at c. So now this is Cauchy's mean value theorem, right? So in this, what you can do is you can assume gx as a linear function x, right? Okay. So when you assume this, you get f at b minus f at a upon, when you substitute it as a linear function, which implies g at b will be equal to b and g at a will be equal to a, right? And what's the derivative of g dash x? It will be equal to 1, right? So you get b minus a is equal to f dash at c, right? So you get lmvt, right? Okay. And you substitute fa equal to fb, you get f dash of c is equal to 0, since fb minus fa will be 0, right? So what you have done is that you have approached from CMVT, you approach to LMVT, and you approach to Rolle's mean value theorem, right? Or Rolle's theorem, right? Simply Rolle's theorem, right? Rolle's, right? In this, to approach this, you substitute g of x is equal to x, and in this you substitute fa equal to fb. So you just need to remember that f at b minus f at a upon g of b minus g at a is equal to simply f dash at c by g dash of c, and in this you substitute g of x as x, you approach to lmvt, and then you substitute fa equal to fb, you approach to Rolle's. It's so simple. Just remember one formula and you can approach all the three methods. So I hope you understood this. So let's see some question on this also, and then we will move on to the next expression. I mean the next topic of Taylor's theorem. So let's see the questions of Cauchy mean value theorem also, and then we will move to the next topic. Let's see the 12th first part, right? Let me change the color. So you get this expression, you have to solve this thing, right? So let's see how do we solve it, and let's see. Okay, 12th first part, and in this case So let's see, in this case, we are given that fx is equal to square root of x, I guess. Let's see what was given. Fx is equal to square root of x and gx is equal to 1 upon root x. Okay, let's see. Fx is equal to root x and gx is equal to 1 by root x, and in the interval 1 to 3, right? This is the question. So it is simple, and it is very simple actually. Just what you can do is f of 3 minus f at 1 upon g at 3 minus g at 1. You have to apply Cauchy mean method, nothing else. Okay, f dash at c by g dash of c. Notice this is continuous in the interval 1 to 3, right? And is a differentiable also, right? You don't need to check, right? Even if you check, you get the same result. Okay, so you get root 3 minus root 1 upon root 3 minus 1 is equal to f dash of c. It is equal to 1 by 2 root x into negative 2 x to the power 3 by 2, right? You can solve it, right? It is simple, right? I don't think so that I need to tell this. It will be equal to root 3 into root 3 minus 1 by 1 minus root 3 is equal to this, and this cancels, and you get negative x, right? You get this expression. So you get x is equal to root 3, right? And obviously x is equal to c, so c is equal to root 3, and yeah, it is correct. You get the c as in between this expression, right? I don't know, I don't remember I wrote over there or not. That c should belong to, yeah, it is correct. Many people write it like this also. The c, they write it like that epsilon. So that is also fine. It is just a number, nothing else. Okay. Okay. So now let's see what else can be done. Well, almost we have done all the parts. Now we are just left with the Taylor's theorem. Let's do the Taylor's theorem also, and then we will do some questions, and then we'll wind up. Okay. So I don't think so I have a space over there, so I will write Taylor's theorem over here, right? So let me create a page. I need 2 pages for that, 2 to 3. So let me write over here Taylor's theorem, right? And okay, now it's fine. Well, coming to the next topic of Taylor's theorem. It is, I guess, the 4th topic, Taylor's theorem, or Taylor's expansion, or Taylor's formula, whatever you want to say. And it is simplest generalization of MVT, right? Somewhat like that. So what we will do in this is we will assume a function that a function fx such that it is n plus 1 at time differentiable. Don't ask me right now why, you will see it later. Okay, and now you will define a polynomial. Pn of x, right? And it will be such that, means it is n, so it will be nth degree obviously, and you have defined it such that Pn of x naught is equal to f at x naught is equal, and Pn of ith derivative of x naught is equal to f of ith derivative of x naught, right? This is the case where I can be any value, right? Okay, so you are basically defining it like that x naught is some value, right? Okay, so just say Pn of x is equal to c naught, a general way to write a polynomial. That's it. Okay, till Cnx minus x naught to the power n, right? This is the case. Okay, that is the case now. Okay, and since you know this thing, right? Okay, so now you'll solve for the coefficients. Let's see how you will solve for coefficients. Let's take derivative of p of x. You get, I am not writing n right now because it takes lots of space. Let's c1 into c1 plus 2 c2 into x minus x naught till n cn x minus x naught to the power n minus 1, right? And notice that if you take the nth derivative, you get n factorial, since you get n, and you get n minus 1 into n minus 2 until 3 into 2 into 1, right? n factorial into x minus x naught to the power 0, right? You get this thing? So you get Pn of x is equal to n factorial into Cn, right? And notice that Pn of x is equal to f of nth derivative of x naught, right? That's correct. Okay, you just substitute x naught over here, right? Simply, okay? So you get Cn is equal to f of nth derivative at x naught by n factorial, right? So from this you get Ci is equal to f of ith derivative of x naught by I factorial, right? This is the case. Okay. So you get Pn of x is equal to f at x naught plus f dash of x naught by 1 factorial into x minus x naught till f of nth derivative of x naught by n factorial into x minus x naught to the power n, right? And this is a polynomial, right? So basically you are converting a polynomial in terms of a function, but we have to convert a function in terms of a polynomial, so that is why we have to interchange somewhat, right? That is what is the main idea of Taylor's theorem? It is used to convert a function in terms of a polynomial, right? But here what is happening is that you are converting a polynomial to in terms of functions, right? And that is not the case which you have to do, right? So in this case we will define a remainder term. Let's see what is its significance. Rn of x is equal to fx minus p of x, right? Just assume for the timing, right? Okay, just assume. And you are defining g of x is equal to x minus x naught raised to the power n minus 1, right? Just for the time being, assume it, right? Why we are assuming? You will understand it later, okay? And in this you are assuming that g of k at x naught will be equal to 0, right? For k is equal to suppose 0, 1 till n, right? Whatever be the case. Since it is simple, when you derivate this term and substitute x naught, you get 0, right? That's the case, okay? So, and now observe that g of n plus 1 of x naught, it will be equal to n plus 1, right? You can observe it, okay? It is very basic idea, right? N plus 1 factorial, sorry, okay? N plus 1 factorial, okay? Now apply the Cauchy mean value theorem, right? Okay. So when you apply Cauchy mean value theorem, what you get? R of x minus r at x naught by g of x minus g of x naught is equal to r of x by g of x is equal to r dash of x, r dash of c by g dash of c, right? Okay, is this fine? Okay, c1 you can say right over here. And why it is equal to, why where is x naught disappeared? Well, let's see. When you substitute x naught over here, you get r of x naught is equal to f at x naught minus p of x naught. But we had proved that p of x naught is equal to fx x naught. So it means fx x naught minus p at x naught, it will be equal to 0, right? And when you substitute x naught over here, you again get a 0, right? I hope you are understanding that what I am saying, right? Okay. Oh, and I am sorry, it will be equal to n plus 1, right? Over here. G of x is equal to n plus 1, okay? I hope you are getting this, okay? And why I have assumed it? Well, it's just an assumption, and you will see it later, okay? So r of x by g of x, you assume r dash of c1 by g dash of c1 is equal to r double dash of c2, g double dash of c2, and you can go up to r of n plus 1 at derivative of c n plus 1 by g of n plus 1 of c plus n plus 1, right? That is the case, okay? I hope you understanding it, okay? What is Rn? Well, we will see it. That is what we need to solve. It is equal to x minus x naught to the power n plus 1, right? That is the case. Was the derivative of n plus 1 at times the derivative of that quantity? Well, let's see. Of this, you can say it's psi And what's the derivative of this expression n plus 1 at time? Well, you calculated it is equal to n plus 1 factorial. N plus 1 factorial. How? Just see, you just differentiate, you get n plus 1, you get then n. So you go till n plus 1, that it will become x minus x naught to the power 0. So it will be independent of the value of x. So you get n plus 1 factorial, right? I hope you are understanding it. Okay. If you don't, then please comment me and I will tell you all. Okay. So now observe that r is equal to f minus p. It was this. So r of n plus 1 is equal to f of n plus 1 at derivative of x minus p of n plus 1 at derivative of x. Notice that it was a polynomial of nth degree. So for example, if you have x square and you derivate it 3 times, you get a 0. So simply it will be also 0. Since it is a nth degree polynomial and you are derivating it n times, right? Okay. And what is f of n plus 1 of x, right? You get this expression, right? Okay. Now let's see, it was psi, so let's write psi only. Okay, it will be better. So you get r of x upon x minus x naught raised to the power n plus 1 is equal to f of n plus 1 at derivative of psi by n plus 1 factorial. So you get Rn is equal to x minus x naught raised to the power n plus 1 upon n plus 1 factorial into f of n plus 1 at derivative of psi. And you can write psi in terms of theta x, but not right now. We will see it later. Okay. So you get this expression, right? Okay. Now this is Lagrange remainder form. And it is like this: n plus 1 by n plus 1 factorial into f of n plus 1 at derivative of psi. And you can also write it like this: x minus x naught raised to the power n plus 1 by x plus 1 factorial by n plus 1 factorial f of n plus 1 at derivative of x naught plus theta into x minus x naught, right? You can write it like this. So what is the significance of this remainder? Well, it is used to convert. It is earlier when you were solving, you are getting the polynomial in terms of a function, but you wanted function in terms of a polynomial. So this remainder will convert that polynomial to a function, right? So you will get a function in terms of a polynomial, and that will be very much helpful, right? So just write px was equal to, let me see what I had written. It was equal to fx minus rx, right? You can solve it. Fx minus rx, right? This is correct. Okay. And now you know that px was equal to fx naught plus x minus x naught into f dash of x naught by 1 factorial till f of n derivative of x naught by n factorial into x minus x naught to the power n, right? Now you can write pn as fx minus rx, and you can bring that rx over here plus rx, and you can write that rx as this thing plus x minus x naught, or f of n plus 1 at derivative of this thing. Well, I don't think so that it is need to be written, but let's write plus theta into x minus x naught by n plus 1 factorial into x minus x naught to the power n plus 1, right? My writing is not good over here, but I hope you understood that it is simply rx. Rx is equal to f of n plus 1 at derivative of this expression, that what I had written over here, right? Okay, we will see some questions on it and then we'll wind up. Okay, and just see what is Maclaurin series. Well, Maclaurin in this case, you just substitute x naught is equal to 0, and as limit x tends towards 0, x tends towards infinity of rx, it should tends towards 0. Then in this case, the Taylor's tends towards Maclaurin. Okay, that's the thing. Okay, I hope you understood. Okay, now let's see a question on it and then we will wind up. Okay, well, let's see the question. The question is, let's see the 16th one, right? 16th, by Taylor's theorem prove that this thing. We will just see the half part. This thing. Okay, or this is bit simpler, you can do it on your own. We will see this one because this is more likely, right, to come or some sort like that. So we will see this part, right? Okay, so let's see the question. I hope I have space. Yeah, so let's see. It was, I guess, question number 16 and you have to prove x minus what was that, let me see, x yeah, x minus x square by 2, x minus x square by 2 is less than this quantity, and okay, x minus x square by 2 is less than log of x is less than log of 1 plus x is less than x, right? This is the expression, I guess. Okay, yeah, this is the expression for x is greater than 0. Okay, for x greater than 0, right? Okay, so that is the basic idea, right? So how do we check it? Well, you apply fx is equal to log x, right? Log 1 plus x, and now you can f at 0, you get a log of 1, you get 0, right? Okay, so that is the thing. Okay, now what you can do is that you can apply the Taylor's now. F of x is equal to f at 0 plus x minus 0, since that is x naught is 0 over here. See, this is the x naught, x belongs to 0 to x, right? So this is the x naught and this is the x, right? So this is this quantity f dash at 0 by 1 factorial plus, and notice that since it is going till x square, right? Since it is going till x square, so I don't think so that we need to work much, right? So let's see, x minus x naught whole square by 2 factorial into f double dash of a plus theta h, you can apply, right? A plus theta h, it is simply that quantity, it is simply the remainder, right? That is the thing. So fx is equal to what is log of 1? It is 1 plus x by what is the derivative of log this? This will be 1 plus x, right? I hope you understood, right? Okay. And we are evaluating it at 0 plus 0, okay? Plus x square by 2 factorial. What is the derivative of 1 by x? It is equal to negative 1 upon x square, right? So negative, wait a minute. Negative 1 upon x plus 1 whole square. Evaluated x is equal to what is a? A is equal to 0, theta x minus 0, right? Since h is equal to x minus x naught, right? Okay. So fx is equal to x minus x square by 2 factorial into 1 plus theta x whole square, right? It is equal to log x, right? Okay. Now put theta as 0, you get the x minus x square by 2 factorial expression, and notice that it is the least value, it is the minimum first value of log x. Why? Because indeed you converted a denominator to minimum, so you get the maximum expression of x square by 2 factorial, but it is a negative sign, so you are subtracting a maximum value from something, you will get the minimum value of this expression. And when you substitute and obviously you can see that since you're subtracting something in this case, so let's apply again the Taylor's theorem. So you prove this, now apply again Taylor's theorem. Fx is equal to f at 0 plus x minus 0 upon 1 factorial into f dash of a plus theta h, right? Just apply. This is indeed LMVT only. LMVT is a general case. Sorry, LMVT is a special case of Taylor's. You can say like that. So f of x is equal to x into 1 plus theta x, right? This you will get obviously. So when you substitute theta as 0, you get the minimum value. So you get the minimum value, you get log x, minimum value of the denominator, so you get the maximum value of the expression. Log x will be less than x. So you end up getting x minus x square by 2 factorial is less than log x, and this is less than x, right? I hope you understood it, right? Rest you can do on your own, okay? So what's the next thing which you can do? Let's see. Well, let's do one more question and then we'll wind up, okay? We've done this. You will solve this on your own with the same logic. Now we will do this one and then we will wind up, okay? You have to find log of x at about point A, okay? Okay. Let's, I need one more page. It was, I guess, 17 question. Fx is equal to log x, and it was still fourth, right? So means you have to go till fourth derivative, right? Okay, that's is something at about a is equal to 1. Okay, let's see. So what you get is that you find first derivative, you get 1 upon x. You find the second derivative, you get negative 1 upon x square. Find the third, you get negative 2 upon x cube. You find the fourth, you get negative 6 by x to the power 4, right? Somewhat like that. Okay. And now you get f at x can be written as f at a plus h, right? F at, or simply x naught plus this x naught plus x minus x naught, right? Like this. So you get f at 1 plus x minus x minus 1, right? So simply just open it. F at 1 plus x minus 1 upon 1 factorial into f dash of 1 plus x minus 1 by 2 factorial in this whole square f double dash of 2 plus x minus 1 whole square whole cube by 3 factorial to f triple dash of 1, it will be 1, sorry, plus since you are going till the fourth expression, so you will simply x minus 1 to the power 4 by 4 factorial into f of fourth derivative at 1, right? Simply just do it like this, okay? So what is the f at 1? Log of 1 is 0, so you get this 0 plus x minus 1 by 1 you substitute, you get 1, and when you substitute 1 over here, you get negative 1. So you get negative x minus 1 whole square by 2 factorial, and when you substitute over here negative, you get over here third, it will become positive, it will become plus 2 by 1 into x minus 1 whole cube, right? I hope if there is some calculation error, you will figure it out, and I'm just telling all the method that how you can do it, okay? Maybe I make some calculation error, so kindly bear with it. To the power 4 upon 4 factorial, right? Okay. So you get f at x is equal to this thing, x minus 1 minus x minus 1 whole square by 2 plus x minus 1 whole cube by 6 by 3 actually minus 4 into 6 x minus 1 to the power 4 by 4, right? Now put 1.1, you get 0.1 plus minus 0.1 whole square by 2 plus 0.1 whole cube by 3 minus 0.1 whole to the power 4 upon 4, and you can solve it, right? So this is how you solve about when you are asked to find about a particular value, right? So I hope I have covered everything which is possible in this chapter, and I hope that it would help you all. So thanks a lot for watching it, and take care, bye bye, and please do one thing, and please do subscribe my channel, and please support me. Thanks a lot, bye bye, take care.
Hello everyone, this is Aditya, and today we'll do a one shot of Engineering Mathematics 1, and we will do all the concepts and questions which are required for midterm examinations. And I'm really sorry, I had said that I would upload the video yesterday only, but I could not make it because of my health issues. I was not well since many days, and so I'm recording today. So I hope you all understand it, and please do support my channel. Please subscribe, like, share, and subscribe. And I will try to speak in English most of the time because, or maybe I will be bilingual so that everyone can understand the language, right? Since there are many people from South India also, and some are, and many are from North India, so I will try to be bilingual so everyone can understand it. So here are series of questions which we'll discuss. It is the functions of single variable, and then we will have functions in several variables. We have lots of questions, so we will discuss not all of them, we will discuss most of them, but not all. We will discuss the important ones. So let's see which one is important for us. Let me change the color of the pen to yellow so that it is easier for me to mark. Okay. So we see the first question: verify Rolle's theorem for the following functions, like this, and this is a very simple type of question. You all can do it, right? Now let's see the second type of question: use Rolle's theorem to prove that this equation. Let's do the second one, and then you will try the third one on your own, right? I am doing the second one, right? Okay, so let's do the second one. So what is the function? We are given that f at x is equal to x is 5x cube minus 2x square, 5x cube minus, let me see, minus 2x square. What is the next term? Plus x minus 6. So what the question states, it states that you use Rolle's theorem to prove that the equation cannot have more than one real root. Okay. So let's just assume that it has two real roots, alpha and beta, right? Let's assume it, right? It means we are assuming that there are more than one real root, right? So it means since it is a polynomial, since fx is a polynomial, which means it is continuous in the domain alpha to beta, in the closed domain, and it is differentiable in the open alpha to beta, right? Is it correct? Yeah, it makes sense. And you also know that f at alpha will be equal to f at beta will be equal to 0. And what is this? This is the condition for Rolle's theorem, right? So there must exist a c such that f dash c is equal to 0, right? So let's see the expression. The expression is, let me change the color of the pen to this, right? So we have f at x is equal to 5x cube minus 2x square, 2x square plus x minus 6. ये हम लोग को दे रखा है, right? We all know it. So what we will do, we will now differentiate the expression, and what we get, f dash at x is equal to 15x square minus 4x plus 1, and now substitute c. F dash at c is equal to 15c square minus 4c plus 1, and it must be equal to 0. But notice that the discriminant of this expression, or this quadratic, is minus 4 whole square minus 4 into 15 into 1, which is less than 0, which means that the discriminant is less than 0, which means that c won't have any real value, right? So it means there exists no c between, there exists, and that c does not belong to alpha to beta, right? Means there exists no such c, right? So it means that there can be either 0 or 1 real root, right? Since we had assumed that there are 2 or more real roots, and we got a contradiction, which means there can be either 0 or 1 real root. So how do we check for 1 real root? Well, the function was fx is equal to 5x cube minus 2x square plus x minus 6, right? This was the expression, I guess. Yeah. So now put f at 1, you get f at 0, you get negative 6, right? You put f at 2, suppose, you get 5 into 8 minus 2 into 4 plus 2 minus 6, and it is obviously greater than 0, which means f at 0 is less than 0 and f at 2 is greater than 0, which means there must exist a point such that the function will go like this. For some value it will be negative and for some value it will be positive. It means there will exist a point, मतलब एक ऐसा point exist करेगा जहाँ पर ये function कहीं ना कहीं x axis को cut करेगा, right, in the real domain, right? Hence there exists one real root, right? Okay, now move on to the next question. Sorry, you will do the third one on your own. Prove that between any two real roots of this there exists at least one. Yeah, it is simply the Rolle's theorem. In this, what you will do is you can you will take a domain. For example, it will be from, you can take from negative pi by 2 to pi by 2. In that you can apply the Rolle's theorem. The fourth one, you try it on your own. If you don't get the answer, you can comment me, right? And I will try to make a separate video for it, or I will explain it later. And let me see if I get a similar question. Prove that between two real roots of this there exists at least. Actually, let's do the fifth one. I will do the fifth one and you will try the fourth one, right? So the what is the function? Function is e to the power x into sine x plus 1, and we have to prove that there exists at least one real root of tan x plus 1. Okay, let's see. So we are doing the fifth question now, and what does it state? Let me change the color of the pen, and let's see, let's keep it as white. So we are given f at x is equal to e to the power x into sine x plus 1. We are given this expression. So now what we are given that between any true that between this there exists at least one real root tan x plus 1. Okay. Okay. So what you can do is you can you see that if you go from you can take the domain as 0 to pi. It's totally upon you, whatever domain you want you can take, right? So notice that e to the power x into sine x, e to the power x is a continuous function, sine x is a continuous function, so their product is also a continuous function, right? E to the power x is differentiable, sine x is also differentiable, so their product is also differentiable, which means it is both continuous and differentiable, and f at 0 is equal to f at pi is equal to 1, which means we can apply the Rolle's theorem and you get f dash x is equal to, what is the expression, e to the power x sine x plus e to the power x tan x, sorry, e to the power x cos x, right? And substitute c, you get e to the power c into sine of c plus e to the power c into tan into cos of c, it is cos of c is equal to 0, which means tan c plus 1 is equal to 0. So you get that c is equal to negative, you get c is equal to 3 pi by 4, and it is and it lies between 0 to pi, right? Is it correct? Yeah. Which means that the question there is at least one real root, so there is a real root of 3 pi by 2, hence so we have got the answer. That is the key. Okay, now moving on to the next question. If everything continuous, then prove that there is, you will do it on your own. It is a simple question. If you all are not able to do it, then you can comment me, I will guide how to do. Let f and g of function continuous, this is also like that. Let's move on to some sort of question which are probable to come, right? For example, we can try doing it and what we can do is you can do ninth first question, right? Let's do the first question of wait, let me change the color. You can do this one, and we are going to do this, and let's see. I think there is some sort of noise over here, don't worry. And let's see the ninth first question, and it is x minus 1 upon x is less than equal to what expression? Log of x. It is log of x, it is less than x minus 1 for x greater than 1. Okay, less than x minus 1 for x greater than 1. Okay, let's do it. Okay, so what we get is that You can assume the middle function as log x, right? And now what you can do is you can simply use the LMVT, Lagrange mean value theorem. You all know it, right? You know the Rolle's theorem. Well, we will discuss it. Okay, let's see first of all Rolle's theorem. What is it? Rolle's theorem. It states that if a function is continuous, well, I discussed this thing, right? Now the Lagrange theorem, you all know it. You all can refer to my previous lectures, and I will here just give a brief outlook that what is it actually. So you all can refer my previous videos, and it is just 25 minutes. You all can refer it, because if I will explain the concept, means I will give a brief intro over here, means just uh, not going much deeper into it, but if you want to understand it deeply, you can check out my previous videos. I will just here show how we apply the things, right? Because we have very less time, and we have to cover lots of things, right? So I hope you understand it. So now you use the Lagrange mean value theorem. Fx is equal to f at a plus h into f dash of a plus theta h, and you get f at x is equal to f at 1 plus x minus 1 into, what is the derivative of log x? It is simply 1 upon x, and we substitute 1 plus theta into x minus 1, right? I hope you understand it. How did I get it? Let's see once again. Fx is equal to log x, which means f dash x is equal to 1 upon x. We substitute x as a plus theta h, right? I just did that. What is f at 1? F at 1 is log of 1, and what is log of 1? It is simply 0. So we get 0 plus x minus 1 by 1 plus theta into x minus 1, and you get f at x is equal to x minus 1 by 1 plus theta x minus 1 is equal to log of x, right? अच्छा, okay. तो अब क्या करना है? Let's see. Well, put theta as 0, and since when you put theta as 0, you get the minimum denominator, which means you are getting the maximum value of log x. So you get log of x is less than, when you substitute this, you get x minus 1. And when you substitute theta as 1, you get the minimum value, because you get the maximum denominator. So this expression will be greater than x minus 1 by x, right? Substitute, this is the condition when you put theta as 1, and this is the condition when you put theta as 0, right? For x greater than 1, hence proved, right? Okay, let's move on to the next question, and let's see that if there is some sort of nice question. You all can practice this, and oh, let's do it using Taylor's theorem, right? E to the power x is greater than, let's do a question on Taylor's also. Ninth, what was that? 9th second or third? Let me see it. It was 9th second part actually, right? Let's see. 9th second part, let me change the color of the pen, and let me take it as like this, right? F at x is equal to e to the power x, right? I have assumed it. Okay, now what? Oh, what's the issue? Sorry, there's some issue. Okay, yeah, now it's, so f at x is equal to e to the power x. I'd assumed this, right? Ignore this expression. So what I get, fx is equal to e to the power x. So what we are going to do now, we will write its Taylor expression. What we get, f dash at x is equal to e to the power x, f double dash of e to the power x, of x is equal to e to the power x, right? You all know it. And since it is still x square only, which means we have to go till h square term, right? So you write f at x is equal to f at a plus h into f dash of a plus h square by 2 factorial into double dash of a plus theta h, right? If you don't know Taylor series, you can watch my previous videos. Here I'm just telling the formula, right? And its application. So e to the power x is equal to, you substitute a as 0, since x is belonging from 0 to x, right? As per the question. So you get e to the power 0 plus x minus 0, that is x only, into e to the power 0 plus h, that is the x square by 2 factorial, into e to the power theta x, right? So you get e to the power x is equal to 1 plus x square by 2 factorial into e to the power theta x. Just put theta as 0, and notice that theta is from 0 to 1, right? and see that 0 is not in the domain of theta also. So we are forcefully setting a value of theta less than its domain even. So that is why we will get a expression that will be less than that term, right? So you get e to the power x is greater than 1 plus x square by 2, right? You get this. In fact, you can put equal to also, it don't matter, right? Hence proved, right? Now let's see the next question. This you will do on your own. We have done this one. This you will do on your own. This one also. It is a simple sort of thing. Let's do this one. This might be important. Oh, let me change this thing first of all. I need some more pages. So let me change it. Yeah, now I think it will work. Yeah. Now we are going to do which question number was that? It is already a 16-minute video and still we are on several single variables. I need to complete the lecture within 1 or 1.5 hour because that will only help. In the end, I will tell all the concepts also. That is no issue. But well, first of all, we have to do question practice because I think that you all must have watched the lectures so that there will be no issue, right? Hello, I'm really sorry there was some disturbance and now it's everything fine. So I'm going to discuss the 10th question now. And what is the question? It states that we have to prove this expression that root 28, it lies between 3 plus 1 by 28 and 3 plus 1 by 27. Okay, we need to prove it. So how we will prove it, right? Sorry, it is the cube root. Sorry. It is the cube root of this quantity. Okay, let's see. So we can take a function f at x is equal to cube root of x. So we are using cube root of x. So what you can do is you can apply LMVT again and you get f dash at x, and yeah, you can assume a as 27 since we are given 3 plus some quantity, which means 3 is the cube root of 27. So you will assume a as 27. It will be easier for evaluation, right? And it will give accurate result also. That is the key. F at a plus h into f dash of a plus theta h, right? Sorry, it is this is f only, right? And you get f at 27 plus what is you are evaluating at 28, so you get 20 b minus a, that is h is equal to b minus a, and we substitute b as 28 and a as 27. What is the derivative of this quantity? You will get let's see, it will 27 plus theta into 27 minus 1 is still 1, right? 28 minus 7, sorry, 28 minus 27 is 1, right? So that is the key, and you substitute over a cube root of 27 plus what is the derivative of cube root of this expression? You get 1 by 3 of the quantity x to the power 2 by 3 evaluated at x is equal to 27 plus theta, right? Okay, you get 3 plus 1 upon 3 into 27 plus theta to the power 2 by 3, right? This is the expression, and this is equal to the cube root of 28, right? Okay, now put theta as 0. When you put theta as 0, what do you get? You get the minimum denominator, and since you are getting the minimum denominator, you will get the maximum value of cube root of 28. And notice that if you put theta as 20 at 0, you get 27 raised by 2 by 3, which is equal to 9, right? And right, so you get cube root of 28 is less than 3 plus 1 upon 3 into 9, that is 27, right? Oh, 27, right? So you have proved the first expression. Now put theta as 1. What do you get? You get 3 plus sorry, there was some issue. 3 plus, let me change it if it is changeable. Yeah, 3 plus 1 by what is 27 plus 1, it will be 3 into 28 raised to the power 2 by 3, right? And now we have to check what, according to the question, it states that we have to check for 3 plus 1 by 28. So either you can evaluate using a calculator or whatever you want. but you know that it will be smaller than cube root of 28, right? When theta is equal to 1. When you substitute theta as 1, you get the maximum value of the expression, and when you put theta as 1, you get the maximum denominator, so you get the minimum value, right? So now we have to check, compare 3 plus 1 by 3 into 28 to the power 2 by 3, 2 by 3, and we have to check if it's greater than 3 plus 1 by 28 or not. If it will be greater than, then it will be very easy task, right? So you can just cancel this expression and you get 1 by 3 is less than 28 to the power 2 by 3 by 28, which means 28 is greater than 3 into 28 to the power 2 by 3, right? Is it correct? And you bring it, you get 28 cube root is less than 23, which means cube root of 28 is less than cube root of 27. I hope you all know this basic maths, right? So it means this is the correct expression, so this is correct, which means 3 plus 1 by 3 into 28 to the power 2 by 3 is less than 3 plus 1 by cube root of 28, and this expression is less than 3 plus 1 by 28, which means 3 plus 1 by 28 is less than 3 cube root of 28 and is less than 3, and this expression is less than 3 plus 1 by 27, and you get this, right? I hope you understood this question, right? And now moving on to the next question. This is still similar kind of question. You all can do this one, you all can solve this using Taylor's. I have told how to use the Taylor series, you all know it, you know the expression. If you have to evaluate, you just use the Taylor's theorem and just put 1.1. okay, so I hope you all can do this sheet now, and if you have any doubt, you can comment me in the section, right, in the comment section, right? So now moving on to the next part of the video, that is functions in several variables. So how do we evaluate such kind of problems? So you all know epsilon delta method and all. I will make you all practice those type of questions and somewhat like that, and then what we will do is so what I was saying that we will start with functions several variables, and in this we will discuss all the important topics related to whatever can come in that, like in the single variable I'll discuss the Rolle's theorem, the Lagrange mean value theorem, which was very important, and then we discussed Taylor's theorem, which is also very important. That is the basic building blocks of that chapter, right? Most of the things are discussed, and rest is your practice, how you do it, right? And if you have any doubt, you can comment me in the okay? And now let's see this question, right? So function several variables, right? You all know this, you all can refer my previous lectures also for that, and some topics I could not cover in my those lecture, and I will cover it over here, right? So I hope you all will understand everything. So let's get started now with the first question. Show that the limit do not exist. We have to show that the limits does not exist. So to show that the limit does not exist, you have to choose two paths such that from both the paths you get different limits, right? For example, limit as x comma y tends to 0 comma 0 of the quantity 2xy by x square plus y square. Suppose I use y is equal to mx path, right? And this indeed is composed of infinitely many paths, because you change the arbitrary, since m is an arbitrary variable, so you can vary it according to your choices. So you get infinite paths that will pass through origin, right? And notice that this satisfies 0 is equal to 0, means at y is equal to 0 and x is equal to 0, this expression is satisfying, this path is correct. So you just substitute this, you get limit as x comma y tends towards 0 comma 0 of 2m x square by x square plus m square x square, and is 2m by 1 plus m square. Notice that it is dependent upon the arbitrary variable m, so it is a path dependent limit, so the limit does not exist. Limit does not exist, right? And now let's see the second question. The second question you substitute, you will do on your own. Just substitute that x is equal to y cube. Use this path and you will get the answer. And in this question, how you'll do, you will use this kind of new type of question, in that you can use y is equal to, let me change the ink, and y is equal to x minus mx to the power 3, right? You will use this expression, you will get this thing, right? So now moving on to the next slide. Now these are some of the important questions. So we have to show that the functions are continuous. You will do this question on your own and this one on your own. I will discuss this one and this one, right? So let's do the second part. And second part, it states, and what you have to show that for showing the continuity, you all know the condition that the limit at f at x naught comma y naught should be defined, and what is the first condition? That that function should be defined at fx naught comma y naught, and the limit should be defined at x naught comma y naught, and limit as f of x comma y tends towards x naught comma y naught, it should be equal to fx naught comma y naught. I hope you all know this. If you don't know, you can refer to my previous lectures, right? Because if time permits, I will tell everything in the end, else you all can refer my previous lectures. It will just take 1 or 2 hours at max, after lecture or after these question practice, right? So now let's do that. F at x comma y is equal to, so we are given that fxy is equal to xy by root x square plus y square, right? So we have to check for the continuity, which means that limit as x comma y tending towards 0 comma 0 of this fx comma y should be equal to f at 0 comma 0, and that is given as 0. So we have to check whether this limit is a true limit, is a valid limit or not. So how do we check it? Let's see. I hope that I need one more slide over here. Let me introduce one. Yeah, now it will work. Let me change it now. Yeah. So you get that limit as x comma y tends to 0 comma 0, not this. Now you will use the epsilon delta approach. Epsilon delta approach or method, whatever you wanna say. You get at fx comma y minus limit is less than epsilon. What is the limit? Limit is 0. And what is the function? Xy by root x square plus y square is less than epsilon. And notice that since x minus y whole square is always greater than equal to 0, since it is the positive value, which means x square plus y square minus 2xy is always greater than equal to 0, which means x square plus y square is greater than equal to 2xy, right? You understand it or not? Yeah, it is correct. And xy, 2xy is indeed greater than xy, right? Is greater than xy. So x square plus y square is strictly, not strictly, it can be x and y, right? So you can use this expression. You get xy by root x square plus y square is less than x square plus y square by root x square plus y square, which is equal to root x square plus y square is less than epsilon, right? And you know from the delta definition, x square plus y square must be less than delta, which means epsilon is equal to delta. So is this the only approach? No, there is one more. This is circular neighborhood, right? Let's use the square one. Mod x greater than delta, which means mod x whole square less than delta square. Mod y less than delta, which means mod y whole square less than delta square, which is mod x square plus mod y square less than 2 delta square. Take the under root, you get this expression, and you get delta root 2 is equal to epsilon, right? अरे भाई इधर था ना, ये वाला एक्सप्रेशन तो रहेगा ना, तो इसलिए ये वाला एक्सप्रेशन, ये तो एप्सिलॉन था ना, तो एप्सिलॉन इज इक्वल टू रूट 2 डेल्टा स्क्वायर बनेगा, बस वही चीज है. And I hope you all can apply this concept for sine also. So I don't think so that I need to do this one also. You will apply the limit, you will get the limit as 0, and then you apply this expression that mod of x sine 1 by y plus y sine 1 by x is less than, is strictly, you will apply the triangle inequality 1 by y plus y sine 1 by x, and what you will get, it will be less than mod x plus mod y, since, and it will be less than epsilon, since sine maximum is 1 and sine again is 1. So you will get and what you get, mod x is less than delta, and you know mod y is less than delta. You add them, you get 2 delta is equal to epsilon, right? Just solve it, you will understand it on your own. I have made lectures on it, you can watch it, but this is a one shot, so I will try to be a bit fast and bit concise, right? So, and again, this is here you have to show that limit does not exist, so you have to show that either the limit is different at that point or the limit does not exist. That is the thing. For here you will take for this one, you will assume the function as y is equal to x minus mx to the power 4, right? That is the key. Okay, now we will move to the some questions of partial derivative. I had introduced partial derivative in previous lecture, but I could not do the questions, so now this is our opportunity to do the questions. So let's start with this first part, right? Or yeah, let's do the first part. So let's do it, and I need some more space, so I need to change this one. So let me see. Yeah, now it will work. Yeah, let me change the color of the pen to suppose this color, and now let's see. Fifth, we should do first one or second one. Second one we will be able to learn two concepts. So let's do fifth second part. It will be more beneficial. Let me see, is my device charged? Yeah, it is charged. Yeah, so the question states that f at xy is equal to root xy. F at xy is equal to root xy, and you are given that, and you are asked that find del 2f by del x square plus del 2f by del y square. Del 2f by del x square plus del 2f by del y square is equal to what? Okay, let's do it. So partial derivative क्या होता है? What is partial derivative? The partial derivative states that you will assume a variable. For example, there are two variables, and two are for example, there are two variables x and y. So while differentiating with respect to x, you will assume y as constant, and while differentiating with respect to y, you will assume x as a constant. This is called a partial derivative, and for geometric interpretation, you can watch my last lecture, that is lecture 7. I had gave the brief idea, and let's do now. I had given the definition and everything, so you all can watch it. So what you get is that since f is equal to root xy, what you get is that you can write it as f is equal to root xy, and you get del f by del x is equal to simply 1 by 2 root y by x, right? Can you write it like this? Yeah. And del 2 f by del x square is equal to, again you will bring root as root in front, and you get negative 1 by 4 root y by x cube, right? Or simply negative 4 by y by x cube, right? And similarly del 2 f by del y square, and I hope if there is any calculation error, you all will let me know in the comment section, since I am not well also, and now, and the thing is that I am too much there's too much the schedule is too much hectic, so that is why there might be chances of mistakes. So please try to avoid those mistakes, and if you find any, then please let me know in the comment section, else please try to खुद से सही कर लीजिएगा if you find. So by symmetricity you will get this expression x by y cube, and simply just add them. Del 2 f by del x square plus del 2 f by del y2 is equal to negative 1 by 4. You get root x by y cube plus y by x cube, and that is the thing, right? And you can eventually just solve it further, and you get at whatever points you want. Okay, now what is the next question? You now you can try this one easily, and this we have done.
and now what is this? Z is equal to this quantity and this is equal to Z. Okay, so it is simple actually what we are given that let me write it so that, so if you are solving this question, wait a minute, it is this one. So if you are solving, you know, the Z is equal to U cube plus V cube. Either you can apply, you can do it using the chain rule. What is the chain rule? Let me tell you. For example, what is the chain rule? Chain rule, it states that del f by del x is equal to del f by del g1 dot g del g1 by del x plus dot till del f by del gn dot del gn by del x. But you don't need to use it many other times, it will work like that. So what you will do is either you can apply over a chain rule or simply substitute the value of u and v and simply apply the theorem. It will work. So either you will write it as sine cube of xy plus y to the power 6. This is the expression. Now you can simply find del y, del z by del x and del z by del y, right? You can find it. This is also a very simple question. Just apply the concept and you get del xy. I told the definition before. Del xy, del z xy is del 2z by del x del y. That is del by del x of del z by del y, right? That is the thing. You can find it. Theta is equal to this you will do, and let's see some sort of, yeah, this fifth question and sixth subpart. Yeah, let's do this one. This one is interesting. Let's see how do we do this. And there's something interesting over here that in the C part, this you will do on your own, and because it is somewhat concept building question, and I hope you all will be able to do it, or else I will discuss it. Yeah, I will discuss, that is better. So let's start with the question and let's see how do we do it. Maybe if I need more space, yeah, I will need. So let me just introduce this to the next slide, or the next slide even, so it will be better for the viewers and me both who all are watching it. So now let's start with let's do, yeah. The question states, what is the question? U is equal to log of this quantity, right? Okay. So see that sixth part, I guess it is sixth, no? You get u is equal to log of x cube plus y cube plus z cube minus 3xyz. अब हम लोग से कहा गया है that u is equal to this quantity and find ux plus uy plus uz. Okay, so ux plus uy plus uz, how do we solve it? Let's see. Now notice that you can write this expression as u is equal to, you know, the identity, u is equal to log of x plus y plus z into x square plus y square plus z square minus, or simply you don't need to apply right now, right? We will apply it later. Just simplify del u by del x. What you get? Upon x cube plus y cube plus z cube minus 3xyz, and you get over here 3x square minus 3yz. And similarly from the pattern, del u by del y is equal to ux, you all know by definition it is equal to 3y square minus 3xz by x cube plus y cube plus z cube minus 3xyz. And del u by del z is equal to 3z square minus 3xy by this x cube plus y cube plus z cube minus 3xyz, and simply add them all, you get 3 into x square plus y square plus z square minus 3 into xy minus plus yz minus plus xz upon x plus y plus z. Notice that you can factorize this expression. Plus y square plus z square minus xy minus yz minus xz. अरे भाई कैसे हो रहा है यहाँ पर? ये एक्स क्यूब प्लस वाई क्यूब प्लस जेड क्यूब माइनस 3x वाई जेड इज इक्वल टू, आप लोगों को पता है ना, एक्स प्लस वाई प्लस जेड
into x square plus y square plus z square minus xy minus yz minus xz होता है. Right? Is it correct? आप लोग शायद पता होगा, and नहीं पता तब भी जान लीजिए. So what you can do is you can take common as 3. You can take 3 as common. You get x square plus y square plus z square minus xy minus yz minus xz y x plus y plus z into the quantity x square plus y square plus this stuff, right? And notice that this and this cancel, and you get simply ux plus uy plus uz is equal to 3 by x plus y plus z, right? Does it make any sense? Yeah, it is correct. Okay. Now, before moving on to the next question, what is the next question? Let's see. The next question, it is states, where's the question? The question is over here. This expression is your question. So you get, okay, let's move on to the C part of this question, because that is much easier than the second part, because first and A and C are related. So what is del by del x plus del by del y plus del by del z whole square into u? It can be written as del by del x plus del by del y plus del by del z plus del by del x plus del by del y plus del by del z into u, right? You can write it as del by del x plus del by del u plus del by del z of the quantity. Yeah, that is fine. Del u by del x plus del u by del y plus del u by del z. You can write it like this, and you get del by del x plus del by del y plus del by del z of the quantity ux plus uy plus uz. ये मिलेगा, and you have proved it right now. Del by del x plus del by del y plus del by del z of the quantity 3 by x plus y plus z. अब इसे अंदर लेके जाइए. 3 into this quantity del by del x of 1 by x plus y plus z plus del by del y of 1 by x plus y plus z plus del by del z of 1 by x plus y plus z, right? वो है, समझ आइएगा थोड़ा सा. And you can just use the question rule now, or simply a simple rule, minus 1 by x plus y plus z ka whole square, right? What is the question? What do we needed to prove? Okay, and it is simply equal to this expression of negative 9. Okay, so we need to prove this expression. So how do we solve it? Where's the question? Yeah, wait, and simply you will get over here also negative 1 by x plus y plus z ka whole square minus 1 by x plus y plus z का whole square. It is simply equal to negative 9 by x plus y plus z का whole square, right? समझ आया? आई होप आप लोग को आ गया समझ में, ठीक है. नाउ मूविंग ऑन टू द बी पार्ट. ठीक है, मैं बी पार्ट जानकर करा रहा हूँ लेट, बिकॉज इट इज बिट लेंदी एंड उसमें कुछ मैनिपुलेशंस लगेंगी, दैट्स व्हाई. So what is the question? It is uxx plus uyy plus uzz. Okay, nice. Let's see. Notice that u is equal to log of x cube plus y cube plus z cube minus 3xyz is equal to log of x plus y plus z plus log of x square plus y square plus z square minus xy minus yz minus xz. ये बनेगा. अच्छा, sorry, bit tired because I'm not well also, so that's why. But not that much energetic, but leave it. Let's start, and you get this expression y plus z by x plus y plus z, right? Oh, sorry, it will be 1 by this quantity plus this expression x square plus y square plus z square minus xy minus yz minus xz. ये बनेगा. अच्छा, plus what else we will get? We get 2x minus y minus z, right? We get this. Is it correct? Okay, now what you can do is you can
Now what you will do is you will find let's find del 2u by del x square, and let's see if we get any pattern. You get negative 1 by x plus y plus z. So this will be a common expression. Plus what you get, you will differentiate this and you get 2 into x square plus y square. Let me call this stuff as k, 2k minus 2x minus y minus z into 2x minus and it will become it's a square. Don't you agree? Yeah, it will be it's a square by this k ka whole square, right? And so what you will get is that del 2u by del y square, what you get, the simple pattern is z whole square plus it will be again 2k minus 2y minus x minus z ka whole square by k square, right? And now let me change this expression. I need some more space. Yeah, now it will work. And simply you get del 2u by del z square, and now you will see a magic. 2k minus 2z minus x minus y whole square by k square. And notice that if you add all this expression, you will eventually see that this cancels this and this. The sum of these three becomes 0. And you will be only left with uxx plus uyy plus uzz is equal to negative 3 by x plus y plus z ka whole square. And please, it's a request, please do calculate it and you will get it as 0 only. You all can check it, right? That you can take it as a homework even, right? So just see that yeah, due to symmetricity it will become 0. You all can calculate it, right? And if there is a mistake in my calculation, please let me know and I will correct it. But you all just focus on the concept, right? Okay. Now let's see some question on Euler's theorem that will work. Let's see the 5th, 10th part. It will be nice to do. Let's do it. Let's do 5th, 10th part. Okay, let's do it. So it states that let me set my mobile. Yeah, that's fine. So what it states that u is equal to x phi of y by x. Sorry, I forgot the question. U is equal to x phi y by x. Okay, x phi y by x. U is equal to x phi y by x plus y psi y by x, right? So what do you get? Where's the question? This is then prove that x squared del 2u by del x2 plus 2xy del 2u by del x del y and y squared del okay. That is the basic result that we always expect to get. Right, let me change the color of the pen and wait, let's start. So you get that so you want to prove this expression plus 2xy del 2u by del x del y plus y square del 2u by del y square, you need to prove it to 0, right? So let's see how we will solve this question. Let's write it as x phi of y by x plus y psi, this is called psi y by x, and you can write it like that capital U plus V, capital V, right? This you can write. And notice that notice nothing. Let's just solve for U, capital U, sorry. Capital U is equal to x into phi of y by x, right? And this is a general form of Euler's theorem, right? So you get x del capital U by del x plus
y del capital U by del y is equal to x into capital U, right? Is it correct? Yeah. And now you will apply simply this concept that you will derive with respect to, sorry, it will be n into 1, na? So n into u, it will be u. What is n? N is the power, this one. This is equal to n. So you differentiate it with respect to x and with respect to y. Let's with respect to y, with respect to x, let's do first. You get del u by del x plus what is the next expression? You will get x del to u by del x square plus y del to u by del y del x, अरे क्या लिखा, y del to x, अरे del x del y is equal to del u by del x. This and this cancel and multiply by x both sides. And what you get? Let's see. Get x square del to u by del x square plus xy del to u by del x del y is equal to 0. And this is the first expression. Now with respect to y, what you get? ये था with respect to differentiate with respect to x. Now differentiate with respect to y. Maybe my writing is not nice right now because it's just cope up with me, okay? So x del u capital U by del x plus y del u by del y is equal to capital U, right? बनेगा. Now with respect to y you get x del to u by del y del x plus y del to u by del y square plus del u by del y is equal to del u by del y, and this cancels, and when you multiply by y you get xy del to u by del y del x plus y square del to u by del y square equal to 0. And now you can just both add first and second equation. You get what? You get x square del to u by del x square plus 2xy del to u by del x del y. Here del to u by del x y del x into del y is equal to del to u by del y square del y into del x. What I mean is del to u by del x del y, you can calculate and check it also, but it's not necessary for exam, right? Here we will assume that this is equal, right? It can be proved easily, but you don't need to, right? Plus y square, due to symmetricity you can say that both are equal, plus y square del to capital U by del y square is equal to 0, right? This is the expression, but we need to not prove this. Now check the, I need more space. Oh, let me change. Yeah, now it will be fine. I need at least 2 slides. Yeah, now it's fine. Now we know that v of x, not v, v was equal to capital V was equal to what? Y psi of y by x. Y psi of y by x, right? So you will apply the same constant. You get x del y by, sorry, del v by del x plus y del v by del y is equal to v, and you will end up getting the similar result, x square del to v by del x square plus 2xy del to v by del x plus del y dot plus y square del to v by del y square equal to 0. You will get the same result as before, and when you will add those two you will get x square del to u by del x square plus del to v by del x square. आई होप आप लोग समझ आ रहा है. मैंने उस वाले जो वहां से रिजल्ट आया था यहाँ से रिजल्ट आया, दोनों को मैंने ऐड कर दिया, ठीक है. प्लस 2xy ऑफ del to u by del x del y plus del to v by del x del y plus y square del to v by del x square plus del to u by del x square del y square is equal to 0. आई होप आप लोग समझ आ रहा होगा, ठीक है, ये कॉन्सेप्ट लगाएं. And since small u was equal to capital U plus v, which means del u by del x del to u by del x is equal to del to u by del x square plus del to u del to v by del x square, and similarly for the y and for the del x and del y also, right?
So you get simply x square del 2 small u by del x square plus 2xy del 2 small u. You can say that the sum of these two is simply equal to that expression, small u, right? Del x del y plus y square del 2 u by del y square equal to 0, and hence proved. Hence proved, right? Please don't mind my writing. It's just becoming bad with time because it is in a one go, so that's why. So I hope rest you will do on your own all this thing. Let me change the ink. All this you will do on your own, right? For practice, I'm just telling the concepts which are important. And now let's see the next question. Move on to the next slide. And this is also similar type. This is also similar type is there. And now let's see if I get something new. Let's move to the Jacobian. What is the Jacobian? Let's see. Jacobian. It is simply, for example, del x del u1 u2 u3 and del x1 x2 x3. Then you say that it is equal to del u1 by del x1 del u1 by del x2. It's simply a determinant, nothing more. Del x1 by del x3 by del u2 by del x1 del u2 by del x2 del u2 by del x3. You get this? It is becoming a music rhythm, some sort of like that. I don't mind it. And del u3 by del, it is 1. Del x1 del u3 by del x2 del u3 by del x3, right? And this is the Jacobian, and for more variable system you can change it to 4 cross 4 or somewhat like that, right? So this is the Jacobian, and what is the question? It is states that we are given x is equal to r cos theta, and we are given x is equal to r cos theta and y is equal to r sin theta, and then we have to write it with respect to this quantity. Okay, it is a simple question just for understanding. Let's do it, and then we will see some amazing question. The cosh function, that is the hyperbolic function, I don't think it is in your syllabus, because I don't think so it has been taught, but if you want I can tell, but I don't think so it is important, right? And let me see what question we will do next. And Taylor series, there is an ambiguity that is it in even course or not, because some are saying that in their section it was taught, and some are saying that it was not taught. So there is an ambiguity, so I am leaving it for now, and even if it comes, it will come in a choice, so don't worry about it. I don't think so it will come in a mandatory section, because there is no mandatory section in our paper. So don't worry about it. And if I get to know that it is there in course, I will make a video immediately. It will just take 5 to 10 minutes, right? So don't worry about it. And now let's just see this question. X is equal to r cos theta, x is equal to r cos theta, and y is equal to r sin theta, right? ये आप लोग को मिला? अच्छा. So what we get is we are getting कहाँ गया? Y is equal to r sin theta, y is equal to r sin theta, and we have to find del xy comma del r theta, del xy comma del r theta. We have to find this, right? So now how we will find it? Let's see. Okay, so just see, let's how we find is it will be equal del x by del r and del x by del theta, del y by del r and del y by del theta, right? Is it correct? Yeah. So del y del r of r cos theta and del y del r del theta of r cos theta, del, and we get del y del r of r sin theta and del by del theta. अरे भाई x and y की वैल्यू पुट कर रहा हूँ और कुछ नहीं कर रहा हूँ, ठीक है? ज्यादा घबराने नहीं, ठीक है? r sin theta, and you get I guess it's 1 hour video already. You get cos theta, and you get or a negative r sin theta, and you get over here sin theta, and you get over here r cos theta, right? And you can simply open it up and you get r cos square theta plus r square plus r sine square theta, right? And you get r, right? That is the answer. If there is any calculation error, please let me know, else it is fine. Okay. And now we have done this also. We have discussed the Jacobian also. We have discussed the Euler's theorem also. We have discussed the different types of problems also. And now let's discuss a problem which might be helpful for us. Yeah, this type of question can also come. Show that since and then you will try this one, right? You will try this one. Let me make it. You will try this one because it involves both Jacobian along with the relation to be proven. So I've done this one and I've done this one, and it is show that the function this and this have they are not independent. We have to show this. So let's see how we'll do that. And then all the questions are interlinked after that. So you get x. What is the expression? U is equal to x plus y plus z. Okay. U equal to x plus y plus z, and v is equal to xy plus yz plus xz, and w is equal to x cube plus y cube plus z cube minus xy minus 3xyz, right? And हम लोग को relation क्या prove करना है? We have to prove that u cube is equal to, what is the u cube, and it is equal to 3uv. Okay. And we have to prove that u cube is equal to 3uv plus w. 3uv plus w. We need to prove this expression. ये हम लोग prove करना है. तो how do we prove it? Well, let's see. Well, if you see over here, what you can do is you know that w is equal to this quantity. It can factorize like this. Let me change the color of the pen. If it won't work, let me tell you the approaches that you can apply while solving this problem. It can be wrong also, it can be correct also, but we need to check so that you don't waste your time in examination. So just let's see if this approach works or not. I hope you know this identity. I discussed it just some time back. And so what is w? And w, it is equal to, what is this? It was equal to u, and this is equal to x plus y plus z whole square minus, and it is with a 3, right? Okay. So it is equal to minus 3 into xy plus yz plus xz, right? Oh, it will work. So w is equal to, and see, x plus y plus z was u, so that is why I have written over here u into u square minus 3, and what is this is equal to v, right? So you get w is equal to u cube minus 3 uv. So you get what? You get u cube, where is it? U cube is equal to w plus 3 uv. That's the answer. Hence proved. It was simple though. And now let's see some new problem if I find any. Well, let's see. No, nothing new. This also you will be able to do it now. Show that this we have done. Your ninth one, it is a three variable system Jacobian, and see, I have written the formula. You need to just substitute the value, and this one you will simply use the whole square term over here, and you will be able to form the expression, and then find the value of this. Okay. And Taylor series, if I will come to know that it is in the syllabus, then I will make a video immediately today. Else don't worry about it. Even if it comes, it will be in the choice part only. So I hope आप लोग को समझ आएगा lecture. And please do subscribe to my channel. Please like, share and subscribe. And आई होप आप लोग समझ आए हो. एंड अगर कोई भी डाउट हो मुझे कमेंट सेक्शन में बता दीजिएगा. एंड मैंने ट्राई किया, मैंने सब कॉन्सेप्ट्स के क्वेश्चन करवा दिए मैक्स टू मैक्स. एंड अगर अभी भी कोई कॉन्सेप्ट बच रहा होगा तो मैं उसके लिए वीडियो बना दूंगा, बट मुझे लगता है अब सब कॉन्सेप्ट हो गए हम लोग के. ठीक है. एंड हाँ, आप लोग एक चीज इंपॉर्टेंट याद रखिएगा कि उसमें जो एक होता है प्रूफ, होता है प्रूफ किसका, ऑयलर्स थ्योरम का, वो कर लीजिएगा, ऑयलर्स थ्योरम का प्रूफ कर लीजिएगा। इंपॉर्टेंट मल्टी वेरिएबल के लिए भी, मतलब एफ एक्स एंड वाई के लिए भी, एंड एक्स वाई जेड वगैरह के लिए भी, ठीक है। तीनों के लिए आप दोनों के लिए आप कर लीजिएगा, एंड इट विल बी रियली हेल्पफुल, एंड आई होप आप लोग पूरा समझ आएगा लेक्चर। एंड प्लीज डू लाइक, शेयर एंड सब्सक्राइब, प्लीज सपोर्ट माई चैनल। एंड नाउ बाय बाय, टेक केयर, ऑल द बेस्ट फॉर योर मिड टर्म्स, एंड ऑल द बेस्ट, बाय बाय। हेलो एवरीवन, दिस इज आदित्य, एंड आज हम जी मैथमेटिक्स 1 का लेक्चर 6 डिस्कस करेंगे। एंड इसमें हम लोग क्वेश्चन सॉल्विंग एंड पीवाईक्यूज देखने वाले हैं, एंड ये पार्ट 1 है। एंड आई एम रियली सॉरी, मैं 3-4 दिन से वीडियो नहीं बना पा रहा हूँ बिकॉज आई वॉज नॉट वेल, बट नाउ आई एम फाइन। एंड प्लीज डू सब्सक्राइब टू माई चैनल, एंड प्लीज सपोर्ट इट, एंड थैंक्स लॉट फॉर सपोर्टिंग इट टिल नाउ ऑल्सो, एंड फॉर cooperating with me. So let's get started with the first question. And what does it state? It states that use Rolle's theorem to prove this expression has only one real root. So let's see. Let's assume that fx is equal to 5x cube minus 2x square plus x minus 6, and assume कर लिया कि इसके दो real roots हैं alpha and beta, right? अच्छा. So since it is a polynomial, since fx is a polynomial, don't you agree to it? Yeah, polynomial ये. So it is continuous, right? It is continuous. It is continuous in the closed interval alpha to beta. Yeah. And it is differentiable also in the open interval alpha to beta. Okay. And one more thing, that f at alpha is equal to f at beta is equal to 0. So ये तीन कंडीशन जो फंक्शन सेटिस्फाई करता है, हम लोग कहते हैं कि वो रोल्स थ्योरम को भी सेटिस्फाई करेगा, which means there should exist a c for which f dash c is equal to 0. अच्छा, then let's see, fx is equal to 5x cube minus 2x square plus x minus 6. So let's just differentiate this expression, and we get 15x square minus 4x plus 1, which means f dash at c is equal to 15c square minus 4c plus 1. But notice that when you set it equal to 0, you won't get any real value of c, because when you calculate the discriminant, it will be minus 4 ka square minus 4 into 15 into 1, which is always less than 0, right? तो डिस्क्रिमिनेंट लेस देन 0, इसका मतलब जो रूट्स भी होंगे वो नॉन रियल होंगे, राइट? तो इसका मतलब देयर एग्जिस्ट नो सच सी, विच मीन्स जो हम लोग का अजम्पशन था दैट देयर आर 2 और मोर रियल रूट्स ऑफ अल्फा बीटा, जहां हम लोग ने अज्यूम किया था, वो स्टेटमेंट गलत है, वो अजम्पशन ही गलत है, कॉन्ट्रडिक्शन वो मिल रहा है। तो इसका मतलब या तो इसके पास एक भी रियल रूट नहीं है, या तो एक रियल रूट है। बट अभी हम लोग चेक कैसे करेंगे, लेट्स सी। एक्सप्रेशन था एफ एक्स इज इक्वल टू 5x क्यूब माइनस 2x स्क्वायर प्लस x माइनस 6. Let's check for f at 0, you get minus 6. And now if you substitute f at 2, you get 5 into 8 minus 2 into 4 minus plus 2 minus 6. And you check it is always greater than 0. Which means f at 0 is less than 0 and f at 2 is greater than 0. Which means एक ऐसा पॉइंट होगा कहीं ना कहीं जहाँ पे नेगेटिव से पॉजिटिव जा रहा है। तो कुछ ऐसा ग्राफ मान लीजिए ऐसा बना है, तो एक ना एक जगह तो वो कट करेगा ग्राफ को। Hence there is one real root. हम लोग को वैल्यू जरूरत नहीं, लेकिन हम लोग पता है कि एक रियल रूट एग्जिस्ट कर रहा है, राइट? Hence proved, right? Okay, moving on to the next question. The question to verify rules for fx is equal to cos of x in the interval in the closed interval negative pi by 2 to pi by 2. Okay. So you know that fx is cos x. And you know that cos x is a continuous function, and it is differentiable always in the interval, in whatever interval you are checking it. And it satisfies that cos at negative pi by 2 is equal to cos at pi by 2, it is pi by 2, is equal to 0, right? It means it is satisfying all the conditions required for the Rolle's theorem, right? So what you can do is you can simply use fx is equal to cos x and simply differentiate it. And now what you can do is you can use a c over here. You get negative sign c and set it equal to 0, right? Which means c is equal to 0. And does c lies between negative pi by 2 to pi by 2? Yeah, it lies. Hence, we have got a value of c. So, we have verified the Rolle's theorem. अगर आपको इसे प्रॉपर स्टेटमेंट साथ लिखना है, then we will write it like that. Let's see. How do we write? Since fx is equal to cos x, which implies fx is continuous in the closed interval alpha to beta, I mean negative pi by 2 to negative pi by 2 to pi by 2, and fx is differentiable in the open interval negative pi by 2 to pi by 2, right? होगा? हाँ होगा ना. And we have also observed that f at negative pi by 2 is equal to pi by 2 is equal to 0, which means Rolle's theorem is satisfied. So hence we will assume a c in the open interval negative pi by 2 to pi by 2, and वहां से हम चेक करेंगे पूरा. ठीक है? Okay. What is this? Use MVT. Okay, the question was this. I think there is some issue. Use MVT means mean value theorem to show this expression lies between. Okay, so let's see how do we solve it. Well, okay, so let's see. We assume our function to be, I mean fx to be equal to cube root of x, right? Is it correct? Yeah. Okay. And now by Lagrange mean value theorem, you know that f of x is equal to f at a plus h into f dash of a plus theta h, right? You know it, right? If you don't know, you can watch my other videos, the previous lectures, to understand it better, right? I can't discuss it over here, else the video will become very long, right? And there are still many questions left to be done, right? So just see what I am doing and assume that we are evaluating at since it is 3 plus some expression, we can use over here 27, right? And what is h? H is basically equal to b minus a, right? And what is b? B is simply equal to x minus 27, right? Into what is f dash of a? It is equal to you can solve it. F dash of x is equal to 1 by 3 x to the power 2 by 3, right? Is it correct? Yeah. So you get 1 upon 3 into x to the power 2 by 3, right? But what was x? X was equal to a plus theta. So you can substitute it over here. What was a? A was 27 plus theta into 27, I mean x minus 27, right? टू द पावर 2 by 3. ऐसा क्यों कर रहा हूँ आप लोगों को धीरे धीरे समझ आएगा. यहाँ पर क्या किया था हमने? एफ डैश एक्स निकाला था एंड एक्स के मैंने ए प्लस थीटा एच यहाँ पे बस सब्स्टिट्यूट किया है. एंड ए की वैल्यू मैंने 27 ली थी एंड एच क्या है? बी माइनस ए होता है एंड बी क्या है यहाँ पे? एक्स है, राइट? तो इसलिए ऐसा किया. ठीक है. एंड सिंस हम लोगों को 28 पे इवेल्युएट करना है तो यहाँ पे मैं एफ एट 28 अज्यूम करूंगा एंड इट इज इक्वल टू 3 प्लस 28 माइनस 27 अपॉन 3 इंटू 27 plus theta into 28 minus 27 whole raised to the power 2 by 3. तो अब यहाँ से मैं इसे सॉल्व करूंगा. क्यूब रूट ऑफ 28 इज इक्वल टू 3 प्लस 1 अपॉन 3 इंटू 27 प्लस थीटा की पावर 2 अपॉन 3, राइट? ये एक्सप्रेशन बनेगा. आप लोग एग्री कर पा रहे हैं ना? एक बार आप लोग इसे खुद चेक करिएगा, आप लोग को ज्यादा अच्छे समझ आएगा. ठीक है. ओके. So now just observe that theta lies between 0 to 1, right? Which means if I substitute theta as 0, I will get the minimum denominator. Which means I will get the maximum expression for cube root of 28, right? अरे भाई डिनोमिनेटर जितना छोटा होगा उतना बड़ा एक्सप्रेशन बनेगा ना. अरे 1/2 इज ग्रेटर देन 1/3 होता है. डिनोमिनेटर इसका छोटा है, इसका बड़ा है, इसलिए ये क्वांटिटी बड़ी हो गई एंड ये क्वांटिटी छोटी हो गई. ठीक है. बहुत सिंपल सा लॉजिक है. ठीक है. तो अगर थीटा को मैं फोर्सफुली 0 सब्स्टिट्यूट कर रहा हूँ So I get 3 plus 1 by 3 into 27 की power 2 by 3. And what is this? It is 3 plus 1 upon 27. Right? सही है? हाँ सही है, ठीक है. So it means यहाँ से हमने एक चीज तो प्रूव कर दिया कि जो क्यूब रूट ऑफ 28 है, इट इज ऑलवेज लेस देन 3 प्लस 1 बाय 27. ठीक है, हम लोगों ने आधा काम कर लिया, अब हम लोग को आधा काम और करना है. नाउ लेट्स सब्स्टिट्यूट थीटा एज 1. हम लोग मैक्सिमम डिनोमिनेटर कर रहे हैं जिससे हम लोग को मिनिमम वैल्यू मिल जाए. ठीक है, you end up getting 3 plus 1 upon 3 into 27 plus 1 की power 2 by 3 and it is equal to 3 plus 1 by 3 into 28 की power 2 by 3. Either now you can use the calculator or you can simply use the question to see whether it is correct or not. Let's assume 3 plus 1 upon 3 into 28 to the power 2 by 3 is greater than, assume कर लिया, less than, is less than 3 plus 1 by 28, right? Assume कर लिया बस for now. You can cancel this 3 and you will get 1 by 3 into 28 to the power 2 by 3 is less than 1 by 28, which means that you can bring those expressions and you get this 3 into 28 to the power 2 by 3 and you get 28 to the power 1 by 3 is less than 3, which is the wrong statement, right? ये अरे क्या ये होता है, 3 का मतलब क्या होता है, 27 का क्यूब रूट होता है ना, तो क्या 28 लेस देन 27 है? बिल्कुल गलत स्टेटमेंट है. हेंस ये जो एक्सप्रेशन है ये रिवर्स होकर के ये बन जाएगा. ठीक है, ओके. नाउ लेट मी इरेज ऑल दिस स्टफ एंड व्हाट आई गेट इज ओवर हियर दैट इसका मतलब ये वाला एक्सप्रेशन इससे भी छोटा है. एंड वी नो दैट 3 प्लस 1 अपॉन 3 इंटू 28 टू द पावर 2 बाय 3 इज ऑलरेडी लेस देन क्यूब रूट ऑफ 28 बिकॉज हमने मैक्स डिनोमिनेटर रखा था तो हम लोग को मिनिमम एक्सप्रेशन मिलेगा, मिनिमम वैल्यू मिलेगी. एंड इन केस वी ऑल्सो नो दैट this expression is still greater than this expression, which means ultimately we have 3 upon 1 plus 28 is less than cube root of 28 and it is less than 1 upon 27, right? Hence proved, right? A simple application, right? Now let's see this this expression, this question use Taylor's theorem to prove that for all x greater than 0 this expression holds true. अच्छा ठीक है, देखते हैं. Well, you can assume fx to be the middle function e to the power x, right? ये वाला function है. This one, let me change the color so that it is more clearly visible. This expression, right? So let me change the color again and we get this. Now from the Taylor's expression we know that fx is equal to f at a plus h by 1 factorial into f dash of a plus h square by 2 factorial. And notice that we are going to fourth expression, so we will have to use till third power, I guess, f double dash of a plus h cube upon 3 factorial into f triple dash of a plus theta h. Is it correct? Yeah. Just substitute the value. You substitute a as 0 and notice that if you differentiate any time, I mean till nth term also, the e to the power x expression, you will still end up getting e to the power x, right? So it don't matter. So you get f at x is equal to f at 0 plus what is h? H is simply x minus 0 since we are going from 0 to x, right? Okay. So we are just substituting x minus 0 and it will be 0 only, it will be x only upon 1 into f dash of 0 plus x by 2 factorial into f dash of 0 plus x cube, here it will be x square by 6 into f triple dash of what is a is 0 and it is theta x, right? Don't you agree? Yeah, you should. So we get that f at x is equal to what is e to the power 0. E to the power 0 is 1 and what is e to the power 0 again? It is again 1. So x plus x square by 2. अरे भाई यहाँ पर देखिए f एट x इज इक्वल टू ई टू द पावर x है, तो f डैश एट x इज इक्वल टू ई टू द पावर x होगा, एंड f nth डेरिवेटिव ऑफ x क्या होगा? ई टू द पावर x होगा. सो आप लोग कितने भी डिफरेंशिएट कर दीजिए, अगर वहां पे आप 0 पुट करेंगे तो ई टू द पावर 0 1 ही मिलेगा आपको. ठीक है, आई होप आप लोग समझ आ रहा होगा. थोड़ा सा मैं फास्ट हूँ बिकॉज यहाँ बहुत सारे क्वेश्चन मुझे कवर करने हैं, दैट्स वाई. थोड़ा सा आप लोग खुद से एफर्ट करेंगे तो आप लोग आ जाएगा, राइट. प्लस एक्स क्यूब बाय 6 इंटू ई टू द पावर थीटा एक्स. ठीक है, करेक्ट है. अच्छा, अब थीटा क्या होता है? 0 से 1 होता है. अगर अब मैं थीटा को 0 सब्स्टिट्यूट करता हूं तो मुझे यहाँ पे इस एक्सप्रेशन की मिनिमम वैल्यू मिल जाएगी. ठीक है, so if you substitute theta as 0, you get e to the power x, e to the power theta x, it will go to 1, right? So you get 1 plus x square plus x cube by 6 into 1, and it will be less than e to the power x, right? Is it correct? Yeah. And now when you substitute theta as 1, you get 1 plus x square by 2 factorial plus x cube by 3 factorial into e to the power 1 into x, which is simply e to the power x, right? And is the maximum value, as you can see from this expression, right? So you end up getting 1 plus x square, which means this expression is greater than e to the power x, right? Don't you agree to it? Yeah, it will be correct. Plus 2 plus x cube by 6 is less than e to the power x, and this indeed is less than 1 plus x by x plus x square by 2 plus x cube by 6 plus into e to the power x, right? Hence proved. शायद आप लोग समझ ना आया हो, अगर नहीं समझ आया मैं दोबारा एक्सप्लेन कर दे रहा हूँ. यहाँ मैंने क्या किया, मैंने यहाँ पे थीटा की मिनिमम वैल्यू ली है जिससे कि मुझे यहाँ पे मिनिमम एक्सप्रेशन मिले. सिंस यहाँ मैं न्यूमरेटर से डील कर रहा हूँ, इसलिए मैं वहाँ पे जब 0 पुट करूंगा तो मुझे मिनिमम एक्सप्रेशन मिलेगा, एंड यहाँ पर मैंने जब 1 सब्स्टिट्यूट किया तो मुझे यहाँ पे मैक्सिमम एक्सप्रेशन मिल जाएगा, राइट. सो इसलिए हम लोग एक्सप्रेशन मिल रहा है. आप लोग खुद से एनालाइज करिएगा, आप लोग समझ आ जाएगा. ठीक है, बहुत सारा क्वेश्चन करने इस वजह से मैं थोड़ा सा फास्ट चल रहा हूँ, एंड ये क्वेश्चन आप लोग थोड़ा सा होमवर्क में कर सकते हैं, राइट. आप लोग यू कैन सिंपली डू दिस क्वेश्चन, दिस ऑल्सो, and this one also. It will be just easier for you, and if you want I can do this one, right? Let's do this one, and rest you will do on your own. ठीक है, so assume fx as sin x, right? आपने sin x assume किया. Let me change the color. तो अब यहाँ पे हम लोग को दो एक्सप्रेशन दिया गया, तो मतलब हम लोग को टेलर के दो सीरीज तक जाना है. ठीक है, तो f एट x इज इक्वल टू f एट 0, क्योंकि हम लोग यहाँ पे क्या कर रहे हैं, 0 से बड़ी वैल्यूज को चेक कर रहे हैं. ठीक है, प्लस h इंटू वॉट. अच्छा, यहाँ पे एक्सप्रेशन क्या है, x माइनस एक्स क्यूब बाय 3. ठीक है, ओके. f एट 0 प्लस h इंटू एफ डैश ऑफ 0, राइट? सही बन रहा है. हाँ, तो इसके बाद हम लोग यहाँ पे क्या करेंगे, यहाँ पे h स्क्वायर बाय 2 फैक्टोरियल इंटू एफ डबल डैश ऑफ a प्लस थीटा h करके देखते हैं. लेट्स सी इफ इट गोज और नॉट, राइट. अभी हम लोग बस यहाँ पे एनालिसिस कर रहे हैं, तो अगर हम यहाँ पे 0 सब्स्टिट्यूट करेंगे तो 0 बनेगा. एंड व्हाट इज h इज x माइनस 0, जैसे हमने पिछले क्वेश्चन में किया था, वो x है. एंड व्हाट इज द डेरिवेटिव ऑफ साइन x? इट इज सिंपली इक्वल टू cos x, and you substitute 0, you get 1 plus x square by 2 factorial into the double derivative, it is minus sine of so from this we get to know that there will be 3 expression. How? Because अगर यहाँ पे आप लोग a plus theta h substitute करते हैं, then it won't make any sense, because यहाँ पे हम लोग के एक्सप्रेशन x स्क्वायर वाला टर्म आ रहा है, एंड क्वेश्चन में कहीं पर भी x स्क्वायर मेंशन नहीं है, राइट. तो यहाँ से हम लोग को आइडिया लग रहा है कि इस वाले टर्म को हमें 0 कहीं ना कहीं से बनाना है. सो लेट मी चेंज दिस एक्सप्रेशन अ बिट, एंड लेट्स सी. f डबल डैश x प्लस h क्यूब बाय 3 फैक्टोरियल इंटू f ट्रिपल डैश ऑफ a प्लस थीटा h हम लोग करेंगे. a इज 0, h इज x, राइट. सो अब यहाँ से हम लोग वैल्यू सब्स्टिट्यूट करते हैं, यू गेट 0, अरे साइन ऑफ 0 0 होता है ना, प्लस x बाय 1 फैक्टोरियल इंटू व्हाट इज द डिफरेंशिएशन ऑफ What is the derivative of sin x? It is cos x, and you substitute 0, you get 1, right? Plus h square. H square is x square by 2 factorial into, what is the derivative of cos x? The derivative of cos x is negative sin x, and you substitute 0, you get 0 as an answer. Plus x cube by 3 factorial. What is the derivative of negative of sin x? It is negative cos a plus theta. You just substitute the value, right? And you get x minus x cube by 6 into cos of what is a is 0, and you get theta x. And notice that this expression is x minus x cube by 6 into cos of theta x. And if you see it, this expression when cos of theta x is maximum is 1, which means we get x minus x cube by 3 factorial is greater than sine of x, right? ऐसा क्यों हुआ? बिकॉज मैंने यहाँ पे cos थीटा x की मैक्स वैल्यू सब्स्टिट्यूट कर दी. मिनिमम सब्स्टिट्यूट करूंगा तो हम लोग को वहां से कुछ और मिलेगा, राइट? ओके, तो लेट्स मूव ऑन टू द नेक्स्ट पार्ट, नेक्स्ट क्वेश्चन. एंड रेस्ट आप लोग खुद से सॉल्व करिएगा एंड मुझे कमेंट सेक्शन में बता दीजिएगा, राइट? एंड राइट, सो लेट्स सी. Oh, sorry, it will be less than, right? Since यहाँ पे हमने cos थीटा को मैक्सिमम किया है, इसका मतलब हमने नेगेटिव वाले टर्म को मैक्सिमम किया है, तो हम लोग x पे कुछ नेगेटिव एक्सप्रेशन ऐड करेंगे तो ऑब्वियसली वो और छोटा बनेगा. हेंस sin x इज ग्रेटर देन x माइनस x क्यूब बाय 3 फैक्टोरियल, राइट? आई होप आप लोग समझ आएगा, ठीक है? अरे देखिए, जैसे कि 2 + 1 कर रहे थे तो ये ग्रेटर देन किसके है? 2 के. बट यहीं पर अगर मैं 2 - 1 कर दूं, इट विल लेस देन 2, राइट? वही चीज़ है. मैंने यहाँ पर एक वैल्यू cos थीटा x को 1 सब्स्टिट्यूट जब किया, मैक्स में सब्स्टिट्यूट किया, सिंस इट वाज विद अ नेगेटिव एक्सप्रेशन, वो हमेशा नेगेटिव मतलब और इसकी वैल्यू कम होती जा रही है, राइट? ओके, x माइनस x क्यूब बाय 6 फैक्टोरियल 3 फैक्टोरियल की वैल्यू कम होती जा रही है, राइट? हेंस साइन x यहाँ पे उससे बड़ा होगा, ठीक है? आई होप आप लोग समझ आया होगा. रेस्ट आप लोग खुद सॉल्व करिएगा. एंड मूविंग ऑन टू द नेक्स्ट क्वेश्चन. यूजिंग MVT शो दैट दिस एक्सप्रेशन इज दिस, ठीक है? आप लोग कर लेंगे, ये होमवर्क है, ठीक है? अब ये बाकी आप लोग कर सकते हैं. एंड दिस एक्सप्रेशन एंड दिस क्वेश्चन, दिस इज अ नाइस क्वेश्चन, ये भी होमवर्क है, आप लोग सॉल्व करिएगा. एंड लेट मी जस्ट शो द क्वेश्चंस प्रॉपरली. ये आप लोग का पहला क्वेश्चन है, ठीक है? कुछ भी नहीं करना है यहाँ पे, हम आप लोग को लाग्रांज मीन वैल्यू थ्योरम लगाना है, ठीक है? और कुछ नहीं. fx को sin x अज्यूम करके आप लाग्रांज मीन वैल्यू थ्योरम लगा देंगे, आप लोग क्वेश्चन हो जाएगा, ठीक है? एंड नहीं होता है देन मुझे आप लोग बताइएगा, मैं कमेंट से मैं आप लोग को किसी वीडियो में एक्सप्लेन कर दूंगा, राइट? सो नाउ लेट्स सी द नेक्स्ट क्वेश्चन. ये भी होमवर्क है, ये थोड़ा सा मैनिपुलेटिव क्वेश्चन है, यहाँ पे आप लोगों को थोड़ा सा लिमिट्स ब्रेक करनी पड़ेगी, आप लोग कर लेंगे, ओके? नहीं होता देन मुझे बताइएगा, मैं इसका सोल्यूशन दे दूंगा, ठीक है? एंड लेट्स सी द नेक्स्ट क्वेश्चन. इज देयर एनी? नो, देयर इज नो question. So thanks a lot for watching, and please do subscribe to my channel, and thanks a lot. Please do support me, and bye bye, take care.
Hello everyone, this is Aditya and today we'll study sequence series in one shot. So let's directly come to the topic, and please do like, share, subscribe my channel. And now let's start the video. Okay, so we will basically study the convergence test, right? You all know what is sequence, what is series. Sequence is a set of numbers which are written according to some pattern and are separated by a comma, right? And series is just the summation of those terms, right? Okay, this is the basic idea, right? So we won't discuss much upon it, right? So now let's start with the first test. Test 1, we are studying the convergence test, that whether a particular series or sequence it is ending, it has a terminating value or not, right? Okay, so let's see. Test 1, we will study integral test. We won't go into the proof because we don't have much time, right? So that is why we will study in a very concise way, right? Okay, suppose you are given summation f of x I, right? You are given this, and I goes from 1 to infinity, right? So what does this test says is, it says that if you integrate it from 1 to infinity of fx dx, right, from where the limit starts. For example, if it would have started from 2, then you would have started from 2, right? Okay. So if it converge, then you say that this series converge, right? It implies series converges, right? Okay. And if it diverge, we say that the series it diverge, right? Okay, I hope you are understanding it. Okay, so let's see. This was the first test. We will see the working in couple of minutes, right? But first we will study the all the tests in a one go, then we will start with the problems. Okay, so test 2, you all can note this all this. Okay, it will better. It is also known as comparison test, right? I am not writing the complete thing because it will take more time. So suppose if you are given two series un and vn, right? Okay, right? Okay, so if un is less than vn, right? Okay, the summation of this is less than this. Okay, this implies if un converges, if vn converges, sorry, then this implies that un should also converge. Why? Because this summation is less than this, sorry, un is less than this, right? So if the bigger term is converging, then it is important for the un also to converge, right? Okay, and if un is diverging, then it implies that vn will also diverge, right? Okay, I be understanding. If the smaller thing is diverging, then obviously the bigger thing will also diverge, right? Basic idea. I am not using the exact terminologies because it will be confusing also. So I am trying to be very crisp and clear, right? Okay. So you can merge all this and you can say that limit as n tends towards infinity of un upon vn is equal to some lambda. Suppose it is equal to some lambda, right? Okay. And suppose if it is finite, right, then there are two conditions. Suppose you calculate vn, and if vn is diverging, right, then this will imply that un is also diverging, right? In this case, when lambda comes out to be a finite value, right? Right? And if vn is converging, then it implies un will also converge, means they both will go together, right? Whatever, for example, if one is diverging, then the other will also be diverging. If one is converging, then the other will also be converging, right? I we are understanding it. Okay, I we understand, right? Okay, so in this case, the limit as n tends towards infinity, un upon vn, right, is equal to lambda. I hope you understood it, right? We will see the problems soon. Okay, now there is one more thing which I need to tell. Suppose theorem or something like this: summation from I is equal to 1 to infinity 1 upon I raised to the power p is convergent when it is convergent if and only if p is greater than 1, right? For this value it is only converging. Okay, you should understand this, because obviously if it is a negative value, it will become all the terms will come into the numerator and it will make the summation a very big term, right? But if it is in the denominator, then it will be fine. Okay. Okay, so now let's come to the third test. Okay, we will see the problem soon, don't worry. Okay, just try to bear with this right now, just try to understand a bit, right? Okay, because we don't have time literally. Okay, so we will try to finish everything as fast as we can, and obviously you should understand it also. I will try to do like that only. Okay, now the test 3, it is a very simple test. Test 3, let's see what is it. D'Alembert's test. Okay, D'Alembert's test. Okay, I hope the spelling is fine. Yeah, D'Alembert's ratio test. And what we do in this is, for example, if you have a series, right, you calculate the unth term and you calculate the un plus 1 term, right? Okay, you calculated. Now you do limit as n tends towards infinity of un plus 1 by un, and suppose it comes out to be some value lambda, right? So if lambda is greater than 1, then the series is divergent, right? Okay. If lambda is less than 1, then the series is convergent, right? And if it is 1, if lambda equal to 1, you can't say anything, right? You need to apply the other test then. Okay. And one more thing to be noted is that if limit as n tends towards infinity of un is not equal to 0 but some other value, then in that case we say that the series is automatically divergent, because the last term is not become 0, right? That is why it will go on till infinity and the sum will become an infinite term, right? Okay. So basically now we are coming to the fourth test number 4. I you are understanding it, right? Okay. It is like bit logical. If the consecutive terms are greater than each other, then it will imply that the series is divergent, right? This is the next term, this is the previous term. You are taking the ratio, and if it's coming greater than 1, it will be obvious that it is divergent, right? Okay. So test 4 is Cauchy root test, right? Yeah, Cauchy root test. Okay. So basically what we do in this is you assume, for example, there is series summation of ui, right? Suppose, and obviously u1 greater than u2 greater than u3 and so on and so forth. They can be equal also, right? There are the possibilities, okay? And obviously the last term greater than equal to 0, right? Means all are positive, okay? So what does it imply? It implies that or basically you basically mean that means all the terms are positive. That is the basic idea, okay? So if this is the case, you just apply the limit as n tends towards infinity of un to the power 1 upon n. So this is the case. If this is coming to be suppose lambda, right? This is lambda, okay? Okay. So it will converge for lambda less than 1 and diverge for lambda greater than 1, right? Okay. I hope you understood, okay? And for lambda is equal to 1, again there is no conclusion, okay? I hope you understood it. There's something called Cauchy condensation test, but I don't think so it is in your course, but still I am telling you all, maybe if it comes, right? So that is why, but I don't think so it will come, right? Okay. So let's see. This is the fifth test, Cauchy condensation test. Condensation test, right? Okay. You all have understood what I have written, right? Okay. Okay. So let's see. The Cauchy condensation test means all the terms. The condition are of the means the condition of this only, that all the terms are positive, right? So in this case, what is the case is that you evaluated this expression. This is convergent if this expression is convergent, right? To the power k, right? This expression is if and only if convergent, if this is convergent, right? Okay. There are many other ways to prove this, but we won't look into it, okay? This is a basic idea, right? There's u1 plus that term, right? You will understand it, okay? And here k goes from 0 and here I goes from 1 to infinity, right? Okay. So now let's sorry. Now come to some basic definition and then we will see the problems, right? I hope it is a bit fast which I'm telling, but it is basically for a revision like thing, right? And don't worry, it will be crystal clear when we solve the problems, right? Okay. So what is the alternating series? Alternating series, for example, if I say 1 minus 2 plus 3 minus 4 plus 5 minus 6, like this, when there is a change in the sign, in the polarity, means one time it is positive, one time it is negative, and so on. It is alternating like this. Okay, then we say that it is a alternating series. Okay, I hope you are understanding. Okay, so test 6 we are coming to. For alternating series we are coming to test 6, and that is the Leibniz rule. Let's see what is it. Okay, let's see the rule first of all, that how it goes. For example, if you have series like this only, u1 minus u2 plus dot 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 like this. Okay, so what you do in this is you will check numerically, means you will take the mod u1 mod u2 and so on and so forth, and you will check whether the numerical values are decreasing or not. For example, 1 negative 1 by 2 negative 1 by positive 1 by 4 and so on and so on, like that. It may follow some pattern, right? So in that case you will check the modular value of this quantities, right? Okay, and if they are decreasing you will check limit as n tends towards infinity of u of n is equal to 0. If this and this condition are satisfied, means in this they are preceding or decreasing, right? And the limit as n tends towards infinity of un is equal to 0, then we say that the series is convergent, right? If it is not equal to 0, then we say that it's oscillatory, right? Okay, now we are coming to some more definition of conditionally convergent series. What are these? Well, let's see. For example, you are having u1 minus u2 plus dot dot so on and so forth. So you compare it with this u1 plus mod u2 plus dot 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 with this. You are comparing with this expression, right? So what basically is happening is that in this case, if this is convergent, then this will imply that this is convergent, right? This is 2, this is first. So if the second series is convergent, then it will imply that the first series is also convergent, since obviously it has a greater magnitude than this. So if the greater magnitude has a finite value, then it implies that the lesser magnitude also will be finite, right? Obviously, right? Okay, so in this case, when this is convergent, then and this is also convergent, we say that so 2 is implying the first to be convergent, right? So it implies that, so this condition is known as conditional, sorry, absolute convergence, right? Absolute convergence, right? I am not writing the complete spelling, but you should understand it. Okay, so it is known as absolutely convergent, right? This is absolutely convergent, right? This expression is the first one, right? And if this is divergent, if 2 is divergent but the first one is convergent, then it is said to be as conditional convergent, the first series, right? Okay, I've understood the basic idea what I wanted to say, and now we will come to the questions, and it will help you all to understand the concept better, right? So let me raise this and let's come to the questions. We will discuss many questions, right? Okay, so let's start with the first question. The question, it states that summation of un of where un is equal to n to the power 4 plus half upon 1 by 2 minus n to the power 4 minus 1 to the power 1 by 2, right? This is the question, right? So in this we will use the ratio test, right? Because you will face bit difficulty in integrating this stuff, right? So we will use ratio test. The maybe we can use comparison test, maybe, right? In that case, so I told that you take the ratio and take the limit as n tends towards infinity of un upon vn, and you solve for the expression. But how you take the limit, that is a big question, right? So first of all, we can take this expression in the denominator. which will make the things simpler. How? Let's see. Observe, you can write this expression n to the power 4 plus 1 raised to the power 1 by 2 minus n to the power 4 minus 1 raised to the power 1 by 2. You can write it like this: 2 upon n to the power 4 plus 1 raised to the power half plus n to the power 4 minus 1 raised to the power half, right? You can write it like this. You all can check it by rationalizing it. I won't discuss it. You all can check, okay? Just multiply by its conjugate, you will get this thing, right? Okay. So this is your un, okay? So you got un. How you get vn? Well, let's see. The vn you can assume as the power, the power of n, the final power of n. For example, n upon n cube plus 1. In this you will assume vn is equal to n by n cube, which is equal to 1 upon n square, right? This power upon this power, you get this, okay? So over here you get 1 upon n to the power 4 of half is equal to 1 upon n square is equal to vn, right? You got this thing, okay? So you get limit as n tends towards infinity of un by vn. You get this thing. What do you get? 2 upon n to the power 4 plus 1 raised to the power half plus n to the power 4 minus 1 raised to the power half upon 1 upon vn, and it will go upwards, it will become into n square, right? Since vn is 1 upon n square, so 1 upon n square, 1 upon n square, it will n square will go upwards, right? Okay, I have you understood it. So you get limit as n tends towards infinity of 2n square by n to the power 4 plus 1 raised to the power half minus plus n to the power 4 minus 1 raised to the power half, right? You get somewhat like this, and it is a limit which you can solve, and on solving you will get 1, and 1 is a finite value, right? So 1 is a finite value, okay, which means un and vn will be convergent and divergent together, right? So let's see what is vn. Vn is equal to 1 upon n square, right? 1 upon, let me change the chalk, right? Okay, so 1 upon n square, right? And you all know that 1 upon n to the power p is convergent if p is greater than 2, right? So if p is greater than 1. So you get vn is convergent, which implies that this expression is also convergent, right? Okay, from the comparison test, right? You can go back to that section and you can study again, right? So let's move to the further questions, right? We will discuss some important questions which can build your concept, right? Okay, we have very less time, so that is why I have to be in a bit hurry, right? Okay, so let's see some nice question. If let's do one more question. 1 upon 1 into 3 plus 2 upon 3 into 5 plus 3 upon 5 into 7. So let's make a general term in this, the un, right? How you will write un? Well, let's see. The upper terms are just a consecutive natural numbers, so you will get n. The denominator is the consecutive odd numbers product. You get 2n minus 1 into 2n plus 1, right? You got this, okay? So in this case, what you get? You get n upon 4n square minus 1. You get this stuff, right? Okay. So in this case, what if you apply the comparison test? In this case, you will get vn as n upon n square. You get 1 upon n, right? Okay, you get this. So you get un by vn as n tends towards infinity. You get n upon 4n square minus 1 into the 1 upon n will go upwards, it will become n, and it is equal to n square by 4n square minus 1 as n tends towards infinity. And you can solve it by several methods, and you will get the result as 1 by 4, I guess, right? This is finite, which means they both will be convergent or divergent together, right? Okay. But 1 upon n, the summation as 1 upon n is a divergent series, right? 1 upon 1 plus 1 upon 2 till the infinity is equal to infinity, means it tends towards infinity. Saying it equal to infinity is wrong, means it tends towards infinity, means it is not a convergent series, which means the expression is divergent, right? Okay, I hope you understood. Okay, now let's move to the second question. Let's see. Try to grasp the things in a more logical way rather than rote learning. It will help you all more, right? Okay. So let's see the question number 2, means whatever number. 2 raised to the power 2 upon 1 to the power p plus 3 upon 2 to the power p, and so on and so forth. What do you get? Well, n plus 1 upon n to the power p is equal to un. What is Vn? Vn is equal to n upon n to the power p, which is equal to 1 upon, right? Okay. Right? Okay. So limit as n tends towards infinity of un by Vn, you solve it, you get n plus 1 by n to the power p into n to the power p minus 1, you get n plus 1 by n. As n tends towards infinity, it will be equal to 1, right? This is finite again, so it will depend upon Vn, and Vn, since we know that 1 upon n to the power x is convergent if x is greater than 1. Here x is p minus 1, so p minus 1 is greater than 1, so p is greater than 2. So this expression is convergent if and only if p is greater than 2, right? I hope you understood. Okay, that is the basic idea. Okay, now move to the next question. Let's see. The next question states summation as n goes from 1 to infinity of n square by 3 to the power n, means you are given un n square by 3 to the power un, right? In this you can't apply the comparison test, right? I hope you are understanding it, right? So in this you can see it is 3 raised to the power n, which means you remember Cauchy root theorem, Cauchy root rule. In that, what you are doing, you are doing un raised to the power 1 by n. So in this, if you do raised to the power 1 by n, this 3 raised to the power n will vanish. So it will make the calculation very easy. So let's do it. You raise both sides, you apply Cauchy root theorem, right? In this case, okay. So in this case, you will get n to the power 2 upon n upon 3, and you get limit as n tends towards infinity of n to the power 2 upon n by 3. And I guess if I am not wrong, this is equal to 1 upon 3, right? If I am not wrong, the limit as n tends towards, let's solve this limit. I hope you all know how to solve, but still let's solve. N to the power 2 by n, let's say it equal to L. You take ln L, you get ln n square, or 2 you bring it out and you get by n. As n tends towards infinity, I'm not writing this is due to the shortest of time, but you all know that it is going towards infinity, right? Okay, let me write it only like this. So ln L, and you apply the L'Hopital rule, you get 2 upon n, and as n tends towards infinity, you get L is equal to 1. Okay, so this is equal to 1 by 3. Okay, so it is less than 1. So Cauchy root theorem states that if this expression, the limit is less than 1, then the limit is convergent. So series is convergent, so this is convergent, right? Okay, simple idea, simple thing, right? Okay, okay. Sorry. Okay, so now let's start another question. X plus x square by 2 plus x cube by 3, so on and so forth till infinity. So you are getting s to the power n upon n, right? This is the un. Very simple, right? So again you say see a power of n. So what? When you see the power of n, you again apply the Cauchy root theorem, and in this case you will get x to the power n by n raised to the power 1 by n, right? You will get this. Okay, so when you get this, you just solve x upon n to the power 1 upon n as n is tending towards infinity, right? Obviously you should write the complete statement that what you are doing. I am just here to guide you also, that is why I am just writing like this. Okay, so basically you get the limit as x, so it means this is convergent when x is less than 1 and greater than 0, right? Okay, so that is the thing. Okay, basically you can say this thing only, and it is divergent for x is greater than 1, right? Okay, okay, so now let's see the next question. Okay, the next question states that the sum as n goes from 1 to infinity of n upon n plus 1 raised to the power n square, right? Again you see that un is equal to n upon n plus 1 raised to the power 1 raised to the power n square. You can see a n power, right? So in this, what you will do, you will again apply the Cauchy root theorem, and what you will get is that n upon n plus 1 raised to the power n square, and as un is equal to this quantity, so what we will get, so now we will apply the Cauchy root theorem, and in this we will get un raised to the power 1 by n. You get limit as n tends towards infinity of n upon n plus 1 of n square by n. You get limit as n tends towards infinity of n by 1 plus n raised to the power n, right? You get this, and notice that if you do it like this, limit as n tends towards infinity of 1 plus 1 upon n, just notice I have reversed the things, negative n, you get e raised to the power minus 1. This is a tricky part, you should understand what I have done. You know that limit as n tends towards infinity of 1 plus 1 upon n raised to the power n is equal to e, right? You know this. Okay, so just we are doing that thing, and in this I just reciprocated this, right? Okay, so let's move on to the next question. Since it is less than 1, it is 1 upon e, which is less than 1, which implies this series is convergent. Okay, so now let's move to the next question, right? Okay, so let's see, the next question is this one you will do on your own. The summation 1 plus 1 upon root n raised to the power minus n raised to the power 3 by 2, you will apply again the same thing, and you will end up getting this thing, right? Limit, you will end up getting limit as n tends towards infinity of 1 upon root n raised to the power negative root n, right? You get this, and you will again get this quantity, right? You all can solve it and check, right? Just apply Cauchy root theorem again. So whenever you see a power of n, you apply Cauchy root theorem, right? Okay, now let's see another expression for let's see for alternating series also. Okay, so let's see for the alternating series, you get 1 upon a minus 1 upon a plus b plus 1 upon a plus 2b, so on and so forth, for a comma b greater than 0, right? Okay, so let's write the general term. What we get negative 1 raised to the power n minus 1 as n goes from 1 to infinity, right, of 1 upon a plus n minus 1 into b, right? Okay, so either you can apply the DLM bars over here also, you can apply that. Let's see, but no, you don't need to actually. This is the alternative series, so there is only one rule in this, the Leibniz test. What you will do is, you will check the mod first of all. So 1 upon a plus b, 1 upon a, 1 upon a plus 2b, since all are positive terms, so it is gradually decreasing. That means the first condition is tested, right? Now check the second condition, the limit as n is tending towards infinity of 1 upon of un, sorry, of un, and it is equal to limit as n tends towards infinity of 1 upon a plus n minus 1 into b, and this is equal to 0 in fact. which means this series is convergent. So it is satisfying the Leibniz test, right? Okay. So now let's see another question. I have to be in a hurry because uh, we don't have much time. That's why. So now let's see the next question, and it states, show that the series cos of pi n by n square n goes from 1 to infinity is convergent. So at first when you see this term you get panic that how we will solve the trig function over here. So basic idea is that when you substitute 1 you get cos of pi, and when you substitute uh, you substitute 2 you get cos of 2 pi, means it is the auxiliary function, it is going from +1 and -1 only, right? So basically it is written as -1 upon n square plus 1 upon means 1 plus 1 upon 2 square and so on and so forth, right? Which is basically when you so now in this you will check for the convergence using absolute and conditional convergence, right? So in this how you will check, you will use 1 upon n square term, right? In this this is somewhat like this, -1 raised to the power n by n square, right? In this case, so you have just applied the mod and you got this. So this, as p is greater than 1, so it is convergent, which implies that this expression is absolutely convergent, right? So which means this is also convergent, right? You all know, remember that theorem na, that in mod we were writing like this, u1 minus u2 and so on and so forth, and I was saying take the mod and just add them, right? This thing. So if this expression will be convergent, then this will imply that this expression is convergent, and that is known as absolutely convergent expression, this one, right? And if this one is diverging and still this one is converging, then it will said that it is conditionally convergent, right? Okay. So now let's come to the next question, right? If you have any doubt, you can comment me or message me, right? So let's see one more question. The question states, show that the summation as n goes from 1 to infinity of 1 upon n factorial is convergent. We have to prove this. So it is a very simple expression, right? So in this you will apply D'Alembert's test. How? Let's see. Let's see if we apply the D'Alembert test, what we get. Okay, you will get limit as n tends towards infinity of u of n plus 1 by un, right? You got this. Okay, you will get 1 upon n plus 1 factorial into n factorial. As n is going towards infinity, you will write like that, limit as n goes to infinity, right? Okay, so I hope you are understanding it, right? Okay, so you get n factorial upon, you can apply the property of factorial, that n factorial is equal to n into n minus 1 factorial. You apply the same thing over here, n plus 1 into n factorial, you get cancelled, right? N factorial gets cancelled, and this is equal to 0. And in the D'Alembert's test, if the lambda comes out to be less than 1, then we say that the series is convergent. So this means this series is convergent, right? Okay, you have to just remember that how the things are going, and then you can calculate it. Okay, so now let's start with okay, so we will see one more question in this, and in this we are given that x upon 1 plus x minus x square by 1 plus x square plus x cube by 1 plus x cube, so on and so forth. So and here we are given that x is lying between 1 and 0, right? So this is again an alternating series. So in this we will apply just that thing, x upon 1 plus x, and what is the next term? It is x square by 1 plus x square, and notice that it is again a decreasing series, right? How? X upon 1 plus x, imagine if it is you can write this as 1 upon 1 plus 1 upon x, right? So you get 1 upon 1 plus 1 upon x. Just imagine if this is less than this expression, means the next expression, means you are assuming this, right? You are assuming this. Okay, 1 upon x square, you just solve this, you will get 1 upon x square 1 plus 1 upon x square less than 1 upon 1 plus x, right? You get this, and you get, on solving, this and this will get cancelled, and when you will reverse you will get x square is greater than x. But this is wrong in this domain, right? Which implies that this inequality is wrong and you will get this inequality, means it is a decreasing expression. So we will get, so we can directly write that limit. So the first test is verified, means the first condition of the Leibniz test. So we will apply the second condition as n tends towards infinity of x to the power n upon 1 plus x to the power n, right? You will get this, and when you solve limit as n tends towards infinity 1 upon 1 plus x to the power negative n, right? And notice that since it is between 0 and 1, means for example 0.5 raised to negative infinity, what you will get? Imagine you'll get 1 upon 1 plus 1 upon this quantity, and you will get over here 1 upon 0, right? You will get this, means you will get 1 upon means 1 upon 2 raised by infinity, just imagine. So this is equal to, in fact, 0, right? So this is the condition. Okay, so this will be equal to, just a minute, yeah. So notice that x is between this quantity. So if you get if you check in this domain, for example x is equal to 0.5, just to verify you can imagine 0.5 raised to the power negative infinity, you got this. So you get 1 by 2 raised to the power negative infinity, which is equal to 2 raised to the power infinity, right? Which is equal to, which is tending towards infinity. Obviously you can't write exactly infinity, but just to explain I'm writing. So as n tends towards infinity of 1 upon x to the power negative infinity, this is equal to 1 upon 1 upon infinity, which is equal to 0. Since this limit is satisfying and we are getting this, so we will get, so we conclude that this is convergent, right? So that's it. I hope you all understood the lecture, and if you like this, then please do like, share, subscribe my channel, and thanks a lot for watching. Bye bye, take care. Hello everyone, this is Aditya, and today we'll cover integral calculus for n-term BTech. So in this we'll cover like two topics: the convergence test and beta and gamma function, right? So in this we are gonna cover all this, and please do like, share, subscribe my channel. And I'm a bit not well, so that is why kindly bear with it. And now let's start with the topic. So let's start with the convergence test first. So like you all know that what is improper and proper integral. Let me give a gist of that, but it is not really important, so that is why I'm skipping all that. And like mean theorem and all, everything is there. I might cover in the on Saturday Sunday lecture, right, a bit of that, but it is not important. So kindly, the topics which are missing, which I am missing, maybe they are not important, somewhat like that. Okay, so kindly bear with it. And now let's start. Okay, so first of all, let's see what is improper integral, right? Suppose an integral of the form negative infinity to a fx dx, or suppose negative infinity to infinity of fx dx, or b to infinity fx dx, right? Or suppose a to b fx dx, but there exists some c belonging to a to b such that f at c is not defined. So in such cases we say that the integral is improper, and we need to cover and we need to take the limit case in that. For example, in this we will break the limit from a to c, then from c to b, and then add them, right? And in this case we will use limit as r tends towards infinity of negative r to a, right, like that. But it's really not a big deal, you all know this. So I am skipping this part because it is a bit logical also, and even if you don't use that, it won't affect. But at last when you substitute the limit, it will be like you have to use the limits, right? When you substitute the integral limits, then if it's infinity or it is breaking at somewhere, then it's obvious you will use the limiting case, right? So I don't think so that it is much need to be taken care of, you all can understand it. But basically, like if it's a to b fx dx, you all know that it will be equal to limit as b tends towards infinity of a to b of fx dx, and you will integrate it, right? It's obvious, right? Okay, so now let's coming to the convergence test. That is the really important topic of today's video, and then the beta gamma function, and that is really important, right? So let's start with the convergence test, and then we'll move to the beta and gamma functions. I hope you all are understanding it. Okay, so now let's start. Okay, so let's see the comparison test. The first one, comparison, right? So we'll study the comparison test first of all, right? So in that case, and I have to be a bit fast because we don't have any time, and I have to make the other lectures also for multiple integral and for the application of integrals, right? So this is like for in this from this lecture you might score from like 10 to 15 marks. Obviously, it's obvious since beta and gamma function carry a huge weightage, and the convergence also, it is obvious that it will come, right? Okay. So the best thing about the convergence test is that it is somewhat relatable to the sequence series term, the sequence series convergence, right? In that case also we used to use the ratio test, somewhat like that, comparison test and all, right? So the same thing we will use over here, but as in a different reference. Okay, let's see. Suppose fx sorry, suppose your fx is given and it is less than gx, right? And you have to check for the convergence of fx convergence. What does it mean? If fx is less than equal to gx, then doesn't it imply that integral from a to infinity of fx dx will be less than integral a to b, a to infinity of gx dx? Doesn't it imply, because since they both are positive always, so there is no chance that the integral will go downwards, then there might be a subtraction of area, somewhat like that. It's no chance. So that is why in this case we will get that we'll get this inequality. So what does it imply? It implies that if this integral converges, then it implies that this integral will also converge. Why? Because if something greater is converging, it will imply that something smaller will also converge, right? I hope you are understanding it. Okay, so I hope you are understanding it and it's not a bit fast. Okay, if you have any doubt you can comment me, right? Okay, and I will cover that thing. Okay, and notice that this is smaller integral, so if a smaller integral will diverge, then this will imply that the greater integral will also diverge, because if the smaller thing is diverging, that is obvious that the bigger thing will also diverge, right? It's a bit logical, so I'm not going deep into it, right? We will see it in the later part. Okay, this is the basic idea. Okay, and it is somewhat related to sequence series lecture also, which I've taken, the comparison test which we used in that. Sorry. Now we'll use the limit test. Okay, so now we are going to use the limit test. How we use it? Okay, suppose fx and gx are two functions, right? They are integrable functions. Okay, means they are not breaking anywhere, right? Okay, so we say that limit as x tends towards infinity of fx upon gx is equal to lambda, and lambda is a finite value, right? So lambda is a finite value. Okay, given lambda is a finite value, so it implies that they both will either converge together or diverge together if lambda is a finite value, which means that if fx converge, that implies that gx will also converge. If fx diverge, it implies that gx will also diverge, and if gx diverges, then it's vice versa, right? If gx diverge, it will also diverge. If gx converge, it will also converge. If this converges, this converges. This converges, this also converges, right? Okay, so that is the thing, basic idea. Okay, so now let's see another test, and that is really important, and I will tell the reason also behind that test, why we basically use it, right? Okay, so now we are going to start with the mu test, and that is really important. So mu test, we will study for two cases: integral a to infinity of fx dx integral, and the second thing for integral a to b fx dx, right? In these two cases, when this is improper, this is proper, right? So in case of proper integral, it will be different, for the improper it will be different. And to a great surprise, this is somewhat related to the ratio test. How? I will discuss it. So let's start with the first condition. First of all, the improper one. Let's see how it goes. Okay, so basically you get this thing. Okay, in this you assume gx as equal to 1 upon x to the power mu. So by this mu term out of nowhere. Well, let's see. Basically, we define our function 1 upon x to the power mu, and in this case we evaluate using p-test. You remember in sequences we used to use p-test. Somewhat it is relatable to that, but not exactly it is that. Okay, we will see how. Okay, so don't panic, we will study and we will see clearly. So limit as x tends towards infinity, where mu is a real value. Okay, don't forget it. Mu belongs to real numbers, obviously it can't be imaginary for our case basically. So in this what we are getting is that, so as limit x is tending towards infinity, what we are getting, sorry there was some disturbance, that is why. Okay, so what I was saying, that limit as x is tending towards infinity of fx by gx, it must be defined, right? This is the idea, right? So it will be equal to limit as x tends towards infinity of fx upon 1 upon x to the power mu, and it is equal to limit as x tends towards infinity of x to the power mu of fx dx, and suppose it comes out to be lambda, where lambda is some finite value again, like in the ratio test. That is it. Okay, so if this comes out to be lambda, so in that case a finite value, so this integral 1 upon x to the power mu, it converge for mu greater than 1 and it diverge for mu less than 1, right? So we know that from the ratio test, if gx is converging, then this will also converge, and if it's diverging, then this will also diverge from the ratio test, that they both go together, which means this is convergent for mu greater than 1 and this is divergent for mu less than 1, right? I hope you're understanding it, and why it works, let's see, because we need to know the reason also, since it helps a lot, right? Don't worry, it won't take much time, just 1 minute. So as an integral a to infinity 1 upon x to the power mu dx, you write it like this. To convert it from improper to proper, you write it as b tends towards infinity of a to b of 1 upon x to the power mu dx, you get this thing. And now what's next? Well, let's see. What's the next thing which we are gonna do? Well, let's see. Simply integrate it. What do you get? Limit as b tends towards infinity of 1 upon 1 minus mu into 1 upon x to the power mu minus 1, and the limits a to b, right? Just solve it. Okay, you will get this. Now you just substitute it like this. Limit as b is tending towards infinity of 1 upon 1 minus mu of 1 upon b to the power mu minus 1 minus 1 upon 1 minus mu into 1 upon a to the power mu minus 1. Don't be in a panic, I just substitute the limits, right, and take a difference. Okay, nothing else. Okay, so basically you can make this a plus and make it mu minus 1, right? Is it correct? Okay, is it correct? Yeah. So in this case, observe that this is a finite quantity, but the problem is over here. For 1 minus mu also it's fine. We have to check for limit as b is tending towards infinity of 1 upon b to the power mu minus 1. So notice that if you take something greater than 1, in this case, what you will get? You will get 1 upon infinity, right? 1 upon infinity to some positive power. So if mu is greater than 1, then in that case the limit as b is tending towards infinity of 1 upon b to the power mu minus 1, it will tend towards 0, since it will become 1 upon infinity to some positive power, right? So it will remain in the denominator. So 1 upon anything 1 upon infinity to the power some positive power, it will go towards 0, right? But if mu is less than 1, then limit as b is tending towards infinity of 1 upon b to the power sorry, I said I'm not well, that's why. So in this case, when mu is less than 1, it will become mu minus 1 and it will become a negative quantity. So 1 upon b raised to power some negative quantity, you will get this. So some negative quantity 1 upon infinity raised to some negative quantity, it will tend towards infinity. So that is why it will diverge for mu less than 1 and will converge for mu greater than 1. Okay, so that is how you prove it. Okay, that's the basic idea of the mu test for the case 1. Now let's see for the case 2. Okay, I hope you are understanding it. It's like very basic, the integral. Okay, it's just a fancy way to call integral, like proper, improper, somewhat like that. Okay, but I don't care much about it. Nor you should also. You should just work on the questions and how to tackle them. Okay, this is the basic idea. Okay, So now let's see another type, integral a to b fx dx. So in this case we have to check the convergence of this function, right? So how we'll do it? Okay, let's see. So what we will do in this is that we will assume a g of x the same as that, but with a difference of a, x minus a to the power mu, right? Just assume it for the time being. And when you apply the ratio test, you get fx upon this quantity, you will get x minus a to the power mu of fx. As x tends towards infinity, this will be equal to lambda, and it is a finite value. If it is a finite value, then this expression, see, gx is convergent. In this case, for mu greater than 1, it will diverge, and for mu less than 1, it will converge. Now many ask me that why opposite in this case? In that case, it is like it is for positive value, for mu greater than 1 it is converging, and why in this case it is diverging? Well, let's see how we will do it. Okay, so let's see. This is the basic idea which you know. Now we will see the proof. Okay, so let's see the basic idea that integral a to b of 1 upon x minus a to the power mu dx, right? Okay, so what you are getting in this, you integrate it, you will get 1 minus mu as a common, and you get limit as x tends towards like when you substitute b, it's okay, 1 upon x minus a to the power mu minus 1, right? To, as it goes from a to b, right? So 1 upon 1 minus mu of 1 upon b minus a to the power mu minus 1 minus, notice that if you substitute a directly over here, you will get 1 upon 0, which is not possible, right? To have a denominator as 0. So you substitute limit x tends towards b of what? Let's see, of 1 upon x minus a to the power, sorry, limit as x tends towards a. And I'm really sorry, there's one problem there. When I said x minus, in that case we will apply this limit as x tends towards a positive of fx by x minus a to the power mu. Notice that in this we will take this for the second case. I'm really sorry, it will not be from infinity, it will be from limit as x tends towards a plus, x is tending towards a positive, right? So in that case it will be fx by x minus a raised to the power mu, and in that case we will get a lambda, right? So in this case we are going to get a lambda. Okay, it is not that, it is not this. Okay, remember this. I'm really sorry, it is 1 upon this quantity. I'm really sorry, I'm not well, that's why. So this is not the case, this is correct. Limit as x tends towards a positive of fx into x minus a to the power mu is equal to lambda, right? This is the case, remember it. Okay, this is correct, not that. Okay, remember it. Sorry, I'm really sorry for that. I will correct it in the later part of the video also, okay, if I made any such mistake. Okay, so basically you got this thing, and now what's next? Okay, so just observe that limit x tends towards a of 1 upon x minus a to the power mu minus 1, right? So notice that if mu is greater than 0, so 1 upon 0 to the power some theta, suppose, where theta is greater than 0, it's obvious that it tends towards infinity, right? For mu greater than 1, right? Since 1 minus something greater minus 1 is always positive, and 1 upon some 0 raised to the power some positive power, it will go towards infinity. And for mu less than 1, it will 1 upon 0 to the power some negative value, some negative theta you can say, and this goes towards 0, which means this integral is defined for mu less than 1, is convergent for mu less than 1, but is divergent for mu greater than 1, right? I hope you understand why there's a difference. Okay, that's the idea. And one thing to be noticed that if fx is this integral a to b fx dx, so it will be limit as x is tending towards a positive of fx by gx, right? And where gx is equal to 1 upon x minus a to the power mu, right? Remember it. Okay, I made a mistake over here, I wrote infinity, it's not infinity in this case, it's a positive, right? Okay, so now let's see if there is any other test, or we will start with the question. Okay, let's start with the question only. So I'm a bit fast right now because there's a lot of things to be covered, right? But I will make sure that you all understand it, and if you don't understand, you can comment or message me. Okay. So now let's come to the first problem of it. Question number 1. The show that this integral is, check whether this is convergent or divergent. We have to check this. Okay. So now we discussed about mu and p test in sequence, series and integrals. But how we calculate the mu in this case? Well, you take such mu such that when you calculate, you try to get a finite value, right? How? Let's see. Or basically you take from the ratio, you get gx as x to the power 3 by 2 upon this x square, simply you get 1 upon x to the power half. This is your gx, and mu is equal to negative 1 by 2, right? And mu is equal to 1 half, right? Okay. You got this? Why didn't I took like 1 by 3 or somewhat like that? Sorry, like 3 by 2 or somewhat like that, because if you put 3 by 2, for example x, for example 5 by 2, I take gx as 1 upon x to the power 5 by 2. Let's see, 3 by 2 by 3x square plus 5 into 1 upon x to the power 5 by 2, right? You get this. Okay, you will get like it will go upwards, it will go x to the power 4 by 3x square plus 5 as x is tending towards infinity, and notice that it will go towards infinity, right? But we try to make such things such that we get a lambda as a finite value. So that is why we will use x to the power halves. In that case, we will get a finite value so that we can easily test the convergence test, right? Let's see. We are basically choosing such a lambda, right? Such a mu, okay? Basically. So in that case, it will be limit as x tends towards infinity of x to the power 3 by 2 by 3x square plus 5 upon gx. Gx is this quantity. 1 upon x to the power half, you get x to the power x square by 3x square plus 5 as x is tending towards infinity, and it is equal to 1 by 3. This simple limit you can use L'Hopital rule also, or you can simply use the limiting case, right? That is very easy. Okay, you can bring x square downwards, something like that. Any method you can use. This is a basic limit. Okay, I am not going into it. Okay. Right, is it correct? Okay, so it is a finite value, which means they both will be either convergent or divergent. So for mu equal to half, and this is an improper integral, so in this case mu is equal to half, which is less than 1, so it is a diverging integral. Gx is diverging, so this is also diverging, hence proof that is a diverging. Okay. Okay, so now let's see another question. Sorry, there was some disturbance, and now let's see the question number. Let's see the question number 2 now. Okay, so the question is like we need to evaluate integral. We have to show that this integral is convergent, right? So in this I'm not covering too high level questions because there's very less chance that they will come even. So we are discussing the basic idea that how the things go, and we are evaluating the things and building a concept. And now in 1 or 2 days before the end sim, I will make a one shot of 1 or 1.5 hour. In that I will cover all the questions from the Rolle's theorem to the multiple integrals, right? So it will be very easy for us to understand the concept. So like this, we are given that fx is equal to this thing e to the power negative x square. So in this case, we are going to assume gx is equal to x square, right? It will be easy for our calculation, right? Okay. So how we are going to evaluate it, right? You can assume 1 upon x square, you can assume any quantity, right? It don't matter. For the simplicity, we have assumed 1 upon x square, okay? So basically now we will apply the ratio test, limit as x is tending towards infinity of fx by gx is equal to the limit as x is tending towards infinity of e to the power negative x square by 1 upon x square. You can just simplify this and you get limit as x is tending towards infinity of x square by e to the power x square, right? As you notice that if you take x cube or x to the power any value, it don't affect, right? Okay, that's the thing. So I prefer to take a positive value in this case, means it is easier for us to calculate, right? So this thing is tending towards 0, it is a finite value, right? Okay, since it is finite, which means they both will be either convergent or divergent, right? Okay, in this case the mu is greater than 2, greater than 1, and it is an improper integral, so which means that this will be convergent. So which means this is convergent, so this implies that this will be also convergent, right? Hence proof. Okay, now let's see one more question and then we'll move on to the beta and gamma function, right? Because that is the heart of this chapter actually. So let's see the question number 3. For now, 0 to pi of sine of x by x cube dx, right? So notice that in that case what will happen is that the limits are defined in both the cases. So in this case we will assume gx is equal to 1 upon x square. Why 1 upon x square? Why? We will not assume 1 upon x square. We will assume 1 upon x minus a whole square, since we try to find such a value such that the lambda is defined, right? If you substitute x square over here, it will sin x by x as x is tending towards 0. Here it is 0, right? Why? Because it is a proper integral, right? So here a is equal to 0. So 1 upon x minus 0 the whole square, which is equal to 1 upon x square. Which means limit as x is tending towards a positive, that is 0 positive, of fx by gx is equal to sin x by x cube into 1 upon x square, which is equal to limit x tends towards 0 positive of sin x by x, right? This will be the case. I hope you are understanding it. And this is equal to 1. And since it is equal to 1, it is a finite value. So which means if this converge, then this will also converge. So notice that in this case the mu is equal to 2, which is greater than 1. But notice that in this case it is a proper integral. So in this case, when mu is greater than 1, in that case it will imply that this expression is diverging, which means that this will also diverge. I hope you are understanding it. Okay, so now let's see if we have any other question left, or we can directly move on to some other topic, right? So let's directly move to, there's a Cauchy principal value which we need to study, then we will move to gamma and beta function, right? And it's really an interesting function, right, to start with. And don't worry, we will do one shot questions also, so everything will become clear more. So let's see the Cauchy principal value. What is it? States that it states integral negative infinity to infinity of fx dx is equal to the integral as r tends towards infinity and r tends towards 0, right? This is the case of integral negative r to some quantity x minus r. This is your x minus r plus integral x plus r to the power r fx dx, right? Are you understanding it? And this will be fx dx of course, right? Okay, so this is your Cauchy principal theorem, but I don't think so there will be any question from it, but still I've told if it comes you can solve it. Okay, okay, so now let's go to the gamma and beta function, and let's start with this. Okay, so let's see the gamma function and the beta function. Gamma function, right? Let's see, and let me change the chalk. Okay, so this is the integral. It states that the integral 0 to infinity of x to the power n minus 1 e to the power minus x dx is equal to gamma of n is equal to n minus 1 factorial, right? This is the case. Okay, okay, so notice that why is it true and why we are even bothered about it, because this function is used to define the gamma values or the factorial values of negative numbers or even the fraction values, right? We generally study fractions, we generally study the factorial terms in the cases of permutation combination, so it is really absurd to think about something like a fractional factorial, like it's something really out of the reach of humanity. But in quantum mechanics and data science, many times we are like encountered with such problems, so like that so that's why gamma function is so much important, right? Okay, So let's see a proof of this, that y is it equal to this. Okay, let's see. Integral 0 to infinity x to the power n minus 1 e to the power negative x dx. So just assume that this is your first function, this is your second function, and just use integration by part. Okay. So what is it? X to the power n minus 1. What is the integral? It will negative e to the power negative x as it goes from 0 to infinity. Obviously, you will use limiting case over here, but I'm not using it, but you should use, right? Minus integral 0 to infinity. Let me break the chalk so that it's easier for me to write. Of n minus 1 into e to the power negative x, and a negative x will come in the denominator, which make this plus x to the power n minus 2 into dx, right? This is the case. And notice that when you substitute, when you do it like this, it will become x to the power n minus 1 by e to the power x 0 to infinity. Notice when you substitute 0, you get a 0. Limit as b tends to, as x is tending towards infinity, of negative x to the power n minus 1 upon e to the power x. This exponential is the increasing function in comparison to this function, which means this will go towards 0, right? Minus plus, this will become 0 by some e to the power 0, which is becoming what? This is becoming 0. So basically this expression is this. How we write it? Let's see. We write it further that this is n minus 1 into integral 0 to infinity of x to the power n minus 2 into e to the power negative x dx. And to a great surprise, you will observe that this is equal to n minus 1 into gamma of n minus 1, right? Don't you agree to it? Yeah. You just make it like this, n minus 1 minus 1, right? So it is gamma of n minus 1, right? Okay. Which means that you proved a relation, this, that gamma of n is equal to n minus 1 into gamma of n minus 1, or gamma of n plus 1 is equal to n into gamma of n, right? Okay. And I hope this was asked in your test also, right, yesterday, I guess, in the CA, right? So, but what we have to do from this? Well, you substitute another thing, you will get n minus 1 into n minus 2, so on and so forth till gamma of 1. 3 into 2 into 1 into gamma of 1. And what is gamma of 1? It will be, it is 0 to infinity of, you substitute 1, you get x to the power 0. So e to the power negative x dx. And it's a very simple integral. When you evaluate it, you will get it 1. So this is 1, right? Okay. So you get gamma of n is equal to n minus 1 factorial, right? Hence proved. Okay. Now let's see some problems. But before that, we need to study the beta function also, right? Let's study beta function and then we will move to the problems, right? And okay, let's see. So beta function, beta, it is a multivariable function actually, and it is equal to 0 to 1 of x to the power m minus 1. We generally use t also, so it don't matter. 1 minus, but it, c variables can be any, okay. 1 minus x to the power n minus 1 dx. This is your beta function, okay. Sometimes we use it in reference of a sine and theta function. How do we check it? Let's see, okay. Obviously m and n are positive, okay. 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 Now substitute x is equal to sine square theta, right? Okay. Limits are from 0 to pi by 2. You substitute 0, you get theta as 0. You substitute pi by, you substitute 1, you get sine of theta is equal to 1. So you get sine, your theta is pi by 2, right? Okay. Is it correct? Is it correct? Yeah. Okay. So you get this sine raised to the power 2 of m minus 1 into theta into 1 minus sine square theta n minus 1. What is the derivative of this function? It is equal to 2 sine theta into cos theta, the chain rule, okay. Notice that dx is equal to 2 sine theta cos theta d theta, right? You get this? It is very simple. Okay, 2 sin theta cos theta d theta, right? You get this? Okay, so from this you get 2 times integral 0 to pi by 2 of sine to the power 2 m minus 2 into the cos theta into cos of this 1 minus sine square is cos square, cos square multiplied by this, you get cos of 2n minus 2 theta. How? See na, uh, um, 2 raised to power a into b is equal to 2 raised to power ab, right? Notice this thing, okay? You remember this property of exponents, right? Just remember some properties, right? It is really helpful for calculation purpose, right? Into sine theta into cos theta d theta, right? Okay, okay. So now let's see, you get 2 of 0 to pi by 2. This just multiply them, you get sine of 2m minus 1 theta to cos of 2n minus theta d theta, and this is equal to beta of mn, right? This is another form of the beta function, right? So you got these two functions, right? Okay, so what's the use of this beta function? Well, let's see, it has a very big use. Let's see how. Okay, so let's see, do you know a relation between gamma and beta function? Well, let's see, beta of mn is equal to gamma of m into gamma of n by gamma of m plus n, right? Okay, and beta of m n is equal to the integral 0 to 1 x to the power m minus 1 into 1 minus x to the power n minus 1 dx, right? This is the thing, which is equal to 2 times integral, don't forget this 2, right? This is really important, right? Okay, 0 to pi by 2 of sine of 2m minus 1 theta of cos of 2n minus 1 theta d theta, right? And you know the gamma function, gamma of n is equal to n minus 1 factorial is equal to the integral 0 to infinity of t to power n minus 1 e to the power negative t dt. You can use x also, it don't matter. Okay, so just observe these formulae, these are really important, right? Okay, just remember these three, these, and this relation is really important. This one is, it's like very important. Okay, so let's see if we can see some nice calculations. Let's see, actually I'm a bit very much tired, so that is why I'm trying to be a bit fast, and we don't have time also, right? Okay, so now let's see some problems, and then we will wind up with the things. And with the proof of gamma and beta function, we will have to see double integrals. Though I can prove it without double integral also, but I don't think so. If the proof comes, it will be like that. It will be like that. You have to prove using double integrals. That is why it's wastage of time right now. But I will surely make a video on it. Okay, how to prove it. Okay. So now let's solve integral a to b of x minus a to the power m minus 1 of the quantity b minus x of n minus 1 dx, and here you need to prove that it is equal to b minus a raised to the power m plus n minus 1 of beta of m comma n. Let me change the chalk first of all. Yeah, okay, so you have to prove this expression. This is b, okay, this is b, right? So how do we need to, so how do we prove it? Well, let's see solution. Well, notice that you have x minus a and then b minus x, so it is the alternating type of thing, which means we need to convert it to some polar thing, right? If you remember, you will assume is equal to a sine square theta plus b cos square theta, right? You will assume this thing. Okay, okay, I hope you are understanding it now. It is very simple, but it is just very much manipulative. That is the thing, means you have to really think a lot before any calculation, like the manipulation is really important in this chapter, right? So please do work upon the manipulations and like that. Okay, but like 3-4 manipulations are enough for this chapter. Okay, you don't need to worry much. Okay, so now let's see this. Okay, so just see the limits, it will be changed to like 0 to pi by 2. How? You substitute a in place of x, right? And you will solve, you will get this. Okay, how? Well, in that case you will just substitute a, then you will solve for theta. In that case you substitute b, you will solve for that. Okay, let me tell. So you substitute A is equal to A sine square theta plus B cos square theta, and you get A 1 minus sine square theta, right? Here it will become cos square theta is equal to B cos square theta, since A is not equal to B, which implies that cos theta must be equal to 0. So cos theta is equal to 0 implies that theta is equal to pi by 2, right? Theta is equal to pi by 2, right? You will get this, okay? And for similarly, you can solve for the upper limit, it will be theta is equal to 0, right? Okay. And when you differentiate it, what you will get? You will get A, it will basically A minus B 2 sine theta minus 2 sine theta into cos theta, right? D theta, right? And you substitute over here, you will get x minus A minus this one. Let me tell how to calculate it, okay? This is your derivative term, okay? So now x A sine square theta plus B cos square theta minus A, what it will become? It will, you can take minus A as a common, you get minus A of 1 minus sine square theta plus B cos square theta, right? So you get basically cos square theta as common, and you get B minus A, right? Is it correct? Yeah, it is correct. So raised to the power this quantity, so you get B minus A, just forget about the limits right now, B minus A to the power m minus 1 into cos to the power 2m minus 1, right? 2m minus 2, right? Into theta. And simply when you substitute this B minus x, what you get? B minus this quantity A sine square theta minus B cos square theta, you get B sine square theta minus A sine square theta, and you get B minus A to the power sine square theta, right? It's a bit long lecture, so that's why. Of the quantity B minus A of n minus 1 of sine 2n minus 2 theta into now this quantity, this A minus B into, I have to erase that stuff so that it becomes clear how we are exactly using it, okay? So let's solve it. Of this quantity into this is 2 sine theta into cos theta d theta, right? Okay, so you are getting this thing, and let's see what we can do further. Notice that the limit was from pi by 2 to 0, right? You are getting this, okay? So I hope you are understanding it, okay? And now when you solve it, what you will get is that you solve this, you get 0 to pi by 2 of b minus a to the power m plus n, m plus n, m plus n raised to the power sorry, m plus n means it will be m plus n minus 2 into this quantity. Since why we change the limit from 0 to pi by 2, since it was b minus a, it was a minus b, I converted to b minus a, right? That is the limit it's going to change, right? So I put a negative sign and the limit changed, okay? B plus n minus 1 sine 2n minus 1 theta into cos 2 m minus 1 theta d theta, right? Of, and we bring a 2 outside, right? So you get 2 times the integral 0 to infinity of b minus a to the power m plus n. Wait, I have to erase this thing. You get b minus a to the power m plus n minus 1 2 of the integral 0 to pi by 2 of so we get the integral 2 into integral 0 to pi by 2 of sine of 2n minus 1 theta into cos of 2m minus 1 theta d theta. And notice that what is this? It is equal to b, and this is equal to the beta of n comma m, right? And there's a property of beta function that beta of m comma n is equal to beta of n comma m, right? So we are just going to substitute this, and you get b minus, let me write it upwards, so it will be equal to b minus a to the power m plus n minus 1 of the quantity this thing multiplied 2 also, right? You get beta of n comma m, but we know this property, so we write m comma n, and that is what we needed to prove, right? Okay, so that is the thing. Okay, so now let's see another question. Sorry. Okay, so let's see what other question we can discuss. Well, you need to prove that gamma of 1 by 2 is equal to root pi. How to prove this? It was like asked in your CA also. So how you are going to prove this? Well, let's see. Okay, since we know that beta of m comma n is equal to 2 times the integral 0 to pi by 2 of sine of 2m minus 1 into theta of into cos theta raised by 2n minus 1 d theta, right? You know this, okay? So in this case, and you also know that this is equal to gamma of m into gamma of n by gamma of m plus 1, right? So what you can do is you substitute m is equal to n is equal to 1 by 2 in this to get the following result, okay? So when you substitute, you get gamma of 1 by 2 into gamma of 1 by 2 upon gamma of 1 by 1 by 2 plus 1 by 2 is equal to integral 2 times the integral 0 to infinity of sine of 2 into 1 by 2 minus 1 theta. I hope you're understanding. We have just substituted m as 1 by 2 over here, like we have used over here, right? Into cos of 2 into 1 by 2 minus 1 theta d theta, right? Okay. So basically when we solve it, what we get is that so on solving, you get gamma of 1 by 2 into gamma 1 by 2. It will be gamma of 1 by 2 the whole square, right? And what is gamma of 1? It is equal to 0 factorial and it is equal to 1, right? So no need to write anything. So it is equal to 2 times the integral 0 to pi by 2. Notice that this thing is equal to sine theta to the power 0. So this is 1, this is 1. So we are left with, it is, sorry, 0 to pi by 2 d theta, right? And it is equal to 2 times pi by 2 minus 0, which is equal to pi, right? Okay. So what's next? Okay, let's see. So you get gamma of 1 by 2, the whole square is equal to root pi, right? Is equal to pi. We will discuss it later in the later part. Let's see some other question if we see. Okay, let's see some practice questions for now, and we'll end the lecture after that. Okay. Okay, so let's assume this question. Does this integral 0 to 1 dx by root x plus x square, does it converge or diverge? We have to check this, okay? So notice that it is a category of like improper integrals. So but in this case we have a defined limit. So what we are going to do is we'll assume that gx is equal to this function root x, 1 upon root x, right? But notice that it is a defined limit. So what we will do is we will assume this thing, 1 upon x minus a to the power half, which is equal to, as a is equal to 0 in this case, so we will get 1 upon x to the power 1 by 2, right? Okay, so simply you use the ratio test or limit test. You get limit as x is tending towards 0 positive of the quantity this fx, this is your fx, so it will be 1 upon root x plus x square upon gx, it is 1 upon x, right? This quantity. So when you solve it, you get limit as x is tending towards 0 positive of root x by root x plus x square, and when you solve this limit it will come to a finite value, right? You can check it also. When you check, it will be a finite value lambda. I'm not calculating it, you can calculate on your own, and if you solve it you get a lambda which is a finite value, right? This is a very simple limit, you can solve it. So since it is a finite value, which means from the ratio test that if this is convergent, that this will imply that this function will also be convergent. So notice that in this case mu is equal to 1 by 2, and since it is a case in which we know the both the limits, in this case it is a type 2 case, so which means in this case mu is less than 1, which implies that this fx will be convergent, right? This are your this was a nice question, and now let's see another question. Well, let me take another joke. Okay, so now we are going to see another question. This is a very simple question. I hope you all can solve it. Integral 0 to infinity of e to the power negative at of t to the power n minus 1 dt, right? It is very simple. You just assume at as equal to, you need to prove it is equal to gamma of n upon a to the power n, right? It is very simple. You just substitute at as equal to x, right? Notice that as x is tending towards as t is tending towards 0, x is also 0, and as t is tending towards infinity, x is also infinity, right? So we get this thing, right? So we get e to the power negative x of the quantity uh, x upon a to the power n minus 1, right? This thing, and when you substitute, when you do the differential part, you will get dt is equal to dx by a, right? So you get dx by a. So this is equal to integral 0 to infinity of the quantity x to the power n minus 1 into 1 upon a to the power n. Just add this power. This is a to the power n minus 1 and this is a. So adding it, it will yield a to the power n, right? And e to the power negative x dx, right? And just bring 1 upon e to the power n outside the integral since it's a constant. So you get this integral 0 to infinity of x to the power n minus 1 into e to the power negative x dx. And as we all know that it is equal to gamma of n, right? Gamma of n, hence proved, right? Okay, now we will see another question and then we will stop this lecture. So let's see if there is some nice question to be done. Well, we will see one more question which is very important and then we will end this lecture. Okay, so let me take another set of problem, then we will see. So there is one more question. The question is that gamma of n plus 1 by 2 is equal to root pi gamma of 2n by 2 raised to by 2n minus 1 of gamma of n. We need to prove this. So how do we prove it? Well, let's see. You know the property of gamma, that gamma of n is equal to n minus 1 into gamma of n minus 1. We proved it earlier, right? So we are just going to use this property and we will end up getting this result. Let's see how. So gamma of n plus 1 by 2 is equal to gamma of it will be equal to n plus 1 by 2 minus 1 of gamma of n plus 1 by 2 minus 1, right? Is it correct or not? Is it correct? No? Okay. So we will get n minus 1 by 2 of gamma of n minus 1 by 2, right? This is a simple mathematics, right? So you get n minus 1 by 2 and you apply this thing till the time we get gamma of 1 by 2, right? So we get n minus 1 by 3 by 2, you just solve it, n minus 5 by 2, like okay, let me tell only, there will be confusion. It will become n minus 1 by 2 minus 1 of gamma of n minus 1 by 2 minus 1, right? This is the case, okay? So you get n minus 1 by 2 of n minus 3 by 2 of gamma of n minus 3 by 2, right? Is it simple? Right. Okay. So let's evaluate it further and let's see what we are going to get. Sorry, I'm not well, so that's why. N minus 1 by 2 into n minus 3 by 2 into n minus 5 by 2 and so on and so forth till we get like we will end up getting like, so okay, till gamma of 1 by 2, right? We will come till over here. Okay, now let's see. Okay, so now we are going to get this thing. Okay, so let's see, you can just bring this thing, you get 2n minus 1 into 2n minus 3 into 2n minus 5 and you are expecting to get 3 into 2 into 3 into 1, right? Into gamma of, what is gamma of 1 by 2? It's root pi, right? Root pi, yeah, upon what will be, there are n terms, so you get 2 raised to the power n, right? I will understood that how we are getting basically 2n minus 1 by 2 into 2n minus 3 by 2 and so on and so forth, right? So notice that it is going from n minus 2n minus 1 to 1, right? So in this case you will understand that there are n terms of 2, right? So that is why I have written 2 raised to power n. since they are in multiplication, right? Okay. So let's see. So now notice that you can do it like this: 2n minus 1 into 2n plus 2n minus 2 into 2n minus 3, so on and so forth, into 3 into 2 into 1 into root pi. But what I've done is basically I've multiplied the even terms also, right? Okay, right. But we have to divide it also, right? So that the expression remains same. 2n minus 4 and so on and so forth till 4 into 2, right? Just bring 2 out of all the expression you get. Let me erase this thing. So you get 2n minus 1 factorial. This is 2n minus 1 factorial, right? Upon 2 raised to the power n into, we will bring a 2 from this, you will get 2. You bring this, you bring 2 from this, you get again a 2, and it is going till n minus 1 times. So you are getting 2n minus 1 into n minus 1 into n minus 2 and so on and so forth of into root pi, right? You are getting this. You know how I proved that gamma 1 by 2 is equal to root pi? It's from the beta and gamma function I had proved earlier. You should remember that. Okay. So 2n minus 1 upon this is n minus 1 factorial. So you get, and just multiply these two. You know that 2a into 2 raised to power b is equal to a plus b. We are just applying this thing. N plus n minus 1 into n minus 1 factorial into root pi, right? Now again this is gamma of 2n. How? Gamma of n is equal to integral 0 to infinity of t to the power n minus 1 e to the power negative t dt. So gamma of 2n minus 1 is equal to integral 0 to infinity of t to the power 2n minus 1 e to the power negative t dt, right? That is the thing. That is why, which is equal to 2 gamma of 2n, sorry, is equal to 2n minus 1 factorial, right? And similarly we will apply this over here also. So we get basically root pi by 2 raised by 2 raised to power 2n minus 1 of gamma of 2n by gamma of n, right? Hence proof, right? Now we will see one more question and then we will end the lecture. Okay, so let's see. And it's really important questions, that is why I'm discussing it right now, and then I will make a one shot on all the chapters, the best question of all the chapters, right? Maybe in 1 or 2 days. So in that we will discuss everything, all the questions, all types of questions. So let's see the question. Wait, it is not in this one. I have to take another sheet. Uh, yeah. This is the question. It states that we have to evaluate this in terms of beta function 0 to 1 of t to the power m 1 minus t to the power n into p dt. And like you have many questions from this, like they will ask 0 to 1 x cube of 1 minus x square to the power 100, like this. They will said how to evaluate this in terms of beta and gamma, like that. So you can just derive this thing, and from this you will easily be able to derive this one. Okay, so I'm just telling the proof of this, and then you just substitute eminent for any value. They will you will be able to solve. Like in this sheet also, there are 50% question of this form only, right? So let's see how we see it. So basically you are having this thing. So how do we convert it? Let's assume t to the power n as x, right, for the time being. Okay, so when you find the, so in this what you will do is you can solve for t is equal to x to the power 1 by n, right? And notice that when t is equal to 0, x is 0. When t is equal to 1, then x is also 1. So we are getting 0 to 1 again. And what is t to the power n? It is x to the power m by n, right? This into 1 minus x to the power e. And what is dt? Dt is negative 1 upon x to the power x1 by n minus 1, right? I hope you are understanding it. So you are getting negative 1 by n over here outside, x to the power 1 by n minus 1 dx, right? So negative 1 by n, 0 to 1 of x to the power, and you can just add the exponents, m by n plus 1 by n minus 1 of 1 minus x to the power p of dx, right? You got this. Okay, it's very simple. So you get negative 1 by n integral 0 to 1 of x to the power m plus 1 by n minus 1 of 1 minus x to the power p plus 1 minus 1. And notice that this is simply in the form of beta function. Let's see how. So we get, just put m plus n. If you have any confusion, then you can use m plus n as equal to, suppose, alpha, and p plus 1 as beta. So you end up getting negative 1 by n integral 0 to 1 x to the power alpha minus 1 of 1 minus x to the power beta minus 1 dx. And notice that it is clearly a form of beta function. So what you get is, you will get that it is equal to negative 1 by n of beta of alpha comma beta. Means this beta is different, this beta is different. So it will be minus 1 by n into, what is beta? Beta is simply equal to the integral. It is equal to beta of, what is alpha? Alpha is m plus n. Sorry, it was m plus 1 by n. M plus 1 by n comma p plus 1, right? This thing. I hope this is the case. I have to verify it because I think there is some mistake in this result. Wait. Okay. Yeah, this is correct. This is the correct result. So you got this. I hope there is not a negative sign in this. Yeah, there is no negative sign. Sorry, because when you are calculating the derivative, it was like x to the power 1 by n. Na? So when it came down, it will be this x to the power 1 by n minus 1, right? So there will be no negative sign over here. That was the mistake. So it is 1 by n beta of m plus 1 by n of p plus 1 fact. This is the case. Okay. So suppose you are given an integral in this question, it was given this integral 0 to 1. For example, this is the question: t to the power 5 of 1 minus t cube to the power 9 dt, right? You are given this. So how do we evaluate this? You just see that m is equal to 5, n is equal to here 3, n is equal to 3, and p is equal to 9, right? Just substitute the value. You get 1 upon 3 into beta of m plus 5 plus 1 by 3. It's 2, and what is p plus 1? It is 10, right? And you know that it is equal to 1 by 3 into gamma of 2 into gamma of 10 by gamma of 12, right? You solve it, you get 1 by 330, and that's the answer. And there are many questions of this form, right? So you just remember the proof, and from that you can solve it very easily. Okay, so now there is one more result which I need to tell, and then we will finally say bye bye. Okay, so now let's see. We know that the beta of mn was actually equal to integral 2 to infinity 2 to pi by 2 of sine of 2m minus 1 theta into cos of 2n minus 1 theta into d theta, right? We know this. So in that case, what we assume? We assume 2m minus 1 as suppose p, and 2n minus 1 as equal to p, and this as q. So basically what we do is that we solve for m is equal to p plus 1 by 2 and n is equal to q plus 1 by 2, right? We get this. So basically gamma beta of p plus 1 by 2 comma q plus 1 by 2, it will become integral 2 times the integral 0 to pi by 2 of sine of p of theta into cos of q to the power theta d theta, right? You are getting this. So from this, when you substitute it, you get so this is equal to basically gamma of p plus 1 by 2 into gamma of q plus 1 by 2 into by gamma of p plus 1 by 2 plus q plus 1 by 1 by 2. Like this you can solve it and you will get this. So I hope you all like the video. Please do like, share, subscribe my channel, and thanks. Bye bye. Take care. Hello everyone, this is Aditya, and today we'll study multiple integral for end sum examination. So without wasting time, let's dive into the topic, and please do like, share, subscribe my channel. And now let's get started with the video. Okay, so let's start with multiple integrals. So why do we use multiple integrals? This is the basic question. Let's see. We have studied till now that integral fx dx. We have studied like till 12th. We have studied that about single variable integral, right? Integral of fx dx, right? So when we move to BTech, then we study like the concept comes of multiple integrals. What is it? Well, let's see. So basically, in the case of double integral, we have a function which is dependent upon two variables x and y. So we are integrating with respect to x first of all, then we will integrate with respect to y upon a given domain, upon a given range, whatever we have to calculate according to the question, right? So that is not our headache. We have to like calculate it using the data given in the question, right? So basically, a function which is dependent upon two variables is called a double integral, right? This is a double integral. Suppose if we use three integral sign and it is dependent upon three variables, then we say that this expression is triple integral, right? Right. So this is a basic idea. This you have studied already. This we are studying right now, and this we will also study, right? Okay. So without going much deep into it, we will directly see some problems and some concepts, right? So let's start with some concepts, then we will start, right? Okay. Have you noted? You can ask questions if you have. Okay. So basically, we all know that fx dx, when we were calculating this integral, what was it actually telling? For example, a to b, it was actually telling the area under the curve fx, right? Okay. So similarly, if we are calculating like c to d integral a to b f of x comma y dx dy, right? So what does it tell? It basically tells the volume under this curve, right? If I tell geometrically, it is somewhat like this. I won't use the limit here. I will just try to explain. Like this is your curve. Suppose this is your curve, like this, and suppose it goes like this, and suppose it is like this. Okay. So you are basically picking this particular element at some length, and then you are integrating it over whole surface along x, y, and z, right? And yeah, x cross y should be z, so it's the direction is okay. This is the basic idea, but you don't need to know much about it. Okay, it's like okay. So basically, this is the basic idea. Like in the case of single variable, it was like you are integrating this region to, for example, this. You are integrating this region to get its area, and in this you are integrating to get the volume of this given particular region, right? Okay. Sorry. Okay. So let's start with some problems because it will be easier for us to understand the concept. And yeah, there are some concepts related to triple integral which I should tell right now. Then after that we will move on to the problems, right? Okay. So first of all, let's see for double integral. Okay, let me write it. Double integral, right? So basically the first property, it's basically we can say property or whatever. Fx comma y dx dy, right? So if the limits are independent of the variables, like they are, for example, limit 1 to 2 integral 3 to 4 fx comma y dx dy, right? If this is the question, so in this directly you will integrate this expression, then whatever result you get, you integrate this, right? It's like iterated it's like you are integrating this, then you are integrating that. Okay, we will see using question basically. And then this is a basic type of integral, right? And there's one more integral, for example, like it's going from a to b, and this is phi of x1, this is phi of x2, f of x comma y dy dx. Okay, this is another type of problem in which the limits are dependent upon the variables, right? So in that case, this also we will see, don't panic about it, right? Just note for now. Okay. Okay, and there's one more thing to be told in this. Okay, I didn't know. Okay, so for example, if you are given like this, let fx be okay. For example, if you are given like this, let me write it like this. Okay, suppose if you are given a rectangle, like don't worry about the term rectangle. It's we don't need to know about it much. Okay. For example, a comma b, c comma d, right? It is basically the x and the y coordinates of the limits, right? This is the lower limit, this is the upper limit of x, and this is the lower limit of y, and this is the upper limit of y, right? So basically, if you have to find the area, then what you will do, you will just simply use the limit a to b for x fx comma y, and since it's the limits of x, so you'll put a dx over here, right? You won't put a dy because it's the limit of x, not y. Okay, and then you use c to d of dy, right? Okay, this is how you go from here to here, right? This is the basic idea. Okay, and let's see if there's something left to be told. Okay, let's know a concept of change of order first of all, right? After that, we will see triple integral, right? Okay. So, for example, if you are given an integral a to b of suppose phi of x1 comma phi of x2 of fx comma y dx dy. Notice that it is the function over here is x. So you will use dy over here. Why? Because here the limits are of y, since y is going from this to this. Obviously x can't be equal to x itself, right? That is why it is the limits of y. I we are understanding. So if you have to change this integral from phi of x1 to suppose psi of x1, means from the function, the limits being the function of x, we have to change it to the limit to the limits which are a function of y. So if you have to change that, that process is known as the change of order, right? So basically it will be equal to integral, suppose limits are changed c to d of suppose psi of y1 comma to psi of y2, right? Okay, don't worry about the variables, it is just we have changed from x to y, right? There's nothing more in it. F of x comma y dx dy. Notice I have changed from dy dx to dx dy. This is known as change of order, right? Now notice, since it is a y, so we will have a limit of so we will have a dx, right? Here it was x, so we had dy, right? Notice it. Okay, so now let's see some properties of triple integral, and then we will move to some questions, right? And there's one more thing in this. Yeah, like suppose you have this d f of x comma y dx dy. Suppose you are given this, right? So suppose you have to change from this to some other function, like you are writing x in terms of function u comma v, right? And you are writing, suppose it is g or whatever, and you are writing y in terms of suppose g dash of u comma v, means you are changing x and y to u and v, right? So basically you can write it like this integral, and over here the region will also change, right? This represent a region. For example, you will be given in the question that in what plane you have to calculate it, right? So that is basically this d. Okay, don't worry about it, we will see it through question. Okay, so we can write it like this: f of x of u comma v. Since we are converting x to a function of u comma v, right? So that is why I written x of u comma v, right? Comma y of u comma v, right? Okay, this is okay. But now here comes a multiplication factor of. But now question arises, why are we using a multiplication factor over here? So let's see. For example, if you have single integral f of x dx, right? You are using it. Okay. To go from here to some other function. Suppose x of suppose this function. Suppose we take an example simply. Integral suppose x square plus 1 dx, right? Very simple integral, right? We are taking a simple example. So you use x square plus 1, suppose t, right? You are changing x in the function of t, right? So this is the basic thing which we were doing over here also, but in the terms of two variables, right? So what we are doing is that we will apply this only. So what we get? We get x is equal to root of 1 minus t, right? We will get this. So we get dx is equal to 1 by root 1 minus t, and with a negative sign dt, right? We will get this thing. Okay, is it okay? Yeah, okay. And yeah, there will be a negative 1 by 2. Okay. So we get like t, and negative 1 by 2 will be out, and it will be right. Okay. Okay. So basically this dx by dt we are calculating now. Dx by dt, dx by dt. This is over here in the single variable. This is also Jacobian. This is Jacobian of x by t, right? Just over here, what we are doing, since it is a two variable system, it is Jacobian of x comma y by u comma v, right? That thing. So over here also, over there also, we are using this concept only, like dx is equal to f of x of t Jacobian. Let me write it, del x dx by dt dot dt. This is the same thing which we are doing over here, right? That's the concept why we use a local magnification factor over here. Okay. Now see some concepts of triple integral. Then we see some problems and end the lecture, right? Okay. Yeah. Now let's now let's start with triple integral, right? Okay. So we are coming to triple integral, right? So basically the properties are still the same. For example, okay, suppose you are given a box. Basically there was a rectangle. Now here we are using box. Why? Because here we are having the dimensions a comma b cross c comma d cross e comma f, right? Okay. And why I was using a rectangle term there and here a box, because there we were using a comma b cross c comma d, which eventually represent, suppose this is your a, this is your b, right? And this is your c, this is your d, right? So this and this and this, so it is representing a rectangle. That's why I was using the term rectangle over there. And in this case we have got a z axis also, e, f and e, right? So over here we will get a like this. I can't draw it in the plane. It will go like this. So we will get a box. Basically it will be coming out like this. Okay, a square or a cuboid, we will get a cuboid basically. Okay. I hope it is clear, right? Okay, so this is your triple integral, and let's substitute the limit. This is your x, This is y, this is z. Okay, so f of x comma y comma z, right? This is your function which is dependent upon three variables. That is why we are using triple integral, right? In this, okay, so we get dx dy dz. So with the corresponding dx variable or the x variable, we will have the limits of x. So that is why it will be from a to b, right? Okay. And with the corresponding y, we will have the limits of y, that is, it goes from c to d, right? And with the corresponding value of z, we will have the limits of z, e to f, right? This is it, okay? And in this case, the limits are properly defined, means they will be a numerical value, right? And it is very easy to solve. We will see through questions, right? Okay. And now let's move into the second question, second topic. Suppose it can be in the form of iterated form also. Let's see how. Integral a to b phi 1 of x1 to phi 1 of x2, and here we get phi 2 of x1 comma y1 of phi of x2 comma y2, right? Like this. So basically in this, what else is left? I have to see 1 minute. Okay. So basically you can write over here like even x only, it's okay, right? X comma y, and this will be x comma y, okay? This is also okay. Okay. So basically note that in this it can be x1, you can take like phi 1 of x to phi 1 of phi 2 of x, sorry. This is another function, and this we are going from, suppose psi 1 of to psi 1 of psi 2, right? Sorry, that was wrong what I wrote. There was some issue. We will have like this, okay? And f of x comma y comma z dx dy dz, right? It will be dz, it will be dy, and this will be dx. Why? Because this is the function of x comma y, which means that it is the limit of z, and it is a function since we use z over here, which means this is the limit of y, because since it contains x, right? That is why it is the limit of y, right? And dx, it is the limit of a to b, right? Okay, it is x is equal to a to x is equal to b, right? Okay. Now let's see some coordinate system which we will need to use when we solve the problems, but it is rare that any difficult question can come from it. So I will discuss it tomorrow. I mean, some questions I will discuss and some questions I will discuss tomorrow in one shot. Okay. So let's see some concept like cylindrical cylindrical coordinates. Okay. Okay. So how we solve it? Let's see. For example, you are having triple integral f of x comma y comma z. I hope it is not going too fast, right? Is it okay? So dx dy dz, right? You have this limits, and suppose this region is R. Okay, you can take R or whatever region you want. So basically, what we are going to do is we will change x, y, z to some polar coordinates, right? Basically, x and y we change to polars in this in cylindrical coordinates. So we'll assume x is equal to r cos theta, and y is equal to r sin theta, and z is equal to z. Okay, we'll assume like this. Okay, and what's next is that we will, in this case, r is greater than equal to 0, and the theta will be between 0 to 2 pi, right? This is the case. Okay, we will see through problems, then it will be more clear. Okay, so for now just note this, and let's see how we can express it further. So this can be written as a integral in another region. We will basically, the region will also change since the limits are changed. Okay, so we will have like f of, what was x? X is r cos theta, right? Is it correct? And what is y? It is r sin theta. okay, and then z is equal to z, so we won't change the z, okay, is it it will be like this, okay, with a Jacobian of x y z and r theta and z, okay, d r d theta dz, okay, this is the case, okay. So now when we are calculating the Jacobian, let's see what value we get. So Jacobian of x comma y comma z upon r theta z is equal to del del x by del r, del x by del theta, del x by del z, right? And del y by del r, del y by del theta, and del y by del z. It sounds so funny, right? Like, and del z by del r, and del z by del theta, del z by del z, right? We are getting this, okay. This is your Jacobian, and and when you will solve this Jacobian, you will get the value of r, right? Notice del x by del z, it will become 0, del y by del z will also become 0, del z by del z it will become 1, and then del x by del r we can solve from this. It will be cos theta, and this will be sin theta, and this will be 0 again, and del x by del theta it will be r of negative sin theta, and del y by del theta will be r cos theta, right? Like that you can simply solve using partial differentiation, right? Okay, and you will end up getting r. So instead of this Jacobian, I can write it like this: integral r star of f of r cos theta, r sin theta, comma z into r d theta dz, right? You will get this thing, right? This Jacobian you all will calculate and tell me that is it r or not, okay? So this is for cylindrical coordinate system, right? Okay. Now we will see spherical coordinates. It is also important topic. Basically we have used a change of variable system, like in two variable system we were doing like that. Here also we are doing this. Let me explain how the change of variable go in this, so that it becomes very easy for evaluation. For example, triple integral r of x comma y comma z d by dz. We are having this thing. So when you have changed, for example, x has to become a function of u comma v comma w, and y has to become a function of u v w, and z also has to become a function of u v w, right? Like this. Since it is a triple integral, so there will be three variables, of course, right? So it will be equal to the triple integral of, suppose this region was r, now it become r dash or r star, right? Of f of x of u v w, y of u v w, u v w, z of u v w, right? You got this, into Jacobian of u, Jacobian of x. I think I should write it on the next line, else it will go out of the frame, okay? So let me write it like this. This is equal to dz. So let me write it. This integral r dash r star f of, it will become x of u v w, y u v w v w, right? And then we get the Jacobian of x y z upon u v w del u del v del w, right? You will get this. Kindly note this. This is really important. I hope there is nothing left. Yeah, I have written the complete expression. This is like this. So I hope you are understanding why we have used a Jacobian over here, because it is a multiplication factor. Like in the single variable, we use it is single variable terms like Jacobian of x by t we use there, and in the two variable system we use x comma y of u comma v. So similarly in the three variable system also we are using this Jacobian x y z u v w, right? Since it is a determinant of differential values, so that's why it helps a lot in calculus, right? That's why we use the Jacobian, right? I hope you all know how to calculate the Jacobian, right? So let's see the spherical coordinate system and then we will come to some problems, right? Okay. If you all face any problem, you can comment me in the comment section and or message me directly. Okay. Okay. So let's see the spherical coordinate system. Okay. So we are coming to the spherical coordinate system now. Okay. Don't go in much deep into this. Just understand the concept and that's it. Okay. Okay. So basically in this you assume x is equal to r sine phi into cos theta, right? Just don't think about what is phi or theta for now. We will see through questions. That is better, okay? But for now, just understand how the things are being written. What is the form actually, right? And y is equal to r sine phi of sine of theta, and z is equal to r cos phi, right? This is the expression. Okay. So why are we even using this? Let's see. Just square them. What you get? Let's see. You get r square sine square phi cos square theta plus r square sine square phi into sine square theta plus r square cos square of phi. Right? You get this thing? Okay. So just take r square common and you will get r square. And notice that we have sine square phi into cos square theta plus sine square phi plus into sine square theta, right? Plus cos square phi. Is it clear? Okay. Now what you can do is you can take sine square phi common this, right? So you'll get r square into sine square phi of cos square theta plus sine square theta plus cos square phi, right? You get this, okay? Now what is this? This is equal to 1. So you end up getting that this is equal to r square into sine square phi plus cos square phi, and notice that this again is equal to 1. So you get 1. So you basically got x square plus y square plus z square is equal to 1, right? Is equal to r square, right? And this is the equation of a sphere. So that is why we call it as a spherical coordinate system, right? Okay. So now let's see what else we have to do in this. Yeah, we have to change the integral also, na? That is good. I hope you all noted this. Yeah. Okay. So now let's come to the most critical part, which we have to remember. It's like really important. Integral sum r f of x comma y comma z dx dy dz, right? You got this? Okay. This is equal to the integral sum r star star of what is x was equal to r sine phi cos theta, right? Comma, this is r, what was y? It was r sine phi into cos theta into sine theta, right? R sine phi into sine theta, right? Comma, yeah, this is your y, this is your x, this is your y, and what was z? Z was r cos phi, right? Is there any confusion in this? Okay. Into the Jacobian of x, y, z, r phi theta, dr, d phi, d theta, right? Okay. Which is from this xyz system to the polar system r theta and phi, right? Again, when you calculate Jacobian in this case, you will end up getting r square sine theta, right? You evaluate it yourself and you will understand how it goes, right? Okay. So now let's see some yeah, and there's one more thing here. Here what will be the limits? R will be equal to 0, and theta will lie between 0 and 2 pi, and phi will lie between 0 and pi, right? Kindly note this, this is important. Like, I hope there was a question in your CA from this exam, from this topic, because the limits were like this and you were getting the answer like 4 pi by 5, I guess. Yeah. Right now I don't have that question, else I would have discussed. I will try to discuss it tomorrow. Okay. So I have that this is it in this. I told every concept which is possible in this, right? Okay. So now let's start with the problems, which is most important part of this chapter, right? Okay. This was just a glimpse of everything. It was not so deep because neither do we require right now, because we have exam in like 2-3 days. That is why we can't waste much time. Okay. So let's see question number 1. What we get? What is there? We start with a very simple question. R 1 minus x dx dy, right? And what is the rectangular region we are given? The region R is 0 comma 1, 0 comma 1. We are given this, right? So what I told was that this was the x term, this was the x, and this was the limit of y, right? They both are independent of each other, right? So we simply put the limit. We put over here the limit of x. It is from 0 to 1. X is equal to 0 to x is equal to 1, right? We are given from there. And from here we put y is equal to 0 to y is equal to 1, right? Of the quantity 1 minus x dx dy, right? Is it okay? When you solve it, you will get 0 to 1, and when you integrate this, you get 1 x minus x square. Limits are from 0 to 1 dy, right? You get this? Yeah. So you get integral 0 to sorry, x square by 2 minus, sorry, you substitute 1, you get 1 minus 1 square, right? Okay. And when you substitute it is x square by 2, yeah, by 2 minus 0 square by 2, right? You get this dy. Okay, correct. You solve it, you get integral 0 to 1 by 2 dy, right? You will get this, yeah. So you get y by 2 integral 0 to 1. You solve it, it is 1 by 2, right? This is how you solve such kind of problems, right? Okay, so we discuss like this one. We will discuss one more problem of this, and then we will see some other questions, right? I hope you all have noted this. Okay. 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 So now let's see another question. It is, we have to evaluate this region x square plus y square of dx dy in the limit r is given from 0 comma 1 to 0 comma 1. Again, the limits are same. We are given same rectangular region, right? So basically we have to evaluate this integral in this, right? So how do we evaluate it? Basically, you again substitute the limit 0 to 1, 0 to 1. It, in this x goes from 0 to x is equal to 1, because the limit of x. So x is going from 0 to 1, and similarly y is going from like 0 to 1, right? So that is why we have substituted the limit of x as x is going from 0 to 1, and similarly y is going from 0 to 1, right? This is the case. And this is the region dx dy, right? You get this, okay? Now you have to just evaluate this integral to get the value. Let's evaluate it and let's see how we get the answer, right? So it goes from 0 to 1 of x cube. What is the integral of x square? It is x cube by 3 plus y square, and what is the integral of 1 dx? It's x, right? So we get to 1, right, of dy, right? We get this. Now when we substitute the limits, we have to be careful. We have to substitute in the value of x, not in the place of y, because obviously we are integrating with respect to x right now. So we have to be clear that we have to substitute the limit in place of x, not in the place of y. Okay. So we substitute the limits. We get 0 to 1, 1 by 3 plus y square, and when you substitute 0, this whole expression is becoming 0, right? Is it okay? And you get basically integral 0 to 1, 1 by 3 plus y square dy, right? You get this. And it is a very simple integral. You can evaluate it. It is 1 by 3 into y plus y cube by 3 as it goes from 0 to 1, right? You just substitute the limit over here. It will be 1 by 3 into 1 minus 0, right? Plus 1 cube minus 0 cube by 3, right? This will be equal to 2 by 3, right? Okay, this is your answer. Okay. We will see similar type of problem in the triple integration right now. This was like we were given a rectangular region, so it was very simple, right? So we will get such type of problems like maybe for 3 or 4 marks. There are chances. Let me see a better problem. Let's see for triple integral how do we evaluate over such cases, and then we will see other questions. Okay. So we have to integrate e to the power x over the box or region. What is the region? Region is from like 0 comma 1 to 0 comma 1 of 0 comma 1, right? This is x, this is y, this is z, right? This is the limits of x, this is the limits of y, and this is the limit of z. Okay. So how do we evaluate it? Again, we just use triple integral in this case. What is the function? Function is x comma y comma z, dx, dy, dz. The region we are given. So we have to just substitute the function over here. We get, and the limits are 0 to 1, 0 to 1, 0 to 1, e to the power x plus y plus z, dx, dy, dz, right? This is the integral which we need to evaluate right now. Okay. So let's see how do we evaluate it, right? Okay. Have you written this? Okay. Okay. So now let's see how do we evaluate it. Okay. This is the integral 0 to 1, 0 to 1, 0 to 1, right? This is the limit of x. X is equal to 0 to x is equal to 1. We are given in the question that this is the limit of x, and similarly this is the limit of y, and the limit of z. Okay. So basically this is the limit, and this, and we can write it like this: e to the power y, e to the power z, dx, dy, dz, right? Okay. So now we are coming to a very important property of integral, that is, if we are given integral a to b, c to d, e to f of fx into fy into fz. So for example, if it is fx y z dx dy dz, right? This is given, and you know a property that is equal to integral e to f, c to d, a to b, right? Fx into fy into fz, dx dy dz, right? Means they can be further broken like this. For example, I broke this function f of x comma y comma z was e to the power x plus y plus z, right? This was the function, but I broke it like this: e to the power x, e to the power y, e to the power z, right? So this is fx into fy into fz, right? Is it okay? So basically, if this is the case, then how do we evaluate it? Well, you can apply the basic concept also, but using this, it becomes very easy. instead of using the iterated integration, you can break them into separate integrals. Like e to f, this is the limit of z, right? E to f is the limit of z. Okay, so we will do f of z dz. Okay, this is a separate integral now. Fy dy into integral a to b fx dx, right? We broke the triple integral into the product of three integrals, right? And this is a very important property which can be used to simplify the calculations, right? And we can prove it also using summation, but I don't think so it is important, so I'm leaving for now. So basically, let's now come to this question, because it also follows this property. So let's see how do we solve it. I hope everyone has written it. Yeah. Okay. So now let's see. This is your fx, this is f of y, this is f of z, right? So what we're going to do is we will simply break the limits. We will simply break the integrals into three integrals, right? So you get 0 to 1 e to the power z dz, integral 0 to 1 e to the power y dy, integral 0 to 1 e to the power x dx, right? You are given this. You means you can break it like this, since it is a product of three different functions, right? So you get e to the power z limit 0 to 1, e to the power y limit 0 to 1, e to the power x limit 0 to 1, right? You are getting this, okay? So you just substitute 1, you get e minus 1, you get e, and when substitute 0, you get 1, right? Similarly, e minus 1, similarly e minus 1, right? That is equal to e minus 1 whole cube. Answer. That is how you solve the box problems when you are given a region in the form of box. That is a cuboid, right? And in this we learned another property, that we can break triple integral into the product of three different integrals and even double integral if it follows such property. Okay, so let's see if there is some other question which we can solve right now. Okay, so let's see. Okay, well, we can evaluate the question like just a minute. Yeah, there's one more question which we will evaluate. We will do a series of questions which are most probable in Sunday's class. So it will be a one shot for all the chapters from the Rolle's theorem to the multiple integrals. Basically, I will follow from the sequence series, because Rolle's theorem and functions in several variables I have already covered. That is why I will start from the sequence series basically. Okay. So let's start with another question. It's integral 0 to 1. It goes from x cube, x square, xy, dx, dy. So we are given this question, but there is a problem in it. And what is the problem is that because here it is x, and the limit is of y. Since it is x cube, so it is the limit of y. So we need to change this thing, right? So the actual question is this: integral 0 to 1 x cube to x square xy dy dx, right? So you need to be careful that it is dx, so it should be the limit of x only, not of y, right? So it was the limit of y, so you needed a dy over here, right? Yeah. So just evaluate it. You get when you evaluate this, you get x y square by 2 x cube x square, right, dx. You get this. Now again, while substituting the limits, you need to be careful that it is the limit of y, not of x. So you have to substitute in place of y, right? 0 to 1, and there's no need to be in confusion. For example, if you are planning to substitute in the place of x, then also it is useless, because you know you can't substitute x as x square. They both are not equal. It's a bit logical. That is why we will substitute in place of y only, right? So you get x by 2 into what is y square, and you substitute, you get x to the power 4, right? Minus, when you substitute over here, you get x to the power 6, right? You will get this. Okay, dx. Is it clear? Yeah. Okay, So we get x by 2, we get the integral, we can bring 1/2 outside, and we get x to the power 5 minus x to the power 7 dx, right? You get this thing. Okay, so let's solve it. Okay, I don't think so the answer is given. What will the value come? Well, let's see. 1 by 2 into this integral x to the power 6 by 6 minus x to the power 8 by 8, limit goes from 0 to 1, right? Is it okay? We have just integrated this integral of x to the power 5 is x to the power 6 by 6, and this is this, right? You simply substitute now the limits. When substitute 0, it will vanish. When substitute 1, let's see what we get. You get this. You solve it, you get 2 by 48. It is 1 by 48, right? This is your answer, 1 by 48, right? I don't know whether it is correct or not, the numeric value, but the method will be this, right? Because in my sheet there is not there is no answer given for this, no numerical value, right? So let's see whatever we can do. Now let's see another question. Like we have to solve for which question can we solve right now? We can go, yeah, there's one more question which we can solve. Let's see. It is, yeah, this one. Okay, so the question is integral, this d is a region, right, of x plus y dx dy, right? We are given this, and the d is it is bounded by y is equal to x square, y is equal to x square, and x is equal to 1 and y is equal to 0, right? This is how the integral is bounded. Okay, so how do we calculate the limits from such case? This is the biggest question. So basically, since this is a dx, so either we can use yeah, either we can interchange the limits, so it will become easy. So we will write x plus y dy dx, right? We wrote this. Now notice that y is going from 0 to x square, right? It goes from 0 to x square, right? Is it clear? And notice that when y is equal to 0, then x is equal to 0, and when x is equal to 1, then y is equal to 1, right? Basically it is going from 0 to 1. This is the limit of x, this is the limit of y, right? If we represent graphically, it will be something like this. This is your y is equal to x square graph, this is your x is equal to 1 and y is equal to 0 is this region. So we are basically trying to find the area of this area under over here, right? Somewhat like this. Okay, this is y is equal to x square, this is your x is equal to 1, y is equal to 0. Okay, so somewhat like this. So basically you are trying to go from x is equal to 0 to x is equal to 1. This is the case, right? And the square and the limits are going from like y is equal to 0 to y is equal to x square, right? Like if we make a box over like a rectangle, it is going like this. It is going from y is equal to 0 to y is equal to x square, right? Is it okay? That is why we will evaluate this. Okay, let me erase this. Well, you can do it logically even if you have idea about graphs. If you don't have, then also no problem. We will do sufficient amount of question that there is no problem. Okay, so let's see 0 to 1, 0 to let's simply integrate it since it is a limit of y. So xy plus y square by 2, right? I hope you all understand how I have done it. Okay, and you're substituting it from like 0 to x square dx, right? You got this? Okay, so you got integral 0 to 1, you substitute 0, everything will become 0. When you substitute x square, then the things will be okay. It will be x cube plus x to the power 4 by 2, right? And dx again, right? You got this. It is x cube plus x to the power 4 by 2 dx, right? Is it okay? Everyone is clear? Okay. So now let's integrate this stuff. We get x to the power 4 by 4 plus x to the power 5 by 10. You substitute limit from 0 to 1. Okay. When you put 0, everything will become 0. When you put 1, it will be 1 by 4 plus 1 by 10, which is equal to 10 plus 4 by 40, which is equal to 7 by 20. That's the answer. Have you all understood it, right? Have you all noted this? Okay, so this is the region and this is bounded and the answer is 7 by 20, right? Let me see if there is some other question which we can do right now. Well, there is a question which we can, okay, integral over this. Well, we can solve this one. This seems to be like, let's solve this one. The integral r sine of x plus y dx, and here we are given that the limits are, region is, rectangle is 0 to pi into 0 to 2 pi, right? This is the region, okay? So basically, this is the limit of x and this is the limit of y, okay? So simply you have to just substitute the limit 0 to pi sine of x plus y dy, right? This will be the case, and this is the limit of y, so it will be like this. Is it clear? Since it is a x, so we put the limit of x. Since it is a y, so we put the limit of y outside, right? So now let's integrate this thing and let's see what we get. Okay, this is 0 to 2 pi with a negative sign outside, since it will become negative cos of x plus y, right? It's integral. So cos of x plus y dy, right? We get this, and you substitute, obviously you have to substitute the limit, so it goes from 0 to pi of dy, right? You get this. So when you substitute the things, let's see what we get. 0 to 2 pi you get, and you substitute pi over here, you get cos of pi plus y, right, minus cos of y dy, right? You get this. Is it okay? Now cos of pi plus y is equal to negative cos y. Is it correct? So negative cos of 2 pi, so it becomes negative cos of y, negative cos of y, negative 2 cos y dy, right? I'm solving it over here. So you get 2 times integral 0 to 2 pi of cos of y dy, right? You get this, okay? And hopefully when you solve it, it becomes 2 into sine of y, right? The limit goes from 0 to 2 pi, right? Is it okay? So you get 2 times the integral, 2 times the sine of 2 pi minus sine of 0, and this comes out to be 0. So sine of 2 pi is equal to 0 and sine of 0 is 0, right? So we get 0, okay? But this should not be your marks. You should remember. Okay, so now let's see some other question. Well, yeah, let's see one more. Here we are given a plane. Have you all written this? Okay. Okay, so now let's see this question. We have to find the volume under the graph fx comma y is equal to x plus y square, right? Between the planes x is equal to 0 to x is equal to 3 and y is equal to negative 1 to y is equal to 1, right? Notice that the planes are independent of each other, which means we are basically trying to find the area under x is equal to 0 will be this line, x is equal to 0, right? And x is equal to 3 will be this, x is equal to 3, y is equal to negative 1 is this, y is equal to negative 1, and y is equal to 1 is this, right? I hope you are understanding it. Okay? So this is the region which we are basically concerned about, right? Okay. So now let's see how we will evaluate. Right. I think it's not boring. Okay. So basically now we are going to substitute the value like it's again this is a rectangular problem because we again made a rectangle. That is why we will get integral x square plus y square dx dy, right? And we substitute since it is a value of x, so we will 0 to 3, right? And this is y, so we substitute negative 1 to 1, right? Is it okay? And now it's that it's the similar question, so I'm not solving it. You will get get the answer as 20 probably as per the sheet. I don't know is it correct or not, but it should be 20. It is given. Well, yeah, it will be 20 only when you calculate it. Yeah. Okay, so sorry. Now we will see change of order of questions, right? Change of order of integral. That is something really important for your examination, right? So we will see it right now. Okay. So let's see that, right? Okay. Okay. So basically, the question is it states that reverse the order of integration reverse the order of integration in the case of x is equal to 0 to this and y is equal to x square to 2x x cube dy dx, right? So what does reversing of order mean? We have to first of all understand this. Basically, I told na that in this you will change it from this is a function of x right now. So we have to go from this to psi of x, right? Psi of y, right? And we have to make this it is a limit of x, so we have to make it a limit of y, right? These are changes we need to do. Let's see how we will do it. Okay. So for this, you need to again go to graphs to understand and analyze the problem. So let's see, this is the limit of y is equal to x square to y is equal to 2x, right? Right? Is it okay? So basically, when you graph this thing, this is your y is equal to x square, right? And this is y is equal to 2x, right? This y is equal to 2x, and we are going from x is equal to 0 to what is the intersection point? It is at x is equal to and x is equal to 0. Okay, so this is your x is equal to 2, right? So we are basically concerned about the area of this region, right? Right. We are concerned about the region of this area of this region. Okay. So right now what we are doing is that we are going from x square to 2x, means we are taking this rectangle like this. But how did I came to know that it is vertical only? Because the limit is going from x square to 2x, means this is the lower portion of the rectangle is touching the x square and the upper portion is touching the y is equal to 2x, which tells that this is the lower limit, this is the upper limit. So that is why I understood that it is y is equal to 2x, that y is equal to 2x is the upper limit and y is equal to x square is the lower limit. Okay. So what does change of order mean is that we have to change this rectangle position from vertical to horizontal. This is what basically it means, right? Okay. So basically you are starting from this position, you are making several rectangles that are horizontal, right? Like this. Okay. So what you do is that you have to reverse the function. So you were earlier going from y is equal to x square, now you are going from x is equal to root y. X is equal to root y, right? And and x is equal to y by 2, right? Okay. And notice that when x is equal to 0, y is 0, right? And when x is equal to 2, x here it was equal to, right? When x is equal to 2, then y is equal to 4, right? So that is why it will go from 0 to 4. Now this is the limit of y, right? Okay. And over here for the limit of x. This is the limit of x actually, right? So it is going now from x by 2, sorry, y by 2 to root y, right? Because notice that this was y is equal to x, right? Since now the lower portion is touching over here on the y is equal to y is equal to x. So that is why this is the lower limit, and the upper portion is touching the y is equal to x square, right? That is why it goes from y by 2 to root y x cube dy, which is the order dx dy. This is how you change the order, right? After that you can evaluate it. This is simple part. Okay, I hope it is clear, right? Okay, so now let's see another question. Probably we have done almost many which can build the concept. Let's see if we get any more which is like helpful. Okay, we have done this one, and this one we will okay, so we are going to do this maybe. Okay, this region we have done, and again this similar question. This is x square cos square. Yeah, this we will discuss tomorrow, and yeah, for now this much is enough, and tomorrow we'll see some better questions. Like in the one shot, in this we have built all the concept from of triple and double integral. So I hope you all understood everything what I taught. So please do like, share, subscribe my channel, and thanks a lot for watching. Bye bye. Take care. Hello everyone, this is Aditya, and today we will do some practice problems for end sem examination for mathematics. And note, in this we will start from sequence series and not from the Rolle's theorem, because I have already covered Rolle's theorem and the like first two chapters already in my previous videos. So you all can watch that. I will send the link for that. Okay. So now let's start with from the sequence series, and without wasting time, we will directly move on to the questions. Right? Okay. So please do like, share, subscribe my channel, and now let's dive into the video. Okay. So let's start with the question number 1. Okay. See, I won't tell any concept. I will tell the concepts over here, but I won't discuss whole theory over here because it will be the waste of time, because I have already covered them in my previous video. So you all can watch that. Okay. So I am directly starting with the questions. Okay. And note that I am not well, so please don't comment me if I make any mistake. Okay. Please see if I make any mistake. Please comment that I made the mistake. I will try to correct it, or maybe I will make a video on the correction of that. Okay. Okay, so now let's start. Let's see the question number 1. We have to check the convergence of n is equal to 1 to infinity of 1 upon root n plus root n plus 1, right? We have to check the convergence of this. So how do we do this? Well, in this we apply the p-test. Okay, how does the p-test go? You all know. For example, if we have a series n to the power p as n goes from 1 to infinity, this is convergent if p is greater than 1 and is divergent equal to 1, right? This is the case, you all know. Okay. So notice that in this, how we will assume the p? We assume such a p so that the limit, when we take the limit as n tends towards infinity of fx by gx is equal to lambda, it should be a finite value, right? So from that we conclude that if gx is converging, then gx will also converge. I mean, if gx is converging, then fx will also converge. If fx diverges, then gx diverges, like that. You all remember from my video of sequence series, right? Okay. So we have to choose such a function gx so that we get a lambda that is a finite value. So basically we choose of the power like this is n to the power 0 by root n, right? So this is equal to g of x, which is equal to root n to the power 1 half, right? Okay. So we have got our gx, right? Okay. So now let's substitute it. What we get? We get limit n tends towards infinity of f of n by g at n, and it is equal to the limit as n tends towards infinity of let me write it over here so that it is clear. Okay, let me keep the duster. Yeah, now let's see. We get the limit as n tends towards infinity, what was the expression? It was 1 upon root n plus 1 divided by gx. Gx was 1 upon root n, right? Okay. Many people ask me that how I wrote root n. So like it's very basic, but still many people get confused because we don't add a 2 over here. So it is equal to n to the power half, right? Don't forget it, okay? So just bring that term in the numerator as n tends towards infinity of root n by root n plus 1, right? You get this, okay? Okay, so what? Well, you notice that as n is tending towards infinity, n plus 1 is almost equal to n only, right? Because we know infinity plus 1 is almost equal to, we assume it equal to be infinity. Obviously, this is wrong. I mean, I can't directly write infinity. I should be using the limiting case, but it's okay. I have to explain, so that's why I'm using it. That is why I can write it like this. Limit n tends towards infinity of root n by root n plus root n, which is equal to 1 by 2, which is a finite value. Okay. So notice that if I would have taken gx as suppose 1 upon n or 1 upon n square, what would be the case? It would be n square by root n plus 1, right? If I would have assumed gx as n square, not a root of n. Okay. So in this case, it would be diverging. You will solve the limit, you will get infinity as the answer, right? So that is why we have to choose very wisely a function g of x such that the limit becomes a finite value so that we can conclude anything, right? That is why. So we got a finite value 1/2, okay? Which means if gx is converging, then fx will also converge. But notice that this term, this is equal to, I mean, g of x was 1 upon n. So in this case, p was less than 1. Since p was less than 1, so g of x is diverging. So this also diverges, okay? The question which was written 1 upon n to the that thing, that will also diverge, okay? So now let's move on to the next question, okay? Sorry. Let's see another question. The question states this one, second one, question number 2. Summation n is going from 1 to infinity of log of n by n to the power 3 by 2, and this is whole square. So how do we evaluate such problems? Okay. So in this way, we'll use integral test. You remember what is integral test? If this is your fx, f of n, summation n is going from 1 to infinity. What is f of n? It is log n whole square by n to the power 3 by 2, right? So you will integrate 1 to infinity of fx dx. And notice that if it would have started from 2, then you would take the integral from 2, right? Okay. So basically you solve this, you get 1 to infinity of log of x by x to the power 3 by 2 dx, right? You will get this expression. Okay. So let's solve this and let's see what we get. And notice that if this will be converging, then the summation will be converging, and if this diverges, then the summation will also diverge, right? The summation is basically, integration is basically a summation of very small elements, right? That is why. Okay. So let's see. Let me erase this. Now starting with the integral. Let's see what we get. Integral 1 to infinity of log of x by x to the power 3 by 2 dx, right? So basically assume log of x equal to t. So you get x is equal to e to the power t, and we get dt is equal to dx by x, right? We get this, okay? And notice that when x is tending towards 1, then t is going towards 0, since log of 1 is 0. And x tends towards infinity, t is going towards infinity, right? Since log of infinity is infinity, okay? Right? I hope that you are understanding it, okay? If there's any doubt, you all can ask me anytime, okay? So let's move on to the topic. Okay? So we get integral 0 to infinity of t square by, what we will get from here, we get dx by x. So it will be written as, notice that we can, first of all, let's see this integral. It was 1 to infinity of log of x by root x into dx by root into dx by dx, right? We got this, okay? Now change the limit 0 to infinity of what is log x. Log x is equal to t by What is it is equal to this quantity, x is equal to this. So you get root of e to the power t, right, into dt, since dx by x is equal to dt, right? Okay. So you get 0 to infinity of t, I guess it will be t only. Yeah, it will be, sorry, log x whole square. So it will be t square, right? T square e to the negative t by 2 dt, right? And I hope so that many must have understood that this is a gamma function. It is form of gamma function. We have to convert it. So let's put t by 2 equal to y, right? So we get dy is equal to dt. So 2 dy is equal to dt, right? Now let's substitute. There is no need to change the limit, since as t is going towards 0, y is 0, and when t goes to infinity, it is equal to infinity, right? So we get 0 to infinity of the quantity. What is t? T is equal to y. So 2y whole square e to the power negative y dy, right? Dy, and it is equal to dt is equal to, so we get 2 another, right? So we get like 8 times integral 0 to infinity y square e to the power negative y dy, and this is equal to 8 times the gamma of 3, which is equal to 8 times 2 factor, which is equal to 16. I also, the method is clear. Maybe my calculation may be wrong at any point. I agree to it. Maybe it is wrong. I don't know. But the method will be this, right? And you got a converging value of this integral. Since you got the converging value, so it means the summation which was given from 1 to infinity of log of x whole square by n to the power 3 by 2, it is also converging, right? So I hope you understood this problem, okay? Now let's see another problem. There's a topic which is there, application of integrals. So in that we are told to find the path length and all. That is a part of JEE syllabus. So I'm not discussing it because it will take lots of time. If I get any time, I will try to make 3-4 question video on it separately by tomorrow evening. Else you all can do it on your own. Okay. So now let's see another question, and let's see what is it given. This question, yeah, this one. This is a series 1 plus 1 plus alpha by 1 plus beta plus 1 plus alpha plus 2 alpha by 1 plus beta plus 2 beta, and so on and so forth. So we have to evaluate this limit. How do we evaluate it? Let's see. Solution. So let's write its general term. We get like we get a of suppose u of n is equal to 1 plus alpha plus 2 alpha, and so on and so forth till n minus 1 alpha upon 1 plus beta plus 2 beta, and so on and so forth till n minus 1 beta. How do I how do I understood that this will be the expression? Because when you substitute 1, you get 1, this thing. When you substitute 2, you get this, okay? And I read the pattern that it is going from 1 alpha and then 2 alpha, right? Which means it is going like this is third term, so you got 2. When it will be fourth term, you will get 3. That is why it is that n minus 1, right? Okay. So you get this, and then oh, I'm sorry, I think I wrote the question wrong. Yeah, I wrote it wrong. 1 minute. Sorry. This is a question. Sorry, I'm really sorry for that. 1 plus 2 alpha by 1 plus beta into 1 plus 2 beta. 1 plus alpha, 1 plus beta, 1 plus 2 alpha into 1 plus 3 alpha by 1 plus beta into 1, this is beta, 1 plus beta, 1 plus 2 beta, 1 plus 3 beta, and so on and so forth. I'm really sorry for that. I was thinking something else. That's why. So now let's see this one. So again, you make a general pattern. It will be like this: 1 plus alpha into 1 plus 2 alpha, and so on and so forth. Still, that is the same thing, n minus 1 times alpha by 1 plus beta into 1 plus 2 beta, so on and so forth, 1 plus n minus 1 beta. You get this thing? Okay, is it okay? So how do we even check this expression? It looks so scary at first, but it's not. See, use that D'Alembert's test in this. How you evaluate, you will understand that it will become very simple when we use that. What is un plus 1? Un plus 1 will be equal to 1 plus alpha, and this thing plus n minus 1 into alpha into 1 plus n alpha, right? You get this upon 1 plus alpha, 1 plus beta, so on and so forth till 1 plus n minus 1 into beta into 1 plus n beta, right? You get this thing? Okay, okay, is it okay? Yeah. So now let's evaluate further how what we get, and to a great surprise you will understand that you got something interesting. How? Let's see. Well, un plus 1 is equal to, notice that this term is your un. I hope you understood, right? Is un times 1 plus n beta by 1 plus n alpha, right? You get this thing? Is it okay? Yeah. So let me erase this thing also, and then we will see another. Okay. So you get un plus 1 by un is equal to 1 plus n beta by 1 plus n alpha, right? And now you use the Albert's test, limit as n tends towards infinity, un plus 1 by un is equal to 1 plus n beta. I should put the limit. Limit n tends towards infinity of 1 plus n beta by 1 plus alpha n, right? Means n alpha, right? Whatever. 1 plus n alpha, right? Many a times it is taught like this, un by un plus 1, but that is like, it may be confusing. So that is why I use the consecutive term first. So un plus 1 by un, okay? You get limit n tends towards infinity of 1 by n plus beta plus 1 by n plus alpha. You substitute infinity, you get beta by alpha, right? Okay? So this thing, limit n tends towards infinity of un plus 1 by un, it will converge for, it will be greater than 1, it will converge, it will diverge, sorry, it diverges, and for less than 1 it will be converging. Is it okay? Why is it so? But it is because you know that since this is the next term and this is the previous term, so when you take the ratio, if the next term is increasing, it is greater than the previous one, then it's obvious that it will be diverging. But if it is less than 1, means if the previous term is greater than the next term, which means it is a decreasing series, so there are chances that it may converge, right? So we get this, okay? So we get, for converging condition, beta by alpha must be less than, so beta must be greater than alpha for the case of convergence, right? Is it okay? Yeah. And I hope I did not make any mistake. Yeah, I did make one. It was 1 plus n alpha and it was n beta, right? So again it was alpha and it was beta and it was alpha and it was alpha and this was beta and this was beta. And now it's fine. It will be alpha by beta. So it is equal to alpha by beta. So you just change the inequality. So beta must be greater than alpha for the given quotient to be convergent. Okay, right. I'm sorry for that. I'm sorry, I'm not well. That's why. Okay. So let's see next problem. I hope you all are enjoying the video and please do like, share, subscribe my channel. So now let's start. Okay. So let's see another type of problem which we can encounter. Well, we discussed this one and this one. I think we should discuss a problem related to the Cauchy root theorem. I hope you all know the Cauchy root theorem. Let's see. Okay, let's see the question. What it states? It states the summation as n goes from 1 to infinity of the quantity n plus 1 of x to the power n upon n to the power n plus 1. Right? Is it okay? Yeah. N to the power n plus 1. Right? This is the question. Yeah. So how do we evaluate this? You get un is equal to n plus 1 into x whole raised to the power n upon n to the power n plus 1, right? You get this thing, okay? So what does Cauchy root test tell? It tells that nth root of un is equal to, as n tends towards limit n tends towards infinity is equal to lambda, it will be converging for lambda, it will converging for lambda less than 1 and it will diverging for lambda greater than 1, right? I hope you understood. I know you all know, right? So we'll apply same thing over here. Okay, let's see. Let me write this thing over here. Un is equal to n plus 1 into x to the power n by n raised to the power n plus 1 as it is. Okay, you have written it. So now let's test it by using Cauchy root test. Let's see. Okay, so we get like limit as n tends towards infinity of un to the power 1 by n, right? I hope so. I should like write it like this. Okay, okay, so you write this limit as n tends towards infinity of n plus 1 x whole raised to the power n upon n plus 1, it is 1 by n, right? Okay, you get this thing, right? So when you evaluate it, you get limit n tends towards infinity of the quantity, you get n plus 1 into x upon n plus 1 by n, right? You get this thing. Okay, is it fine? Yeah. So notice that it is again infinity plus 1, n is infinity, n is tending towards infinity, so infinity plus something very very small, that is 1, it is obviously equal to n only itself, right? So you can make this equal to n for simplicity. Okay, upon n to the power you can write n plus 1 by n as equal to 1 as equal to n by n plus 1 by n is equal to 1 plus 1 by n. I'm doing the simplest calculation so that no one faces any problem. Okay, that is why. Okay, I hope you understand, right? Okay. Sorry. So we get 1 plus 1 by n, right? Now you can simply bring it down. You get limit n tends towards infinity of x by n to the power 1 by n. And notice that I have already solved this limit in my sequence series lecture. You can watch that, right? I won't be able to solve right now because we have very less time. So that's why. So this is equal to x. Now this was your lambda. So lambda for greater than for less than 1 this converges, and for lambda greater than 1 this will diverge. So it means if x is less than 1 then this series converges, right? Okay, that's the thing. Now let's see one more problem. These questions are based on your PYQs and some of the reference books which you all use, and probably some of the notes or the PDFs which are getting circulated. So from that I picked some nice questions which may be asked. I'm not sure they will be asked. I'm not God, so that's why. Maybe they may be asked, they may not, but it's like I'm trying to build a concept for you all, right? That's the thing. Okay, so let's see one more question. We are given a question as summation n goes from 3 to infinity of the quantity root of 2n square minus 5n plus 1 upon this is plus 1 upon 4n cube minus 7n square plus 2, right? This is the thing which you are given. Okay, okay. So in this again you will use the p test. Why? Because you see a simple algebraic terms, right? Okay. So what basically will be the value of p? You will take like root of the highest power of this upon the highest power of this. You get n by n cube. 1 upon n square is equal to g of n, right? So we know that g of n is converging since p is greater than 2, right? We know this. But now we have to check the limit also to confirm it. I may have written there f of n, it is un, everything is same. So un by vn, this is your g of n, or we say in general term v of n, right? Okay. It is like in integrals we use a function and this we use a terms. There's the difference, nothing else. Okay. So basically you get root of 2n square minus 5n plus 1 upon 4n cube minus 7n square plus 2 into 1 upon n square. It will that 1 upon n square, 1 upon n square, and this 1 upon n square will go upwards, so it will become into n square, and after that you can solve the limit. Okay, I'm not going to solve the limit, and you will check what value you get in the limit. Okay, and then accordingly you will say that this is convergent or divergent. But g of n, that is Vn, is convergent, we know that. Okay, so now let's see another problem. If I will discuss every problem numerically, then it will take lots of time. Okay, so I'm just telling you all the concept which is required for every problem. Okay, so let's see another problem, and I hope you all are understanding it, right? It's not like that it's going everything blank. No, it should not be. You have come to learn, so you have to learn. Okay, that is the thing. Okay, so now let's see this question. This is last question from sequence series, and then we will move on to some other topic, to maybe integrals, right? So you get x minus x square by 2 plus x cube by 3 minus x to the power 4 by 4, and so on and so forth. This is known as a alternating series, right? You all know this. I covered this, right? Solution. So we have to check whether is it converging or not. So what is the nth term in this case? It is equal to like un is equal to negative 1 to the power n minus 1 of the quantity x to the power n by n, right? You substitute 1, you get substitute 1, you get this. You put 2, yeah, that's okay. So by absolutely convergence test, we'll prove this thing. How? Let's see. So for absolutely convergence test, you have to check for this quantity, so on and so forth, right? So if this will be convergent, then this will be absolutely convergent, right? Okay, else we can prove it conditionally also, but let's see for absolute convergence first of all, right? So what is the general term in this case? It is equal to u of n is equal to, let's say, u dash of this, so there's no confusion. Okay, it is equal to x to the power n by n, right? You got this very simple expression, right? So u of n is equal to x to the power n by n, right? This very simple expression which you have got. And now how do you evaluate it? Again, you see power of n, which means you will apply Cauchy root theorem, Cauchy root test, I mean. Okay, so you get nth root of un of limit as n tends towards infinity of this quantity. You get limit as n tends towards infinity of x to the power n by n upon x to the power 1 by n, which we get limit as n tends towards infinity x by n to the power 1 by n. Again, you know this limit. This is x and this is n, right? So as n tends towards infinity, this limit is going towards 1, so we get x, right? So notice that this expression is convergent for like x less than 1, and for x greater than 1 this is divergent, and for x it is convergent. So if x is less than 1, then this expression is, if x is less than 1, then this is absolutely convergent, and for x greater than 1 this may be convergent, this may be not convergent. If but we are sure for x less than 1 this is absolutely convergent, right? This is absolutely convergent, but for x greater than 1 we can't say anything, so we have to test for x less than 1. So we have to test this in a general way also, right? Let's see how. Okay, so notice that if x is for x greater than, so for x is greater than 1, let's see, x greater than 1, right? We are checking. Okay, greater than equal to, because in that case 1 is also not included, so I am including 1. Okay, so basically you get x minus the, what is the general term? It is again equal to negative 1 to the power n minus 1 x to the power n minus 1 by, sorry, n upon n, right? This is the thing. Okay, so what is the last term? We have to check now. Okay, so limit as n tends towards infinity x to the power n by n, right? This is the thing. You differentiate, you get x to the power n minus 1. This is the Leibniz test, right? You remember for Leibniz test, I'm writing LT, it's Leibniz test. This must be a decreasing sequence first of all, and second, that limit as n tends towards infinity, this expression must be equal to 0. So x to the power infinity, basically this is x to the power infinity, so this will be equal to 0 when x is less than 1 and greater than 0, obviously, because we obviously assume it is greater than 0. It means for x greater than 1, this is divergent, right? Greater than or equal to 1, right? Okay, understood. Okay, so which means this is convergent only for this value of x, right? So with this we come to an end of the sequence series, and now let's come to integrals part, right? Okay. Sorry. Okay, so now let's come to the integral calculus. Integral calculus, right? Okay. So we are coming to now integral calculus, and in this we will solve like many problems based on the beta gamma function. And in this I'm not doing the problems for the convergence of integral because I have already covered that in a separate one shot. So I'm not covering that because I don't think so. If the question comes from the sequence series convergence, then it will be asked in the integral one, right? That is why I'm skipping that part. You can watch that in my one shot of the integral calculus that I covered it deeply. It is like 1 hour lecture only. So let's start with the beta gamma function first of all in this. Okay, we will do one question first of all. So let's see the first question of integral calculus. Let's see the question, what it states. It states that we have to prove that beta of m comma n is equal to the integral 0 to infinity of the quantity t to the power m minus 1 by 1 plus t to the power m plus n dt, right? So how do we evaluate such kind of problem? Well, let's see. Maybe I can erase the upper stuff also so that I get more writing space. So let me erase this. Yeah. So now let's solve the problem and let's see how we get. Okay. So beta of m comma n. Okay. So we will take this expression. This is 0 to infinity t to the power m minus 1 by 1 plus t to the power n plus n dt, right? You get this. Let me erase the everything written on the board so that now I have more space to write. And this problem looks like it is very difficult, but it is very easy. How? Well, you see 1 plus t, 1 plus something, which means you will start thinking about some trick function. And what is 1 plus t? You think that, yeah, if I put t square, then it will 1 plus t square, it becomes sec square theta, and it may work. Okay. So we will use t is equal to tan square theta, right? You may have used another function like cot also, but in that case maybe it would have been more easy. It don't matter. Okay, whatever be the case, you have to just use like tan or cot in this since you have a plus sign. Okay, if if it would be like negative, then you would have used sine square or cos square, whatever. Okay, so dt is equal to 2 tan theta into sec square theta, right? You get this. Okay, so notice that when t is equal to 0, then theta is also equal to 0, and when t is equal to infinity, then theta is equal to pi by 2, right? So you get the limit 0 to pi by 2, halfway done, right? You get tan to the power 2 m minus 1 by 1 plus t square 1 plus tan square theta to the quantity m plus n into 2 tan theta square theta d theta, right? You get this thing. So you get 0 to pi by 2 of tan of 2m minus 2 theta by, what is this? This sec square theta whole raised to power m plus n into 2 times tan theta into sec square theta d theta, right? You get this thing. Okay, right. Sorry. Okay, so now let's see if I can put somewhere duster. Like, okay, so this is the limit. This is the integral 0 to pi by 2 of the quantity. You can write tan in terms of like sine and cos theta. You remember tan theta is equal to sine theta by cos theta, right? You remember the simple thing, right? Okay, sine to the power 2m minus 2 theta by cos 2m minus 2 theta, right? And what is sec square theta? It is 1 upon cos square theta, so that cos will go upwards. So you get cos of 2m plus 2n, 2m plus 2n, right? I hope this is a question, yeah. Into what we are getting over here is this, yeah. Into, yeah, this theta into 2 tan you can write again sine theta, 2 sine theta and cos theta into this quantity. This is again 1 upon cos square theta d theta, right? You get this. Okay, as simple as that. Okay. Okay, so let's evaluate it further. Let me raise that stuff also, else it will like confuse many times. Okay, so let me write it further. Okay. So it is 0 to pi by 2 of the quantity sine of 2m minus 1 sine theta, and this multiplier will add 1, so it will be 2m minus 1 theta cos 2m minus cos 2m plus this quantity upon this. What do you get? 2m plus 2n minus 2m plus 2, and this is minus 2 minus 1, this and this like it will become cos cube theta, right? So basically it is minus 3. Okay, no need to be confused. And this is like cos, this is in the denominator, so it will be like subtracted from that power, right? I hope you are understanding it. D theta, right? Obviously 2 will be outside, so 2 times the integral 0 to pi by 2 sine 2m minus 1 theta. This will be like this theta, 2m and 2m cancel, and this becomes cos of 2n minus 1 theta d theta, right? And this is equal to beta of m comma n, right? You know the polar form of that beta and beta mn, right? It is this, right? That is what, hence proved. Okay, it is as simple as that. It looked like it was very difficult, but it is very easy when you solve it, right? Okay. Okay, so now let's see another type of problem. Let's see what we get first of all. Okay, so you are given to prove like this question. This is very simple. 2 times the integral, this is equal to, you need to prove this stuff, e minus x square x to the power 2n minus 1 dx. You need to prove this thing. Okay, how do we check it? It's very easy, right? It's like let's see. So you put x square equal to t first of all, so you get dt is equal to 2x dx, right? Okay, so notice that integral 0 to infinity of e to the power negative x square x to the power 2n minus 1 dx, it can be written as the integral, and notice that the limit will be unaltered, because when x is equal to 0, then that is also equal to 0. Yeah, so this is 0 to infinity, and it is e to the power negative t, and what is x over here right now? So x is equal to, well, wait, we can write x as x to the power 2n minus 2 by into x, or x to the power n by x dx. We can write it like this, and we get dx is equal to dt by, yeah, we can write it like this, or yeah, x to the power 2n minus 1, we can write it like x to the power 2n minus 2 into x, we can write. Okay, so notice that there was a 2 over here, so you bring that, so you change it like this, 0 to infinity of e to the power negative x square x to the power 2n minus 2 into 2x dx, right? Now it is very easy to transpose, right? And you can write it like this, x square to the power n minus 1, right? Is it okay? Right. You put over here, you get t to the power n minus 1, since x square was t, right? That's why. And this 2x dx is dt. And this is equal to gamma of n. As simple as that. Right? So simple problem. Okay. Okay, so now let's see another problem, and then we will start with some other topic. Yeah. We will do like 2 problems more in this gamma and beta function, then we will move to some other problems of like integral, multiple integral, right? So let's evaluate this thing, and then let's see. Okay. So let's do this question. Is it okay? Beta of m comma n is equal to beta of m plus comma n plus beta of m comma n plus 1. We need to prove this thing, right? Well, this is something new which you may have learned today, because I don't think so it was ever taught. So this is equal to, how do we prove this? So we'll start with the RHS term, okay? And it's very simple proof, right? Let's see. Beta of m, I should write it like this. Beta of m plus 1 comma, I hope I should change the chalk, this is not working properly. So we get like beta of m plus 1 comma n is equal to integral 0 to 1 of x to the power m plus 1 minus 1 minus x to the power 1 minus x to the power n minus 1, right? So you get 0 to 1 x to the power m 1 minus x to the power n minus 1 dx, right? You will get this thing, okay? And now when you do beta of m comma n plus 1, you will get integral 0 to 1 x to the power m minus 1 1 minus x to the power n plus 1 minus 1 dx, right? And again you can write it like this directly, okay. So you just add these two things, beta of m plus 1 comma n plus beta of m comma n plus 1, right? You get integral 0 to 1 x to the power m 1 minus x to the power n minus 1 dx plus this quantity dx, right? You will get this thing, okay. Now let's see what we get after adding, okay. Okay, you take integral outside 0 to 1, and this you make another function. You get x to the power m into 1 minus x to the power n minus 1 plus x to the power m minus 1 minus x to the power n dx, right? You get this stuff, right? Okay, you take x to the power m minus 1 and 1 minus x to the power n minus 1 as common. You get x plus 1 minus x dx, and to a great surprise you get like x to the power m minus 1 1 minus x to the power n minus 1 dx, and it is equal to beta of m comma n. Hence proved whatever was asked, okay. You should remember this property, this is important, right? Okay. Obviously I can't do all the problems in this video, so you have to watch my other one shots also, like there are 3-4 one shots available for end sem, so you can watch them, because in that I got like many questions. I can't cover every question in this right now, okay. So there's a property which I need to tell you all, that gamma of n into gamma of 1 minus n is equal to pi sine of n, right? Like you should remember this property, it's helpful in many cases, right? Okay, so now let's see a question. Yeah, this question is really important, right? You should like know this, it is really important in my opinion, because I hope so there can be a question related to it. Sorry. Integral 0 to 1 of t to the power m 1 minus t to the power n to the power p dt. Obviously I covered this in my one shot, because at that time also I said it is very important, so that is why I am covering it again, else I should have not covered this, okay. So you have to use t to the power n as equal to x, right? Basic idea. So you get over here that dx is equal to ntn minus 1 dt, right? You get this? No, you get x is equal to t to the power 1 by, sorry, t is equal to x to the power 1 by n, right? This is the case, okay. And t is equal to, yeah, so dt is equal to 1 upon n x to the power 1 by n minus 1, okay. Is it okay? Yeah. So t to the power m is equal to, like, you raise both sides, x to the power m by n, right? So notice that when t is equal to 0, x is equal to 0. When t is equal to 1, then x is also equal to 1, right? 0 to 1, x to the power m by n of the quantity 1 minus, what is t to the power n? It is again x to the power p of the quantity dt 1 by n, this is dx also, 1 by n into x to this x, right? My x and n look like similar. I'm sorry for that. 1 by n minus 1 dx, right? Have to be careful right now, okay? Have to be careful. So it is 0 to 1. You can take 1 by n as common. So you get x to the power m by n. You add this and this. You get plus 1 by n minus 1. 1 minus x to the power p plus 1 minus 1. You know why I have did this. Because it is of the form n minus 1. So that is why I have to make in that form. We are told to write this in terms of beta function. So that is why. Okay. So 1 by n integral 0 to 1 of the quantity x to the power m plus 1 by n minus 1, 1 minus x to the power p plus 1 minus 1 and dx. You get the answer as 1 by n into beta of m plus 1 by n comma p plus 1. It is like really important result. You should remember this result even and the proof even, because there are multiple, like they will ask you a question like 0 to 1 t to the power 9 into 1 minus cube to the power like suppose 10 dt, right? There are some problems like this, or maybe they might ask 1 minus root, whatever, like they can change the values m n and p, they can permutate or combinate that, and they will like give you such questions, right? Okay, so that is why you should remember this thing. That is why I discussed it again. Okay, okay, so let me write another question and then we'll solve it. Okay, okay, so now let's see another problem. It's I guess around 40 or 50 minutes lecture already. I have to complete it like in some less time. Let's see question. So gamma of n plus 1 by 2 is equal to root pi by 2 to the power 2n minus 1 gamma of 2n by gamma of n. We need to prove it. So how do we prove it? Let's see. Okay. Yeah, and the proof that gamma is of 1 by 2 is equal to root pi is really important, right? I won't discuss it right now because we don't have time. So that is why you should watch my integral calculus video. In that I have covered this also, and there are many other questions which I have covered. So you should watch that lecture first of all, then you should come to this lecture. Okay, right? Okay. So gamma of n plus 1 by 2, you can write it from the property that gamma of this is the property. Just apply it. N plus 1 by 2 minus 1 into gamma of n plus 1 by 2 minus 1, right? This is the thing. So you get n minus 1 by 2 into gamma of n minus 1 by 2. And you again apply this property, you get n minus 1 by 2 into n minus 3 by 2 into gamma of n minus 5 by 2, right? You'll get like this n minus 3 by 2, right? Is it okay? Is it clear? Yeah. And you will go till gamma of 1 by 2, right? Okay. Let's see. So let's see what we get. Sorry. So you get gamma of n plus 1 by 2 is equal to like n minus 1 by 2 into n minus 3 by 2 and so on and so forth till gamma of 1 by 2 till here 1, right? Okay. So you get 2n minus 1 into 2n minus 3, so on and so forth till 3 into 1 into gamma of 1 by 2 and by 2 by 2 by 2 by 2, right? You'll get this thing, okay? 1 by 2, right? Okay. So let's see. And notice that they are like n terms over here because 2n minus 1 is equal to 1, right? 1 plus n minus 1, what is the common difference? 2, you will bring it over here, so 2n minus 2 is equal to n minus 1. So this is the, suppose the k term, k minus 1 is 2, so you get k is equal to n, which means there are n terms. So there will be n power, or there will be n power of 2 in the denominator, right? Okay, so let's see. Okay, so let's see this thing. You get 2n minus 1, 2n minus 3, so on and so forth till 3 into 1. 3 into 1 into gamma of 1 by 2, you know it is root pi, but I am not substituting right now, okay? For some reason. 2 raised to power n, right? You get this thing. Now what you do is you will write it like this: 2n minus 1 into 2n minus 2 into 2n minus 3 into 2n minus 4 and so on and so forth till 3 into 2 into 1 into gamma of 1 by 2 upon 2 raised to power n into 2n minus 2. Obviously you multiplied by that, so you have to divide by that to make it equal to 1. Okay, 2n minus 4, 2n minus 6, so on and so forth till 4 into 2 into this quantity. Now you take 2 common from each expression in this. Okay, so this is equal to 2n minus 1 factorial by 2n into 2 into 2 into 2 and so on and so forth till n minus 1, n minus 2 and so on till 3 into 2 into 1 into gamma of 1 by 2, right? Is it okay? I taken out 2 from this. I took common 2. I took 2 from this, 2 from this, and 2 from this. Right? Okay. That is why it become n minus 1, n minus 2, n minus 3, n minus 4, and so on and so forth, and so on and so on. And you got 3 to 2 into 1, right? Okay. So sorry, I'm really tired, so that's why my words are like fluctuating. So that's why don't worry about that. I will try to keep the same energy throughout the lecture. So this is equal to gamma of 2n, right? And this is equal to 2 raised to power n into 2 raised to power 2n minus 1. This is n minus 1 factorial into gamma of 1 by 2, right? You got this thing? Okay. Let's see it further. Okay, so you get gamma of 2n by 2 raised to the power 2n minus 1. How? 2 raised to the power 2n into 2 raised to the power 2 raised to the power n minus 1, which is equal to 2 raised to the power n plus n minus 1, which is equal to 2 raised to the power 2n minus 1. Right, you got this? Is it correct? Yeah. So you get 2n minus 1 into n minus 1 factorial, it is equal to gamma of n, and it is equal to root pi by root pi. That gamma of 1 by 2 is equal to root pi. Those who don't know, kindly visit my video of integral calculus. In that I have covered like that one shot. I have covered like many questions and all the concept related to integral calculus which is required. So okay, let's move on to the next question right now. Okay, let's see another problem. Yeah, it's done. For integral calculus, it's done. Like these are some important questions, and if I'm not covering like improper that convergence one, because I have already covered in the integral calculus part, so you can visit that. Okay, these are really important, so that is why I had to discuss it again. Okay. Now let's see some concept, some questions on multiple integral, multiple integrals, right? So let's see how we approach multiple integral. First of all, you should know that how we assume the polar coordinates in that. Suppose you are given this region, suppose W, some region, f of x comma y comma z dx dy dz. Okay, so first of all I will start with the spherical region. Why do we assume, like we assume x is equal to r sine theta cos sine phi, then we assume y is equal to r sine theta into cos phi, and then we assume, right, it's sine phi and cos theta, right, and z is equal to r cos phi. Why we do like this? In this case you get Jacobian xyz is equal to upon r theta and phi, you get r square sine phi, right? Okay, remember this. Okay, so what's the need of all this? In this we say that r is greater than 0 and theta belongs to like 0 to 2 pi, pi belongs to like 0 to pi. Why this case? Well, let's try to understand it. This was your like original coordinate system x, y, z. We are not worried about this. We are worried about this thing. So how do we approach it? Let's see. R square sine phi, right? Now I need this much space. You write this, you write it like this, and you make like x-axis over here. You make a z-axis, whatever axis you want to say. This is your r, this is your phi, this is your theta, right? So basically you are going like this. This is your semicircle, right? This is your semicircle, right? And this is your, like, this is your radius r, this is your 0. So that is why when you integrate it, so this is somewhat like this. If I can show you, yeah, this. Suppose this is a plane, this is this paper. So this is your, if I'm not having anything right now to show, but you will take it is somewhat like this. Okay, you will rotate it like this, counterclockwise or maybe clockwise, whatever. So in this case also you will take the semicircle, you will like rotate it 2 pi 360 degree. So that is why the theta will be like theta will range from 2 pi, right? And see the phi is from like it is 180 degrees. So that is a phi is lying between 0 to pi, right? And r is like 0 to r. Okay, so this we integrated from 0 to here, right? Right. So we are concerned about the volume of this sphere right now. Okay, so that is why we put limits like this. Okay, and notice that if it is asked like for in the first quadrant we have to calculate. So in that case we will erase this stuff and it will be left like this. Okay, so in this case, for one quadrant, we will go like from here to here. So here r will be greater than 0 and phi will lie from 0 to pi by 2 since we only covered first quadrant. Okay, and theta will also be 0 to pi by 2, right? This is how you assume the limits. Okay, obviously opposite, right? This is for the first quadrant and that was for the complete sphere, right? So that is why how you assume the things, right? Okay, now coming to the cylindrical part. Okay, cylindrical coordinate system, let's see how we assume it, and then we'll see some problems and then we'll end the lecture because I am really tired also, and like we have covered everything almost, right? That is why, and I hope so that please you will subscribe the channel at least. Okay, and please support my channel. So now let's see the questions. Cylindrical basically cylindrical coordinates, let's see. So this is the integral again. Suppose D is the region, f of x, y, z, dx, dy, dz. You get this thing, right? Okay. And now what we are going to do is that we have to assume the cylindrical coordinate system. So in that, how we will use x is equal to r cos theta, y is equal to r sin theta, and z is equal to z. Why are we doing like this? This is the basic question. Well, suppose this is your sheet, this is your z axis. Okay, you take x and y plane. Suppose this is your let me try to draw it. This is your y, x, and this is your z which is coming out. Okay, so you basically taking a sheet, suppose this, and you are trying to revolve it, rotate it like this around a length of z. So that is why we haven't changed the value of z. And notice you are getting a circle. So that is why you converted to the polar of circles, right? That is why x is equal to r cos theta, y is equal to r sin theta, and z is equal to z. And in this case, the limit also you will take like 0 to 2 pi, right? And r will be greater than 0, right? That's the thing. Okay? It is going across this whole plane. Okay, that's why. So now let's see some problems and then we will end this lecture. Okay. Sorry. I'm really sorry, my words are fluctuating a lot, so kindly bear with it. Okay. Okay, thanks. Okay, so now let's see a question. So I won't solve the complete question, I will just tell the method and you all will solve it. Suppose I covered this in my like previous lecture also. Integral this e to the power x, e to the power x plus y plus z, dx, dy, dz in the box region 0 to 1 cross 0 to 1 cross 0 to 2, right? 0 to 1, sorry. So how you will do this? This is your x limit, this is your y limit, this is your z limit, and they all are independent. So you get 0 to 1, 0 to 1, 0 to 1, e to the power x plus y plus z dx dy dz, right? That is how you will integrate it, right? I am not solving further because I covered in my integral calculus lecture. You all can visit that channel, okay? That video, sorry, channel is only one, that was for second. Okay, this is the thing, okay? You can evaluate it, you will get the answer as e minus 1 to the power whole cube, right? I covered in that lecture, so please I can't waste time on that, okay? Okay. It's like have been a very hectic schedule for me also because I was like covering all this like I made everything in like 3 4 days only. Like I used to take daily lectures, so that is why. And it takes like lots of time to prepare for one lecture because I have to teach like that. If even the one who does not know anything, they should also learn something. I try to make like that. That is why. So let's see another type of problem. Let's see this one. 0 to 1, 0 to x square plus y square to 2 of dz dy dx, right? So we are having this thing. So we are having this thing, and now let's say evaluate 0 to 1, 0 to x, and this dz, this is the limit of z since it is the limit is dependent upon x and y, so that is why it will be the limit of z only, okay? So we get z limit as it goes from x square plus y square till 2 of the quantity dy dx, right? So you again get 0 to x, 0 to sorry 0 to x, right? This is again the limit of y since it is over here we see x, right? You have to watch my integral calculus lecture for that to know how we are doing this. This is 2 minus x square minus y square. It is very simple, okay? Dy dz dx. You have to watch integral calculus first of all, else this will go like a bouncer to you. That is why. I hope you all are understanding now. So that is why. I guess my lecture is not getting bored. I guess my lecture is not boring. I hope so. So please try to learn as much as you can. And right, and yeah, really, I'm really tired and I'm not well. So that is why my words are like fluctuating like anything. So please kindly ignore this thing. Okay. Okay. So now let's see. 0 to 1, and you evaluate this, you will get 2y minus x square y minus y cube by 3. You substitute 0 to x dx, right? 0 to 1, you substitute 0 over here, you get 0 everything, you substitute x. Obviously, you will substitute x in the place of y only, you won't substitute x in place of x square, it is useless, okay? So so just remember that whenever you're substituting the value of the limits, you have to remember that in what reference you were integrating it. Like you were integrating with respect to y, so you have to put the value of the limits in y only, not in the place of any other variable, right? So 2x minus x square and x cube, since it is x, yeah, minus x cube by 3 dx. 0 to 1 integral, you can evaluate it 2x minus 4x cube by 3 dx. You get x square minus x to the power 4, 0 to 1, and this is equal to 0. Sorry, by 3. 1 minus 1 by 3, this is equal to 2 by 3. I hope the answer is correct or not, I don't know, but this is the method, okay? Right. Okay. So we have now the question is to find the volume of a sphere of radius equal to r. Right? This is the, I guess this is the question. Find the volume of the ball or the sphere of radius r, and in the region x square plus y square plus z square less than equal to r, of course, right? So we write volume as equal to x y z, right? Length into breadth into height. So that is why, that is how you write in the terms of integral. You write integral dz dy dz, right? Like this, okay? Since it's a sphere, we can use spherical coordinate system. It is very easy to that. So notice that if we use the spherical coordinate system, it will be like dr, this will be d phi, this will be d or wait, d upon a region, d upon a region, dz dy dx. You get this thing, okay? Now it will 1 over here because we are just calculating x y z, dx dz dy dx. That is the thing, okay? Sorry. So now when you convert it, like you will convert x is equal to r sine phi into cos into sine theta, and y is equal to r sine phi into cos theta, and z is equal to r sine r cos phi, right? You will convert this, and when you will solve, you get that now. What was Jacobian? It was r square sine phi, right? R square sine phi times d phi d theta. Limits are from 0 to capital R. Phi is going from 0 to pi, since we are calculating the complete volume of the sphere. And for d theta, it will go from 0 to 2 pi, right? This thing. And suppose if you are asked like to find only the quarter, then it will go from 0 to pi by 2 and 0 to pi by 2. All this, okay? I explained that earlier. Okay, you should watch that from beginning then if you could not understand. Okay, so now let's see how we evaluate it. Okay, so now let's see this integral 0 to 2 pi d theta. Since d theta there is no term of theta in this, so we can break this integral like this into this integral and this integral separately. 0 to pi sine phi d phi integral 0 to r square dr. You know that if the function are like this, some region f of x y z dx dy dz is equal to integral like f y f z dz, and the limits are supposed to defined a to b, b to c to d, e to f, and they're like independent limits, like they're not dependent upon any variable. E to f, d to c to d, a to b. You can break it like this: integral a to b fx d dx, right? Fx dx, since it will be fz dz multiplied by c to d fy dy and so on, right? That and the function, okay? I'm not writing that, but I covered that in integral calculus class. You can please visit there, okay? I can't tell everything right now. Okay, this is the thing. So basically this is equal to pi. This is equal to like negative of negative cos phi. Negative cos phi limit goes from 0 to pi. Let me write it. Negative cos phi limit goes from 0 to pi, 0 to r, and this is r square, r cube by 3, and it goes from 0 to r, right? And you can change the limit 0 to this, right? You get this thing, okay? You get this. So you get 2 pi times cos of 0 minus cos of pi into r cube by 3. You get 4 pi r cube by 3. That's it. This is the volume of a sphere, right? You all know it. Okay. Okay, so let's see if we have another question. We will solve 2 more and then we will end the lecture finally. I hope you all learned a lot from this video. If you learned anything new, then please do like, share, and subscribe my channel. And really, lots of thanks to you for watching my video also. Okay, so now let's see this question. We are given x square plus this triple integral dx dy dz x square plus y square plus z square 3 by 2, right? We are given this, and the region is given that we have to find the derivative. X square plus y square plus z square equal to a square, x square plus y square plus z square is less than equal to b square. And you have to find like what is the question? Yeah, you have to find this. You have to evaluate this integral, and you are given a is greater than b. Okay. So again, you will use the spherical coordinate system in this, so it will become really easy for you to evaluate it. Let's see. So you get, this will be 1 upon r square to the power 3 by 2. I'm not showing how I converted, I already showed it. Okay, so please don't ask me to write that. R square into sine of phi dr d phi d theta. Notice that the theta goes from 0 to 2 pi, phi is going from 0 to pi, and r goes from like b to a, right? Okay. Again, evaluate this integral, you will get like 4 pi by 3 times ln a by, okay, so it will like I just wrote this. Okay, 0 to 2 pi d theta, 0 to pi sine phi d phi integral 0 a to b, b to a, sorry, b to a of the quantity 1 upon r dr. You get 2 pi into this 2 pi into 2 into ln r b to a. You get 4 pi, you get 4 pi, right? 4 pi ln of a by b, right? So all you get this. Okay, I hope that the calculation is right. Even if it is wrong, it don't matter, because I wanted to tell the concept first of all, right? That's the thing. Okay, if there is any problem, you can comment me in the comment section that I made a mistake over there. I will try to see that thing. Okay, maybe I am right now very much tired, so that is why there are chances that I can make mistakes. That is why. Okay, and bear with it. Okay, so now let's see another problem. Well, if we have any, let me check. Well, yeah, this is the last question. No, this is like, yeah, this is the last question. You have to find the volume of tetrahedron in the region x equal to y equal to 0, and z is equal to 0, and x plus y plus z is equal to 1. Right? Is it okay? So basically, you will do this integral this dz, dy, dx. You will draw a region, you will draw a tetrahedron, and then that you will show. Like, let me tell you all. This is your x, y, z. This is your 1 comma 0 comma 0. This is your 0 comma 0 comma 1. This is how the region looks. So you are consider the area, the volume of this thing, right? That is why. That is the thing. So it goes from like 1 0 to 1 minus x minus y. Then you substitute y as 0. You get, it goes from 0 to 1 minus x, and then it goes from 0 to 1. You evaluate this, you will get the answer, right? Whatever you get. Okay. This is how you solve such kind of problems. Okay. So I hope you all understood everything what I taught, and if there's any issue, you all can comment. You all can comment in the comment section, right? Or you can message me directly, okay, on Telegram or WhatsApp, whatever. Okay, and please do like and subscribe my channel. And yeah, there are many questions which I could not cover in this one shot. For that, you have to watch my lectures so that everything becomes clear. Like the change of order I could not cover in this because of the lack of time. So that is why you can watch it from the integral calculus video. In that I have explained it clearly. Okay. So I hope please I hope that you all learned something new from what I told today. So I hope that you will like the video. Please do like and subscribe my channel. And thanks a lot for watching it. Bye bye. Take care.
Hello everyone, this is Aditya and today we'll study complex analysis in a one go. So let's start with the lecture, but before that please do like, share, subscribe my channel and we support studio. Now let's start. So let's start with a very basic term over here, complex numbers. I hope so that you are well acquainted with that, but still I'll give you a brief idea about complex numbers so that everyone is well familiar with those terms. So if I ask you square root of -1, well, we all know square root of 4 is equal to 2, square root of 9 is equal to 3, square root of 3 is equal to 1.732. But if I ask square root of a negative number, then you all think that how we can find that. So to solve this problem,
we defined square root of negative 1 as I. I is the square root of negative 1. So based on this imaginary number, whole complex number was developed, right? So a complex number is of the form x comma y is an ordered pair. Well, complex number is an ordered pair. How we can say that it is an ordered pair? I'll be telling in a few moments. So it is equal to x plus iy. So how do we plot it? Well, we define a complex axis or complex plane, I mean. This is real axis and this is the imaginary axis. So x comma y will be over here. So this is the x unit and this is y unit. Okay. So this is commonly represented as z, right? So z is equal to x plus iy. Now coming back to that topic, ordered pair, that term, ordered pair. So if I say 1 plus 2i, right? And I say 2 plus I, tell me just from your common sense, are they both equal? Well, if you plot them also, they will be at different positions. So if they are at different positions, how they can be equal? Hence, x comma y over here is an ordered pair. Hence, complex number is an ordered pair, right? So with that, we are coming to equality of complex number. Okay. So suppose I define z1 as one complex number x1 plus iy1, right? And I define another complex number x2 plus iy2, right? So if I say that these two complex numbers are equal, then what do we mean? Well, if z1 is equal to z2, then we mean that x1 plus iy1 is equal to x2 plus iy2, correct? So for the representation of these 2 points, I mean z1 and z2 on this plane, they both should coincide, right? It means that its x component must be equal and its y component must be equal. So they are equal if and only if this condition is satisfied. So this is the equality of two complex numbers. Now let's move to the operations on complex number. Now one more thing I need to tell, that when I said z is equal to x plus iy, so there x and y were real numbers and I was the imaginary number, right? Okay. So z is equal to x plus iy. Here x comma y belongs to real number and z belongs to complex number. Now one thing I need to tell you, suppose y is equal to 0, then z is equal to x, right? Correct. Okay. And when x is equal to 0, then z is equal to I times y, right? So it means when the imaginary part becomes 0, then z becomes a real number, and when x becomes 0, then it is purely imaginary number, which means that the complex number is the superset of real number, right? Or we can say R is the subset of complex number. Okay. So this is the basic thing which I need to tell, that real numbers is basically the subset of complex number. Okay. So it means that all complex number are not contained in real number, but all real numbers are contained in set C, that is complex number. So we generally represent complex number using the set C, right? Okay. So now let's move further. So let's study some operations on complex numbers. Operations on complex numbers. Now what do we mean by operation? Well, for example, when you were studying your algebra, like very simple thing, when you were studying about suppose real numbers, then what was the first thing you learned? How to add them, how to subtract them, how to multiply them, how to divide them, right? These four operations you had studied, and how to equate them, right? These were the 4 5 operators which you used to study real numbers. So similar we will study in complex numbers also. So let's see that. Okay. So how do we add two complex numbers? So z1 plus z2. So it is equal to x1 plus iy1 plus x2 plus iy2, right? Okay. So how you used to add two ordered pairs when you were studying real numbers? Well, it was very simple. you used to do x1 comma y1 plus x2 comma y2. It was equal to x1 plus x2 comma y1 plus y2. Similarly, this is also an ordered pair, so you have to apply the same concept over here also. So what it will become is that it will become x1 plus x2 plus I times y1 plus y2, right? Simple. Okay, so I can apply a negative sign also, so it will be plus minus, so it is valid for addition also and for subtraction also, right? And how do we multiply it? Well, z1 times z2, right? It is equal to x1 plus iy1 into x2 plus iy2, right? So if I say find the product of a plus b into c plus d, how used to find? Used to distribute this, right? Okay, so used to get ac plus ad plus bc plus bd, right? So you used to get this expression. Okay, so similarly, you have to apply the same concept over here. So you get x1, x2 plus I times y2 into x1 plus I y1 x2 negative y1 y2. Now note one thing. I times y is equal to negative 1 times negative 1, which is equal to negative 1. Okay, correct? Okay. So basically, if root negative 1 is equal to I, so it means that I square is equal to negative 1. Okay, so that is what I have applied over here. I dot I is equal to negative 1. Okay, correct. So this is how you divide, this is how you multiply. And for division, it is very simple. Z1 by Z2, it is x1 plus iy1 divided by x2 plus iy2. Now we generally don't keep a complex term in the denominator, so what we do is we rationalize this by the conjugate. So coming to the term conjugate, so if z is equal to x plus iy, if z is equal to x plus iy, then its conjugate is defined as x minus iy. Just replace the positive sign of I term into a negative sign. Okay, so just multiply x1 plus iy1 divided by x2 plus iy2 times this complex, this conjugate, x2 minus iy2 divided x2 minus iy2. Now what is the product of these two? Well, you know, from the multiplication law, you can easily find out. You will get z dot z bar is equal to x square plus y square. If you evaluate this, just evaluate this, you will get this expression only. So x times x, it will become that, and yeah, you can evaluate this. It is very simple. So it is x1 plus iy1 into the quantity x2 minus iy2 divided by x2 square plus y2 square, right? And you know how to multiply these two expressions, right? So let me tell you a few example also, so that you don't get confused. So for example, addition, 1 plus 2i plus 3 plus 4i. So how you will add? 1 plus 4, 1 plus 3 is 4, plus 2 plus 6 is 6i, right? Fine. Okay, now how you will multiply these two expressions? 1 plus 2i times 3 plus 4i. Well, it will be equal to what? It will be equal to 1 into 3, it is 3 plus 4i plus 6i minus 8, correct? So it is equal to negative 5 plus 10i, right? Okay, now how you will divide this? For example, 3 plus 4i divided by 1 plus 2i. So you have to just multiply by the conjugate of the denominator. So it will be equal to 3 plus 4i times 1 minus 2i divided by 5. Okay, now you have to just evaluate this expression, which is very simple. Okay, so for multiplication, put a dot sign over here, right? So this is the basic operations which we study in this. So there are some more properties which I need to tell, and then we'll move further. Okay, so let me erase this. Now let's see some properties. Okay, these are very basic properties which you must be familiar. Z1 plus Z2 is equal to Z2 plus Z1. Which property is this? It is commutative property, which we have studied in real numbers also, right? So this is commutative property. Okay, And now which property we have to study? It is again commutative. Z1 dot Z2 is equal to Z2 dot Z1. Okay, so there is no restriction like it has to be like in one order only. It can be in both ways. Unlike matrices in which we have to follow the order, but over here it is okay. Okay, so now we see associative law. Z1 plus Z2 plus Z3 is equal to Z1 plus Z2 plus Z3. This is associative law or property, whatever you want to say. And again Z1 dot Z2 dot Z3 is similar to saying Z1 dot Z2 dot Z3. Okay, and this is distributive law. Z1 dot Z2 plus Z3 is Z1 dot Z2 plus Z1 dot Z3. This is very basic properties which you have already studied in your 12th grade, probably in 11th or 12th grade, but still I am discussing everything so that you don't get confused. So that is why I am in a faster speed, because these are things which you have already studied, so I don't think so that we have to spend much time on this. Okay, but still I am discussing. Now we have Z plus negative Z is equal to 0. This is additive inverse, right? So this is additive inverse, and Z dot 1 by Z is equal to 1. This is multiplicative inverse. Multiplicative inverse. Of course, Z can't be equal to 0. If it will be 0, then there will be problem. It will be division by 0, right? Which is not allowed as per mathematics, right? So let's move to some other concepts. Now there's a concept which I need to tell. You can skip it also, or you can try to understand the deepness of the statement which I'm going to say now or write on the board. A plus IB is equal to. Kindly note this. It is like a bit deep thing which I'm going to tell. Is equal to A plus I dot 0 plus 0 plus I dot 1 dot B plus I dot 0. So we can write this as this. So this is complex addition. This is complex addition. And this is complex multiplication, right? Okay. So this is how we can represent it, like in this form. Still, if you don't want to understand this, you can skip it. It is not that much important. But if you want to understand this, it is very much helpful for your higher studies. So you can try to understand it, okay? But if you don't want to, then it's fine, okay? Now let's discuss. I was telling about the conjugate, right? The conjugate. I defined it like the conjugate is like x minus iy, right? Okay. So let's discuss this now. Okay. So suppose there's a complex number a plus ib or x plus ib, whatever you want to say. Then z bar is equal to a minus ib, right? Okay. This is fine. Okay. So there are some of the properties which you need to study regarding this conjugate. So first property is z double conjugate. Conjugate of conjugate is again equal to z. Why? Because x plus iy, when you do the conjugate you get x minus iy. When you again do the conjugate you get x plus iy again, right? Okay. So that is why z conjugate of conjugate is equal to z. Okay. Now the second property, z1 plus z2 conjugate is equal to z1 conjugate plus z2 conjugate. If you want, you can prove it also. Just say z1 is equal to x1 plus iy1 and z2 is equal to x2 plus iy2, right? Just take the conjugate on both sides. You will get x1 minus iy1 is equal to x2 minus iy2. Just add, you will get x1 plus x2 minus I times y1 plus y2. And if you directly evaluate this, you will get x1 plus x2 plus I times y1 plus y2 is equal to x1 plus x2 minus I times y1 plus y2. Hence, this expression is verified, or you can do it on your own also if you want. Okay. And similarly for multiplication also, z1 dot z2 is equal to z1 conjugate dot z2 conjugate. Okay. So these are the basic properties of conjugate which you should know. and now I will be telling you certain things which are very important, so kindly note it. Now I was writing z is equal to x plus iy. Okay. Now if I ask you what is the real part of this z, then what you will say? Real part of z is equal to x because it has no item. And if I say you imaginary part of z, then it is equal to y, not iy. We are just asking the magnitude, so it is equal to y. Okay. Now what is another way to represent x? Can we represent it in terms of z? Of course we can. How? Using conjugate. So z is equal to x plus iy, hence z conjugate is equal to x minus iy, right? Okay. So just add this, you'll get 2x is equal to z plus z bar. Hence x is equal to z plus z bar by 2. Hence real part of z is z plus z bar by 2. Similarly, you just subtract this, what you will get? Z minus z bar is equal to 2iy. Hence y is equal to z minus z bar by 2i. Hence imaginary part of z is equal to z minus z bar by 2i. So this is how you represent the real part and the imaginary part. Okay. So this is very important. We will be often using this again and again, right? Okay. So kindly note this. Okay. Now let's see what is left. Okay. So in this we have to study the representation, the polar form. Let's study that also. I am sure that you must have studied, but still I'll just give you a glimpse of that. Okay. So I draw this complex plane, right? This is imaginary axis, or it is called Argand plane also. This is Argand plane also. Argand plane or complex plane, right? Complex plane. Okay. Suppose there is a point x comma y, right? Like this. Okay. Suppose it makes an angle theta and it has a value r, suppose. Now I have to define r and theta. What are these quantities? Well, what is it? It is equal to x and this is equal to y. So by Pythagoras theorem we can say r is equal to x square plus y square under root. Now if you remember, we had defined one thing, that z dot z bar was equal to x square plus y square, right? And this is something very much similar. So we can say that it is equal to square root of z dot z bar, or it is equal to mod of z. This is called the modulus of z. So modulus of z is defined as x square plus y square under root. Okay. So r is basically the modulus of z. Suppose if x plus iy is a complex number, so z mod z is equal to x square plus y square under root. Okay. So it is always a real number. Okay. Okay. Now what is this angle theta? Well, we define this angle theta as argument of z. Okay. So this is defined as argument of z, which is equal to y by x. Okay. You can also say it is equal to tan of theta, right? Okay. So these are some of the basic things which you should know, and I'll be telling some of the properties which you should be well acquainted. Now I need to tell you how we can write its polar form. Well, we all know that e raised to power I theta is defined as cos of theta plus I sin theta, right? Okay. Now, why am I writing this? Just a minute. This is nothing to do with current calculation. I'll be telling this, I will be using this statement in like 2-3 steps. You have to just remember that this is an identity, right? You all must have studied it. Okay. So, what is x? X is equal to r cos theta, right? X is equal to r cos theta and y is equal to r sin theta, correct? So z was equal to r cos theta plus I sin theta, I times r sin theta. Okay. Why? Because it was equal to x plus iy, so we have just substituted the value. So we get it as r times cos theta plus I sin theta. Now what is this expression? Well, it is equal to e raised to power I theta. R times e raised to power I theta. So z can also be represented like this. And believe me, it is very much helpful in calculations. But I don't think so that there's much calculation required for this particular unit. But I hope so that you know the gravity of this particular expression. This is very much important, and this is polar form of z, right? So now this is known as the polar form, and that is it. Okay. So let's move to some next topic. Yeah, we have to see some of the properties of the modulus and argument, and then we'll move to the next concept. Okay, so let me raise this. So let's see some of the properties. So we'll be just winding up it now because I hope so that you all know this, so there's no need to extend it much. So that is why. So we all know that mod z was equal to r, right? It is equal to root x square plus y square, right? So it was basically the distance of z from origin, correct? Okay. And this is something which you should be well acquainted with, that it is the distance, right? Because it was the distance from origin, of course. And z1 minus z2 is equal to distance in plane, in complex plane or plane of z1 from z2, right? So we can write this as mod z minus 0 basically. Okay, so that is why this is also distance from 0 from origin, right? So third, modulus of real part of z is less than equal to mod of z, and imaginary part of z is less than equal to mod of z. Well, you all can try this, and it is very simple. X is of course less than equal to x square plus y square square root, and similarly in this case also y is of course less than equal to x square plus y square, right? So that is it. Fourth, we have triangular inequality. It is very much helpful. So we have mod of z1 plus z2 is always less than equal to z1 plus mod of z2, right? Okay. And mod of z1 minus z2 is greater than equal to, so not double mod, we don't need double mod. Over here we will need double mod. So this is a very important identity. This is known as triangular identity. So you should be well acquainted with this. If you want, you can try its proof, or I will make another video in which I will be telling its proof, right? So let's see what else we need to discuss over here. So there are some more concepts which I need to discuss. So let me erase this, then I will be discussing it further. Now it is very basic thing. Suppose z1 is equal to r1 into cos theta 1 plus I sin theta 1, and z2 is equal to r2 cos theta 2 plus I sin theta 2. Then z1 into z2 is equal to r1 r2 into cos of theta 1 plus theta 2 plus I sin theta 1 plus theta 2. How? Well, you can write it like r times e raised to power I theta 1, and this is r e I theta 2. When you multiply it, you will get I theta 1 plus theta 2. So you just expanded this expression, okay? So this is how you write this, okay? So now the argument has become theta 1 plus theta 2. Hence, argument of z1 dot z2 is argument of z1 plus argument of z2. This is what we have got, okay? So this is the property which you should be well acquainted with, okay? And I have, so there's something else, so just give me a minute. Now from this we can say z square is z times z, which is equal to r times the quantity, r square times the quantity cos of 2 theta plus I sin of 2 theta, correct? Hence z raised to power n is equal to r to the power n into the quantity cos of n theta plus I sin n theta, and this is known as De Moivre's theorem. So this is a very much important theorem which you can study or you can just prove it. It is very simple. So either ways are correct. Okay. So now there's some concept which I need to tell. Yeah, one more thing. Z raised to the power n raised to the power negative 1 or any power is equal to z raised to a negative 1 to the power n, which is equal to 1 upon z to the power n. Okay. So basically we can just interchange the powers. It is similar to as exponents. Okay. So there's one more thing I need to tell. So let me raise this and then I'll be telling that. Okay. So we all discussed square root of negative 1 is equal to I. But if I ask you all what is the square root of I, then many of you will say that we can equate it to x plus iy and then we can solve for x and y. Okay, this is a correct approach. But is it feasible if I ask you what is the 10th root of I? Of course not. Then how you will evaluate such kind of problems? So for that, we all know that I is equal to what? 1 times cos of what? Just a minute. Some angle plus I times sine of some angle. Now we want I. So we want cos to be 0 and sine to be 1. Which means that we want angle as pi by 2. Right? Okay. Now, is it wrong if I say it like this? Cos of 2n pi plus pi by 2 plus I times sine of 2n pi plus pi by 2. It is correct because if you are adding 2n pi, then you are just completing another revolution. So it does not change the value. Of course, where n belongs to integers. Okay. Now we had defined z raised to the power n was equal to r raised to the power n times cos of n theta plus I sine n theta. Right? We had defined like this. Hence, I raised to the power 1 by 2, that is square root of I, is equal to 1 raised to the power half, that is 1 only. Cos of 2n pi means n pi plus pi by 4 plus I sine n pi plus pi by 4. Now, if n is equal to 0, then if n is equal to 0, we get square root of I is 1 times the quantity cos of pi by 4. What is cos of pi by 4? It is equal to 1 by root 2. 1 by root 2 plus I times sine of pi by 4, which is equal to 1 by root 2 again. So it is equal to 1 by root 2 plus I 1 by root 2, right? And if you substitute n is equal to 1, then you will get cos of pi plus pi by 4, that is cos of 5 pi by 4. So we all know that if I tell you here all are positive, here over here sine is positive, over here tan is positive, and over here cos is positive, right? It is just a very basic thing of trigonometry which I am telling from your 11th grade, right? So it means that pi plus pi by 4 will lie somewhere in this quadrant, in the third quadrant. Hence sine and cos both will be negative with the magnitude of sine pi by 4 and cos pi by 4. Hence square root of I is also equal to 1 times, if n is equal to 1, cos of pi plus pi by 4, or basically we all know that cos of pi plus theta is equal to negative cos theta, right? And sine of pi plus theta is also equal to negative sine theta. Okay. So it is equal to negative 1 by root 2 minus I by root 2. So we have two values for square root of a complex number. But if I ask you what is the square root of 4, well, don't say it is equal to plus minus 2. It is equal to 2. Why? Because square root of any quantity x square is equal to mod of x, the modulus. So it is always a positive quantity. But if I say x square is equal to 4, then yes, it has solutions as plus minus 2. But square root of any number, of any real number, is just one value, one positive value. Okay. So this thing you should know, that how we evaluate square root of complex numbers. So you can evaluate for any power now. Maybe for 10th root also you can evaluate, for 5th root or whatever root you want. you can just substitute any complex number over here and you can find any root, right? So as so that this is clear, now let's move forward. Now let's understand what do we actually mean by complex functions, not complex numbers. Let's understand that. Complex functions. Okay, so let me read out the definition first of all, that what do we actually mean by complex number. So suppose let D belong to some complex number. A function f defined on D is a rule that assigns a complex number w to each complex number z in D. Let me tell you. Suppose w is equal to f of z, okay, such that the function is going from D to C, okay, correct. So now we write f of z as u plus iv, where u is itself a function of x comma y and this is a function of x comma y again. So w is equal to f of x plus iy is equal to u of x comma y plus I times v of x comma y, right? So this is a complex function, okay? This is a complex function, okay? So now let's see what are the terms which we need to study. So there's one more thing which I need to discuss over here, that if one value of w corresponds to a value of z, then f of z is a single valued function of z, and if more than one value of w corresponds to a value of z, then f of z is a multi-valued function. Is a multi-valued function, whatever. Okay, multi-valued function. Okay. So for example, f of z is equal to root z. Is it a multi-valued function or a single-valued function? Well, if I give the input as square root of I, okay, if I give the input as I, then what is w? W is equal to square root of I. Now we had calculated that square root of I had two values. It means that for a value of z, we are getting multiple results. We are getting multiple values of w. Hence, it is a multi-valued function. Okay. But if on the other hand we say f of z is equal to z square, then it is a single valued function, because for any input we won't be getting the result like this. We have only one result over here, that a square is just a square, there is nothing else in the result. Okay, so that is it. So now we move to the next topic. Let's see what we have to study. Okay, now let's start with the limits in complex analysis. So let's see that. Okay, so limits. So it is just similar concept which you used to apply in real numbers also. Limit z tends to z naught if it is equal to L. So we have defined f of z, the complex function, as u of x comma y plus I of v of x comma y. Correct? Okay. So suppose limit as z tends to z naught of the quantity u of x comma y plus I v x comma y. We all know that it was equal to L, so it is equal to L. Now we can distribute the limit, so we will have limit. Now we can write z as x comma y. X comma y tends to x naught comma y naught. Now it is function several variables. So I have already made a video on this topic. You can check out that video. So in that I have discussed everything like this, the double limit case. Okay, so you can check out that video. Okay, so u of x comma y plus limit x comma y tends to x naught comma y naught I times V of x comma y is equal to L. Hence we have L1 plus I times L2. Suppose this is L1 and this is equal to L2 is equal to L. This is the actual limit. Okay. Well, how we'll be using it, we'll just see in a few moments. So don't panic. I'll just discuss it. Okay. So let me raise this and let's see some of the questions and we will understand this. Okay. So let's see that. Okay. So let's see the question. So it states, let's start with a very simple question right now. Limit as z tends to 1 plus 2i of the quantity mod of z. Very simple question. Okay. So of course it will be equal to, just substitute the limit over here because there is no divide by 0 case or 0 by 0 case, something like that. So it is limit, we just substitute the value. So 1 plus 2i mod is equal to root 5. Okay. Simple. In question it is z square, so let's do squaring. So we will have 5. Okay. Now we can also do it like this. Limit z tends to 1 plus 2i. We can write it like x square plus y square. Right. Now we can just move the limits. So we have limit x comma y tends to 1 comma 2 x square plus limit x comma y tends to 1 comma 2 y square. So it is equal to 1 plus 2 square, which is equal to 5 again. So this was L1 plus L2, that concept. L1 plus I times L2, right? So that is, so this is the concept which we were applying there. And now let's see one more question. Yeah, we have one more question. So let's discuss that also. So in this case, limit exists. And now let's see another case. Okay. So we have the question limit. Okay, we have to discuss one more thing. Then I will discuss that question. Limit z tends to 1 plus 3i z square minus 3z plus 1 divided by z minus 1. So how we can solve this kind of question? Well, it is very simple. Sorry, it is plus 2 over here. Okay. So how we can solve this kind of problem? Well, I'll be telling you 3 methods. Right? The first one is by factorization. So we will have limit z tends to 1 plus 3i. So it is z minus 1 into z minus 2 divided by z minus 1. So this and this gets cancelled. So we can just substitute the limit. So we have limit z tends to 1 plus 3i of the quantity z minus 2. You can just substitute and you can solve it. Okay. The other method is, we can see that in denominator we won't get a 0 when you substitute the limit directly. So just substitute the limit directly. Just substitute the value directly. Substitute directly. What is the other method? Well, it is lengthy. Write z is equal to x plus iy. So you have 3 methods. Whatever you want to do, you can do it. Okay. So now let me raise this and now let me discuss the question which I was saying. It was a good question. So let's discuss that. Yeah. So it was equal to, it was limit z tends to 0 of the quantity conjugate of z divided by z. Okay. Now it's a nice question. Well, it can be written as limit as z tends to 0 x minus iy x plus iy. Now what is z? Z is 0, is approaching towards 0. Hence, it is basically limit x comma y tending towards 0 comma 0. It is x minus iy divided x plus iy. Now if you have watched my video, the one shot on functions in several variables, you must be knowing that for a limit to exist, it must be path independent. But we can easily prove that, suppose if I define a path y is equal to mx, where m is arbitrary, you can choose on yourself, then you will get limit x comma y tends to 0 comma 0. You will have x minus y, I mean mx, x plus I times mx, right? Okay, so it becomes limit x comma y tends to 0 comma 0. It will become 1 minus m divided by 1 plus I times m. Now since the limit is dependent upon m, we can say that the limit does not exist. Hence limit does not exist. Limit does not exist. Okay, so this is the concept of limit. And now what we are going to do is that we will study continuity. Well, it is very simple. Let's study that also. Continuity Okay, so how we say that a function is continuous? Well, uh, you must have studied in your 12th grade about limits, maybe in 11th or 12th, I don't remember. So there's a concept of quantity for real numbers. Now we will be extending that idea in the case of complex numbers also. So let's see that for complex functions. Okay. So first of all, let me define it. A continuous function. How we define it? Continuous function. Okay. So let f of z be defined and it be a single valued function. Okay. In a neighbor, I think you must be knowing about neighbor, right? When we define delta and epsilon delta method, you have to check that video on several variables. So I will give the link in the description. You can check out that video. But if you don't, if you remember, then it's okay. If you don't remember, you can check out that video. In that I've explained everything very clearly. Okay. Neighbor neighborhood of z naught. The function f of z is said to be continuous at z naught if for given epsilon greater than 0 there exists a delta greater than 0 such that f of z minus f of z naught mod is less than epsilon and mod of z minus z naught is less than delta. Okay, or we can just say that limit z tends to z naught of the quantity f of z, if it exists, it should be equal to f of z naught. Okay, so to understand neighborhood in this concept, you must be knowing about something called ball of radius r centered at a, which is something uh, which we will study in later part of this lecture. And yeah, I will making two one shot for complex analysis. One in which I'll be dealing till harmonic functions, and in the second one shot it will be related to contour integrals and the transformation, the bilinear transformation, linear transformation, and the sorts of thing, right? So it becomes very much comprehensible and understandable. So that is why. So first in this, I'll be telling the basic idea of complex analysis, and in that we'll be dealing with the calculation and the integral part. Okay. So this part will be dealing till harmonic function. I'm telling again, and in the second one shot, which I'll making in 1 2 3 days, whatever, before 5th of November or 6th of November, I'll try to upload everything. Okay, till contour integral part. So what I was saying is that in this one shot I will be covering till harmonic functions, and in the second one shot I'll cover the transformations and integrals. Okay, I hope so that it is clear now. So let's see some questions on it. Yeah, one more thing. If f of z is u of x comma y plus I times v of x comma y, it is a complex function and it is continuous as z naught, then it should be continuous for x comma y and v x comma y. Basically u of x comma y should also be continuous at x naught comma y naught, and it should also be continuous at x naught comma y naught. Okay, so this is basic idea. Of course, if function is continuous, then of course whatever bases are creating that function, they must also be continuous. It is very logical statement, so it's not nothing new. Okay, so let's erase this and let's discuss some questions. So question: limit z tends to I of the quantity z square plus 1. Now of course it is a polynomial, so of course it will be continuous over whole plane, right? So it will be simply equal to I square plus 1, which is equal to 0, right? Okay, or if you want to check using that statement, so limit z tends to I x plus iy, so it can be written as x comma y tends to 0 comma 1 whole square plus 1, which is equal to limit x comma y tends to 0 comma 1 of the quantity x square minus y square plus 1 plus the limit as x comma y tends to 0 comma 1 of the quantity 2 x y I times this quantity. Okay, so this will become 0 because if x is equal to 0 then 2xy will become 0. Very simple thing. And if x is equal to 0 this is 0, and if it is equal to 1, so negative 1 square is negative 1, negative 1 plus 1 is equal to 0. So again the answer is 0. Okay, so now let's see one more question, and it is an interesting question, so let's discuss that. And it is like it will build your concept. Okay, if we discuss that. So question, f of z is equal to mod of z divided by z. Okay, so it is given that it is equal to mod of z divided by z if z is not equal to 0 and is 0 if z is equal to 0. Okay, so this is something which we are given, and we are given that we have to check for the continuity at 0. Okay, so let's see that. Now let's just apply simple concept. Limit as z tends to 0 from the right side. It will be mod z by z. It is equal to limit as z tends to 0 from the right side. It will be positive z divided z, which is equal to 1. Now limit z tends to 0 from the left side. So mod of z by z is equal to the limit z tends to from 0 from the left side. It will be negative z divided by z, which is equal to negative 1. Now they both are not equal, right? Hence we can say that limit does not, so we can say that the function does not, the function is not continuous at 0, right? We can say that. Okay, now one thing, did you notice that I took right hand and left hand limit, but while checking for limit I was checking for different paths? Well, what I've done is over here is that I assumed z is equal to x or real number. I neglected the complex part or the imaginary part. Why? Because I had to just check for the limit. So I can take any path. So I took the path along real axis. So in that case, the y-axis has no role, right? So that is why we can just write this as limit as x tends to 0 from right hand side mod x by x, which is equal to 1, and limit as x tends to 0 from negative side from left side mod x by x is equal to negative 1, right? So both mean the same thing. We have just changed the path. In this, the path is along x-axis, right? And earlier in which I had assumed y is equal to mx, in that the path was y is equal to mx. So there's no harm in that. Okay, so that is why I assumed 0 positive, 0 negative. The final aim was to just prove that the limit does not exist. I mean, the function is not continuous, right? That the limit, the right hand and the left hand limit are not equal. So it means that the function is discontinuous at 0. Okay, so we needed to check that only. Okay, so that is why we assumed just along the real axis. Okay, so that is the reason behind this. So let me erase this, and now we will study differentiability. Okay, let's study that. So let's start with differentiability. Well, just like we defined differentiability for real numbers, same is the case over here also. So a function f going from d to c is differentiable at z is equal to z naught, or simply at z naught, if limit as z tends to z naught of the quantity f of z minus f of z naught divided by z minus z naught, it exists and it is equal to f dash of z naught. Okay, or you can evaluate this, or you can evaluate limit as h tends to 0 f of z naught plus h minus f at z naught divided by h, right? Okay, so both are equal to f dash of z naught. So you can check either this or this. If they exist, then the derivative exists at that point. Now one thing which I need to tell you, that one more thing. If the function f is differentiable for all points in D, then the function f is differentiable in D, right? So let me write this statement.
if f function is differentiable at f dash of z naught at each point in D, we say function is differentiable in D, right? Okay. Now one more thing I need to tell, that if a function is not continuous, if the function is not continuous at z naught, then the derivative also does not exist. But if the derivative does not exist, then it does not imply that the function is discontinuous. So it means that continuity is the necessary condition for differentiability. Continuity is the necessary condition for differentiability, but differentiability is not any condition for continuity. Okay, so let's move to the next concept now. So let's see a question now. Suppose f of z is equal to z square, then we have to find its derivative. Okay, for z belongs to complex numbers. Okay, so f of z is equal to z square, hence f dash of z is equal to the limit as h tends to 0 of the quantity f of z plus h minus f at z divided by h, right? So it will equal to limit as h tends to 0 of the quantity z plus h whole square minus z square divided by h, which implies this is equal to limit as h tends to 0 z square plus 2zh plus h square minus z square. So z and z cancel. I mean z square and z square get cancelled. So we get limit as h tends to 0 2zh plus h square by h, which is equal to the limit as h tends to 0 of the quantity 2z plus h, which is equal to 2z. Hence the derivative of this quantity is equal to 2z, right? Okay, so now let's see another question now. Now there's a question that f of z is equal to z bar. We need to prove that it is continuous but not differentiable. At which point? Over whole plane. Okay. Well, of course, f of z is equal to x minus iy, correct? Okay. So of course it is always continuous. It is clear because it has no divide by zero case or anything like that. Okay. But for continuity we need to do something. Limit as h tends to 0, and for differentiability I mean f of z plus h minus f at z divided by h, right? Okay. So we have limit as h tends to 0 of the quantity z plus h whole bar minus z bar divided by h, correct? So it means it is equal to limit as h tends to 0 of the quantity. Now we know that a plus b bar is equal to a bar plus b bar, right? So it is equal to z bar plus h bar minus z bar divided by h. So it is equal to limit as h tends to 0 of the quantity h bar by h. Now, how can we evaluate this now? Well, you can say h is equal to h1 plus ih2, right? You can say it like this, right? Hence, we have the quantity limit as h1 h2 tends to 0 comma 0 of the quantity h1 minus I h2 divided by h1 plus I h2. Now don't you remember that we had a similar expression like this, x minus iy divided x plus iy, limit as xy was tending to 0 comma 0, right? We had solved such kind of problem in, I guess, in limits or continuity, I don't remember exactly. So in this also, if you take the path as h1 is equal to mh2, so of course the limit is path dependent, hence limit does not exist, so differentiability is not possible in this case. So it is non-differentiable at any point. Okay, hence it is a non-differentiable function. Okay, now let's see this question. We have to prove that f of z is equal to z mod of z is not differentiable at origin. At origin we have to check. Okay, so if we have to check at origin, so we will do like this. Limit as z tends to 0
f of z minus f at 0 divided by z minus 0, right? Okay, so it is limit as z tends to 0 of the quantity mod of z by z. Okay, now how can we evaluate this limit? Well, again, first of all we will approach the limit along real axis. Okay, so if we approach from real axis, then what will happen? Limit as x tends to 0 from the RHS, it will be mod x by x is equal to plus 1, and if we come from left hand side, x tends to 0 negative, I mean 0 from left hand side, mod x by x is equal to negative 1. You can do it like this also along the path along the real axis. So of course these two limits are not equal, hence it is non-differentiable at origin. Okay, now there are certain properties which you should know for differentiation, so let's note that. So if a function is going from d to c and another function is going from d to c, then it follows product rule, chain rule, quotient rule, and all other rule. I mean, f plus g prime is f prime plus g prime first. Second, f g prime is equal to f dash g plus f g dash. Okay. Third, f by g dash is equal to f dash g minus f g dash by g square, right? And fourth, f of g of z. Of course, these functions are f of z and g of z, right? Whole derivative is equal to f dash of g of z times g dash of z, right? So this chain rule, this is the quotient rule, this is the product rule, and this is the addition rule. Okay, so this is applicable for addition, subtraction both. Okay, so yeah, these are some of the laws which I need to tell. So now let's move to something called as real valued function. What is meant by a real valued function? We have to see that. Okay, now what is a real valued function? Well, let me define something, then I will tell its definition. A real valued function of a complex number either has derivative 0 or derivative does not exist. So this is a theorem, and a real valued function is a function in which you give input as a complex number and you get the output as a real number. So basically it is from C to R, or basically D to R, whatever you want to say. Okay, now let's prove this statement also. So let's see its proof. So suppose there is a real valued function f going from D to R, real number, right? Because we want output as real number, right? And we said that it is differentiable at z0, and of course z0 should belong to D. Then this statement means that this should exist limit as h tends to 0, f of z0 plus h minus f at z0 by h, right? Okay, so let's read the statement again. So it is given a real valued function of a complex number either has derivative 0 or the derivative does not exist. It is or derivative does not exist. Well, we all know that this function, this numerator, is a real valued function. This is also a real valued function. But the numerator is a complex number, right? Which means that if you are approaching this limit along real axis, if you are approaching along real axis, you will get the derivative, you will get h as a real number and numerator is also real number. So we will get f dash z as some real value, right? So we will get some real value. But if you are approaching the value of, if you are approaching this limit along the path of imaginary, along the imaginary axis, right? Then in that case h will be an imaginary number, it will have the form ih2, something like this. Then in that case numerator is a real value and the denominator is a complex value or an imaginary value. So in that case we will get the limit as the derivative as an imaginary complex value, complex number, complex or basically imaginary value. So how can they both be equal? Well, so now we are coming to this statement. A real valued function of a complex number either has the derivative 0. So if f dash z naught becomes 0, then all problems sorted. So if this is 0 and this is also 0, then okay. So if it exists, then the derivative will be z naught is equal to 0. Because of course imaginary and real cannot be equal unless they both have the value as 0. And the second case, it does not exist, right? So this is what it means over here, that a real valued function derivative is always equal to 0 or it does not exist. Okay, so now let's move to next topic. Now let's do a question also. Suppose f of z is equal to the real part of z and we have to show that it is nowhere differentiable. Let's see how we'll prove it. So of course it is a real valued function. So solution. Well, I told that real part of z can be written as z plus z bar by 2, if you remember, right? Okay. So we all know that limit as h tends to 0, f of z plus h minus f at z divided by h, it is the derivative, right? Hence we have limit as h tends to 0 of the quantity, we can substitute it over here. So we have z plus h, right? Instead of z we are substituting this z plus h plus h bar whole divided by 2 minus z plus z bar by 2 divided by h, correct? So we have limit as h tends to 0 of the quantity z plus, now we can break this, z plus z bar plus h bar by 2 plus minus z bar by 2, right, divided by h. Now this and this will get cancelled, so we'll be left with 1 by 2 limit h tends to 0 of the quantity h plus h bar by h, correct? Hence we have 1 by 2 times the quantity 1 plus the limit as h tends to 0 h bar by h. Now of course this limit does not exist, we all know, we had proved this. Hence the derivative is nowhere differentiable. I mean this function is nowhere differentiable because the limit does not exist, right? Okay, so now let's move to the next topic, Cauchy-Riemann equations. So let's see that. So let's study Cauchy-Riemann equations. Cauchy-Riemann equation. So first of all, let me write the statement. If f of z is equal to u plus iv and it is differentiable, if this function, if f of z is differentiable at z naught, then fx is equal to ux plus ivx. Of course fx is del f by del x, right? I think you know it. Okay, and fy is equal to uy plus ivy, right? Del f by del y. Okay, exist at z naught and satisfy Cauchy-Riemann or CR equation at z naught. Okay, so how it satisfy? It satisfy like f of y is equal to I times f of x. We will see its proof in a few moments, don't worry. Okay, so this implies that uy plus ivy is I times ux plus ivx, correct? So we have uy plus ivy is equal to iux minus vx, right? Hence we have uy is equal to negative vx and vy is equal to ux, correct? or you can say that ux is equal to vy and uy is equal to negative vx. Okay, now we will see its proof also. So let's see its proof. So let's see its proof. So suppose there is a function f of z, it is equal to u plus iv, where u is x comma y, u is a function of x comma y and v is also a function of x and y, right? So f dash at z naught we have to evaluate. Okay, so it is equal to limit as h tends to 0 of the quantity f of z naught plus h minus f at z naught divided by h, right? Now we can write h as h1 plus I h2, right? Now let's approach this limit along x-axis, then let's see what we get. So we'll have limit as h1 tends to 0 f of z naught plus h1 minus f of z naught divided by h1, and it is equal to fx of z. From the definition we can clearly see, if you know the definition. If you are not able to understand this, I can represent it in another form. Basically it is limit, I should write over here because I need his space over here. So it can be written as limit as h1 tends to 0 f of x plus, I mean x naught plus h comma y naught minus f of x naught comma y naught divided by h1. This is h1. So if you know the definition of derivative, then you will be very much familiar that this is equal to fx of z naught, right? So this is equal to f dash of z naught, correct? Okay. Now we can write f of z naught plus h in this form, right? Okay. So we have limit as h1 tends to 0 u of x naught plus h1 comma y naught plus I times v of x naught plus h1 comma y naught minus the quantity v of x naught comma y naught plus, sorry, u of x naught comma y naught I times v of x naught comma y naught divided by h1, right? So it is basically I substitute the value of u and v over here, that is f of z is equal to this expression. I just substitute the value over here. Okay, correct. So it is equal to limit. Now let's club the u term together and v term together, right? Limit as h1 tends to 0 u of x naught plus h comma y naught minus u of x naught comma y naught divided by h1 plus I times the limit as h1 tends to 0 of the quantity. Try to understand things because it is just a calculation part which I am doing. The concept is this only, and I am just expressing it in form of u and v, right? That is it what I am doing. Okay, you will understand in a few minutes that why I am doing this. V of x naught plus h1 comma y naught minus, sorry, u of, yeah, it is v of this expression minus v of x naught comma y naught divided by h1, right? Now this is equal to u of x. This is ux and this is plus ivx, right? Understood? So you can write this as ux plus ivx2. Correct? Okay. Now let's apply the same thing but along imaginary axis. Let's do that also along y-axis. Okay, so let me erase this and let me note the result that f dash of z naught was equal to fx z naught is equal to ux plus ivx. Okay, now let me erase this stuff. So along y-axis if we go, f dash of z naught is equal to limit as h2 tends to 0 of the quantity f of x naught comma y naught plus h2 minus f of x naught comma y naught divided by h2, right? Divided by h2. Of course it will be I times h2 because now we have taken along x-axis, along y-axis. Okay, so this is equal to 1 upon I times the quantity f of y x naught comma, just we can say z, or f dash of z naught, right? So from this we have already got that fx is equal to 1 upon I fy of z. Okay, or you can say just like this. Okay, so from this, since both are equal to f dash of z naught, okay, now we can expand this also. So we will have limit as h2 tends to 0 of the quantity u of x naught y naught plus h2 minus and plus I times v of x naught comma h2 minus u of x naught y naught plus iv x naught comma y naught divided by I h2, which is equal to limit as h2 tends to 0. Now we can club u term again together and v term together again. Okay, so we will have u of x naught comma y naught plus h2 minus u of x naught comma y naught divided by I h2 plus the quantity limit I times the limit of the quantity as it tends towards 0, h2 tends towards 0 of the quantity v of x naught comma y naught plus h2 minus the quantity v of x naught comma y naught divided by I h2. I and I gets cancelled. Okay. Now this is equal to uy divided by I plus vy divided by 1. Right. So it is basically uy divided by I plus vy. Now this expression should be equal to what? It should be equal to ux plus ivx, what we had got, right? Hence we have from this we can multiply I together, so we will have negative iy is equal to this expression. So we have uy is equal to negative vx and we have ux is equal to vy, correct? So from this we have got this expression again, right? So this is the proof. If you want, you can understand this. If you don't want, you can skip it. You can just remember the result, that this is equal to this. Okay, that is it. Okay, so now let me erase this and let's see a question. Now before discussing the question, I should tell you all that Cauchy-Riemann equation is the necessary condition for differentiability at any point. If Cauchy-Riemann equation is not satisfied at that point, then the equation or the function is not differentiable at that point. And if it is satisfied, then it does not imply that the function is differentiable or not at that point. But if it is not satisfied, then it is obvious that the function is not differentiable at that point. Now let's discuss the question. So the question states f of z is equal to a real valued function xy x square plus y square, z is not equal to 0 for z is not equal to 0 and is 0 if z is equal to 0. So we have to prove that the Cauchy-Riemann at z is equal to 0 is satisfied, but f dash 0 is not satisfied. Well, let's see that. Basically we have to prove that the Cauchy-Riemann equation is satisfied, but still the function is not differentiable at z. So let's see that. So what is the condition for Cauchy-Riemann equation? Well, it was fx fy was equal to ifx, right? You should just remember this and you can solve further. So basically it is uy plus ivy is equal to I times ux plus ivx. Now I could have directly applied the formula that ux is equal to that stuff and uy is equal to that stuff. I could have used that. But suppose if you forget how to use it, then this is the very basic thing which you should know. From this you can easily get that result. So that is why I prefer telling from the basic, right? Okay, it will just take 1-2 steps more, and but it will make sure that your question is solved correctly. Okay, because many people get confused where to put the negative sign, right? So uy plus ivy is equal to iux minus vx, right? Okay, so uy is equal to negative vx and ux is equal to vy, correct? Okay, so we have to check for these conditions. Okay, so let's check that. So how we can check for this? Either you differentiate directly using partial derivatives, or you can apply the first principle. So let's apply the formula that ux is equal to the limit as h tends to 0 of the quantity u of x naught plus h comma y naught minus u of x naught comma y naught divided by h. Now note x naught and y naught are 0 because we have to check at origin. So this is just 0 comma 0. Now when substitute 0 comma 0, it is 0, right? So this expression is 0. And if you substitute 0 over here, so it is h comma 0, right? Now if you substitute 0 over here, so of course 0 into anything is 0. Hence it is equal to limit h tends to 0 of 0 exact 0 by h, so it is equal to 0, right? So ux is equal to 0, and similarly you can check for uy on yourself, right? What will be different over there is it is limit as h tends to 0, u of 0 comma h minus u of 0 comma 0 divided by h, and this also will be equal to 0, right? You can check on yourself. Okay, so it means that uy is also equal to 0, vx is also equal to 0, so this is satisfied. Ux is equal to uy, 0 is equal to 0, it is satisfied. It is satisfied, I mean. Now it means that the CR equation is satisfied, but still the function is not differentiable. Now it's your job to find that whether the function is differentiable or not differentiable. Well, I don't think so that you need to check the differentiability. Why? Because if you check for continuity only, what will happen? Limit as z tends to 0, or we can say x comma y tends to 0, it will be xy divided by x square plus y square, right? F at z. Okay, so y is equal to mx. It will give us multiple paths over here. So the limit is actually path dependent. So the function, so the limit is actually path dependent, right? Since the limit is path dependent, it means that the function is not continuous. If the function is not continuous, that means that the function is not differentiable at that point. Hence it is not differentiable. Or if you want, you can use the first principle definition, and then also you can prove that the function is not differentiable. It's on you. Okay, so let me erase this and let's see what's left now. Now this is a theorem which I'm going to discuss, but I will discuss it in form of a question, right? So let f of z is equal to u plus iv be differentiable in a domain D. Show that f is constant in D if it follows: first, f dash z is equal to 0. Of course, if f dash z is equal to 0, it means that it is a constant value, right? Second, it is a bit obvious, right? So second, the real part of f of z is equal to constant. Third, if the imaginary part of f of z is equal to constant, or the fourth case, if mod of f of z is a constant value, right? So let's see the first one. So f dash z, right? So f dash z is equal to 0. We are given this expression, correct? Okay, so if f dash z is equal to 0, we know that this is also equal to fx. So fx is equal to 0, which means that ux plus ivx is equal to 0. Hence ux is equal to 0 and vx is equal to 0, which implies that uy is equal to 0 and vy is also equal to 0 from the CR equation, right? Okay, right? Okay, so it is a part of CR only, CR equation, right? So from this we can say that uy is equal to 0 and vy is also equal to 0, right? Okay, now so if these are equal to 0, then it means that the function, basically the function which is composed of these two expressions, these two basis function, so if they are also equal to 0, hence f of z itself is a constant function. Okay, so I think this is what we needed to prove. Okay, now let's check for this one, real part of f of z. We are given this is equal to constant, so we can assume it as u, right? Well, why u? Because the real part of f of z is equal to u, right? So we are given that this is equal to constant, hence ux is equal to 0. Ux is equal to 0, right? Okay, so we are given that ux is equal to 0, so we can say that uy is also equal to 0. Now again from CR we have vx is equal to vy is equal to 0. Again from CR we can say that, right? Because vx and uy and vy and ux are connected together, right? Hence they are also equal to 0, which implies that u and v are constant, hence the function itself is a constant function, right? So now you can check for imaginary part on yourself, and this modulus part also on yourself if you want. Okay, so modulus part maybe I can discuss. Let's discuss that. So mod of f of z, so let's assume it equal to k, right? Let's assume it equal to k, right? So we can say that u square plus v square is equal to k square, right? We can say this. Now let's take the derivative. You will have ux plus vx is equal to 0, and take the derivative with respect to y also. So you have uy plus vvy is equal to 0, right? So we've got this expression. So what we are going to do is that we will square and add this stuff, right? So let's see what we'll get. So this one plus 2ux vvx plus v square vx square, correct? And there we will get u square uy square plus 2uuy plus into vvy plus v square vy square is equal to 0. Now how many of you can notice that this and this will get cancelled, because ux was equal to and uy was equal to what it was equal to? Well, if you don't remember, fy is equal to ifx. So you have uy plus ivy is equal to I times ux plus ivy. So you can say that vy is equal to uy plus ivy is equal to negative vy plus iux. So it is equal to vy and it is negative vx, right? So it means that ux and vx, so it means that let me write it like this. So we can just interchange it. You will get ux is equal to vy and negative vx is equal to uy. So just multiply it, you will get ux vx is equal to negative vy uy. So we have ux vx plus vy uy is equal to 0, right? So this is what you will get when you add them. You will get ux vx plus uy vy. So they both will get cancelled. Okay, right? So just do that, and you will get u square ux square plus uy square plus v square vx square plus vy square. Now how many of you will get confused if I do it like this? Because vx is again equal to, since it is square, so sign does not matter. So vx square will be equal to uy square and vy square will be equal to ux square. So this is what we have over here. So this is equal to k square, right? And k square, or what I defined it as, I defined it like yeah, it was k square. K square times the mod of f dash of z is equal to 0, right? Okay, so this is what we need to prove. We have to check that f dash of z, f mod of f of z is equal to constant, then be differentiable in domain. Yeah, okay. So from this we can say that f is a constant value, because its derivative is also constant, the mod of its derivative is also constant, and the mod of the function itself is a constant. So it means that the function itself is a constant function. Okay, so now let's erase this and let's move to further concept. Okay, and one more thing, if you think that how I wrote this, we know that this is ux square and this will become vx square, right? So now you understood. Okay, now let's discuss analytic function. So we are going to discuss analytic function. So a function, let's define it first of all. A function f going from d to c is said to be analytic at a point z not belonging to d if it is differentiable at every point of some neighborhood of z naught. Okay, so this is how we define analytic function, and now there's some terms related to it. So Let's study that also. So analytical or analytic function is also called regular function, or it is also called holomorphic function. Holomorphic function. Well, the name itself has many significance, but I don't think so we should discuss it right now. Okay, the function f is said to be analytic is said to be analytic on D if it is analytic at every point on D, right? Okay, now fourth point, a function is said to be a function which is analytic 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 at every point in complete in complex plane, sorry, in complex plane, is said to be it is said to be a entire function. So basically a function f going from D to C is said to be an analytic at a point z naught if it is differentiable at every point of some neighborhood. Do you remember epsilon delta, that method only, of z naught. So analytic function, it is also called regular function or holomorphic function. If the function is analytic over a complete D, then we say that it is a analytic function, and a function which is analytic at every point on complex plane, it is called an entire function. Okay, so now let's see a question to understand it, right? So let's see a question. We have to show that f of z is equal to z bar is nowhere analytic or analytical. Well, we know that f of z is equal to z bar is equal to x minus iy, correct? Okay, now let's find ux, uy, vy, vx, right? So what is ux? Well, u of x comma y is equal to x. Basically we are given that u is equal to x and v is equal to negative y, right? Hence ux is equal to 1, uy is equal to 0, and vx is equal to 0 and vy is equal to negative 1, correct? Okay, now we know the condition that uy, it should be equal to vx, right? Okay, negative of vx actually, and ux must be equal to the positive value of the quantity vy. Now it is not satisfied. Why? Because ux is 1 and this is negative 1, so they both are not equal, of course. Hence the function is not differentiable, since it is not following CR equation. Hence it is not differentiable, hence it is not analytical, because to be analytical it should be differentiable, right? Okay, so let's see the next question. We are given f of z is equal to mod z square. So we have to prove that it is differentiable only at origin, and hence it is nowhere analytical. Okay, solution. So basically f of z is equal to x square plus y square, so it is a real valued function. Hence u is equal to x square plus y square and v is equal to 0. Hence ux is equal to 2x and uy is equal to 2y and vx is equal to 0 and vy is equal to 0. Now we all know that vx must be equal to what? It should be equal to negative uy and vy should be equal to ux, right? Now it means that 2y should be equal to 0 and 2x should be equal to 0 for differentiability, because if it will be another value, then CR equation won't be satisfied, hence the function will be not differentiable. Hence the function is only differentiable at origin. Hence the function is nowhere analytic. Okay, hence proved. Now if you have to check the differentiability also, you can check it like that also if you have any doubt. Z tends to 0 of mod z square by z, it is equal to limit z tends to 0 of the quantity z times z bar divided by z, so it is equal to 0, right? It is very simple. Okay, so don't worry. Now let's see some of the standard functions, standard analytic function. Standard, let me write it properly. Standard functions. First, any polynomial p of z is equal to summation a I z n zi, where I goes from 0 to n, is an entire function, okay, and sin z, cos z, e to the power z, they are entire function again, right? Third, f of z is equal to 1 upon is equal to z by 1 minus z, 1 minus z. It is an analytic function, in complex plane except one. Hence, due to this one, it couldn't become an entire function, but it is analytic. Fourth, real part of z, imaginary part of z, e raised to power z bar, they are nowhere analytic. So this was analytic functions, and now we are going to study the last portion of this one shot, that is harmonic functions. So let's see how we will study that. Okay, harmonic functions. So let's study this harmonic functions. So a function phi going from omega to r is said, basically it is a real, this is a real valued function, right? Because it is going till r, okay, going to r, right? Is said to be harmonic in an open set. Well, open set, if I have to tell, uh, basically in simple words, if I tell, basically in which the values are in which the values which you choose are not from the boundary, basically boundary is excluded in that. So basically when you will study the ball of radius r centered at a, in that it will be very much easy to understand. For example, this is a circle centered at a of radius r, and in this you neglect this boundary region, the values from this boundary region, then we say it is an open set, right? It was very basic idea to give, but still I hope so that from this you can understand it a bit. But of course, for this I have to teach you like ball of radius r, that those subsets. So I don't think so that right now we should discuss that, because it will create confusion, right? So for now, just take it as a word, right? Okay, if you want, I will make a video on this separately. Okay, so set phi, if it has continuous partial derivatives, and if you want to study partial differential equations, I have already made a video on this. It is a one shot of 2.5 hours. You can check out that video. In that I've recorded everything. I've taught everything which is required for partial differential equations, from very basics to Monge's method. I've covered everything. It includes everything. Maybe certain topics are not even a syllabus of BTech. I covered that also. So don't worry, you can check out that. Okay. So now. Continuous partial differential, but of course it is mostly inclined for BTech students, so you can check out that video. It is very much helpful, right? So continuous partial differential equation, right? Sorry, what I was saying, a function phi going from omega to r is said to be harmonic in a set if it has continuous partial derivatives of second order, and it satisfies Laplace equation, that is del 2 phi del x square is equal to phi xx plus phi yy is equal to 0. Okay, so we'll be using this, and we'll be solving some questions to understand this. So let's see a question, right? So let's see the question. Prove both real and imaginary part of analytical function of analytic function is harmonic function. Okay, so f is equal to solution. So we know f is equal to u plus iv, correct? Okay, so we have f dash is equal to ux plus ivx, correct? Okay, and from this we can say that ux, using the property of using Cauchy-Riemann equation, we can say that ux is equal to vy, which implies that uxx is equal to vxy, and vy is equal to negative, I mean uy is equal to negative vx, which implies uyy is equal to vyx. Okay, negative. Now just add them. These both will get cancelled. So we will have uxx plus uyy is equal to 0. Hence, del del 2u by del x square plus del 2u by del y square is equal to 0. So this is for the real part. For imaginary also, you can apply the same rule and you will get again the same result. This result. Okay. So this is for imaginary and this is for real. And for this again you will have, since it is like this, so del 2f by del x square plus del 2f by del y square is equal to 0, right? So either ways it's correct. Okay, so now let's erase this and let's move to next question. Now there's a term called harmonic conjugate, which I won't define right now, but I will use it in question and I will explain it because it has something to do with simply connected domain, and I don't think so that I should discuss it right now. In the second one shot, in which I will cover complex integrals and transformation, in that I will discuss it. So from that you can get an idea. So I'm skipping the definition right now. I'll just discuss the question, right? So question. So we are given, show u of x comma y is equal to 4xy minus x cube plus 3xy square is harmonic, and we have to find v. This v is called harmonic conjugate actually. Okay, such that f is equal to u plus iv is analytic where v is harmonic conjugate. Okay, harmonic conjugate of u, and we have to find f also. So we will cover everything in one question only. So let's see that. So we have u is equal to 4xy minus x cube plus 3xy square. So first of all you have to show that it is harmonic. So we will find ux, it is equal to 4y minus 3x square plus 3y square. So we have uxx is equal to negative 6x, and similarly u is equal to this, so uy will be equal to 4x minus 4x plus 6xy, and for uyy it will be equal to 6x, right? So when you add them you will get uxx plus uyy is equal to 0, right? Hence it is harmonic. So first thing which we have converted, so first thing we have checked, right, that it is harmonic. We have proved that. Now what is the second thing? We need to find v. So how we find v? Well, we know that uy is equal to, and ux is equal to what? We know that it is equal to, ux is equal to vy and uy is equal to negative vx from CR equation. So from this we can say that uy is equal to 4x plus 6xy is equal to negative vx, and we have vy is equal to the quantity ux 4y minus 3x square plus 3y square, correct? Okay, now how can we find v using this? Well, we all know that v, the complete derivative is equal to the partial derivative with respect to x dx plus partial derivative with respect to y dy, right? So it is equal to Vx dx plus Vy dy. So it is equal to, what is Vx? Well, Vx is equal to negative 4x negative 6xy dx plus 4y minus 3x square plus 3y square, right? dy, right? So we have negative 4x dx minus 6xy dx minus 3x square. Well, I should write in proper sequence only. 4y dy minus 3x square dy plus 3y square dy, correct? Now how can we evaluate this expression? Well, we can see that here we have x with dx only and y with dy and y with dy again. Now the problem is with these two terms. So we have dv is equal to negative 4x dx plus 4y dy plus 3y square dy, right? Minus, we can take 3 common, so we will have 2xy dx plus x square dy, correct? Now can we do something of it? Well, it is in exact form, so what we can do is that we know that x square y derivative is equal to 2xy plus, or we can put it like this, the derivative of x square y is equal to 2xy dx plus the quantity x square dy, right? So this is what it is written over here. So it is basically d of x square y. So dv is equal to negative 4x dx plus 4y dy plus 3y square dy minus 3 times d of x square y. Now let's just integrate this stuff. So when you integrate this, you will get v is equal to negative 2x square plus 2y square plus 3 plus y cube minus 3x square y 3x square y plus a constant k. So this is the value of v, the harmonic conjugate. So I hope so that now it is clear how you evaluate. So basically you find vx and vy, then use the complete derivative equation, and then you just use some exact form, and then you solve this, right? So I think that this is only the result, 2y square minus 2x square minus 3x this cube. Okay, correct. Now one thing is left, we have to find function also. So let's find the function, how we will find it. Now to find function, you should know something called Milne-Thomson method. Thomson method. So if del u by del x is equal to phi 1 of z comma 0 and del u by del y is equal to phi 2, basically if we are solving in case of u, real part of z, real part of f of z, then we will set it equal to phi 1 of z comma 0 and phi 2 of z comma 0, and then we will say f of z is equal to the integral over the region phi 1 of z comma 0 minus I times phi 2 of z comma 0 dz. And if del v by del x is equal to phi 1 of z comma 0 and, sorry, it will be equal to phi, over here we define it as phi 2, right? And del v by del y is equal to phi 1 of z comma 0, right? This is a very minute change which you should know. So over here f of z will be equal to integral phi 1 z comma 0 plus I times phi 2 z comma 0 dz, right? So this is how you will evaluate this. Now let's see how we will get the answer. And yeah, one more thing, over here of course there will be an arbitrary constant added right at the last. Okay, so let's evaluate this. What we had got as the value of ux? Well, we had got ux is equal to 4y minus 3x square plus 3y square, and we had got uy as 4x plus 6xy, right? Now in the place of y you have to substitute 0, and in place of x you have to substitute as z. So you will get negative 3z square over here. And in this also you have to do same, so you will get 4z, right? Now integrate this over the region, you will get minus 3z square minus 4z I dz, it is equal to negative z cube minus 2i z square plus constant. This is f of z. Okay. Now using this method also, let's see. So we had got Vx is equal to what? We had got Vx. Well, Vx was equal to it was equal to negative 4x, negative 6xy, and we had got Vy as 4x plus 6xy, right? So again, this will be equal to what? This is phi 2, so it will be equal to negative 4z, and this will be equal to, when you substitute over here z, you will get 4z again over here, right? Sorry, it is not this, it is equal to 4y minus 3x square plus 3y square, so it is equal to negative 3z square. So we have the integral over this region, so you have minus 3z square plus 4z negative I dz plus constant, which is again equal to negative z cube negative 2iz square plus the constant. So this is equal to f of z, right? So this is again the formula which we are applying. So over here phi 2 is over here, this negative 4z phi 2, and this is phi 1. Okay, so basically in this the value of function is f of z is equal to negative z cube minus 2iz square plus constant. So I've taught everything related to the basics of complex analysis, and not basics, I've taught everything basically with all questions and all types which was needed. And now I'll make another one shot in which I will cover the transformations, the linear, bilinear transformations, and other sorts of transformations. I will teach curves, and I will teach the complex integrals and other Taylor series and all, everything I will teach in that. Okay, now this lecture you can take as a part 1 maybe, or it is in itself it is sufficient, but still you can take it as part 1, and in part 2 I'll cover complex integrals, right? Though I take complex integrals and complex analysis in a different way, because they both don't match too much, because one is related to integrals and one is related to an introduction, right? So it is basically an advanced form of this, basically, if I speak frankly. Okay, but still I think that this much is enough for the first part, and I hope so that you will enjoy this video. If you did, then please do like, share, subscribe my channel, and please support this video. Bye bye, take care, and all the best. Hello everyone, this is Aditya, and today study conformal transformations in a one go. But for that, please do like, share, subscribe my channel, and please support this video. Now let's start. Before starting, I need to tell you all that when I had made the complex analysis one shot, I had told you that I will cover transformations and complex integrals together. But when I was making the notes for this lecture, I felt that if I cover them together, then it will like too lengthy lecture. So I have made conformal transformations in a different video and complex integrals in a different one shot, so that every topic can be covered. Now let's start. So first of all, let's understand what do we mean by mapping. Mapping. So for example, if I give you a simple function fx is equal to 2x, right? Okay, so suppose these are set A and this is our set B, right? Suppose I give the input as 1, then what output should come? It should come like 2, because fx is equal to 2x. Okay, if I give 2, the output should be 4, right? And if I give 3, it should be 6. So they are linked like this, right? So this is a mapping where fx is equal to 2x, right? So if this is x, this is 2x, right? So this is how, this is the relation between y and x, right? Y is equal to fx, correct? Now similar mapping is used in complex numbers also. Complex functions. Let's learn them also, right? And yeah, one more thing, if I say you to graph this, then it is very simple. You draw a y-axis and an x-axis, and you draw it like this, right? This is y is equal to 2x, right? Very simple. Now similar we'll be applying complex functions too. Let's see that. Now let's assume a very simple complex function f of z is equal to z square. Now we all know that z is equal to x plus iota y, right? So z is equal to x plus iota y, correct? Where I is equal to square root of -1. And I would recommend first of all was the complex analysis one shot, then you will be able to understand everything better, right? So z is equal to x plus iota y. I will give the link in description or in comment section, whatever you want, I will give, okay? So f of z is equal to x plus iota y whole square, right? Just open this term, you will get x square plus 2x times iota y plus iy whole square, which is equal to x square minus y square, right? Plus I times 2xy, right? This is equal to f of z, right? Now instead of writing f of z every time, what we do is that we write it like w. We set it equal to w basically. So basically we will be representing f of z as w, okay? Now we all know that complex function is equal to u plus iota v, correct? Where u is a function of x and y and v is also a function of x and y, right? Hence we can equate this expression to this. So we'll have u of x comma y is equal to x square minus y square, and we have v of x comma y is equal to 2xy, right? So we have this relation. Now how can we represent this stuff on graph? Because we can easily represent like this on mapping like this. So this is our z and this is f of z, or it is w, right? Suppose it is equal to 1 comma 1, right? So if it is 1 comma 1, then we will simply substitute over here 1 comma 1. So 1 square minus 1 square is equal to 0 plus 2 times this quantity, it will be equal to 2i, right? It will be equal to 0 comma 2, right? This is u value and this is v value, right? So this is linked like this. So it is basically f of z is equal to z square. You can check it also. 1 plus iota whole square is 1 square plus 2i plus I square, which is equal to 2i, right? Hence it is 0 comma 2, right? Where we all know that I is along the vertical axis and real is along the horizontal axis, right? Hence it is this, right? So we can represent all the points like this. But how can we plot this on a graph? Well, we all know that this is two-dimensional because it has two axes, and this also has two axes. It means that to represent its graph, we will need a 4D plane system, but it is not possible. Hence, what we do is that to represent such kind of stuff, we use two graphs, two plane. One, the Z plane, this is Y and this is X, right? Okay. So in this, we represent the values of the z plane, that is x plus iota y, and in the other plane we say it as w plane. We set the value of u and v, and accordingly we draw the graphs. So corresponding to some value over here, we will be having some value over here also, right? For example, we had used this value, right? So this is 1, this is 1, right? So this was the point 1 comma 1, this one, okay? So it represents to 0 comma 2 in this w plane, right? So this is 0, this is 1 and this is 2, this is 1 and this is 2. So this is 0 comma 2. So this is how you will represent it, right? So basically it is a 4D plane, but of course we can't draw 4D, so that is why we draw it separately, right? Understood? Okay, so now let's move to some further concepts. Now let's define conformal mapping, right? Conformal mapping. So let me define a very simple words. For example, if you have a curve like this, in the z plane you have two curves starting from this point. Suppose it goes like this maybe, or the other one goes something like this, maybe whatever be it. Suppose this is C1, this curve 1, and this is curve 2, right? And there is an angle in the anti-clockwise direction as theta, right? Okay. And suppose corresponding to these curves, suppose this is equal to f of z is equal to some value, okay? So some whatever be it, okay? This is z plane. So it depends upon some function. W is equal to f of z, right? We know this. So this is our z plane, right? This is z plane, and here we have w is equal to f of z. This is w plane, right? This is u, and this is v. And suppose corresponding to c1, suppose we have a curve like this, suppose maybe like this, and suppose corresponding to this, suppose name it as p1, and suppose corresponding to c2 we have a curve like this. This is suppose p2, right? Now if this angle is alpha, right? Okay, so this is equal to theta and this is equal to alpha, right? Now to be conformal transformation, it must follow that the magnitude of alpha must be equal to magnitude of theta, and they both should be along same direction. In this, they both are along anti-clockwise direction. But suppose if c1 corresponding p1 over here and it was p2 over here, then the angle would be like this. It would be clockwise direction, right? So in this case, even if the magnitude is equal but the direction is different, so it is not a conformal mapping. It is then called, so for being conformal, it must have same magnitude and the direction should also be same. That is, if it is along anti-clockwise direction, it should be anti-clockwise only, both the angles, right? Direction should be same, right? And if magnitude is equal but the directions are opposite, then we say direction opposite, right? Opposite, then it is called isogonal mapping. Okay, so this is isogonal mapping, and if it is like this, this is p2 and this is p1, then it is conformal mapping. Okay, provided that this condition is satisfied. Okay, so these are some of the basic conditions. It is just for an introduction. Now we'll be moving to different types of transformations. Let's understand that. Different types of mapping. Transformations, we can say. Transformations or mapping, whatever you want to say. Transformations, okay? So the first one is translation. The second one is magnification. Magnification. The third one is rotation, and the fourth one is inversion, right? Now I know that it is a bit confusing that I already wrote the term over here, but you will understand in a few moments. Translation, suppose there is a curve in z plane, suppose like this is x and y. Okay, now over here, now if in the w plane, suppose it moves like this, suppose it comes over here or anywhere, suppose over here it can come, maybe this is v, this is u, this is w plane. So what's exactly happening over here is that we have just picked this curve and we have placed it over here without changing its magnitude or anything, right? So such kind of transformation is called a translation, right? And it is given as w is equal to z plus alpha, where alpha belongs to complex number, right? So this is called translation, right? Okay, suppose if it was a rectangle like this, then suppose I placed it over here, this is a translation. Okay, now let's understand magnification also. Suppose this was the rectangle, at the same place if I just increase the size of this rectangle, then this is called magnification, right? It is given by w is equal to alpha z, where alpha belongs to real number this time. Okay, and yeah, of course, if alpha is greater than 1, then there will magnification. If alpha is less than 0, sorry, less than 1 and greater than 0, then it will be shrinking, right? Okay, so now let's see rotation. Well, suppose this is the rectangle and I rotated it. Well, I should now place it over here so you can understand it better, right? So suppose it is over here. Now I rotate it by some angle, suppose alpha, right? So what will happen is that it will be like this. Yeah. Suppose I rotate it in anti-clockwise direction like this. Suppose like this. Okay. This is angle alpha, right? So this is called rotation, right? So rotation, it is given by W is equal to e to the power I alpha times the quantity Z, right? Now one question is that will the magnitude change or not? Well, we all know that Z is equal to R raised to the power R into e raised to the power I theta, correct? Okay. Hence we have W is equal to e raised to the power I alpha times R e to the power I theta, which is equal to R times e to the power I times alpha plus theta. So we can clearly see that just the angle has changed, the argument has changed, but the magnitude is still same, right? So its magnitude and this magnitude will be same. Of course it is like too big, so I should also draw it like big only. Yeah, now at least they are looking of same size. Now inversion is like a bit complex, so I don't think so I should discuss it right now, but if I tell you it is W is equal to 1 upon Z, so in this case the magnitude becomes 1 by R, because Z is of course it is equal to R times e to the power negative e to the power I theta, right? So in this case W will become 1 upon R e to the power I theta, correct? Okay. Hence, what we'll get is that the magnitude is 1 upon r and the argument is what? E to the power negative I theta. So, argument is negative theta now. Okay? Correct? So, suppose if it was something like this angle is theta. Of course, I'm not talking about the magnitude right now. So, it will be somewhat like this in negative theta, right? Of course, this is not any accurate graph for now. But negative theta is along this axis, right? In the clockwise direction. And this along anti-clockwise, correct? Okay, so this was the basic introduction. Now we will discuss each and every transformation in detail, right? So let me raise this, then we will see. So first transformation is translation, transformation, transformation, okay, or mapping. Okay, so it is a mapping where W is equal to Z plus alpha, right? Where alpha is a complex number, right? So let's understand it using a question. What is the image of rectangular region? This is a very basic question. I think everyone discussed this type of question, right? These are very basic questions which you will find everywhere, right? In your exam also you'll find such kind of questions, right? These are very common questions actually, right? So of rectangular region of the z plane bounded by the lines x is equal to 0, y is equal to 0, and x is equal to 1 and y is equal to 2, right? Under the transformation w is equal to z plus 2 minus I, sorry what I have written, z plus 2 minus I in w plane, right? Okay, so I think that you all know how to draw a graph, right? If you don't know, let me explain it. So let's solve this question. So this is our z plane, x and y, these are the axes, these are the axes, this is z plane. Now we have to find the image of rectangular region of z plane bounded by the lines x is equal to 0 and y is equal to 0 and so on. Okay, okay, yeah. So x is equal to 0, y is equal to 0. So what is x is equal to 0? Well, it is this axis, correct? And what is y is equal to 0? Well, it is this axis, correct? What is x is equal to 1? Well, it is this, right? Okay. What is y is equal to? It is this. So basically this is the region. Okay. So let's name the points. Well, we don't need it actually. Okay. So x is equal to 0, y is equal to 0, x is equal to 1 and y is equal to 2, right?
Now we know this transformation that w is equal to z plus 2 minus iota, right? So z is equal to, sorry, w is equal to z plus 2 minus iota, right? Now we all know that z is equal to x plus iy, right? So it is equal to x plus iy plus 2 minus I, right? Okay, correct. Now we can say it is equal to x plus 2 plus I times y minus 1, correct, right? Now what is w? W was equal to f of z, which is equal to u plus iota v, right? So it is u plus iota v, hence u is equal to x plus 2 and v is equal to y minus 1, correct, right? Now what are we going to do? Well, first of all we will draw a u v axis, that is w plane, right? Now we know these values. So when x is equal to 0, so when x is equal to 0, u is equal to 2, right? This is the line, u is equal to. When y is equal to 0, when y is equal to 0, v is equal to negative 1, right? Okay. When x is equal to 1, then we have u is equal to 3, okay? And when y is equal to, then v is equal to 1, correct? 2 minus 1 is equal to 1, right? Okay, so why am I calculating the value of u and v? Well, we are just transforming it from here to here. We are basically finding its image, right? So if we are finding the image, we should know that x correspond to what in u and y correspond to what in v, right? So we have these 4 lines actually, right? So now we can just plot it very easily. So this is 0 and let me erase this. This is 1. Suppose this is 2, this is 3, we have to go till 3 and we don't need to go there in negative, and this is negative 1, this is negative 2, this is 1, this is 2 and this is 3, right? Now when u is equal to, what is this line? It is this one, okay? U is equal to 2, correct? Okay. Now v is equal to negative 1, v is equal to negative 1 is this line, okay? Now what is u is equal to 3? It is this one. It is this line, okay? This one. Now what is v is equal to 1? It is this line. So this is the region. Okay? So this is the image of this, right? After transformation. That w is equal to z plus 2 minus iota, right? Now I think you should be asking me a question right now that how can we say that it is conformal mapping? Well, it is very simple to say because it is just a linear function of z, and in linear function the angle is not changed, if you can understand it from this. It is very much obvious that angle is same in both the cases. That is, the angle in this, the angle, whatever be the angle, because if you remember in the conformal transformations, I have defined how a transformation is conformal transformation if the angle is same and it is in the same direction, right? So this is 0 comma 0, right? This is which point? This is what? This is 1 comma 0, and this is 1 comma 2, and this is 2, and this is 0 comma 2, right? So this is A, this is B, this is C, and this is D, right? Now corresponding to this, what points we have over there? Well, when x is equal to 0 and y is equal to 0, they intersect, we got the point A. So when x is equal to 0, y is equal to 0, it means that when u is equal to 2, u is equal to, and v is equal to negative 1 coincide, that is this is A dash, right? This is A dash. Similarly over here, when y is equal to 0 and x is equal to 1 intersected, then we got the point B, right? So when x is equal to 0 and y is equal to, sorry, x is equal to 1 and y is equal to 0, this one, okay? So u is equal to 3 and v is equal to negative 1. So this is the B dash point, right?
Okay, and again this will be c dash and d dash, right? So it means that it is in anti-clockwise direction and this also in anti-clockwise direction, right? So angle is also same and the direction is also same, right? Understood? Okay, now let's understand this question. Image of triangular triangular region region of z plane bounded by x is equal to 0, y is equal to 0, x plus y is equal to 1, and the transformation is w is equal to z plus 1 plus I, right? So this is the transformation which we are given, and of course it is a translation transformation, and we have to find the image of the triangular region which is formed using these lines. So this is our z plane, x and y, and we are given x is equal to 0, that is y axis, and we are given y is equal to 0, that is x axis, right? And x plus y is equal to 1, which is this line, correct? Okay, so we have to basically find the transformation of this triangle, this one. Okay, so suppose this is a, this is b, and this is c, right? Okay, so here we have three curves, this one, and this one, right? Okay, so when you find its transformation, what you will get, let's see that. So again w is equal to z plus 1 plus I. Now it is equal to x plus iota y plus 1 plus I, which is equal to x plus 1 plus y plus 1 I, right? U plus iota v. So u is equal to x plus 1 and v is equal to y plus 1, correct? Okay, now notice one thing that here we have okay, these two are just points, but this is a straight line. So how can we use it to form our equation over here? Well, first of all, let's use x is equal to 0, then we will have u is equal to 1. Okay, u is equal to 1, and when y is equal to 0, we have v is equal to 1, right? Now when x plus y is equal to 1, then what will have? Well, just add these two equations. What you will get? You will have u plus v is equal to x plus y plus 1 plus 2, sorry. Hence u plus v is equal to 1 plus 2, that is 3. Hence u plus v is equal to 3, right? Now just plot it, right? This is u, this is v, this is w plane, right? Now what is u is equal to 1? Well, u is equal to 1 is this, right? Okay, and what is v is equal to 1? It is somewhere over here, right? And what is u plus v is equal to 3? Well, now this is a tricky part, so let me write the points over here, right? So we have to draw this, right? I think it should be a bit close because of course it is a bit big graph. So this is 1, this is 2, this is 3, this is 1, this is 2, this is 3. So this region and this region, right? So we have got this graph. So this is basically u is equal to 1 and this is v is equal to 1. Okay, now what is u plus v is equal to 3? Well, it will go like this. So it is this region, right? And again, when you will see the direction, it is again in anti-clockwise direction. It's your job to check. So this is the transformation, the translational mapping over here, right? Of this curve, of this region, I mean. Okay. So I hope so that it is clear. Now let's move to magnification translation. Okay. Sorry, magnification transformation. Magnification transformation. Magnification transformation. Transformation or mapping, whatever you want to say, mapping or transformation over here. Now again I defined it like w is equal to what? W is equal to alpha times z, where alpha belongs to real number in this case. Okay, right? Hence we can either prove it over here also, or whatever you can do. Alpha x plus iota y, right? Hence it is equal to alpha x plus iota alpha y. Hence we have u is equal to alpha x and v is equal to alpha y, right? Similarly, you can do it over here, over there also in translation also. You can just instead of z plus alpha, you could have checked it like this also: x plus iota y plus some a plus iota b, right? That is also this is the general form actually when you solve it, right? But it's okay if you don't want to use like this. You can just understand it using a question, right? That whatever values are given in the question, you can just use them to place in place of a and b, right? So it is not necessary that you prove the general formula, right? General form, right? So it's okay. So this is also just a redundant part. I just told it like this. Okay. So let's erase this and this also. Okay. So let's see a question as the question which I discussed before only. The rectangular region only. This one. This is x-axis and this is y-axis. And this was x is equal to 1 and this was y is equal to 2, right? The previous question only which we were discussing of rectangle, right? That is only, this is z plane, and in this the transformation which we are given is that w is equal to 2z, right? Now so w is equal to 2 times x plus iota v, hence u is equal to x and v is equal to 2y, right? Okay, hence what we have now, x is equal to 0, y is equal to 0, x is equal to 1 and y is equal to 2, right? Just like in previous case. Hence u is equal to 0, v is equal to 0, u is equal to 2 and v is equal to 4, right? Now just draw the uv plane, that is w plane, right? And in this just plot this. So it will be this region, and u is equal to 2, that is if this is 1, this is 2, so this region, and this is 1 2 3 4, this, so this region. And again if you check, it is along anti-clockwise direction only, right? Okay, so I think that it is clear that how we do magnification. We just use the same concept which we were using in transformation also, using the concept that z is equal to x plus iota y, and then we frame a relation between u and x, basically u and x and y and v and x and y, and then we formulate all that, and then we substitute the values at different points which we are given, and using the intersections we take the image in w plane, right? That is the basic concept. Now let's see what's next. Well, you can try the triangular one on your own, right? You can just try that one on your own using this function only. Suppose w is equal to 2z. If you will have in doubt, I can make a video on that, okay? But you should give it a try, that that one, x is equal to 0, y is equal to 0, x plus y is equal to 1, right? This one. So you can give it a try, and if you get any doubt, just let me know in the comment section. I will make a video on that, okay? So this you can do for homework, right? The concept will be same, okay? So now let's move to rotation. Let's study rotational mapping or transformation, okay? So in this we had already find that w is equal to e raised to power I alpha times the quantity z, right? Okay, so we all know that z is equal to e raised to power I theta times r, the magnitude. Hence w is equal to r e to the power I times theta plus alpha, right? So from this we can say that the magnitude is constant in this, right? Okay, just it has rotated. So let's just again use that question of rectangle to understand this also. This is 0, this is 1, this is 2, and this is 1 comma 2, right? This is x-axis, this is y-axis, and this is z-plane, right? Now suppose we are given a transformation in this as w e raised to power I into pi by 4 times z, right? Okay, now here you have two methods. The first one you already know this, you can just rotate it by 45 degree, that is it, okay? That I won't discuss. I will discuss the complete method over here. That is we can write e raised to power, we know that e raised to power I theta is equal to cos theta plus I sine theta, right? Okay, plus I sine theta. Hence, e raised to power I into pi by 4 is equal to cos of pi by 4 is equal to 1 by root 2, right? Plus I into 1 by root 2, right? Okay. And I know if it is getting a bit tough for you, then please to check out the complex analysis one shot, because of course if you don't know complex functions, then how you can discuss all this, how you can understand all this, I mean. So watch that video first of all, then you should move to this one. Okay, so this is equal to this. So we have 1 by root 2 plus I by root 2 into the quantity x plus iota y, right? Hence now just multiply this stuff. What you will get? X by root 2 plus I into y by root 2 plus xi by root 2 minus, right? So we have x by root 2 minus y by root 2 plus the quantity I times x by root 2 plus y by root 2. It is equal to u plus iota v, correct? So x is equal to x by root 2, sorry, u is equal to x by root 2 minus y by root 2, and we have v is equal to x by root 2 plus y by root 2. Just check it once if you're getting exhausted from seeing all this. Just try to understand. What I've done is I've just used the Euler's identity, Euler's formula, and then I've just formatted all this into this equation, and then I just evaluated this, and I got this from comparing the coefficients. Okay. Okay. Okay, so now let's see this. So we have this expression. Now we have x is equal to 0, y is equal to 0, and x is equal to 1 and y is equal to 2, right? Now there is a problem. We have two variables over here in one equation, in both the equations, and we have just points over here. Then how we can do? Well, just eliminate them. I mean, when you add them, you will have u plus v is equal to x2 by this quantity, and when you subtract v minus u, what you will get? You will get 2y by root 2, right? Okay, so it is equal to x root 2 and this is equal to y root 2, right? Okay, now everything is clear. Now what you can do is that sorry, yeah, x is equal to 0, y is equal to 0, x is equal to 1, y is equal to 2, right? Okay, so when x is equal to 0, what we have? We have u plus v is equal to 0, u plus v equal to 0, right? And when we have y is equal to 0, we have v minus u is equal to 0. And when we have x is equal to 1, what we have? We have u plus v is equal to root 2, right? And when y is equal to, we have v minus u is equal to 2 root 2. V minus u is equal to 2 root 2, right? Okay, are you understanding it or not? Okay, so let me raise this, then we'll plot its graph. Okay, so let's see it. So this is uv plane, w plane, right? Okay, so v minus u is equal to 0. It means that this is the line at 45 degree, right? Pi by 4, because of course the angle between y is equal to, I mean, the angle in this case is equal to 45 degree. We all know that this is inclined by 45 degree, right? This line. So we have this, and how does this v minus u look? That is v is equal to negative u look. It looks like this, passing through origin. Now let's see how does v minus u is equal to root 2 look. Well, v is equal to u plus 2 root 2. Well, when v is equal to 0, u is equal to negative 2 root 2. Hence it will somewhat over here, negative 2 root 2. And when u is equal to 0, it is over here, 2 root 2, right? So it looks like this. Okay, correct? Okay. And when now let's see this one, v is equal to negative u plus root 2. So when u is equal to 0, v is over here, right? Somewhat over here. Okay, it should be in the middle, I guess, somewhat over here. And when we have u is, that is v is equal to 0, then we have u is equal to root 2, somewhat over here, right? So it is going like this. So it is basically this region. Okay, so after transformation it looks like this after rotation, right? Inclined by 45 degree. Understood? So what I've done, and again, this is, if this is A, B, C, D, right? So the angle and the rotation and the direction is same, right? Hence it is again conformal transformation. Okay. So let's move to the next topic now. Inversion, right? Let's erase this. And yeah, try the triangle one on your own. Now let's study inversion transformation. Inversion transformation. Transformation. Okay. So again, W is equal to 1 upon Z, that is 1 upon R e raised to power I theta, which is equal to 1 upon R e raised to power I negative theta, right? Okay. So let's study it using a question first of all. And yeah, let's study it using a question. But one more thing, we can also write it like this: 1 upon Z is equal to 1 upon Z times Z bar, and over here Z bar, okay? So it is equal to x minus iota y divided by, that is the mod z, that is equal to x square plus y square, which is equal to u plus iota v. Hence u is equal to x by x square plus y square, and v is equal to negative y by x square plus y square. And this is a very helpful information. So we should remember this. You can easily prove it also, but it is better to remember it. Okay. So from here you can say that u square plus v square is 1 upon x square plus y square, right? It is very much helpful, right? You can prove it also, just square it and add it, right? You will get it. Okay, so let's erase this and let's discuss it using a question. So the question states image of circle x square plus y square is equal to 4y under the transformation w is equal to 1 upon z, right? So we have to find its image, right? That's it. So x square plus y square is equal to 4y. So this is the z plane equation, right? So we can clearly see that it is the equation of a circle, right? Hence we have x square plus y square minus 4y is equal to 0. Let's complete the square. So we have x square plus y square minus 4y plus 4 is equal to 4, right? Hence we have x square plus y square, this y square, that is y minus 2 whole square, right? This is equal to 4. So we have x square plus y minus 2 whole square is equal to 2 square. Check it once. I hope so that you remember circle, what you studied in that. So its center is 0 comma 2 and its radius is equal to 2 units. Okay. So this is a circle. Okay. Now the transformation is this, right? So we have the transformation as u is equal to x upon x square plus y square, and v is equal to negative y by x square plus y square, right? Well, this is one way to write it. What is another way to write it? Well, I can also say that z is equal to 1 upon w. We can say this, right? So we have x plus iota y is equal to 1 upon u plus iota v, right? And similarly, when you will rationalize this, you will get x is equal to u by u square plus v square, and y is equal to negative v by u square plus v square. So depending upon the criteria, depending on the question, if you have to use this, then use this. If you have to use this, use this one. Okay. So over here I have an equation in x and y. Hence we will use this one. So just substitute over here. What is x square plus y square? Well, u square plus v square was equal to 1 upon x square plus y square. Similarly, x square plus y square is equal to 1 upon u square plus v square. So it is equal to 1 upon u square plus v square is equal to 4. What is y? Y is equal to negative v divided by the quantity u square plus v square. So this and this gets cancelled. Hence we get the value v is equal to negative 1 upon 4. So in the w plane it looks like this. This is negative 1 upon 4. So it is a straight line parallel to the u axis, right? This is the w plane, right? Okay. Now how you draw this curve? This circle. Do you know how to draw a circle? Well, try it on your own. Okay. Try to draw the circle on the xy plane. Okay. On the z plane. Okay. It is a very simple thing. You can use the help of some graph generators also, if you don't remember, right? But it is a very simple thing. Okay, I have already made a video on circles, I guess, somewhat. It was like some months back, so you can check out that video also. So it's your homework, try to draw the graph of circle. If you don't remember, it is a very simple thing. Okay, so now let me raise this. Now there are two theorems related to inversion transformation. Let's discuss them. Theorem 1, right? So what is it? We will prove it. So I will write in form of question. Show that transformation W is equal to 1 upon Z maps a circle in Z plane to a circle in W plane, or a straight line if the former passes through origin. Well, what does it mean? Well, it means that we have to prove that under the transformation W is equal to 1 upon Z, it maps a circle in Z plane. If it maps a circle in Z plane, then in W plane it is either a circle or a straight line. If it passes through the origin, the circle passes through the origin, for example, like this, or whatever, then it will be a straight line. And if it does not pass through the origin, then it will be a circle in W plane also. Let's prove this. Well, what's the general equation of a circle? It is x square plus y square plus 2gx plus 2fy plus c, right? Plus c is equal to 0, right? Okay. Now we all know that x square plus y square is equal to 1 upon u square plus v square. We remember it. So it is 1 upon u square plus v square plus 2gu by u square plus v square minus 2fv by u square plus v square plus c is equal to 0. Hence we have 1 plus 2gu minus 2fv plus c times the quantity. Now notice that this is a circle if c is not equal to 0, and it is a straight line if c is equal to 0. Why? Because what makes a circle? This term u square plus v square. If this will become 0, then of course it will be a straight line. And if c is equal to 0, it implies that this expression is x square plus y square plus 2gx plus 2fy is equal to 0, right? So notice that x comma y is satisfying this equation always. X comma y equal to 0 comma 0, it will satisfy this equation always, because x is equal to 0, y is equal to 0, 0 plus 0 is equal to 0. Hence it is passing through origin if c is equal to 0. Hence if it passes through origin, then it is a straight line, and if it does not pass through origin, then it is a circle, right? Understood the theorem 1? Okay, so now let's move to the next theorem. Okay, now let's discuss the second theorem, theorem 2. What it states: show that transformation W is equal to 1 upon Z maps a line in Z plane. If it maps a line in Z plane, a straight line in Z plane, to a circle or a straight line in W plane, right? Okay, whatever be it. Okay, so let's understand its proof. So what is the equation of a straight line? Well, it is ax plus by plus c is equal to 0, right? Now u square plus v square minus bv divided by u square plus v square plus c is equal to 0, right? So au minus bv plus c times u square plus v square is equal to 0. Now if c is equal to 0, then of course it is the equation of a straight line au minus bv is equal to 0, and if c is not equal to 0, straight line, then it is a circle, because we have u square plus v square term over here. So I think here should be in W plane, if, yeah, depending upon the criteria, that if former passes through origin. Why? Because again, if c is equal to 0, then ax plus by. So 0 comma 0 will satisfy this thing, right? Understood? Okay. So now let's erase this, and now let's move to some next topic. Okay. Let's see. Now let's study linear mapping, linear transformations. Linear transformation. Well, what is a linear transformation? A transformation, it is a combination of translation, magnification, and rotation. So we will study linear transformation now. So its general form is given as z is equal to alpha z plus some beta. Alpha and beta belong to complex number, right? Well, how is it then combination of translation, magnification, rotation? Well, some complex integers, or this w, some complex function plus a complex number, it is a translation. Okay. Now alpha is a complex number, now so it can be written as r e raised per I theta, where r is a real number and e raised by I theta is a complex number, right? Hence w is equal to r e raised to power, or I can write it like this, e raised to power I theta, it is the rotation, or I can write it as some theta only because I've used alpha over here, r into z. So this r times z is magnification, and this is rotation, and this translation. So of course it is a combination of these three, right? Okay, so let's erase this, and let's move to some questions to understand this, right? Okay, so let me erase this. So this is the question. So we are given the linear transformation as w is equal to 1 plus I z plus 2 minus I, right? This is the linear transformation. Again we are taking an example of that rectangle, that x is equal to 0, y is equal to 0, x is equal to 1, and y is equal to 2, right? So we have to find its transformation. So again it is very simple. So z plane, it looks like this. This is x, this is y, this is 1, this is 2, this is 0, right? That is it. Okay, so w is equal to 1 plus iota times x plus iota y plus 2 minus iota, right? That is it. Okay, simple. So just multiply it, x plus iy plus ix, x plus iota y, right? This multiplied by this plus ix minus y, right? Correct? I square is equal to negative 1 plus 2 minus iota, right? So we have x minus y plus 2 plus I times x plus y minus 1 is equal to u plus iota v. Hence u is equal to x minus y plus 2 and v is equal to x plus y minus 1, right? Now again here we had just these lines, that x is equal to 0, y is equal to 0. We had just one variable, right? Okay. Hence we will just add them just like we did there. So u plus v is equal to what? 2x plus 1, and v minus u is equal to 2y minus 3. 2y minus 3, right? Okay. So now we have this. Let me refill the ink. So we have x is equal to 0, then we have if x is equal to 0, y is equal to 0, x is equal to 1, x is equal to 1, and y is equal to 2, right? Y is equal to 2, correct? Okay. Then what we will get is that u plus v is equal to 1, and when y is equal to 0, we will have v minus u is equal to negative 3, and when x is equal to 1, we have u plus v is equal to 3, and we have then v minus u is equal to 1, right? Okay, see it, right? So now let's plot this. Let me erase this. So this is our u plane or w plane. This is u, this is v, this is w plane. Okay, and now we have these lines. So v is equal to u plus 1. So v is equal to u plus 1, right? So it goes somewhat like this, correct? Okay, this is v is equal to u plus 1, right? Okay, and v is equal to u minus 3. Well, it will go somewhat like this, correct? I think I should make it a bit far, because of course this point is 0 comma 1, right? So it will go like this. This is 0 comma negative 3, right? I hope so you're understanding what I'm doing. It is just plotting the lines. I hope so that you understand this. Okay. And what is v is equal to negative u plus 3? Well, when u is equal to 0, v is equal to 3, right? And when v is equal to when u is equal to 0, then v is equal to 3, right? And when v is equal to 0, then u is also equal to 3, right? So it will be what will be its intersection? This is v is equal to u minus 3. So when v is equal to 0, u is equal to 3. So this is 3 comma 0, right? So it will pass like this. Okay, correct? Right, okay. So now let's check this one. So we have v plus u is equal to 1, that is v is equal to negative u plus 1, right? So when u is equal to 0, then v is equal to this quantity. Okay. And when v is equal to 0, then u is equal to positive 1, right? That is somewhere over here, right? 1 comma 0. So it goes like this. So we have got this region. Okay. It is inclined at 45 degree. We can easily see, because here the coefficient is 1, that is m is equal to 1. Since m is equal to 1, hence tan of 1 is equal to 45 degree. So it is rotated by 45 degree over here, and it has moved like this. Okay. So we have seen translation also, and we have seen rotation also, and probably there must have been magnification also, right? Okay. So now let's move to next question, right? Now this is a question in which we have to determine the linear transformation that maps. So determine the linear transformation, whatever be the question, that maps the rectangle z1 is equal to 0, z2 is equal to 1 by 2, z3 is equal to I, z4 is equal to 1 by 2 plus iota onto the rectangle w1 is equal to I, w2 is equal to I, w3 is equal to negative 2 plus I, and w4 is negative 2 plus 2I, right? Okay, so let's see this one. Okay, so basically we have to determine the linear transformation in this case. So we are given a curve in this, and we have to determine what linear transformation is bringing that bringing that image, right? So let's plot this first of all. So z is equal to 0, z1 is equal to 0, that is 0 comma 0, that is this point. Okay, and z1 is equal to 1 by 2, that is over here, 1 by 2 is over here, and z3 is equal to I, that is over here, this is 1, and z4 is equal to 1 by 2 plus iota, right? This one. So this is the basic this is basically the curve which we are given in xy plane or z plane, right? And what is the y plane? Let me draw it up like this. Yeah, this is v, this is u, this is w plane, right? So we are given w1 is equal to I, that is uh, over here, right? Because we have 2I also, and we have 2I over here, right? This is 2, this is 1. Okay, this is 1 by 2 over here, and we have negative 2 plus I, so negative 2 plus I, so this is 1, this over here, this is negative 2, so negative 2 plus I, and 2I, negative 2 plus 2I, so basically this is the rectangle, final rectangle. Okay, so which transformation, which we will determine that linear transformation which will give this image of z plane. So we can see that it is like rotated by which angle? Well, we all can just see it on our own, that if we check this line and this line, right, they both are perpendicular to each other, right? Means it has rotated by 90 degree. Suppose if the angle was like 30 degree or any other angle other than 90 or any other angle, then in that case you just find the slope of this one and the slope of this one. Suppose this is like this, then we have this, right? So we can find the angle between them, right, using the slopes, using the formula which we know, the relation between slopes, if you remember, right? in a straight line. You should check that one, that how we find the angle using the slopes of line, right? Just check it once. Okay, of lines or curves, right? Both are same, I guess, right? So we know that if we set z to, if we rotate z by e to the power I pi by 2 times the quantity z. If we do rotation, then we will have we will rotate it by like this. So this will become, so when we rotate it, it will become something like this. When it is rotated by 90 degree, it will go like this, right? Somewhat like this. Now we know that this length is equal to 1 by 2 and this is 1, which means that we have to multiply this by 2, right? So we will magnify it, that is we will use magnification. So here 2 into e to the power I pi by 2 into z, right? So it will get magnified. Now we know that this was earlier at origin and we have to bring it to 1, right, along y axis, along the basically the vertical axis. Hence we will use translation or translation. Okay, so 2 e raised to the power I pi by 2 z plus iota, right? This is the value, this is the transformation, this is the linear transformation required. Okay, now of course you can say e raised to the power I by theta is equal to I, so it is basically equal to w is equal to 2iz plus iota, right? Like this. So this is the final transformation which you will get, right? So now let's move to next topic. Now let's study bilinear transformation, and I know that max of you get doubt in this only. So let's discuss it. Bilinear transformations or mapping transformations. Okay. So well, a transformation which is of the form az plus b divided by cz plus d, right? Az plus b divided by az plus cz plus d, right? It is a combination of all four. Translation, it is a combination of all four, that is translation, rotation, magnification and inversion, right? Okay, so hence it is called bilinear. Okay, now let's see a theorem, right? Theorem, bilinear transformation w is equal to az plus b divided by cz plus d is combination of elementary transformation, that is them. These are called elementary transformation. Translation, rotation, magnification, inversion are called elementary transformations. Okay, so how we can prove it? Well, w is equal to az plus b divided by cz plus d. Well, what we can do is that just multiply by cw and divide by a, cw by a. Okay, cw by a is equal to CAZ plus CB divided by the quantity ACZ plus AD, right? Okay. Now what we can do is that we can arrange it a bit and just solve it. Let me show you. ACZ plus AD minus AD plus CB divided by quantity ACZ plus AD, right? So it is equal to, now this, it will become 1 minus the quantity 1 plus CB minus AD divided by the quantity ACZ plus AD, right? Now just multiply this expression, so you will get W is equal to A by C plus the quantity A by C times BC minus AD divided by the quantity ACZ plus AD, right? So A gets cancelled over here, so you will have W is equal to A by C plus the quantity BC minus AD divided by C square. We can take C common, right? So we will have C square Z plus D by C, right? Okay, so we have over here W is A by C, BC minus AD, C square Z plus D by C, right? Okay, now how can we say that it is formed of elementary transformations? Well, let's start with Z. Okay, now let's translate it. So we'll have z plus d by c, right? Okay, now let's take its inverse, that is inversion. You will have 1 upon z plus d by c, right? Now let's magnify it. So magnification, we will have bc minus ad divided by the quantity c square z plus d, right? D by c, right? Here the magnification factor is this, right? Alpha is this, okay? And when you take it is of course magnification plus rotation, because I forgot to tell over here, a b c d belong to complex number, right? Since these are complex number, this is a complex number, hence it has magnification plus rotation both, right? Okay, and then we can again take translation. So you have a by c plus bc minus ad divided by the quantity c square z plus d by c, right? Hence it is hence bilinear transformation is composed of elementary transformations, hence proved, right? And one more thing here, BC minus AD shouldn't be equal to 0. Why should not be equal to 0? Because if it will be equal to 0, then this expression will become 0, which means that W will be equal to A by C, that is a constant value. So if W is a constant value, then it does not make any sense. Why? Because then what kind of transformation is that? There is no transformation in that, right? Hence it means that basically if W is equal to 0, that is if there are infinite points in x and y plane, it will just end at one point. It will be just mapping to a single point in uv, right? So there is no kind of transformation in this, right? Okay, hence ad minus bc minus ad shouldn't be equal to 0, right? Hence this is the basic idea of bilinear transformation. Now let's see some question to understand it, right? Okay, now there's something called a cross ratio, right? So let's understand this. If bilinear transformation transforms the points, suppose if it transforms the point z1, z2, z3 into the points in w plane as w1, w2, w3, then the relation between w and z is given by cross ratio w minus w1 times w2 minus w3 divided by the quantity w1 minus w2 times the quantity w3 minus w is z minus z1 times the quantity z1 z2 minus z3 divided by the quantity z1 minus z2 times the quantity z3 minus z, right? Okay, it is a big expression, but don't worry, you have to just remember any one of them and you can just find the second one easily, right? Because they both follow the same pattern, right? So from this you can find the w as a function of z, right? Easily. Okay, how can you prove it? Well, proof, we know that w is equal to az plus b divided by cz plus d, right? Okay, hence w1 is equal to az1 plus b divided by cz1 plus d, and so on. We can find w2 and w2 similarly. Just replace z1 by z2 and z3 and z3 and I mean z by z3 for w3. Okay, and just find the difference w1 w minus w1, w minus w1 minus w2, w3 minus w, and you will, when you will put the values, the substitute the values, you will get the expression in this. It is very easy, you can do it. If I've written, I can tell you the expression, but I guess it is not necessary, right? You can just prove it very easily. Just find w minus w1, you will get some value. W1 minus w2, you will get some value. W2 minus w3, you will get some value. W3 minus w, you will get some value. And when you substitute it into this format, you will get this expression only. Okay, just try it as homework, right? So try to prove it once. Okay, so let's erase this and let's move to something called as invariant or fixed point. What is an invariant or fixed point? Invariant or a fixed point? Well, suppose there's a point in x plane like this. Suppose 1 comma 2, right? In xy plane, z plane, that is. After transformation, the point is still at 1 comma 2 in uv plane also, that is w plane. then such kind of points are called invariant points or fixed points. So in such cases, f of z is equal to z, right? For those points. Okay. So for example, if we have to find the invariant point in the curve z minus 1 divided z plus 1, this is w, then what we do is that we set it equal to z itself, right? So when you set it equal to z, you get z minus 1 is equal to z square plus z. So we have z square is equal to negative 1 and z is equal to plus minus iota. So this is the invariant point. Okay. So if you substitute it back over here, suppose I, if suppose you substitute z is equal to I, so you have I minus 1 divided I plus 1, rationalize it. So it is equal to I, right? And if you substitute negative I, you will again get negative I. So it means that fz is equal to z in this case. Not for all values, for finding the invariant points. So there are two invariant points in this case. Understood? Okay. So now let's move to questions, I guess. Let's see then. So let's do a question now. Find the bilinear transformation which maps the points 2, I, negative 2 in z plane to the point 1, I, negative 1 in w plane. Okay, so this is z plane, this is w plane. Okay, so we have z1 is equal to, z2 is equal to I, and z3 is equal to negative 2, and we have z, and we have w1 is equal to 1, w2 is equal to I, and w3 is equal to negative 1, right? Hence we will use the cross ratio w minus w1 into w2 minus w3 divided by the quantity w1 minus w2 into the quantity w3 minus w is equal to z minus z1 times the quantity z2 minus z3 divided by the quantity z1 minus z2 times the quantity z3 minus z1, right? I know it is very much confusing, but if you once prove that theorem, which I have told, that not theorem, just prove the method that how we got cross ratio, which I have given as homework, then you will easily understand that how it works, right? That is why I have not given the proof. I have told the method. It is very simple. Just do the calculation part on your own. You will see that it is very simple, right? It is nothing difficult over here. Okay. So yeah. So we have this expression now. Just substitute the values. You have w minus 1 times the quantity w2 minus this quantity, that is I plus 1, divided by quantity w1 minus this 1 minus iota times the quantity w3 minus w is z minus 2 times the quantity z2 minus this I plus 2 divided by the quantity z1 minus z2, it is 2 minus iota times the quantity z3 minus 2, sorry, z3 is equal to negative 2 minus z, right? And you can easily solve it, I guess, right? You can solve it right now. You can easily find a relation. Let me show you also. So I should write this expression over here. W minus 1 divided W plus 1 times the quantity I plus 1 divided by I minus 1, right? I just took negative sign common and multiplied it over here, is equal to z minus 2 divided by z plus 2 times the quantity I plus 2 divided by I minus 2, right? Okay, so now let's erase. Now 1 plus I divided by negative 1 minus I, it is equal to 1 plus I whole square divided by the quantity 1 minus I whole square, which is equal to negative 2, right? Because here we have a negative sign, and when you square it you will get 2i, right? So you will have negative I over here. So w minus 1 divided w plus 1 is multiplied by negative I, right? This is equal to z minus 2 divided z plus 2, right? And again I'm saying, please watch the complex analysis one shot if you're getting any confusion, right? Because you have to learn the complex analysis first of all, then you can only understand them, right? These concepts times the value, means times this expression I plus 2 divided I minus 2, right? So I plus 2 divided by I minus 2. So again you can take negative sign in common, so you have 2 minus iota, 2 plus iota, 2 plus iota, 2 plus iota, right? So you have 2 plus iota whole square divided negative 2, that is, it will be 4 minus I square, that is 5, right? So it is equal to 4 minus 3 plus 4i divided by negative 5. So we have 1 plus, sorry, 4 minus 1 it will be, right? I square is equal to negative 1. So it is equal to 3 plus 4 iota divided by negative 5, right? So this we can write it as 3 plus 4 iota divided by negative 5. So this and this will become positive. Okay. So we have w minus 1 divided by w plus 1 is equal to the quantity z minus 2 divided by z plus 2, right? 3 plus 4i divided by 5i, right? Now we have w1 minus w minus 1 divided by w plus 1 is equal to z minus 2 divided by z plus 2 times the quantity 3 by 5i plus 4 by 5, right? But we don't need to do this, okay? Because we can just multiply these stuffs, right? Easily. We can just multiply I in denominator and numerator, so you will have negative over here, and here you will have, what is I times I? It is equal to negative value over here and I over here, right? Correct? So we have 4 minus 3i. 4 minus 3i, right? Correct? So we have 4z minus 3iz minus 8 plus 6i divided by 5z plus 10, right? So it is equal to 4z minus 8 plus, minus 3iz plus 6i, or we can take I as common. So we have minus 3z plus 6 over here I, right, divided by 5z plus 10, right? So it is w1 minus this quantity. Okay. Now how we can solve for w over here? Well, if you remember, you know something called componendo and dividendo, right? If a by c is equal to a by b is equal to c by d, then we have a plus b divided by a minus b is equal to c plus d divided by c minus d, right? If you remember componendo and dividendo, right? So just do that. So you will have w, that stuff. First of all, you will add. So we'll have 2w divided by the quantity this minus this. It is negative 2. Hence again we will add numerator and denominator. What we will have? 9z plus 2 plus I times the quantity negative 3z plus 6 divided by the quantity. What we will get? We will have over here this expression 4z minus 8 plus I times negative 3z plus 6 minus this expression minus 5z minus 10, right? Of course, this is the calculation part, and I also that it is getting a bit lengthy, but you should try the calculation on your own, right? This is just for an example, right? So it is equal to 9z plus 2 plus iota times negative 3z plus 6 divided by the quantity negative z minus 18, right? Just see the calculation, plus I times negative 3z plus 6, right? So now let's erase this thing and let's evaluate it further. Okay, so what we had got over plus 6, right? So this and this gets cancelled and this plus. Okay, so we just multiply both sides by negative 1. So we will get w is equal to 9z minus 3i, that is 9 minus 3i times the quantity z plus the quantity 6i plus 2 divided by the expression z, that is 1 minus 3i z plus the expression 18 and over here minus 6. So I times, that is we can simply write it over here. This will become 6i minus sign, so we will have 18 minus 6i, right? So this is the value of w, right? Now you can simplify it further by dividing both sides by, means the numerator and denominator by 3 minus I, right? Just divide it and you will understand on your own, right? So I guess I've written it correctly. Yeah, I guess over here it will be a positive sign. Yeah, because of course if negative sign will go inside, then it will become positive, right? So 9 minus 3i z plus 6i, yeah, correct. Okay, now you can take this common numerator and denominator and divide it, And if you simplify it further, you will get W is equal to 3Z plus 2I divided by IZ plus 6. Now this is your job to do. You just take 3I common and then evaluate it. You will get this expression only. Just give it a try. You will understand that this is much more simpler than this, right? Because it looks a bit messed up, but this looks better, right? So both are correct, but still it is in simplified form, so it looks better, right? Okay. There's another method also to do such kind of problem. Like what you can do is that you know the value of W1, that is Z1, Z2, Z3, right? So you put the value AZ plus B, CZ plus D, W1 as AZ1 plus B divided by CZ1 plus D, and W2 as A Z2 plus B divided by C Z2 plus D, and for W3 also, right? So if, for example, if W is equal to 1, so 1 is equal to 2A plus B divided by the quantity C 2C plus D, right? Like this. And when W is equal to I, then I is equal to AI plus B divided by CI plus D, right? And so on and so forth. So you will get three equations, right? So for example, you have got three equations, right? So in that you can express the variables in terms of one variable then, right? For example, if x plus y is equal to 0, x plus 2z is equal to 0, then we have y is equal to negative x and z is equal to negative x by 2. So we have expressed the all the three variables in just one variable, right? And x is equal to x, of course, right? So suppose if in this I ask you to find the value of x plus 2y divided by x plus 10y, so 10z, right? Then in this case you can easily find the value because you know the relation. So if we know that y is equal to negative x, so x minus 2x divided by the quantity x minus the quantity 10 times x by 2, that is 5x. So it is equal to negative x by negative 4s, which is equal to 1 by 4, right? So this is how you will get over here also when you will substitute it. If you will substitute all the three equations, you will get all the equations in terms of one variable, and then you can just substitute it over here and you will get your desired result. Okay, right? So let's erase this now and let's move to another question, right? So let's erase this. So let's discuss this last question. Let f of z be a bilinear transformation such that, now it is something interesting, f at infinity is equal to 1, f at I is equal to I, and f at negative I is equal to negative I, right? Okay, so this is which we are given, and find the image. Yeah, so we are given find image of the unit disk z belongs to C such that mod z is less than 1 under f at z. Okay, so we have to find this. Let's see solution. Okay, so now this is a tricky question because here there's something interesting involved over here, and we have a point infinity. So basically z1 is equal to infinity and z2 is equal to I, z3 is equal to negative I, right? w1 is equal to 1, w2 is equal to I, w3 is equal to negative I. Let me recheck the question, the values are correct or not. I, okay, I have to check that. Okay, this is I and this is also I. Okay, yeah, okay. So w minus w1, what is w1? It is equal to 1, okay, times the quantity w2 minus this is 2i, okay, divided by w1 minus this quantity 1 minus I, right? w3 minus w, right? This is equal to, now what is z minus z1? Well, it is approaching towards infinity, so we have z minus z1 times z1 minus z2, sorry, z2 minus z3 divided by z1 minus z2 times the quantity z3 minus z. Now we all know that z1 is approaching towards infinity, right? So just take z1 common. So z1 taken as common, we have z by z1 minus 1 multiplied with z2 minus z3 divided by z1 times the quantity z1, sorry, 1 minus z2 by z1, z3 minus z, right? Okay, z1 and z1 gets cancelled, and as z1 tends towards infinity, this expression tends to 0. So this is tending towards -1 and this is tending towards 1, right? So whenever you see infinity, just try to make the denominator 0 in this case, in that case, okay? So you have negative, so this we have to just evaluate negative of the quantity z2 minus z3 divided by z3 minus z, right? So we will get from here negative z2 minus z3. What is it? What is z3? Z3 is equal to, I mean z2 is equal to this and this. So it is 2i divided by the quantity z3 minus the quantity z. So this will become positive and this gets cancelled. So we have w minus 1 divided by I minus 1 is equal to quantity 1 upon negative 1 upon z plus iota, right? Now from this we know that modulus of z is less than equal to 1. Hence we need to express z in terms of w, not w in terms of z over here, because if we will express w in terms of z, then it will become very difficult, right? So if we express it, then what we'll get? Well, I am writing the final result only. We will get over here z is equal to 1 plus w divided by 1 minus w, right? Okay. Of course, you should check the calculation once because I am just doing it right now. I'm not sure if it is correct, the calculation are correct, but the result will be this, okay? So just check the calculations once, okay? So z is equal to this. Now we know that this we are asked that this is a disk, okay? So it is a disk. Just a minute. Yeah. So it is a disk with modulus of z, this, and it is centered at 0. So it looks like this. Sorry. It will look like this. I mean it looks like this. This xy. So mod z is equal to is less than 1. Hence we have to image this region, right? Mod z less than 1, right? This is the z plane. So when you do this, what you will get? You will get mod of 1 plus w divided by 1 minus w is less than 1, just using this condition. So we have 1 plus w less than mod of 1 minus w. Now we know that w is equal to u plus iv, right? So from this you have 1 plus u plus iv mod less than 1 minus u minus iv, right? Mod, right? Now just square both sides. When you square it, you will get 1 plus u whole square plus v square less than 1 minus u whole square plus v square. V square and v square gets cancelled. When you open this, you have 1 plus 2u plus u square less than negative 2u plus u square. This and this gets cancelled. This and this gets cancelled. 1 and 1, everything gets cancelled. So u is less than 0. So this is the region. This is the image in w plane. Hence it looks like this. So this is u is equal to 0. U is equal to 0. So this is the region in w plane. This region is the transformation of this. This is the image. If it was greater than 1, then we would have got this region, right? It is excluding this u is equal to 0 line. Okay. So this region. So I hope so that you enjoyed this lecture. If you did, then please do like, share, subscribe my channel, and support this video. And of course, please do check out the one shot of complex analysis too. And I hope so that this much is enough for understanding conformal transformations. And soon, maybe in 1 or 2 days, I'll be uploading the one shot of the complex integrations. So please do subscribe this channel. Bye bye. Hello everyone, this is Aditya and today we study complex integrations in a one shot. So let's start with the lecture, but for that please do like, share, subscribe my channel and please support this video. Now let's start. And yeah, I have already made a one shot on complex analysis and conformal transformations. Please do check it out, else you will face problem in understanding all these. Okay, so now let's start. Let's start the lecture with the proof of complex integrations. That how is it done? Well, it is nothing new which you have studied in 12th grade. That is what we are going to do, right? Nothing new. Okay. So in a complex plane, we are defining a contour z of t, and t is called the parameter, right? And we are defining a function f, right? First statement is basically we are defining a function and a contour, right? Okay. Now let P be this set. Okay. Now what is P? P is called partition, right? Partition, let me explain it. Basically, we had defined that A is less than T and B is greater than T, right? So this T is called a parameter. So basically we are defining the parameter for different sections of a curve. Suppose this is the curve. So in this we are defining different parameters, right? So for example, corresponding to Z1 we will have a T1, right? Corresponding to Z2 we will have some T2 and somewhat like that, okay? So that is why for every Z we have a T, right? Or I should say that for every T we have a Z over here, right? So that is why we are defining it like this, that this is T0, this is T1, this is T2 and so on till Tn, right? And we have said that Tn is equal to B, right? Okay. So corresponding to the partition P, curve C is divided in n smaller arcs, right? Which is denoted as sigma k. That arc is denoted as sigma k, which is from zk minus 1 to zk, where k is equal to this, right? So we can see over here that z of k is equal to z of t k, right? So basically this value of function, this is basically z1, or we can say z at t1, right? That is what I have said when I had said about partition. So basically we have divided the curve into n different regions, right? So yeah, let zeta k is equal to z of sk, where sk is lying between t of k minus 1 till t of k. So basically this curve is represented as zeta 1, right? From z0 to z1, and from z1 to z2 it is zeta 2, right? Understood? So basically that curve is known as zeta over here, okay? So we have defined it like this, correct? Now we have defined something called norm of a partition. When norm of partition is basically, suppose it is basically this partition value, right? So what does it mean? Well, it actually means we are finding the maximum value of the partition. So maximum value of the partition will come from this difference, right? Okay. So what we are doing next is that we are defining this partition, the number of partitions, as infinite. Why? Because why infinite? Because the more numbers you have, the more close you get to the curve, right? Understood? That is why. It is simply what you have studied in your 12th grade, nothing new in this. So that is why I'm a bit fast, because we will discuss after these questions. Okay. So basically it is this, okay? So we have choose that n is tending towards infinity in such a way that the norm of partition is tending towards 0, right? Okay. So basically if there are infinite terms in a curve, then of course the partition will keep on decreasing and there will come a time that it will tend towards 0, right? Okay. Simply, if you are just increasing the number of partitions, then of course z1 will come close to z0 and so on till infinity, right? If we are going towards infinity, right? Hence the partition value will keep on decreasing and there will come a point where this norm of partition becomes approximately 0, right? Okay. So norm is the maximum that I have told. Okay. So yeah, now this term, this is the sum. Can you understand it? Well, over here it shouldn't be infinity for now. See, it is basically the region, the area of this curve, right? Basically, if I try to define in terms of the real numbers, then this represents the area under the curve. If I talk about in real terms, but in complex it is bit different, but don't worry. So for now, I'm just telling, when you are integrating this, then what is f at zeta of k? Let's understand it this way. So f of zeta k will represent the function value from z0 to z1, right? Z0 to z1, okay? Times the difference. So basically, this curve and this value, right? Okay. So basically, kind of the area of this region, right? But of course, it is the idea of real numbers. But to understand this, I am just introducing it in complex number, but that is not required at all, right? But basically, this is the idea, okay? The idea of real numbers only, okay? So that is why we are taking the sum from k is equal to 0 to n and then this quantity. So basically, we are trying to evaluate at every zeta, right, at every arc, right? Okay, now if line SP this it exists, then f is said to be integrable, and as the norm of partition tends towards 0, that is n is tending towards infinity, this expression evaluated at the norm of partition at 0, it will be equal to this integration. And if C is a closed curve, then this will represent like this. Okay, so in a nutshell, what I've done is that I've just taken different arcs and then I've applied the summation over different arcs over there, right? And from there we got this expression, and from that if I set the norm as 0 tending towards 0, then this expression will be basically k is equal to 1 to infinity, nothing else, right? It means k is equal to 1 to infinity if I remove this limit sign over here. So then this thing is called the complex integral of f of z, right? So that is the basic idea, and I am sure that you have already studied it in your 12th grade, so I don't think so that I should discuss much on it. Okay, now let's discuss some of the properties and all, right? Let me list this. So this is the complex integration, right? Now we all know that z of t was equal to x of t plus I y of t, right? So let's convert it into parameterized form. So z dash of t is x dash of t plus I y dash of t, right? Correct? Or you can say it as dz by dt is x dash of t plus I y dash of t, correct? So we can say this is the integration, the complex integration f of z. This is dz. It is equal to complex integration f of z d, or we can just substitute over this value x dash of t plus I y dash of t dt, right? And it is going from a to b because t was going from a to b, right? We are defined like this, correct? Okay, now let's see some of the properties. First property, linearity, right? Linearity, right? So basically the complex integration of some alpha f of z plus beta g of z is equal to alpha f of z dz plus beta g of z dz, right? What is the second property? Negative c f of z dz is negative c f of z dz, right? Okay, let me tell you that c is curve joining suppose z0 to z1, right? And minus c is the curve joining z1 to z0. Okay, just the difference of direction. Now c1 plus c2 f of z dz is equal to c1 f of z plus c2, of course dz also, plus c2 f of z dz, right? This expression. Now there's something called ML inequality, right? So if L is the length of contour, how we calculate the length of contour? Basically this integration. Okay, so it means it states that this value, this whole mod f of z dz is less than equal to the quantity f of z dz, right? Now if f of z has a maximum value, the mod of f of z, if suppose it has a maximum value of m, right? So we can set it equal to like this, m, this complex integration, right? So it is less than ml. So it means that this integration f of z dz is less than equal to ml, right? Okay, so this is called ml inequality, where l is the arc length, l is the length of the contour, right? Contour c. Okay, so yeah, that is it. Now yeah, let me write it like this, that m is the maximum value in a to b of f of z, right? Okay, that is it. Okay, So now let's see some other concepts. Okay. So now let's solve this question. It states we have to find this complex integration from z is equal to 0 to z is equal to 4 plus 2i along z of t is equal to t square plus iota t, right? So we are given this curve. Okay. Okay. So this is the curve. So we all know that z bar dz. This is the question which we are given. So z bar is equal to x minus iota y, correct? And what is dz? It is dx plus iota dy. Remember we had proved right there, over there. We had said f of z is equal to u plus iota v, and dz is dx plus I dy. Remember this which we had done, right? Okay. So this is that is the expression, and now we can just substitute the value. So what is the value of x? It is t square minus t I, of course, because we already had an item over here. So the value of y is t over here, right? Y is equal to t. Okay. So I can write it like it, correct? Okay. Now what is dx? Dx is equal to 2t dt, right? Because dx is equal to 2t dt, simple differentiation, and dy is equal to dt, correct? So it is equal to 2t dt, 2t dt plus I dt, correct? Okay. So now let's substitute the limits over here. So what will be the limits? Well, t is going from here. We can say that let me write over here. Z is equal to 0 comma 0 to z is equal to 4 plus, that is 4 comma 2, and z of x comma y is equal to t square comma t, right? Hence we can say that this is the value of t, this is the value of x, this is the value of y. Hence t is going from 0 to 2, right? From here 0 to 2, this is the value of t, right? So it is going from 0 to 2, right? Okay. So now let's just solve it. 0 to 2, t square minus it 2t plus I dt, right? Now just multiply it. 0 to 2 of the point 2t cube plus it square minus I 2t square plus t dt, right? Now just evaluate this expression. You will get 2t raised to the power 4 divided by 4 plus it cube divided by 3 minus I 2t cube divided by 3 plus t square by 2, evaluate from 0 to 2, and just substitute the value. You will get your integral value. Okay. So you will get some a plus iota b over here, right? That is it. So it is just basic integration only. Just the concept is how you convert it from here to here. That is it. Nothing more in this. Okay. So let's see another example. You will understand more. Okay. So the question states this integration f of that is 3z square dz from z is equal to 0 to z is equal to 4 plus 2 iota along the line from z is equal to 0 to 2i, right? Z is equal to 0 to 2i, right? Along this line. And of course whenever you are evaluating this integration, then of course you will be given along which curve you are going, right? Okay. From z is equal to 0 to 2i, right? And then from and then the line from z is equal to 2 iota plus 4 plus 2i, right? So now you can see that there are two curves. First curve is this one c1 and this is c2. So basically we have to evaluate this c1 plus c2 f of z dz. Now if you remember that I told you the property, if you remember, it was c1 f of z dz plus c2 f of z dz, right? If you remember this property. So there are two curves, so we have to apply this only. So first of all, let's evaluate for C1 and then we'll evaluate for C2, right? So let's calculate it. So the region is, the curve is, let me draw it. This is X, this is Y. So the line joining, line from Z is equal to 0, Z is equal to 0 to 2i, that is over here. This 2i, right? Okay, correct. This is the Z plane. Okay. Okay, and then the line from z is equal to 2i to 2i to 4 plus 2i, that is this. So this is 4 plus 2 iota, right? Okay. So this is the first curve and this is the second curve, right? What is the equation of first curve? Well, so C1, so it is integration in the C of the quantity f of z dz, it is equal to 3z square dz, right? Now what is z in C1? Well, z is equal to iota y because it is along vertical axis, right? Hence, it is equal to 0 to 2, the integral 0 to 2, because it is going from 0 to 2, right? Of the quantity 3 iota y squared I dy. Why there is no dx term over here? Because there is no change along x axis, right? That's why. Hence, we have this expression as negative 3 iota integral 0 to 2 y square dy minus 8i, right? So this is the integral for C1, right? This is the value of integration for C1 is negative 8i, right? Okay. Now for C2, what is the expression for curve in this? Well, it will be x plus 2 iota by z is equal to x plus 2 iota, because of course it is along the, it is already in y axis by 2 units, so of course we have to add 2i, right? So it is x is variable plus 2i because 2 is a constant over here in y axis, right? So now let's evaluate this integration. So it is going from 0 to 4 x plus 2 iota whole square 3 times whole square dx, right? Of course there is no change along y axis, so there will be no dy term over here, right? Okay, so 3 and then this integration x square plus 4 ix plus, let me write here, minus 4 dx, right? So it is equal to 3 times the integral x cube by 3 plus 2ix square minus 4x evaluated from 0 to 4. So it is basically 64 by 3 plus the quantity 32i minus 16, right? Minus 16. Okay, so it is basically 64 plus 96 iota minus 48, right? So what is 64 minus 48? Well, it is equal to 16, right? 16 plus 96 iota, right? Correct. Okay, now this is the value of integral in C2, right? So we all know that integral C1 plus C2 is basically C1 plus C2, right? Hence the final value of this integral will be the sum of this and this, so it will be equal to 16 plus 96 iota minus 8 iota, hence 16 plus 88 iota is the final answer. Understood? So basically this is the idea. Basically that is why I have told this identity. It is very much important to learn it and to understand this, right? So basically this is how you solve such kind of problems, right? Now let's move to some other concepts. That is, now we are going to move to Cauchy theorem, right? Now let's see Cauchy theorem. Cauchy theorem, okay? So let me write the statement first of all. If f of z is analytic with a continuous derivative in a simply connected domain D, and C is closed contour, lying in D, then we have f of z dz is equal to 0. Did you understand anything? Well, suppose this is it, and inside you have a suppose a contour. So if it is analytic, right? If fz is analytic with a continuous derivative, yeah, okay. So if fz is analytic with a continuous derivative in a simply connected domain D, and C is closed contour lying in D, right? So it means that fz is analytic everywhere. Then in that case, this integral, suppose this C, this integral will become z, right? Will be equal to 0, right? So this is the Cauchy theorem. Okay. So you can prove it also. Let's prove it, right? Let me derive it also. Let me erase this first of all. So let's see the proof. Well, we all know that f of z is u plus iota v, right? Okay. Okay. Now we know that this integration f of z dz was equal to what? It was equal to this integration u plus iota v dx plus I dy, correct? If you remember, we had already proved this. So it was equal to, let me write the result only, u dx minus v dy plus iota the integration c v dx plus u dy, right? Okay. Now if you remember Green's theorem, basically this is a line integral. So if we have to convert it to a surface integral, then we use Green's theorem, right? So it states this expression, mdx plus ndy is equal to, in R, the region R, del n by del x minus del m by del y dx dy, right? So this is Green's theorem, right? Okay. So this is m dx and this is n dy, right? So over here m is equal to u and n is equal to negative v, and over here m is equal to v and n is equal to u, correct? So just apply over here the Green's theorem. So you will have this value negative vx negative uy. Just evaluate this. I'm just writing the result because so that you know Green's theorem. So basically I'm just substituting the values back over here, right? So it does not require that much explanation. It is just I'm substituting the values over here, nothing more. Okay. Plus this integration minus vy dx dy, right? Now we all know that the Cauchy theorem is valid for analytic function, f as an analytic function, and if f is an analytic function, it means that it should follow CR equation, that is Cauchy-Riemann equations. Hence we have u, x and uy, there must be a relation, so it is equal to vy, it is equal to negative vx, right? So it is negative vx, okay? So it is basically equal to uy. So this is uy basically. So uy minus uy is 0, right? Similarly, this expression is also 0. Hence, this is equal to 0. Now we were evaluating this integral, right? So f of z dz is equal to 0. This is the Cauchy theorem. It is valid for analytic functions. Okay. So now let me raise this. Now let's study Cauchy integral formula. Well, if a point is not analytic at any point, then in this case we use Cauchy integral formula. Then at that point the integration is still possible. It will have non-zero integral value. So let me explain it. So for example, it is given like f of a is equal to this value 1 upon 2 pi iota f of z minus a dz. Okay. Now we can clearly see that this expression is not analytic at z is equal to a. So basically this is the d and this is c, and inside that c there's a point a where the function is not analytic. Then in this case we use Cauchy integral formula. There's still, in that case, at that point the value of integral will not be equal to 0, right? Okay. So this we can say f of z divided z minus a dz is equal to pi iota f of a, right? So this is the another way to write this expression. Okay. Now what we can do is that first of all we all know that f of a is 1 upon 2 pi iota in the contour this f of z f of z, z minus a dz, right? Now let's differentiate it with respect to a, right? F dash of a is equal to 1 upon 2 pi iota c f of z, z minus a whole square dz, correct? So when you take its derivative, the z minus a term goes in the numerator. So it becomes z minus a raised to power negative 1, right? So when you take its derivative, it will become negative will come outside. So it will become negative z minus a raised to power negative 2. And since a also has a negative term, so it will become positive. So it will be this expression. Now let's take the second derivative. It will be equal to, it will be z minus a raised to power negative 2, right? So it will be 2 by 2 pi I f of z z minus a whole cube dz, right? Sorry. Now let's take the derivative n times. So f any derivative at a is equal to the quantity n factorial 2 pi iota complex integral f of z z minus a raised to power n dz, right? So this is another way of writing this. It is for a general case, right? So now let's discuss some questions to understand this, right? It is like confusing. I also know that suddenly I told so many formulae. Let's discuss the questions so you will understand it. Sorry, it will be n plus 1, right? Okay, sorry, it will be n plus 1. Notice over here. Because second derivative had 3 power, so n power will have n plus 1 power over here. Okay? Okay. So let's do this question, this integration where C is a circle first, mod z equal to 1 and mod z equal to 3, right? Okay. So for the first one, this integral e to the power z z minus 2 dz, it will be equal to what? 2 pi iota f of a? No. Why? Because over here the value of mod z is equal to 1. It means that it is a circle like this. 2 will lie somewhere here, 2 comma 0. It means that 2 is lying outside the contour, hence we can't apply Cauchy integral formula there, so it will be equal to 0. Okay? Okay. Now, second one, this e to the power z z minus 2 dz, it will be equal to 2 pi iota f of 3, which is equal to 2 pi iota, sorry, f of 2, 2 pi e square, right? That's it. Understood? So over here we could apply Cauchy integral formula because the mod z value, since the circle was mod z is equal to 3, right? And z is equal to was lying inside that circle, right? It is lying inside that. That's it. Okay. So let's erase this. Now let's see another question. I will not discuss its solution. You can do on your own. Suppose this integral tan z divided by z square minus 1 dz and mod z is equal to 3 by 2, right? Okay. So how you will do this? You can see that there is a 2 power over here. So you will do partial fraction. That is, you write 1 upon z square minus 1 as 1 upon z minus 1 minus 1 upon z plus 1 into 1 by 2, right? Like this you can write. And then you can just simplify this because it will be of the form z minus that form only. F of z divided by z minus a, right? Now it is in the same form where f of z is equal to tan of z. Yeah, over there also f of z was e to the power z. Over here f of z is equal to tan z, right? Correct. And notice since f of z, notice that mod z is equal to 3 by 2. Okay, so we know the region also. Now we can solve it. So both z is equal to 1 and z is equal to negative 1. Both are inside this region, hence we will have to evaluate for both. Okay, let me solve it only. So it will be tan z, that is, it will be simply tan of 1 over here. Let me evaluate this. Tan z divided by z minus 1 plus the quantity minus the quantity, tan z divided by the quantity z plus 1 dz, right? So it is basically equal to 1 by 2 is common, 1 by 2. So it is 2 pi iota tan of 1 minus the quantity tan of that is 2 pi I tan of negative 1. What is it? It is equal to plus 1 over here, right? So it will be just equal to 2 pi iota tan of 1, right? That's the answer. Okay, correct. Just check it once. Basically what I've done is that I've taken the partial fraction, and after that I've just write it like this, and then I evaluated. I used the Cauchy integral formula over here and over here also in both the expressions. So I got 2 pi I tan of 1 minus 2 pi I tan of negative 1. So tan of negative x is equal to negative tan x. So I applied that formula and I got this expression. I added them, and since there was 1 by 2 also, so after adding I got 2 pi iota tan of 1. That is it. Simple. Okay. So now let's see another question. So this integral e to the power 2z z plus 1 raised to the power 4 dz, right? This expression, and where c is the circle where mod z is equal to 3. Okay, is it 0 or is it having some value? Think. Well, we can clearly see that z is equal to negative 1, where it means that a is equal to negative 1 over here, and negative 1 of course lies in this expression, right, in this region. If you remember this expression, f of z, z minus a raised to power n plus 1 dz is 2 pi I f nth derivative of a, right? Correct? Okay. So now over here we have a power 4, right? Hence we have 2z, z minus minus 1 raised to power 4 dz is equal to 2 pi iota f nth derivative of negative 1, right? So what is n over here? N is equal to 3, right? Correct. Now we know that f of z is equal to e to the power 2z. Hence f dash of z is equal to 2 e to the power 2z, and f double dash of z is equal to 4 e to the power 2z. F triple dash of z is equal to 8 e to the power 2z, right? Okay. So f triple dash of z is equal to this. Hence f triple dash of negative 1 is equal to 8 e to the power negative 2, right? Hence we have the expression 2 pi iota into the quantity 8 divided by the quantity e square. That's it. Okay. And yeah, one more thing, here was an n factorial also. So n factorial, so it is 2 pi I into 8 divided by 3 factorial into e square, which is equal to what? 8 pi iota divided by 3 e square, right? That's it. There was an n factorial also in the denominator. Okay. So let's move to next topic now, power series. Okay. So let's erase this. Power series, right? Okay. So a series of this form is called a power series. Power series about z is equal to a, right? Okay, where an and a are the fixed complex numbers and z is a variable complex number, right? So n is equal to 0 to infinity a n z minus a raised to power n is absolutely convergent if n is equal to 0 to infinity of the quantity a n mod times z minus a, and this is also convergent, right? So this is called absolutely convergent if this converges, right? So this is the same thing which we discussed in integral calculus also. If you remember, I taken that lecture in probably it's like about 6-7 months back. I have taken that lecture. So I discussed about, not in that, I discussed in sequence series. Sequence series I discussed that. Okay, so you can check out that video if you want to learn more about this. But it's okay if you know till over here. Okay. So now for every power series, this n is equal to 0 to infinity a n z minus a raised to the power n, there exists a real number r such that this expression z minus a is less than r, right? The series is absolutely convergent, and for so if there exists such r for every such number, then it is said to be a convergent series. And if for every z minus a, if it is greater than 0 for every z, then it is called a divergent series, right? So we'll be checking it using some example. You will understand it using some examples, I mean. just now it's just theory which I'm just writing for now. If you will, when you will see questions, you will understand it better. Okay, so if you want, you can note this, all this, else it's not necessary. Okay, so over here, R is called the radius of convergence of the power series. Okay, so how do we check for the convergence? Well, there's something called a ratio test and a root test, which is similar, which we have discussed in sequence series, right, in first year lectures. Okay, so first of all, let me raise this and then we will discuss a question so you understand it, right? Okay, so find the radius of convergence of the power series summation n is equal to 0 to infinity z raised to the power n factorial, and we have to check for convergence. Okay, solution. So of course it is about z is equal to 0, right? Okay, so n is equal to 0 to infinity, right? So we know that a is equal to 0 over here and an is equal to 1 upon n factorial. If we compare from that form, an z minus a raised to the power n, right? It is just this. Okay, so where an is equal to 1 upon n factorial and a is equal to 0. Okay, now the ratio test, it states that 1 upon r, the radius of convergence, is the limit as n tends towards infinity an plus 1 divided an, right? So it is equal to an plus 1 divided an. So what is an? An is equal to 1 upon n factorial, right? So it is basically 1 upon n plus 1 factorial times n factorial as the limit tends towards infinity. Hence limit n tends towards infinity of the quantity n factorial divided n plus 1 factorial, it is equal to limit as n tends towards infinity of 1 upon n plus 1, which is equal to 0, right? Hence r, 1 upon r is equal to 0, hence r is basically tending towards infinity, right? Now to be convergent, it should be mod of z minus 0, this z minus 0 less than r, and of course if r is tending towards infinity, hence it is convergent, convergent for all z, right? It is convergent for all z, since of course mod z is less than infinity, hence it's of course always convergent, right? Okay, so now let's see another question. So this is the question, n is equal to 0 to infinity 3 plus iota raised to power negative n into z raised to power n, right? So now in this we'll apply root test. Why root test? Because we can see a power of n over here. Let me explain. Root test is basically limit as n tends towards infinity mod of an 1 upon n, right? This is equal to again 1 upon r, right? So we can see a power of n over here, so we will apply this because it will of course cancel out the power of n, right? Hence we have limit n tends towards infinity of the quantity 3 plus iota raised to power negative 1 mod, right? So it is limit n tends towards infinity raised to power 1 upon n mod of the quantity 1 upon 3 plus iota raised to power n 1 upon n, so n and n gets cancelled, so it is basically equal to 1 by root 10, which is equal to 1 upon r, right? Hence r is equal to root 10. Now again a is equal to 0, since z minus 0, since z is equal to z minus 0, hence a is equal to 0, right? Hence mod of z minus 0 is less than root 10, and for these values it will be convergent, right? And if mod z minus 0 is greater than root 10, then for these values it will be divergent. So this series is convergent if mod of z is less than root 10. Okay, understood? Okay, now let's study Taylor series, right? So basically you must have studied Taylor series in functions in several variables, I guess, in single variable or several variables, I don't remember. I taught that in first year, right, if you remember. So it is that only, but in complex numbers. So f of z is equal to summation n is equal to 0 to infinity a n z minus a raised to power n, right? Where mod of z minus a of course is less than some delta. Okay, so an is equal to f nth derivative of a divided by n factorial. It is called Taylor's coefficient. Okay, and delta is the distance of A to the nearest point of C, right? So basically delta is the distance of point A to the nearest point of C, right? Okay. So basically over here we have certain other formulae. Yeah, if A is equal to 0, then it is called Maclaurin series. Maclaurin series, right? Maclaurin series, okay. And if D, if you remember what is D, I defined D and C if you remember, right? So if D is a disk, then delta is called the radius of convergence of Taylor series, right? Let's discuss that now using question. So f of z is equal to 1 upon 1 minus z. So you have to find the Taylor series about z is equal to 0. Okay. So f of z is basically this: n is equal to 0 to infinity of the quantity f nth derivative 0 divided by n factorial times the quantity z minus 0 raised to power n, right? Okay, simple. Now what we can do is that f of z we can write, since we know that it is equal to 1 upon 1 minus z, right? Hence f one derivative of z is, it is equal to 1 upon 1 minus z whole square. F second derivative is equal to 1 upon 1 minus z whole cube raised to the power 2, right? Correct. Hence from this we can say that f nth derivative of z is equal to n factorial divided by 1 minus z raised to power n plus 1. Correct? Right? You can see yourself, right? Hence f of z is equal to this summation n is equal to 0 to infinity. What is fn of this quantity? It is and of course evaluated at 0, then it will be n factorial itself, right? So it is n factorial divided by n factorial times z raised to power n. So it is equal to 1 plus z plus till so on till infinity, right? So this is your expression over here. Now how you find the convergence over here? Well, you remember 1 upon r is equal to the quantity this mod of an plus 1 divided by an, right? This as limit n tends towards infinity, right? Of course this is inside a mod. If you forgot this is inside a mod, right? So now we all know that what is an. Well, an is basically f n derivative at 0 divided by n factorial, right? Hence an is basically equal to n factorial divided by n factorial, which is equal to 1. Hence this is also equal to 1 and this is also equal to 1, right? So it is equal to 1. Hence r is equal to 1, right? So this is the radius of convergence for Taylor series, right? Hence if mod z minus 0 less than 1, then this is convergent, and if mod z minus 0 is greater than 1, then it is divergent, right? So for here it will be mod z less than 1, right? Okay, so this is the basic idea of Taylor series, right? So now let's move to next concept. Now let's study Lorentz series. Lorentz series. So basically it is of the form fz is summation n is equal to 0 to infinity an z minus a raised to power n plus the quantity n is equal to 1 to infinity bn divided by z minus a raised to power n, where bn is equal to a subscript negative n, right? Okay, so let's see that question only. F of z is 1 upon 1 minus z, okay? We have to write its Lorentz series for mod z greater than 1, right? So in that case when we were forming Taylor series, then in that when mod z was greater than 1, we said that it is divergent, but in this case we can still solve it. Let's see how. Well, either you apply this formula, or you, if you remember, 1 plus x raised to by negative 1, what is it equal to? And what is 1 minus x raised to by negative 1 it is equal to? Well, it is equal to 1 plus x square and so on, right? Correct? And if I talk about this expression, it is 1 minus x plus x square minus x cube and so on, right? If you remember this expression from the binomial expansion, right? So similarly, okay, so over here what we'll get, 1 upon, we can take z as common, 1 by z minus 1, right? Because if mod z is greater than 1, then 1 upon z 1 upon mod z will of course be less than 1, correct? Okay, hence this is negative z taken as common 1 minus 1 upon z, right? And it can be written as negative 1 upon z times 1 minus 1 by z negative 1, right? Okay, so now just apply this expansion. You will have negative 1 by z times the quantity 1 plus the quantity 1 by z, 1 by z square, 1 by z cube, and so on till infinity. So it is negative 1 by z, negative 1 by z square, negative 1 by z cube, and so on till infinity. And that is the expansion, that is the Lorentz expansion for 1 upon 1 by z for mod z is greater than 1, right? Okay. And we can say one more thing, that a n over here is basically 1 upon 2 pi I integral f of z, z minus a dz, right? That is it. Okay. You can prove it also, because we all know that a n was equal to what? N plus 1 also. So you can prove it also if you want using Cauchy integral formula, right? Okay, so now let's move to next topic. Now zeros of a analytic function. Well, let f of z be analytic at z naught, right? Then z naught is called the zero of f of z if f at z naught is equal to 0, right? Now there's something called order of 0 at z naught, right? So suppose if f of z is equal to some w, right? So w is equal to f of z, right? Okay, so if f at z naught, if f at z naught is equal to 0, and suppose f dash of z naught is also equal to 0, till some f of k derivative of z naught is equal to 0, and suppose after that k plus 1 derivative at z naught is not equal to 0, then so the order of 0 at z is equal to z naught is k plus 1 over here, that is the derivative value. Okay, so for example f of z is equal to z square, hence f of z naught, that is f of 0, is equal to 0, f dash of 0 is equal to z at 0 is equal to 0, f double dash of 0 is equal to 2 at 0 is equal to 2. Hence over here it is 1 plus 1, that is 2 is the order of derivative over here, sorry, order of 0 over here at z is equal to 0. Okay, so now let's see some of the concepts. Basically now we are going to understand what is singularity, right? You must have heard it like in black holes also and many other concepts of physics. So let's discuss that now. So what is a singular point? Let me write its definition. A point z naught is called singular point of a function f of z if fz is not analytic at z naught. Maybe it is not defined, okay, may even be undefined at z naught also, right? So basically what I want to say is that if a function, sorry, please don't mind my writing, it is just for uh, to tell you all what is it. It is just not for any notes and all. We will discuss everything using questions. I was just writing it for like that. Okay, so basically maybe it is undefined also, but is analytic at some point in every neighborhood of z naught. The function is said to have a singularity at z naught, right? So basically if the function is not analytic at that particular point, basically if suppose z is equal to a, that is it, then that point is called a singular point. Okay, now singularity can be of two types, like isolated and non-isolated. Isolated singularity is basically okay, we will not discuss it like that, we will discuss it using questions, right? So I need to tell you one thing, that isolated singularity is divided into three categories, right? Which I will be telling using questions, right? So let's see them. So if you remember, f of z was equal to summation n is equal to 0 to infinity a n the quantity z minus a raised to power n plus the quantity n is equal to 1 to infinity b n divided by z minus a raised to power n, right? This expression, this was Lorentz series, right? So this is called the principal part, okay, okay, of at so if suppose I am naming it as p, okay, so if p has no terms, if p has no terms, that is called as removable isolated singularity, okay. If p has finite terms, then it is called as a pole singularity, right? And if p has infinite terms, then it is called essential singularity, right? Okay. So removable singularity basically suppose sin z divided by z, right? Limit as z tends to 0, right? So of course it is 0 by 0, so it is so there is a singularity at z is equal to 0, right? But if you use the L'Hospital's rule, then you will get limit as z tends to 0 cos of z, which is equal to 0, sorry, which is equal to 1. Hence this function has become analytic at z is equal to 0, right? So it was an removable singularity. And if you want to check it using the principal part, you know that sin z is z minus z cube by 3 factorial plus z raised to the power 5 divided 5 factorial and so on. Hence sin z by z will be 1 minus z square by 3 factorial plus z raised to the power 4 divided by 5 factorial and so on. Now we can notice that there is no 1 upon z term in any of these expressions, right? Hence it has no p term. Hence if it has no p term, that is a removable singularity, right? Which we saw it, right? Now let's see pole singularity and essential singularity, right? Okay. Let me define also. Suppose there is a function f of z is equal to phi of z divided by z minus a raised to power m. Then this denominator, when set it equal to 0, when set as 0, then it has a pole, right? The value of pole is a over here. Hence what is the order? The order of the pole is equal to m. How do we calculate the order of a pole? Well, limit z tends to some z naught, z minus z naught raised to power some k f of z. If this is a finite value, then this k is called the order of pole. So similarly over here, if I multiply by z minus a raised to power m, then this expression will get cancelled, and then I will get phi of z at 0, sorry, z naught, right? Hence this will be the order of this pole is m, right? So if this is finite and limit z tends to z naught f of z is infinity, then this is called a pole in singularity, right? And if in essential singularity, if this expression is not finite, it is tending towards infinity, then this is called an essential singularity. In that case, you will have infinite singular points, sorry, infinite terms in principal part of f of z at z is equal to z naught, okay? So this is a basic idea. That is the idea basically of the singularity over here, right? So now we will do some questions, and I will tell you the difference between isolated and non-isolated singularity. For example, if we have suppose a function tan z, right? Tan z. So it is sine z divided by cos z. So at what points it is not defined? Well, at 0, sorry, when z is equal to plus minus pi by 2, when plus minus 3 pi by 2, and so on, the odd multiples of pi, right? So it is not defined at particular points, right? So if that is the case, at particular points, there are different points, and the function is not defined, then it is called an isolated singularity. And if there are multiple points in the neighborhood of suppose neighborhood of pi by 2, there are multiple points near that pi by 2, then in that case we say that is an as a non-isolated singularity, right? So there is a difference between isolated and non-isolated. So basically isolated, it is isolated. Basically it is at different points, and in non-isolated it is like it is like very close. Okay. So now let's see some questions. Okay. So suppose this is a question. So I have already discussed the question for removable singularity. So suppose f of z is this expression 1 upon z times z minus 2 raised to power 5 plus 3 upon z minus 2 whole square, right? So of course it has singularity at z is equal to 0 and z is equal to 2, right? Okay. So we can clearly see that it is a pole singularity. How? Just apply limit as z tends to 0 of the quantity z times. Okay, now it is a simple pole. What is a simple pole? When its order is equal to 1. So z is equal to 0 is a simple pole, and z is equal to is a pole of order 5, because you will need z minus 2 raised to power 5 to cancel both the terms. Okay. Okay. This multiplied by f of z, so it is equal to limit z tends to 0. When you multiply by z, you will have 1 upon z minus 2 raised to power 5 plus 3 upon z minus 2 raised to power 5. So it is equal to 1 upon 32 plus 3 upon z minus 2. It will be negative this value. Z minus 2. What is z minus 2? It is negative 2 whole square is equal to 4. So that is the expression. You can solve it further, right? Now if limit at z tends to 0, so 2, z minus 2 raised to power 5 f of z, right? So it is equal to limit z tends to 2 of the quantity 1 by z plus 3 times z minus 2 raised to power 3. So this is 0 and this is 1 by 2, right? So now you understood. Okay, so if this is the expression, so this is a finite value and this is a finite value over here, right? Okay, hence it is a pole singularity. Okay, so now let's see essential singularity. Question: f of z is equal to e to the power 1 by z, right? Okay, now we know that e to the power z can be written as 1 plus 1 by z plus 1 by 2 factorial into z square plus 1 by 3 factorial into z cube and so on till infinity, since e to the power x is equal to 1 plus x square by 2 factorial and so on, so right? Hence there are infinite principal power terms over here, infinite terms in denominator. Hence it is an essential singularity, right? Okay. Now if you remember, I defined tan z, right? So in that it was sin z by cos z, right? So cos, so if z was equal to 2n plus 1 divided by 2, or we can say pi by 2, right? If this was the, if it was an odd multiple of pi by 2, then the function was undefined, right? Hence, is it a pole? Let's check. Limit as z tends to zn. Suppose this is zn, okay? Of the point z minus zn times the function this tan z, right? This tan z divided by cot z, it will become cot z, okay? F of z is equal to tan z, hence it is equal to 1 upon cot z, right? Okay. So now if you apply L'Hospital rule, because if z tends to zn, then it will be 0 by 0 case, right? Hence we will have limit as z tends to zn of the quantity 1 upon negative 1 upon cosec square zn, right? If you substitute the value also, so it will equal to negative sine square zn. Now at these values, the sign will become what? It will be 1 only, so it will equal to negative 1, right? Plus minus 1 squared, it will become plus 1, right? So plus 1 multiplied by 1 by negative 1, it will be equal to negative 1, okay? So it is a pole. So all these Zn are the simple pole, right? Okay, so it is a pole singularity, right? Understood? Okay. Now isolated singularity at z is equal to infinity. Basically, if we have to check for isolated singularity at z is equal to infinity, then just check for the isolated singularity in this case. Z is equal to 0. Rest everything will be same. If this will be isolated singularity, then this will also be isolated singularity, right? Okay, so if the pole exists at some value in this case, so pole will exist at same value in this case also, right? That is it. Now let's study something called residue, right? So let's start with the question itself. E to the power z square divided by z minus iota cube. So we will solve this question. So we have to find the singularity and residue at those singular points, okay, of this function. So residue of a function f of z at some z naught is given as 1 upon m minus 1 factorial limit as z tends towards z naught of the quantity dm minus 1 derivative dz m plus m minus 1 z minus z naught raised to the power m f at z, right? This is the value, okay? If z if f of z, sorry, has m poles at z is equal to z naught, okay? And yeah, residue at z at of f of z at infinity is equal to negative the residue value of 1 upon z square function at z, sorry, function at 1 upon z and at 0, okay? So this is how you calculate the residue at infinity, and this is how you calculate the residue at any general point, right? So instead of where you have z, z is tend to a z naught, just substitute 0 over here and change the function as this, okay? Okay, so this is what is required in case of residue. This is basically the question. This is basically the theory. But what exactly is a residue? Let's discuss that. Remember the Laurent series summation as n is equal to 0 to infinity a n z minus z naught raised to the power n plus summation from n is equal to 1 to infinity of the quantity b n divided by z minus a raised to the power n, right? So B1 is called the residue of function at z naught. B1 is called the residue. Okay. So now let's start with the question. So this is the question. Okay. So of course over here z is equal to iota, right? This is the pole. Okay. Of order 3, because we can see there is a 3. Okay. Hence we have the residue f of z at iota is 1 upon 3 minus 1 factorial d2 by d as dz square, right? Of course there should be a limit also, limit as z tends to iota d2 by dz square z minus iota whole cube f of z, right? Where f of z is equal to ez square divided by z minus iota, right? Cube. So this and this will get cancelled, so we will have 1 upon 2 limit z tends to iota d2 by dz square e to the power z square, right? Okay. So now you can just differentiate it. You will get negative 1 upon 1 upon e, right? This is the value of residue. Okay. And this is the pole singularity. Okay. Now let's see something called Cauchy residue theorem, right? So let f of z be an analytic function inside and on a simple curve contour C except for the isolated singularity z. Okay. So suppose if f of z is an analytic function, right? Inside or on a curve, okay? Except it has singularities inside C at z1, z2 till zn. Then this integration f of z dz is equal to 2 pi iota summation of the residue of f of z comma zk, right? Okay. Okay. So this is it. Okay. This is the formula, the summation of all the residues of these values. Okay, at these values. For example, this question, integration mod z minus 1 is equal to 1 by 2 dz divided by the quantity z square minus 1. Hence we can just see that z is equal to 0, z is equal to plus minus 1. So these are the simple pole, this is the pole of order 2. Now this is the region. Now which values lie in this region? Well, this is a circle, right? Centered at 1, and it is like this. Okay. So over here it has a value 3 by 2, and over here it has a value of what? It has a value of 0.5. Okay, correct. So now 0, of course 0 does not lie over here, and we can see that negative 1 also does not lie over here. Hence only 1 lies in this region. So we have this integral is equal to, the limit is equal to 2 pi I residue of f of z at 1, right? Now residue of the quantity f of z at 1 is basically equal to z limit as z tends to 1 of the quantity z minus 1 times the quantity f of z, right? Okay, you remember the formula, 1 upon m minus 1 factorial times the quantity, the limit as z tends towards z naught of the quantity dm minus 1 divided dzm minus 1 times the quantity z minus z naught raised to the power m times f of z. So if m is equal to 1, then it converges to this. Basically it becomes that this expression, right? So it is equal to, from this we can say limit z tends to 1, 1 upon z square z plus 1, so it is equal to 1 by 2. So this becomes 2 pi I into 1 by 2, which is equal to pi I. So this is the integral value of this. Okay, so this was the all the concept in complex integrals, and I hope so that you understood something from this video. And if you did enjoy this video, then please do like, share, subscribe my channel, and please support this video. And yeah, this was a one shot, so of course I did not cover many questions in this. I covered all the concepts in this video, and I tried to discuss all different types of questions, but of course I could not discuss many deep questions over here. But I can say that if you watch this lecture, you can like cover your basics easily, and after this, if you, it's on your practice, right? And of course, if you want a detailed topic wise videos, you can just tell me in the comment section. I will make a detailed topic wise video, so in that I can cover everything, right? So till then, bye bye, take care, and all the best.